everyone to ViteConf. My name is Brittney Postma. I am here with Patrick today. How are you doing, Patrick?
Hey, I'm great here. Very, very happy that it's finally the day and we are going to see all the speakers and the talks. I'm very, very excited about the day.
I know, it's so exciting. I'm so excited to be here as well.
Yeah, and I think we should start by thanking everybody because there was like so much work involved for the conference, like starting by the speakers that they put a lot of effort in their talks. And also, yeah, like we will have some surprise MCs like joining during the stream. Thanks to them also.
Oh, nice.
Yeah, and the community in general, like that is watching us and like discussing with us in Discord. Please join chat.vitejs.dev if you're not there, and go to the ViteConf channel, and like we can take it from there. Like we are going to discuss with the speakers, with the community. So yeah,
that's where we're going to be having all of the conversations about all of the amazing talks. I'm so excited for some of these talks. They're really looking good.
Yeah, and to close the thanks to StackBlitz and the community partners to make this possible. Like again, like a lot of work involved in having this conference today, and also to the Vite team actually that it's kind of like we are going to hear a lot of Vite today.
Absolutely, which is very exciting. I feel like everyone is starting to adopt Vite, so I'm so excited to hear all of these different frameworks kind of coming together. I love the cohesion that Vite brings to the community.
Yeah, and yeah, something that is interesting about the conference today also is that we are going to see some talks about Vite, but if you see the schedule, it's mainly about like the spotlight is on the frameworks and in the tools using Vite. So that is really, really interesting that like all these frameworks are the ones that are pushing and innovating, and we are collaborating on a common tool.
Which is just so great for the web in general. Like I love everything that Vite is doing and all the frameworks like building around that. Before we dive more into like about the conference, how to view the conference and things, I just want to take a minute to tell everyone to go and look at the code of conduct. We take the code of conduct very seriously. And if you have any trouble with anything, we have some Vite.js moderators in the chat, in the Discord that you can go and talk to if you have any issues. But go and check that out at the link. And I know you have to accept it before you even are able to watch the live stream. So we want to make sure that everyone is being kind and genuine and just be an ally to everyone and be nice.
Nice. Yes. All the moderators are going to be on the top of the sidebar. So like if you have any trouble, please contact us there. And
that's in the Discord, right? So in the Discord on the top right of the sidebar.
Exactly. And okay, so if you have to grab one link and share it around today, it is like viteconf.org/live. There is going to be like the stream that like hopefully you are already there seeing this. But like share it around. Let's invite like everybody, and also like let's invite others to the Discord, because like really is going to be today a celebration. The conference is going to be 24 hours from now on, so it is quite long.
Yeah, my mind is blown.
There was a lot of projects that are using Vite, so like we didn't want to
and you're
leave.
Planning on staying up the full 24 hours, right?
I will try. Let's see.
Yeah.
So, but then the idea is that there is like 12 hours of content, and then that 12 hours will repeat. This will allow that no matter where you start watching, you could watch the whole thing. Please don't be worried, like, and go to eat and sleep in the middle of that 12 hours also, because all the talks are going to be available in viteconf.org afterwards. So like, don't worry if you miss something. But yeah, like we hope that you enjoy.
Please take care of yourself. Be healthy. Like, don't worry about missing something. They're all going to be available later. Is there a Twitter hashtag or tag that we should be sharing this with?
Yeah, like we could share like hashtag ViteConf, then like to share, or like tag ViteConf also.
Yeah.
We are going to be sharing from the ViteConf Twitter also things that are happening and the community. I know that there were some groups that are going to watch it live together. Some people already
fun.
are like, so
like watch parties.
Yes, if you're in one of them, like we say hi from here. And yeah, like if you go to ViteConf.org.live, you're going to see the code of conduct. You're going to also get a link to the Discord. And there is going to be in Discord a channel that is ViteConf to just chat with the community, and a forum channel that has one post for each talk. And this is going to order. It works as a schedule too in Discord. And we can talk with each of the speaker and the community in each of these posts.
Yeah, so each one has their own little place so you can have your conversations. And I think some of the speakers are even going to be available to have some conversations in there as well.
Yeah, totally. We are all going to try to be there.
That is incredible. I am so excited to be involved in this, and just make sure that you're sharing that link with everyone, that viteconf.org/live. Go share that on Twitter, tag ViteConf, hashtag ViteConf, all the things. And we're so excited for everyone to be here and to be with us.
Yeah. And yeah, well, maybe we should talk a little bit about the structure of the conference moving forward. So if you go to /schedule, or there in the live, the /live, you're going to see the schedule below the stream. Mm-hmm. And you're going to see that there are sections. So you can choose what is more interesting to you and like watch later some things. And we are going to start live first with Eric Simmons, the CEO of StackBlitz, that is going to introduce Evan Yu for a live keynote. And from there, we have like talks from Anthony Fu. We have the Rollup team is represented. Lukas is going to give us a talk, so don't miss that one. And there, like, check the sections. Like you have like custom frameworks. You have like the StackBlitz keynote. They are going to do some big announcement. I saw some things that I don't want to talk about them, but please don't miss it. And yeah, then the design and monorepos, like also the Storybook talk will be there with other alternatives. And PMPM is also represented, and NX. There is so many projects and so much content for today.
There's so many good things.
Yeah. And then we have the VitePress is going to have like a deep dive. And then we have like one of the main sections of the talks that are the frameworks building on top of Vite. So there are two sections. They are separated just because there were like too many. They are like
so many.
Yeah, they're like 10 talks that are related to frameworks building on top of Vite. Wow. So these are like separated in two sections. You can check them out. And after the first section and a small Tory talk, we are going to have the first live panel. These are hosted by Labs. Thanks a lot also to Lab for being there. Like Trace Lee and the team are going to like help us. The first one is about frameworks. This is quite exciting. There is like represented from like a lot of frameworks.
There are, yeah.
Yeah, I don't know if you saw the names
in there. I did, yeah. There's some big names in there. That's going to be an exciting talk. I'm very excited to listen in on that one.
Yeah, really looking forward to it too. So yeah, tune in for that discussion. And we then have like hosting on the edge. We have like environments, like we're going to see Van plus Vite and Dino plus Vite. It's quite exciting.
Yes, that is like all the new things.
Yeah, and then the backend section with Vite Ruby and Laravel, and yeah, testing also. There's so many. It's going to be a long day. It's going to be a really fun day.
I know. And then it looks like we have our second framework section. So we had the first framework section in the first block, and then the second framework section down in the second block.
Yeah. And then we arrive to the end of the first half of the conference. That is with again getting back to Vite, We are going to have some talks about contributing to Vite Core. So if you are interested in contributing, like, we are a very welcoming community, and so get involved, and that will be great talks to watch for that. And we have the final live panel again with Evan and the rest of the team. This is interesting because Evan will be live before going to sleep, and then it will be live when waking up for the
I think that is
panel.
Crazy. But it's so nice that we're making this a global experience, right? You're playing at the 12 hours back so everyone can experience something and have conversations with people along the way. Yeah. We hope it, let's hope it works for everybody. And if you're seeing this in the second half, actually, like, welcome from other parts of the world. And absolutely,
this is interesting because even if the live panels there will not be live, we are still going to be live in Discord watching the whole thing. So, and the speakers will also be there. There are some speakers that already told me, because they are in Europe or in Asia, and they told me that they are going to be for their second talk and not available in the first one. So the whole event will have a lot of live content. So be around, and don't worry, you're not going to miss anything because you didn't saw the first part. Yeah. So stick around, and if you're up for parts of both too, you might be able to experience two different sides of the world there. Yeah. And I don't know, should we start? Should we go? Did we miss anything? I don't know, like, if we miss anything, like, people should contact us there in Discord. Absolutely. Look for those moderators if you need anything. Go and get in the Discord, start chatting, start having those conversations. Yeah. Thanks again, everybody. Like, it's just a dream. It's amazing to be here today. Let's enjoy. Thanks. Thanks.
Good morning or good evening, depending on where you're tuning in from. I'm Eric Simons. I'm the co-founder and CEO of StackBlitz. And StackBlitz is the one hosting the ViteConf conference this year. And we're really excited to have you all be a part of it. And StackBlitz has been involved in the Vite community for just over a year now. And we originally were drawn in because of, all the things I think we all love about Vite. It's incredibly fast. It's just simple and a delight to use. But what was really special, too, from our perspective about Vite was the ecosystem and community and the way in which the maintainers of Vite had built Vite and were really encouraging collaboration between all the major frameworks. For the past decade, most frameworks were building their own tooling and there's not a lot of collaboration happening. But Vite has just been an incredible boon for the web ecosystem, because it allows all of these frameworks to collaborate together and bring everyone together. And that's why we put on ViteConf is, we saw all the amazing work happening in the Vite ecosystem, and we wanted to give a spotlight to all the amazing folks doing great work in the web development world. And so to kick things off, I first want to give a huge shout out to all the maintainers that have built frameworks on Vite, all the work that they've done on that and all the projects that are using Vite. And also too, the speakers that are going to be giving talks today have spent a ton of time and effort making them insanely great. There's an incredible lineup of talks happening here today. And third, I wanted to give a shout out to all of you tuning in. Over 20,000 developers are going to be attending ViteConf, the first ever ViteConf. As far as I know, it's one of the, if not the biggest turnout ever for the first version of a conference. So we're really excited to have you all here. And I think I'm very excited about some of the stuff that StackBlitz is going to be announcing. They've been working with the Vite core team on in a couple of hours here, so tune in for that. But without further ado, I want to hand it over to the first speaker, the original creator of Vite, who spawned all of this, Evan Yu. I think you're on the line. How are you doing?
Hello. Hey, great. Doing great here.
Heck yeah. I'm excited to hear your talk. I believe you're going to be talking about the origins of Vite, yeah?
Exactly. Yeah. So I think I've talked about this in different few occasions, maybe podcasts, but never in the form of a talk. So I think it's a good opportunity to sort of go through how it all started and some of the reasons, some of the thinking behind it, some interesting little things maybe nobody know about. So
awesome. Well, I'm excited to listen in. So without further ado, I'll hand it over to you and you can get things kicked off here.
Thank you. All right. So should I share my screen? I guess let's do this. So first of all, welcome everyone, and thank you all for being here. I'm super excited, and and before getting started, I'm Evan Yeo, the original author of Vite and Vue. So similar to how I started on Vue, I really had no idea that Vite would grow into something that deserves a whole conference about it. And seeing such a great and vibrant community forming around it, it's truly amazing. That's the magic of open source. I'm super proud to see there are so many participants from all across the web development world, not just from the Vue community, but also from all these other frameworks. So for me, Vite has really grown out of the original Vue ecosystem that I intended to be, and I'm super happy that it is able to become what it is today. So to many people who are just getting onto Vite, Vite may still feel like a new and shiny toy. But what you probably don't know is it's actually already 2.5 years old. So in this talk, I'm going to share some history on its origins. But before we talk about its origins, one may ask the question, what is Vite? What was the original idea that made you start working on it? Many people have asked me that question, and I've always found it a little difficult to explain concisely. Our tagline on the docs is next generation front-end tooling, which actually doesn't say much to non-front-end developers. In fact, that was a whole thread on Hacker News complaining about it. So on one hand, this is because the term front-end tooling carries a lot of historical burden. You need to know how front-end has evolved over the years to understand what kind of problems we're dealing with and why we need to build toolings in the first place. On the other hand, Vite's own scope, its mission or its intended use case has also evolved and changed quite a bit over time, right? So let's go back to the pre-build tool days and think about how we wrote web pages before there were any sort of tooling involved, right? The only way for us to include JavaScript on the page is by using a script tag. And all these JavaScript are implicitly evaluated in the shared global scope. So the default way of working was just writing everything in a single big file. So when the app gets more complex, a single file obviously gets unwieldy. So we start breaking things up into smaller files. But JavaScript didn't have modules back then. So all these files still implicitly share the same global scope. And sometimes we would do things like IFE, immediately invoked function expressions. This is kind of like an inline scope, so kind of like a module, but we still have to communicate through the global scope, attaching things to window. And if you look at some of the source code of early day libraries, we actually use very simple scripts to concatenate a lot of these IFEs together, which is why you would see that semicolon in the front to just avoid two concatenated IFEs being considered calling the previous expression. Right? So, and then early frameworks like Dojo and YUI started implementing their own runtime module loaders. There was an attempt to standardize this into AMD, which stands for Asynchronous Module Definition. Some of you might have used this before, and Require.js was the runtime loader for AMD. So it's actually interesting to look back from today because Require.js was loading and transforming modules on the fly during development. You can actually write plugins to transpile code on the fly. And it also provided a optimized tool, essentially the build command, to build the project for production. And it was written with Node.js 0.4 or something. So this was actually really cool because it sounds quite like how Vite works today, right? The big difference here is that Require.js is still largely a runtime tool, right? All the transformation actually happens in the browser side. So it greatly limits what kind of transforms we can do to our code. And the difference between the optimization tool and the runtime behavior is still quite stark, because some of the things is just impractical to do when you in the browser when you ship it to production, right? So then Node.js came along and blew up, and CommonJS became the de facto standard for JavaScript modules. And the effect still lingers today. You still see a lot of libraries only shipping CommonJS or UMD. And people started wanting to use Node.js packages in the browser. And they also want to use the same module format for both the browser and Node.js code, right? They want to use CommonJS everywhere. So people invented module bundlers like Browserify and Webpack. They took our CommonJS modules and combined them into a single bundle, which then gets included on the actual page via script tags. So these build tools also provided powerful plugging and loader mechanisms. And I was just started working on Vue back then in 2013, and that was super early. And later on, I had this idea of single file components, a format that defines a component with its template script and style in a single file. You're probably familiar with this if you've used Vue or Svelte. I realized it was possible to write loaders that transform this format into plain JavaScript, right? And that also the cost of the compilation would be at build time only. It won't affect the runtime performance. It won't affect the performance in production. So I wrote the Vue single file component transforms for both Browserify and Webpack. So for Browserify, it was called Vueify, and for Webpack, it's called VueLoader. This worked quite well for early adopters. So I created the Git templates. So essentially just 2 Git repos. People have to clone them, then install the dependencies locally, tweak the configuration to their liking, then eventually they get a project working. So this worked great for early adopters, people who are okay with just adopting new tools, figuring out how to configure bundlers themselves. But it was a bit too low level for the general developers, because when we had more and more beginners starting to trying to adopt Vue, we realized, okay, they are not interested in learning how to configure these bundlers or build tools. And what they cared about is to have a convention, to have a starter point, to get things going quickly. So in 2015, I created Vue CLI, which is a higher level toolchain dedicated for Vue, built on top of Webpack. It does many things we consider standard today. For example, pre-configured, which means most common features one would need should work out of the box, like what you would expect from Vite today, right? So, but in order to get that kind of configuration working on top of plain Webpack is in fact a lot of work. And making sure all these different options, like whether you're using TypeScript and whether you're using which test runner you're using, and making sure all these different combinations of options that can work together, and no matter what options you've chosen, was in fact a lot of work. It also came with a dev server with hot module replacement, build command with automatic optimizations. It also included the modern mode, which Vite kind of serves. When you use Vite plugin legacy with Vite today, you get the legacy mode. Back then in Vue CLI, it was called modern mode, where it shipped ESM by default and then falls back to a non-ESM bundle format by using runtime native module support detection. So outside of Vue CLI, we also saw Create React app, which served a similar role for React, and also worth mentioning is Parcel, which was the first build tool to pioneer the zero configuration concept. So around this time, we were starting to see a set of framework agnostic conventions that's sort of convergent, which we still see today in Vite, right? For example, how to import and handle CSS, how you expect assets to work, how you would combine ship your static assets with a index HTML template. So a lot of the things that we're familiar with in these early generation tools, we see them essentially working out of the box in Vite today. And then with ES 2015, finally, JavaScript got its own standardized module system. So this started a somewhat challenging transition period, moving from the AMD, UMD, CommonJS, a very fragmented system, trying to converge towards ESM, but this has been quite of a painful period so far, right? Which we're technically still in today. We're still not quite fully there yet, but that's out of the scope of this talk. In some way, Vite is an effort to help the ecosystem move forward and converge on ESM. And we've dealt with a lot of bugs related to these module formats along the way. Anyway, the implication of ES modules is that we started to see tools that were designed with ES modules first. For example, Rollup. So Rollup was the first bundler that was designed with the premise of serving ES module as the only standard module format, where CommonJS handling is actually added on via a plugin as an additional feature. Right? So Rollup being ES module first allowed its core to be simpler and more efficient. It also unlocked capabilities like tree shaking, thanks to the static analysis friendliness of the design of ES modules. But the ecosystem was so heavily invested in Webpack, and due to the lack of support for hot module replacement for Rollup, right, we didn't really see a higher level app solution built on top of Rollup going mainstream. Most of the mainstream solutions you see, Next.js, Create React App, Vue.ci was mostly still Webpack based because users are so reliant on hot module replacement, and the way that Webpack was essentially able to handle any module format, even some of the modules were just shipped incorrectly with mixed formats. Webpack was still able to handle them. So most users use Rollup mostly for custom setups or bundling libraries. So in 2017, we finally saw native ES modules in the browser. And so this means we can now use ES modules natively without the need of a build step. At this time, the community also started to acknowledge the pain of ever-growing size of node modules. We're realizing, okay, maybe some of the tools that we built were too heavy. Some of the tools we built could be faster. It was because maybe we just got used to the slowness of it. Maybe there could be ways of making it faster. But at the same time, if we go with native ES modules and go buildless, but we're still used to a lot of the things that were enabled only because of build tools. For example, we want to use single file components. We want to transpile TypeScript. We want to use JSX, PostCSS, all the good stuff that we need a build step to deal with, right? So what if native VSM had a transform API? That was the question that I was asking. Well, and soon I realized maybe it didn't need to, since native ES modules are fetched over HTTP requests. So we can let a dev server perform whatever transform needed on the fly. And that dev server would feel quite similar to just a static file server, if you think about it. A static file server just reads a file and sends it as is, where a smarter dev server would read a TypeScript file, notice that it isn't actually JavaScript, so it just transforms it to JavaScript before serving it, right? So this could totally work. So as I was searching for a lighter alternative for Speed CLI myself, because I was sometimes fed up with the slowness and heaviness of the toolchain, I started experimenting with this idea. So in March 2019, I created a proof of concept dev server that was able to transform and load Vue single file components over native ES module imports. However, there were two major problems that I didn't quite solve back then. So the first is how to handle NPM dependencies. And the second is how to perform hot module replacement over native ES modules. I was also busy working on Vue 3 at the time, so I didn't really continue this POC. It was until a year later, as I was going to bed, I suddenly had this epiphany of how to perform hot module replacement over native ESM. I can't remember exactly why I came up with the idea. Maybe because making that POC work has always been at the back of my head. But once I had the idea, I just had to test it out. So I started hacking on it and working until 6 a.m. in the morning and got another proof of concept working. This time it was the actual start of Vite. So this time I got a dev server that was able to transform a Vue single file component on the fly and also handle hot module replacement over native ESM. So the very first release came out the next day with a very crude hard-coded logic that supported only Vue components, right? The initial intention was for it to be a lightweight Vue CLI alternative. So the next step was to move from proof of concept to a more serious structure. So I did some research and found out about Web Dev Server, which was also a bundleless dev server. I think it was called ES Dev Server back then. Which is now called @web/dev server. So since my main interest was in making hot module replacement work over native ESM, I actually considered making Vite just a middleware for ES Dev Server after I saw it. But looking deeper into it, I also had the vision for Vite to be a higher level out-of-the-box experience like Vue CLI and Parcel in some way. So making it a middleware of only a dev server just seemed too limiting overall. So I ended up using a Koa-based server setup, which was inspired by ES Dev Server. And the initial implementation was that each plugin would be implemented as a Koa middleware. So the Vue transform logic, the Vue plugin would be a middleware, Koa middleware. So 2 days later, I got the hot module replacement also working for plain.js, which was important because hot module replacement only for Vue components obviously isn't going to be super useful. We also need to handle generic JavaScript logic. And in addition, for handling NPM dependencies, I opted to use Snowpack version 1, so which is now known as ES install. So version 1 of Snowpack was in fact a pre-configured rollup tool that is able to convert NPM packages, no matter what format it is in, into ES modules that could run in the browser. So this solved the problem because the biggest problem is that we have this very fragmented module system where some modules are in UMD, some in CommonJS, some in ESM. Right? So we need to normalize them into the same ESM format that can run in the browser, and Snowpack V1 served that purpose. So, and then in 0.5, I was able to land a Rollup-powered Vite build. I decided to still use a bundler for production because unbundled deployment is still tricky to get right. We explained this in the docs. I also use Rollup instead of Webpack because Rollup is more ESM first, so it aligns much better with Vite. In fact, back then, I believe Webpack was still not able to output direct ES modules. So from the other perspective, Vite also kind of started to becoming this hot replacement dev server for Rollup, right? So it becomes a complementary relationship. So now at this point, most of the major questions have been answered, but I also wanted to validate whether Vite's plugin and API design is flexible enough to power even higher solutions, especially in the scenario of server-side rendering. What if people want to build meta frameworks on top of it, right? So in the Vue ecosystem, we had a static site generator called VitePress, which many users liked. It allows you to write file-based routing with markup files, and you can embed Vue components in it, and it just generates documentation for you. It uses Vue's server-side rendering capabilities, so it parses Markdown into a Vue component, then compiles it as a Vue component, and then run it during SSR to generate the static HTML. However, VitePress was Webpack-based, and in larger projects, it could take a very long time to start the dev server. And a single edit could take seconds to be reflected with hot module replacement. So I wanted to see, with a similar system, but based on Vue, how much improvement we can get in terms of DX. So I created VitePress, a Vite-powered static site generator. This was developed in parallel with Vite itself. So you can see the date is like a few days after a 0.5 release of Vite. And today it powers the documentation for both Vite and Vue.js themselves. So the important role of VitePress during this whole process is that it served as an experiment field for server rendering, API design, and some of the internal API changes, including the plugin API design in the early versions of Vite. So as I was working on VitePress, I have a firsthand experience of, okay, this is what I need if I were building a higher level tool on top of Vite. So it also allows me to think about the right level of abstraction. Should I expose? So how much should I expose? If you expose too much, you risk making the usage super verbose and complex. But if you don't expose enough, then you won't be able to build actually something useful, right? So finding the balance, in order to find the balance, I had to build something myself on top of Vite to find out. So what followed was the long grind to reach 1.0. I was aiming for feature parity with Vue CLI, and we were also getting more users. And with more users, we got a lot more bugs. Most of the bugs were related to mixed module formats with NPM dependencies, the optimizer having issues, and a lot of small bugs fixed along the way. So between April and November 2020, I shipped 91 releases, all the way up to 1.0 RC9, but Vite 1.0 never actually landed. So the reason for that was because as I worked towards 1.0, I realized Vite can be much more than just a replacement of Vue CLI. It could be two things. First is that it could be a framework agnostic minimal config build tool for end users. Something like, so this was essentially a more generic Vue CLI. The goal was so that each framework should be able to encapsulate this framework specific logic in a single plugin. And then you would, most of the other common share features should just work out of the box for end users. The second is a shared tooling layer for framework authors so that people working on Nuxt or SvelteKit or maybe the Next.js could be able to leverage some of the work we've done in Vite so that they don't need to reinvent the wheels, so that we can focus on the differentiating features that we focus on the innovations instead of the reinventing the same wheels over and over again. So I decided to rewrite Vite completely in order to fulfill these goals. So Vite 2 was complete rewrite, started in December 2020. Some of the main goals were, first, we want to go framework agnostic. We opted for a universal Rollup compatible plugin API inspired by HTMR, which is created by Jason Miller, the author of Preact. We also adopted a new SSR runtime, which was inspired by SvelteKit and first appeared. So Rich Harris created this in early SvelteKit, and then Fred ported to Snowpack, and then we ported to Vite. And we also switched to an ES-Build powered dependency pre-bundling system, which made the whole dependency handling 100 times faster. And finally, in February 16th, we shipped to Vite 2. So that was so December 7th to February 16th, a bit over 3 months. So I think the rewrite was relatively fast because we already learned a lot. We fixed a lot of things on the way to 1.0. And I got enough time to also think along the way of how to restructure things better for Vite 2. So after Vite 2 released, which was technically the actual 1.0, right? I plan to move some of the focus back to Vue because I put so much time into Vite while working on towards 1.0 and 2.0. So I need to give some love back to Vue after it's shipped. I also want to make sure Vite can be properly maintained, even if I split time between the two projects. So I knew it could only be possible if we have a team. So I did, and I created a discussion thread, nominated a few initial team members, and today, the majority of daily maintenance is performed by our team members. And the team with our latest 3.0 major release, mainly driven by team efforts. I would like to give a big shout out to the team, in particular Matias, who have been doing a phenomenal job in pushing Vite forward. I'm also very, very grateful to the incredible community that has formed around Vite. We're seeing many frameworks authors actively collaborating with Vite, providing feedback and sharing ideas on how Vite can better serve as a common tooling layer. It is truly amazing and inspiring to see so many exciting new directions being explored by Vite-powered projects. And I am honored to have you all here sharing insights at this conference. So I hope you enjoy the rest of the talks. Thank you.
Awesome. That was a great talk. I've kind of been glued to my screen, just kind of watching this entire time. Thanks for giving us the history of how Vite came to be, Evan. That was really well done. Awesome. All right. And we got some great talks coming up. Next, we got Matias, also from the Vite core team, who's going to be talking about the Vite ecosystem and the different projects that are a part of it and how everyone's collaborating. We've got Anthony, who's going to be talking about Vite On-Demand DX, which is going to be great. And also Lukas from the Rollup team, which I think I just saw you teased maybe a little hint of a special announcement or something in his talk. So without further ado, we'll go ahead and kick it over and get the next talk started here.
Welcome to the Vite ecosystem, a story about collaboration. I'm Matias Capeletto, also known as Patak. I am part of the Vite core team and I work at the StackBlitz, where I get to spend my time focusing on Vite. I'm very happy to be at ViteConf today. We're going to hear about a lot of project names and concepts in this talk. Don't worry if you don't understand them all. Let's try to focus on the big picture of what it means to be part of an ecosystem and the relationship between the projects. Also, behind each of the logos, there is a lot of people involved. This story is about them. Vite isn't developed in isolation. It is actually part of a universe of interconnected communities. And the ViteConf stage today is a great example of that. You're going to hear talks from the maintainers of most of the projects we're going to check here. So stay tuned if you want to learn more about them. Vite is part of a tradition of JS tools in the JS ecosystem. Webpack was developed at a time where modules weren't even supported on the browser. The Webpack team had to overcome a lot of complexity. They also needed a very flexible tool because a lot of the patterns and conventions that we now give for granted weren't there yet. The Rollup team made huge advancement in tree shaking and also developed an intuitive and flexible plugin API to extend it. Parcel popularized the idea of the index HTML at the center of your application, and also of sane defaults and zero config wherever possible. There is a new breed of tools written in native language. For example, SWC, that is a Rust alternative to Babel, or ESBuild, a Go bundler for JS that also supports TypeScript and JSX. These native tools achieve speeds that were impossible on JS land. Vite is part of a new wave of tools that during development don't bundle at all. We use the module support in modern browsers to fire up a dev server that transpiles modules on the fly, serving them to the browser. And we can achieve instant feedback because we can have code module replacement at the module level. Web dev server, Snowpack, WMR, they are all part of this wave of tools, and they heavily influence each other. For example, WMR was the first to introduce the idea of a universal Rollup-like plugin API that works both in dev and build at the same time, that later on Vite adopted. Vite is an abstraction over other tools in the ecosystem. During build time, you can think about it as an opinionated setup for Rollup. We use ESBuild wherever we can to speed up processing, for example, minification of CSS and JS, or stripping types. And we take a pragmatic approach. We don't need Babel in all cases, but for plugin legacy to support older browsers, we reach out to it. We also use PostCSS to process CSS internally and also to better align with CSS standards. When using Vite, you are guarding yourself against changes in the ecosystem. For example, we could change Babel to SWC in the future. And the Parcel team has now released Lighting CSS, that is a Rust alternative to PostCSS. We could also adopt it to speed up CSS processing. And right now we are very happy with ESBuild, but if the ecosystem moves towards SWC, we may end up also replacing ESBuild internally. And all of this can be done with little disruption for users. And I don't know if this is going to be the tools we will use in the future, but you either. So vetting in Vite actually, again, help you guard against these changes. Vite has great support for Vue, React, Preact, Svelte, Lead, Solid, and many others UI frameworks. Actually, the teams from these frameworks are involved in the development of Vite core. And we have really good hot model replacement for all of them. This allows tools like Astro to build on top of Vite and focus on new features or explore new architectures like Islands architecture. Astro doesn't need to re-implement everything that is already done in Vite by the frameworks and the maintainers of Vite core. The same goes for Storybook, that actually imagine if a Storybook will have to recreate everything that has been done by these frameworks. And we get to share at a lower level because the Rollup-based plugin API is very flexible. So we can have, for example, Vite plugin PWA to abstract the support for PWA in our frameworks, or a plugin to add Partytown to speed up third-party scripts, or a plugin for CSS. And there is also a lot of innovation in SSR frameworks. On the Vue side, we have Nuxt that in its third version has adopted Vite by default. But it was really interesting because they actually created an abstraction that lets users choose Webpack or Vite. And in the process, they created a set of libraries under the AnJS umbrella that others can later use to achieve the same. On the React side, we have Hydrogen, that is a framework developed by Shopify for e-commerce. And they are working with the React team to ensure that React server components work properly on Vite. On the Svelte side, they are working on SvelteKit. And SvelteKit is quite important because the SSR primitives that we all enjoy right now were originally developed as part of SvelteKit when it was using Snowpack. And on the Solid side, we have Solid Start and so many more. VitePress is a static size generator based on Vue and Vite that we use in a lot of documentations in the ecosystem. QuickCity from the Quick team, and Analog that is an Angular and Vite framework. Also Astro, we say, and many more. Isles, FastifyDX, Vite plugin SSR, Rakas, and Vite disappears from the picture. A lot of users are going to experience Vite through a framework. Most of them, actually. But all these frameworks get to collaborate together into improving the shared tool. So this is a non-zero sum game. Everybody gets a better tool. Vite also had a big impact on testing. Playwright and Cypress has adopted Vite for their new features of component testing. And Vitest is a native Vite alternative to Jest. And it actually deserves an ecosystem talk of its own. It's seen a huge amount of adoption, and it's going to be probably one of the main drivers of adoption of Vite moving forward. You can use it also to test Node, and for example, the Remix folks are using Vitest in their starters, but they are not using Vite. And Vitest get to enjoy the fast hot module replacement on Vite for your unit tests. So you get this instant feedback that we have while developing now while you check your tests. And we are in the dawn of a new era of JS environments. Node.js is no longer alone. You have other environments like Deno or Ban and web containers from StackBlitz that let you run Node.js in the browser, or Cloudflare workers and other edge networks. And all of these environments care a lot about proper Vite support because of the rich ecosystem of frameworks that we saw before. If they get Vite working on them, they are going to get a lot of users. So there is a lot of collaboration between Vite and these environments and these teams. We also need to deploy our applications. And for that, we need the services to have out-of-the-box support for our build tools. And we are seeing this already with Vite. Netlify, Vercel, Cloudflare Workers, Firebase, AWS Amplify, Deno, and others care a lot about giving a good user story for Vite. For example, Netlify has created a plugin, a Vite plugin, so frameworks can use their edge network in an easier way. Vite is also seeing a lot of adoption on backend frameworks, pioneered by Vite Ruby, that show that you can use Vite to get instant feedback while developing Rails applications. This paved the way for Laravel, now adopted Vite as their default. And this is huge for Vite adoption moving forward. Let's focus on one of the sub-ecosystems, the stories ecosystem. We have to give a lot of credit to a Storybook here, because they created an open standard for stories that is benefiting like this ecosystem. Vite lowered the barrier for creating a new Storybook-like framework. So we are seeing frameworks like Histoire, ViteBook, Ladle, and they all get to try new ideas. We are also seeing Preview.js and Volar that are VS Code extensions, but they use Vite internally to preview components in real time where you develop, kind of like inline stories. And also Y-frame that gives primitive to build your own storybook. And this has a lot of benefits for a storybook itself, because a storybook gets to see what others are doing and what works and not, and they can later adopt it. Storybook is also using Vite a lot now. And Vite also has bridges to other communities that are not directly downstream or upstream projects. For example, there is a lot of usage of PMPM on Vite-related projects. And there is a lot of alignment in the values of PMPM. Like PMPM is a very fast and efficient package manager. Also, Tori that lets you create desktop applications that are very small and efficient and secure. They are also using Vite internally. So it makes sense to collaborate with them. StackBlitz, for the playground feature, they need their applications to start right away. And the on-demand nature of the Vite dev server is amazing for that use case, because you get in a split second a playground working. So we are seeing a lot of adoption of Vite, for example, in documentation, playgrounds, and examples powered by StackBlitz, so you can open them in your browser. And again, Vite isn't developed in isolation. Vite is part of a huge ecosystem of tools and frameworks and plugins, and all these projects work together to collaborate and share ideas and patterns. We actually didn't scratch the surface of how rich all this ecosystem is. And again, this is about people working together, helping each other. And this is really difficult to replicate. An ecosystem is one of the best assets of an open source project. So again, this stage of ViteConf is really important for us at this moment. We have worked together during all this time, and I'm eager to see all the maintainers show how they are using Vite and what new ideas they bring to the table. And I hope we can continue to collaborate and share patterns and ideas and code and create something that is bigger than each of our projects. I want to thank a lot the Vite team and contributors, also the maintainers of plugins and frameworks and tools, the communities that are helping each other constantly, and also the ViteConf speakers and collaborators. I know how much effort they put in all the talks, and the StackBlitz team and community partner for making ViteConf possible. This is really a dream come true. And enjoy a lot the rest of the conference, and see you in Discord, and we are going to discuss all the talks there.
I'm so happy we finally have the first ever ViteConf. So today I would like to talk about Vite, the on-demand developer experience. It's about how Vite becomes great using the mindset of on-demand. My name is Anthony Fu and I'm a core team member of Vite, Vue, and Nux. I'm also a creator of VitePress, Vueuse, Uno CSS, Slide Div, and Unplugin. I'm currently working at Nux Labs in the framework team. And if you prefer visually, these are their icons. So you can find me on GitHub at ANTFU or Twitter at MTFU7. So before we dive into on-demand, let's first see what the heck the on-demand is. So this was my childhood. Back at that times, let's say when I want to watch a movie, I need to download the whole files in order to play it. It's not really taking 39 years to download, but indeed it could take a few hours. And it could be a nightmare if I want to pick a good ones out of a dozen of movies. So nowadays, thanks for the on-demand streaming service like YouTube or Netflix, our lives becomes much easier. So if I have to give a definition to on-demand, I would say, provide what you need upon the request. Compared to the traditional all-at-once approach, I think on-demand is offering a few pros. The first is efficient, is that you only load the parts you need. And the second one is responsive and customizable. For example, if you are watching a same movies on two different devices, the one on your phone will get lower resolution streams than your desktop since it has a smaller screen to consume. That would make things more efficient. And then we could find that the web itself is actually also on demand. That makes the total sense for a build tool to also doing so. But things are not perfect. Indeed, it comes with some cons. The first is overhead like network, request water flows, etc. For example, in a very poor network connection, it will be a terrible experience to watch your YouTube videos online, right? And the second one is the complexity. It requires actual work to implement and maintain the functionality of on-demand. Since there is no silver bullet, let's see how Vite made those trade-offs. We are talking about on-demand in a few different aspects. The first and probably the most well-known one is that Vite is on-demand on processing. Vite only transpile the modules you need for the request pages, or so-called bundle lists. This allows Vite to keep fast as your project grows. And the second one, I would like to call it on-demand on strategies. We actually have different needs on development and production. In development, we are changing our code constantly, and having a good feedback loop will be important to see the changes, and that will be developer experience. And in production, we are more focusing on the runtime performance and the size of the bundle, and that will be user experience. So Vite provides two different modes, dev and build, to provide the best to the both worlds. So in development, Vite is offering bundle lists, hot module replacement, and the dev server to make those things happen on demand. On the other hand, in productions, Vite is actually using Rollup to bundle the app and providing optimizations like tree shaking, code splitting, and minification. On top of that, even though there are two different strategies, we still make it consistent by providing a shared configurations and plugin system. By taking it further, we could have on-demand on optimization. If Vite could provide different strategies on different targets, we could actually have more fine-grained strategies on different type of files. We could separate the project code into user code and the node modules you installed from the third party. So Vite made the assumptions is that the user code will be changed frequently while the node modules will be only changed once a while. Taking that assumption, Vite serves user code per module as bundle list, while pre-bundling the node modules into a single file that browser could consume more efficiently. And Vite injecting the code for hot module replacement for user code while skipping it in node modules. And finally, the bonus of on-demand, the customizability. Vite is using adapt servers in development. That means plugins could use it to do some client-server communication. For example, here are the pages provided by Vite plugin inspect, an inspector of Vite internal transformation. Here we could see a view file is being transformed by a few plugins, and you can see each step of the plugin being transformed. And here the view single file component is being transferred into JavaScript, and the import analyze changes the import statements into a browser compatible path. And the slides you are looking at is actually powered by SlideDiv, which is on top of Vite. By using the client-server communication, it allows you to directly write back to the file system inside a page. For example, I can open up the built-in editor of SlideDiv, and I can say that change the title into orange. And you can see that the change is being reflected instantly. So since Vite providing a lot of things on demand, I would like to encourage plugin authors to also build integrations with on-demand in mind. For example, in Nuxt, we are building a full-stack framework for Vue, and indeed we need server-side rendering. Since Node.js cannot directly understand our source code authoring in TypeScript or Vue SFC, the traditional approach is that we bundle our app into plain JavaScript for Node.js to execute and render. The problem is that in development time server-side renderings, our source code changes frequently, and that means we have to rebuild the entire bundles and re-execute it on every single changes we made. And that would be very inefficient in on-demand systems that like Vite. So we better figure out a better way to do that. In Act 3, we implement the on-demand server-side rendering for Vite by introducing a new Vite runtime called ViteNode. Instead of bundling the entire app, ViteNode directly uses the transform result from the Vite server and execute them on demand. It also makes it possible for hot module replacement by only re-executing the changed modules. This results Nuxt to have 10 to 50 times faster performance on development, depending on the scale of the project. About the technical details of this, you can refer to my blog post as the link below. And finally, let's do a brief introduction to ViteNode. ViteNode is a Node.js runtime powered by Vite pipeline. It provides on-demand evaluations, and it could reuse Vite configurations, plugins, etc. to be consistent with your client app. Inherent from Vite, it also has out-of-box ESM and TypeScript support. It also has a watch mode with hot module replacement similar to Node mode. And for programmatically usage, it has separate server-client architecture so that you can execute the code from the other thread or even another process. ViteNode is now powering Nuxt 3's development time server-side rendering, and also make Vitess, the testing framework on Vite, possible. It also powers Histoire, the Storybook alternative on Vite, and Vue Terminal UI, the terminal UIs for Vue. To demo about how Vite make Nuxt possible, I would highly recommend you to watch the upcoming talk by Daniel. And for Vite, you definitely don't want to miss the talk by Vladimir, one of the core team members of Vitess. And that's it for today. Finally, I would like to thank for all my sponsors for supporting my work. And if you enjoy my works as well, you can consider sponsoring me at GitHub to help me keep them sustainable. The slides of my talk can be found on my website ntfu.me. Thank you, and see you next time.
and thank you very much. My name is Lukas Taegert-Atkinson, and I'm speaking on behalf of Rollup.js. So I think it is fair to say that Rollup is one of the foundations that Vite is built upon. And when I was invited, there was at least one person who expected me to shed a little more light on this relationship. And yes, I will talk about that a bit later. First, I want to talk about something else entirely, but bear with me, it will be relevant for Vite as well. What I want to talk about is a very old Rollup bug that we had for quite some time, and it is this one. Chunk hashes should be based on the output. It's from May 2019. As you see, it's still open, and yes, it is kind of critical. It is critical enough so that one well-known Google developer advocate was really making a great case that Rollup's plugin system is superior to the alternatives, was citing it as the most important issue he found with Rollup. Hashing happens at the wrong time, which can lead to bad caching. And what is this all about? So to understand that, you need to understand content-based file names. So the idea is that we use file names that have something that we call a hash of the content in its name, so that they are unique identifiers for their content. So in this example, I have a chunk that dynamically imports two other chunks. Now, if I were to change something in the upper right chunk, let's say we're logging something else, then this would mean the hash of that chunk would change. That means the import in the main chunk on the left would also change, which would also lead the hash of the main chunk to change. And that is it. So why is this important? Why do we want to do that? If we have file names as unique identifiers, we can configure our servers to use very long caching time, so that the browser cache retains the files basically indefinitely, and they don't need to be pulled again from the server. While we still have the ability to deploy at any time, because changing the content means changing the file name. With the advantage that in this example, the lower right chunk, which is unchanged, can still be taken from the cache. So this sounds kind of straightforward, but what happens if you have circular references, which is not too uncommon? So imagine you are using some routing solution, then usually the router will dynamically import other chunks when you change pages, while the other chunks all reference the router. So you have a circular reference between the router and all other chunks. So in my example, I'm just having dynamic imports between my two chunks. How do I create a hash for that when the content of the file would depend on the hash of the other file? One approach could be to say, okay, then we hash everything except the hash of the other file. And the way Rollup 2 does this is just hashing the original files with the original import targets in place. So in my examples, we are using emojis as hashes because it's kind of easier to see, and you don't have to memorize numbers and letters. And then what we do is we're basically creating a dependency graph of hashes. So in this example, we know that the apple chunk is kind of referencing the broccoli chunk. So the hash of the apple chunk should be apple plus broccoli is fish in my example, while the hash of the other chunk is broccoli plus apple, because it happens in the wrong order, in the reversed order, which say it's my squiddy hash. And then as a last step, we are replacing the imports again with the actual chunk names. Now these hashes are indeed very fishy. Why are they fishy? Because we want to have a minification step in our setup. And minification cannot happen before we change the imports, because after minification, we would not find the import again. Everything has moved around. We need to repass the entire file, and it's still maybe possible that stuff is missing or done in an entirely different way. So what happens is that Rollup runs the render chunk plugin hook after that, which changes the content, but it cannot change the hash. And now we have different files that have the same hash, which basically breaks all assumptions we have for content-based caching. So this algorithm is kind of easy to implement. It handles cycles, but one drawback was that we had the original file names in the content hashes, which is bad because if I rename the file, the output would not change, but the hash would change. And the big problem is that chunk transformations by plugins are not in a position to change hashes. So how can we solve this issue? Well, let's go back to the first step, because that's what we're doing in Rollup 3. So assume you have two chunks referring to each other. So I said, okay, we wanted to have a hash that contains everything but the chunk hash. And we wanted to run render chunk first. So what we're doing is we're replacing everything with placeholders. The placeholders have a number. The number corresponds to the chunk. So the left is kind of chunk 1 and the right one is chunk 2. Then we directly run the render chunk hook, which does its magic. So in this example, it just changes the logging, but it could be anything. It could even change the import or remove the import entirely. And because we don't make assumptions what render chunk does, the next step, we're just doing a full text search to find all placeholders in the output. So then we find our dependencies. So we see the chunk 1, except for the content of 1, it also depends on placeholder 2 and vice versa for the other chunk. Then to get a content hash, we replace all placeholders with a default placeholder because those numbers 1, 2, they aren't necessarily stable. They can kind of depend on some race conditions. So then we get a stable content only hash. And as a last step, we're now calculating the final hashes, which gives me a pear and an orange hash. And we solve the issue we originally had. So yes, we have very stable hashes that only depend on content. We can have arbitrary file transformations in render chunk that add imports, remove imports. And due to the nature of this, we now have a cool new feature in our render chunk hook, which will also benefit Vite plugins, which is we get the entire chunk graph available. So there's a new fourth parameter to render chunk, which basically contains a list of all chunks with their imports, exports, and how they're related. And now this is really cool. And we also got very good feedback from the Vite developers that it allows them to remove a lot of complexity from Vite. And this is good. It makes Vite happy. But the question is, so we didn't do this for Vite. We did this because this is a serious bug. But how is our relationship actually with Vite? And more precisely, how do we feel about Vite? And if you look from the surface, asking Andrew, maybe we were slightly overwhelmed by the success of Vite, which also put a lot of new issues for Rollup, especially for the plugins. But if you go a little deeper, there is more to it. And to understand this, the question is, why did Vite choose Rollup in the first place? So to my understanding, one key reason was the plugin system. So if you reuse an existing plugin system that solves your purpose, you get access to a broad range of plugins, which means that users will be much more likely to adopt your solution because they already have ways to adapt them to their needs. On the other hand, if you develop an entirely new plugin system, there will be no plugins except for a few main one, and then users will not go, and you also need the users to write new plugins. Another reason apparently was that Rollup output is slightly smaller, which is something that we pride upon. I still think that Rollup has one of the best tree shaking algorithms out there, maybe except for Clojure compiler, but I didn't look recently where they are. And we are constantly working to make that better. And we have apparently a more mature code splitting approach compared to ES build. So, and this is exactly where we wanted Rollup to be. Why did we want Rollup to be there? So a little more background going into my personal history. So Rollup was developed, as you may know, by Rich Harris. It was in 2015. And in 2017, I happened to create some pull requests to improve tree shaking for reasons because I was interested in the topic and looking into Rollup sources, I found some potential for improvement. And then I kind of became maintainer, which was like Rich saying, okay, this was very cool what you did here. Why not just merge your own stuff? Here are the access rights to the repository. And yes, after that point, he no longer merged my pull requests. So I gathered after 2 months, maybe I should merge my own pull requests. And then he also did no longer release anything. So I said, okay, maybe can you give me the publishing rights? And then I was basically maintainer. And that's history. I think it was good for Rich because he was already developing on Svelte at this time. But of course, being a maintainer means you have to make strategic decisions. Where should Rollup go? We do not have a large team. Most contributors are single-time contributors who want to have this feature or that feature. Guy Bedford was, for a longer time, a regular contributor. That was very nice. So the question is, what should we focus on? So one thing to focus on, I decided, should be core improvements. We don't want to expand Rollup scope lightly. We want to stick with the stuff that we already have. And if we add a new feature, then we will really want to be sure that this is a feature we are going to maintain for a long time. So code splitting was one new thing we added, and there are lots of small features we added, but they are more making the picture, completing the picture than really expanding into new areas. Another thing is we do not expose internal stuff. This is, for instance, in contrast to Webpack, which allows you to basically plug everything, which is kind of cool for hacking, but it means that you cannot just easily do a new release because every change, every internal change can now break something. You cannot rename stuff, you cannot improve stuff easily, and we didn't want to be there. So by default, internal stuff is closed in Rollup to allow us to remain agile. Another thing we wanted to focus in is configurability. So we make very few assumptions about what Rollup is used for, which means that Rollup is used for many niche use cases, which is very important to us. So for instance, you can run Rollup in a browser. You cannot do this with many other bundlers as far as I know. And we want to retain that ability. But most importantly, we have the plugin interface as a stable, well-documented, first-class API. What is missing on this list, maybe, is developer experience. And yes, developer experience is very important. It's also very important to us. But the thing is, if you want to focus on developer experience, you need to make assumptions about what Rollup is used for. And this kind of conflicts with some of the other goals here. Now, our hope was that maybe with the other decisions we made, third-party developers will step in and close that gap. And there was some success. So for instance, there was TSDX, which is a nice tool for zero config TypeScript library bundling, or similarly microbundle from Jason Miller. And there are many other tools like this. And one thing we're also very proud of is Stencil, which is a web component framework. They don't really advertise it, but Stencil is built very much around Rollup. It's doing the heavy lifting here, and you can find it if you dig deep in their documentation that basically Rollup is at its core. But what WMR and especially Vite were doing, this was beyond our wildest hopes. And of course, we support this. So how do you create a partnership? So we started including Vite and WMR developers early in plugin API extensions, asking for feedback, saying, okay, does this work for you? What do you want to do with this? But also, Vite was really expanding on the API, adding new features. And we started basically porting some of their extensions into Rollup. So one example is the order attribute for plugins hooks, which is kind of a replacement for enforce, because I think enforce is really solving an issue at the wrong level. But the main idea is that people should be able to write Rollup plugins instead of Vite plugins, unless they really need to target Vite. So this brings us to the future. Where do you want to go from here? Of course, the next step is Rollup 3. And there are more nice features here. One thing maybe I want to mention is per chunk banner footer intro outro. So there's an option that allows you to inject code at the top or bottom of each generated chunk. And with Rollup 3, you have now the ability to basically look into that chunk before you do that. And this is a really great way to add imports, exports, whatever, specialized logging, which will also automatically get source maps right, which is an important thing. So I really recommend looking into this if you need this. Otherwise, source map handling has been improved. Default values have been improved, especially around CommonJS interoperation. And also we separate the browser build, which basically cuts Rollup's install size to less than a half. And where do we want to go from here? So as I said, we want to keep focusing on our strengths. This is, of course, tree shaking and code optimization, and also code splitting. So one thing I promised really to work on next is to add an option to define a minimum chunk size target. This was requested by many people because apparently one issue is that you have a lot of very small chunks. And the solution I want to implement is to merge small chunks that do not have side effects into larger chunks with similar dependencies. Rollup already knows if a chunk has side effects, so the analysis is there. We just need to implement a nice algorithm to figure out how to do that so that you have very little overhead from this. And another question, of course, is, do we want to make Rollup faster? And of course, we want to do that. The thing is, like in the Vite documentation, it says, we won't rule out the possibility of using ES build for production builds when it stabilizes these features in the future. So ES build is really breathing up our necks here. And we want to stay the build tool for Vite, definitely. So yes, we're open to start converting Rollup parts to native code eventually. And if we do that, it will probably not be Go, it will likely be Rust because the tooling is very mature. And then we could use SWC as our parser, which apparently exposes much of what we need as crates. And but of course, we would need new contributors to pull this off. So if you are fluent in Rust and maybe know a little JavaScript, then maybe we can talk. Very happy to start new collaborations on this one. And this is what I wanted to talk about. Thank you very much for listening. Maybe you learned something. Otherwise, maybe I could entertain you with our kids' car collection. See you around.
My name is Sylwia Vargas, and I'm a developer advocate at StackBlitz. I'm so thrilled to be here with you, and I hope that you are enjoying the conference so far. In this upcoming section, we'll talk about documentation. Good documentation can be a make or break when it comes to helping your users fall in love with your project. Your project may be super fast, blazingly fast even, may have all possible features, solve all possible problems, but if your users don't know how to use your project, what's the point? Good documentation means happier users and way fewer customer support requests. So in this section, we'll talk about the documentation tools that bring joy. Listen, it's 2022. You deserve beautiful collaborative docs. So we have 3 talks for you. First, we'll hear from Ishii, who is a Vue.js core team member, an optimistic web designer, and a developer. A fun fact about Kia is that his birthday is on October 10th. So join me on Discord right now to wish him happy birthday. If you haven't seen the Discord channel yet, it's at chat.vitejs.dev. Kia will take us on a deep dive into VitePress. At StackBlitz, we have just migrated our docs to VitePress, and I can't be more enthusiastic about this library. Our second speaker is Dan Jutan, who is an Astro and Solid team member. He's also a singer and songwriter, so I hope that this talk will be a musical. No pressure, Dan. As an educator and documentarian himself, Dan will talk about using Vite for education. He will demo a new way to write interactive tutorials by using Web Container API, which allows you to run Vite inside your own apps and create stunning educational experiences. The last slot in the section belongs to StackBlitz Keynote, where my colleagues Eric Simons and Tomek Sułkowski, and also myself, will unveil all the goodies, all the hot new stuff that StackBlitz has to offer you, your dev team, and your documentarians. So grab some tea, get some popcorn, make some noise on Discord, and I will see you in a bit.
Hello everyone. I'm Kia. I hope you guys are having fun. Thank you so much for having me. It's really a huge honor for me to be here, and I would like to thank all of the ViteConf organizers and staff for making this happen. I know how hard it is to organize an event of this size, so thank you so much for having me, ViteConf, and thank you all for joining this big event. Today, my talk is deep dive into VitePress. For those who don't know what VitePress is a Vite-powered static site generator. It can build any kind of static website, and with this talk, I'll try to introduce what VitePress can do, and more importantly, how VitePress does all of the things it does. However, before going into the talk, please let me introduce myself a bit. I'm Kia. I'm a web designer and also a developer. I'm Vue.js core team member and currently focusing on, well, obviously, VitePress. I'm working at Global Brain, which is one of the largest venture capital in Japan. We have offices around the world and doing startup investments everywhere. I'm pretty sure there's lots of startups members joining this event as well. So if you have any cool ideas about your business, please feel free to hit me on Twitter or somewhere else, and I might be able to help. Okay, enough about me. Let's dive into VitePress. So what is VitePress in the first place? VitePress is a Vite and Vue-powered static site generator. So you can build any static website with Vite's super fast dev server, and it can write content in Markdown. Well, I think many static site generator out there can do this, but I mean, writing contents in Markdown is kind of basic thing that all of the static site generator can do, but VitePress can too. And more importantly, it can use Vue component inside Markdown file. So if you're a Vue developer, you might already know about VitePress, which is very similar, or maybe I should say it's pretty much the same thing as VitePress, but it was built on top of Webpack, where VitePress is built on Vite. The point is that you can use Vue component inside Markdown, and the render output of those Vue component will get server-side rendered and become static HTML, CSS, and JavaScript at the end. So now let's see the basic usage of VitePress. In this talk, I'm not planning to explain each features of VitePress, but rather would like to talk about how VitePress do all of those features, and how it integrates with Vite, and how it uses Vite to accomplish static site generation. But to do so, we need to have basic understanding of what VitePress can do. So let's quickly go through the basic features that VitePress offers. The very minimum VitePress setup will look like this. First, you create your project folder, then put package.json and index.md. As you can see, the index.md is a root file, and you write anything in this markdown. And then you install VitePress via npm, then run VitePress through like npx VitePress command. And then you get this website up and running on your local machine. You kind of see the markdown file got parsed. There's a heading server 1 and level 2 with its contents. Even this single markdown file, it comes with this outline features where you can see at the right side of the page, we have light and dark mode switch on top right of the page. So by the way, even this no config single markdown file, it looks pretty clean and beautiful. So maybe this works pretty well on your resume website or something simple like that. But with this setup, we only have one single page, and that's not enough for most of the website. So you can further customize your website by adding configs. To do so, place config.js under the .vitepress folder. And in this file, you can add many configs such as site title, languages, description. These are the metadata for the website. You can add navbar config, which is the header of this website. And you can add sidebar, which is shown on the left side of the page. And after doing all of the configuration and adding more files inside folders, and finally, you get website something look like this. This is the offshore documentation website for VitePress. As you can see, there's a sidebar navigation, search button, and header. You have different navigation. You can even add ads. I'm hiding it in the screen, but on the right bottom of the corner, you can see you can put the advertisement and such. Now, VitePress comes with this default theme, which is focused on creating documentation website, which is why VitePress offers features that are required by most of the documentation website by default, such as having sidebars and displaying the outline of the page. However, but again, VitePress is a static site generator and not a documentation website generator. So it just happens to be that the current main usage is for creating documentation because, Markdown is quite good at building documentations, right? But the default theme is focused on adding features related to documentation website because of that. But it can use any view component inside it. In fact, all of the default theme is built with view component. So we have more example, which is not really a documentation. For example, I forgot to mention, but Vite website is also built with VitePress. And it makes sense because Vite website is Vite documentation website, right? So we want to use VitePress. But on Vite website, you see pages like theme page. Well, this page is not a custom page, but rather included in VitePress default theme, but it's quite hard to write this kind of page with Markdown, right? So we use view component for this. The source code of this page looks like this. This is actually a Markdown file. There's no Markdown syntax you find here, but you can really mix Markdown content and view component together. Here you see we import view components and using it just as if this is a view single file component. So again, VitePress default theme is focused on creating documentation website. You can use VitePress to create any static website. It doesn't have to be a documentation. Another example would be this one. This is a website I built recently at my company. It doesn't use any of VitePress default theme. The theming is completely original, but it's still using VitePress. So if you are a Vue developer and if you want to have static website and use Vue, write content, VitePress might be one of your choice, even for things that are not a documentation. Now, I hope you have a basic understanding of what VitePress can do. Now, let's go into how VitePress works. Again, I'm not going through the features of VitePress, but rather look into how VitePress enables those features and how it uses Vite to do so, like to do anything that VitePress does. Now, VitePress is deeply integrated to Vue because the whole point of VitePress is it's Vite and Vue-powered static site generator. However, as you already know, Vite is not locked in to Vue. You can use Vite with many, many other JavaScript frameworks, such as React, Solid, Svelte, and such, right? So by learning how VitePress uses Vue, you may apply the same technique for other frameworks too. And that's what I'm hoping you guys would learn and, create some awesome software and make the world better. In order to understand how VitePress works, the most precise thing you can do is look into the source code. Oops, sorry. Which is this. Well, there are lots of files, but you only have to look into source folder. But even for me, it was kind of overwhelming to go through like each file. In fact, I was planning to open this source folder on my text editor and show everyone the low source code and go through like lines by lines. But well, it was harder than I thought. So there are lots of codes. So instead, I'll pick important part of the code and explain as simple as much as I can. It becomes a bit more abstract, but I hope you'll get more glance idea of what VitePress is doing. And after you know what it does, and if you go through the actual source code, you will get more better understanding. So I made the following slides so to match the actual source code structure as much as possible. So I hope it will make it easier for you to locate the corresponding code once after you saw the slides. So the core components. VitePress has two big components, which is client-side code and server-side code. Client code is in the client folder, and server-side code is on node folder. Client code runs on browsers, and server-side code runs on server-side, but it's a static site generator. So in production environment, there's no VitePress server up and running. By Vite server, I should say, maybe. But so usually the server-side code means that the code runs on your local machine. Inside client folder, we have folder two different types of client code. One is called app and the other is C. App code is the core VitePress code. It handles all basic features such as routing, hot module replacement, DevTools integration, and managing the site metadata, loading configs, and such. Theme code, on the other hand, is in this case named theme default, is a theme-specific code. All of the config that only relates to theme will be used in this code only. So if you were to build your own website without using the theme, none of this theme code will be running. So we can completely delete this folder and VitePress would work without a problem. Now, the best way to understand how some application works is to go through step by step from the entry point. By that, I mean, if we want to create a static site generator, what do we need to do at the beginning? Like, how do we start the dev server or how can we build a code? Well, we need CLI command. We need to have some command to start building the website. That means VitePress is a CLI application. So VitePress has several commands that the main ones does. Main ones are these ones: VitePress dev and VitePress build. Dev command will boot up dev server using Vite, and build command will build the production build. So let's check out what happens when we execute these commands. First of all, which file will these commands run? Actually, it's in the bin folder, and it looks like this. Well, that's it. This is simple JS file, and it's loading CLI.js under dist folder. Now, this folder is where compiled file gets generated, because VitePress is written in TypeScript. So the actual CLI file is under source/node folder. And let's see how that looks like. It looks like this. Well, you don't have to worry so much about details because these are just handling users' CLI input. But now we can see what the actual command is doing at the moment. Now let's see what dev command is doing. It's doing this. Okay, so the first line is the dev command, right? The main thing it does is creating a dev server and starting it. It looks like it's doing more, but let's focus on dev server things here. It creates a new server and starting it. Okay, so where does this create dev server is coming from? It comes from source/node/server.ts file. It looks like this. I'm not showing everything here, but stay with me. I'll going to go through it. Maybe it does, mainly it does two things here. One, it resolves the config. Well, because we need to apply any config the users defined, so that the first thing we do is to resolve the config. I'm not going to look into config file where, because all it does is tries to set default value for the config. If any user input is given, it will use that and use that instead of the default one. But because there's lots of config, the config file is quite huge. But what it does is simple. It just loads all users' config and set up the final config object that should be used throughout the app code. Now, the next thing it does is this, which is actually the last thing it does. It creates a dev server. Now you can see that it's calling a create Vite server, which is imported from Vite. This is actually it. It's calling Vite server, and there's nothing else it does in this file. The part we should be focusing is here. Plugins we passed into this server. So here you can see that this plugin is named Create Vite plugin. So essentially, VitePress is just a Vite plugin. It does all of the things as Vite plugin. And also now you can see how it is easy to create Vite server programmatically, right? You just import create server from Vite and run it. And you can create your own Vite server. So if you want to create any like custom command that's going to boot up Vite server, this is how you do it. Now let's go into create VitePress plugin function. What does it do? Now, this function, the plugin function, comes from source/node/plugin folder. Now from here, things get interesting and more complicated, of course. Now, this is the actual source code, but as you can see, and I don't have enough space to show all the actual code, so let's cut off some codes here and make it simple. The main goal here is to create Vite plugin. So that code looks like this. Now, Vite plugin is an object with lots of configuration you can add. You can find all of the documentation at Vite website to learn what kind of options they have. But here again, let's focus on what matters for VitePress. As a Vite plugin, what we want to do is transform a given markdown file to something that Vite can handle. Because as a default, Vite does nothing for markdown file, right? So if some markdown comes in, we need to do, well, whatever VitePress want to do with that file. To do so, we have transform option in Vite plugin, which look like this. Here, I'm cutting off not that important code and only showing the important ones, but here it is. You can see that it's trying to handle incoming file. The first if statement checks if the file extension is .view or not. Well, VitePress renders markdown, but it can also handle view file directly too. So if any view file comes in, not markdown file, but the view file comes in, we'll just handle it. We just handle that too. You see, there is a process client JS function. This is the function that processes any user-defined JavaScript code written in the file and add to the hash map. So we can use that with rendered output on the final output. But it's not really the huge things. Don't worry so much about this. The next if statement is looking for .md extension, which is the markdown. In this case, incoming file is actually the markdown file. In this case, we need to parse the markdown file in order to process the file later on. How we do this is to parse markdown file into view source code and then pass it down to the Vite pipeline. After that, Vite can handle view file via its view plugin. So all we have to do here is transform markdown file and make it view file. To do that, we have this markdown to view function, which returns view SLC object, view source object, and the view source object gets passed to process client JS file as the same as we did when transforming the view file. Actually, this is the key part of VitePress. It handles markdown. Now let's go see what markdown to view file does. The actual name of markdown to view command is the return function from create markdown to view render function. Now that's a long name, but it's quite precise. This function returns function that can parse Markdown, taking user configs into account. Now, again, it's very complicated and looks like many things are going on, but let's look at important part of this code. The first one is this: create Markdown renderer. This function is creating a pure Markdown renderer function that can later use to actually render the Markdown content, which means convert Markdown into HTML. Let's see how it looks like. This is the function. This function looks very simple, I will say. You can see that it's creating a new Markdown instance, Markdown it instance, and Markdown it is very famous Markdown parser for JavaScript, and VitePress uses it too. All it does is creating a new Markdown it instance and adds lots of Markdown plugins. As you can see, there's a lot of md.use function in its code. These are adding plugins to Markdown parser. Many plugins are usual Markdown plugins, not special to VitePress, such as highlight the line plugin, highlights the code block. It's using Ishii as a plugin. The special one that I would like to mention here is component plugin that you can see at the very first plugin to be added. This plugin handles view component inside Markdown file. It allows view component code inside Markdown file and be executed. This plugin is actually published as a different package called mdit-view. There's lots of different view-specific Markdown plugins published here. So if you are planning to create software that uses Markdown parsing with Vue, please check it out. It uses cool technique to handle view file. And if you're trying to create parser for other frameworks like React, I'm pretty sure you can find cool ideas from this package so that you can apply it to those frameworks as well. Now, let's get back to Vite plugin code. Remember, here's where we left off. We've created Markdown parser. There's still lots of things going on, but there are a few things that I want to point out, which is simple but interesting technique to apply when parsing the Markdown to actual HTML output. In same file, parsed, we call Markdown function we've created earlier. Here, now this HTML variable contains parsed Markdown file. And here, we actually create view source object. Remember, this is the object we return from this function so that it gets passed to Vite, and Vite handles this object as a view file. There's a few things it doesn't, which I didn't go through, like it's passing injected page data code and stuff. But the important part is that there is a template string, this one. So what it's doing here is it's passing parsed HTML inside the template tag. Because in view file, you wrap all the HTML code inside template tag. So what it does here is that's trying to create an actual view file. This might be obvious for someone with familiar with Vite, but this is a good takeaway from this code. Basically, we want Vite to handle code as much as possible. And we know that Vite can handle view code. So all we need to do here is to convert or transform Markdown file into view code that Vite can understand. That means if you create some custom Vite plugin that passes, I don't know, but something other than Markdown, the same logic goes here. You get the file you want to convert, then transform it to the file format where Vite can understand. Then everything else will be handled by Vite. Just remember this. Now we're capable of handling Markdown file. Now we need to return index.html to the client, which is done here. Now in normal Vite application, you would have index.html file under your project folder as an entry point. But in VitePress, we don't have index.html. So we need to create it and send it back to the client. So we use server middleware to interact the response and send back this empty HTML. Remember, this is dev server, so it's not a production build. So all we need is pretty much empty index.html content, and the content that client can fill in the rest of the data, things like metadata such as title of the site and such. VitePress creates a full HTML with all of the content rendered on production build, but in dev server, we don't need to do that. And other than this, VitePress has many more configs to handle things like hot module replacement and such. But here I'm kind of going short of the time, so let's move to the client-side code here. You can always look into the source code and learn about more advanced technique after later on. So once we know that now the server side is returning this index HTML, on the client side, what we do is more straightforward, I would say. Well, the code itself is a bit complicated, but what it does is it creates new view app. Here you can see app.mount method, which is view way of mounting view component to the DOM. It's nothing special. This is a plain view app. There's no create VitePress app or something like that. It's just a view. Well, we are wrapping everything on in-browser if statement here because VitePress is a server-side rendering application, right? In production mode, it's going to run this command on the server side, so this only runs on dev server. However, the app contents that we're mounting has VitePress specific features, and it looks like this. It's creating a client-side router, adding default components such as not found component. It's injecting some VitePress specific data to the child components and such. But from here, because we've done all heavy lifting on Vite side, on server side, this is just a simple client-side code. By that, I mean, for example, we don't pass markdown on client side because it's already done on server side. So the client code works as if there's a fixed view file written to the actual file system, and it's same as loading those fixed view file from the file system, right? And at last, this is the theme file. It's loading the default theme as the default view component, which looks like this. This is even more plain view file than app file. This is just a typical view component. There's lots of slots and so many things going on because there are many customization you can do with the default theme, but still it's just a plain view file. This is the default theme. So from here on, none of these codes matter if you would like to have your own custom VitePress theme. No core feature is included here. So if you don't care so much about how default theme is created, you can just ignore all of the theme-default folder, and you can just look into app folder and see what it's doing. Now, sorry, I skipped lots of things on client side, but I'm kind of getting short on time. But I hope you're getting some idea on how VitePress works and how it's integrated with Vite. So let's go into the final big command that Vite has, which is build command. This command will build the final static HTML file when it gets executed. This is how build function looks like. Once again, well, it's complicated. Now for build, what we want to do is pretty much the same as before. We want to pass markdown and finally output it on HTML. And instead of returning the output HTML from Vite dev server, we want to output it to file system as a static file. To do so, we need to render it. And that's why we have render function inside this build command. The render function looks like this. Here it gets the render object by passing in the file path. Because we want to render all pages, right? So instead, inside promise.all function, we pass all of the pages. Now the actual render function inside node/build/render.ts file, here we define how we render the given file. Again, as always, lots of things going on, but the important part is this. Now, it seems more simple. It's just rendering HTML as a string. The content variable inside the body tag is the content got rendered from the file. As you can see, it's wrapped inside a div with ID of app, which means this is the div that view will mount on. Once we get this string of HTML, what we need to do is to render it to the file system. And we use FS module from Node to do that. Well, I've skipped so many codes. For example, it also output like JS and CSS chunks. So it creates like subfolders and such, but I think you get the idea of what we're trying to do here. We're just trying to render a file into a string and then save it as plain HTML file. Now, if you find anything that interests you, please go into the actual source code of VitePress. And by focusing on how it uses Vite and how it handles incoming files, you will learn so much about how Vite plugin works. I'll pick important part of the code, but at the same time, I've skipped lots of things as well. But I hope you got some idea on what Vite plugin would look like. And I hope it made you more familiar on writing Vite plugin. Because VitePress is a standalone CLI application, but as I've shown, VitePress is a Vite plugin. And also it's one of the official big projects that Vue community manages. So if you're looking for a way to learn how to create Vite plugin or looking for an idea of what Vite plugin can do, I think VitePress is one of the software you might want to look into it. Also, it's good software to write your documentation or create static website too. So yeah, please check out the VitePress. Thank you so much for watching. I'm Kia. If you have any question or just want to say hi, I'm always open on Twitter, so just let me know. Thank you so much, and I hope you keep enjoying the rest of the event. Thank you so much.
My name is Dan, and I care about documentation. Docs don't just have to be pages of Markdown anymore. We can leverage ideas from educational technology to create experiences that help people learn better. As I've been working on open source docs, I've been thinking about ways to make docs easy to follow, interactive so you can try out what you're learning, and easier to maintain. So to celebrate open source and education and Vite, I want to show an idea I've been exploring to make good interactive docs easier to write. Lots of projects have been embedding interactive code samples into their tutorials. Svelte has this popular format where they pair a lesson on the left with an interactive code sample on the right, so you can read the lesson, try something out, and see what happens. Solid has a similar approach with our tutorial made by Ryan, and Lit even takes this format a bit further by allowing you to go step by step through building a project. These are usually set up with a browser-based script that is built to run that specific framework. But this approach has some limitations. It doesn't really show a full setup for building an app. You'd need a package JSON and some config files. You might have to run some terminal commands. And that's just because of the browser's limitations. With a browser-based tutorial, you get rid of the friction of having to set everything up and all of the problems that can come along the way. But you also lose some realism and the ability to teach those pieces of the setup. So when I first heard about the Web Container API, I got super excited. This is what powers StackBlitz to run Node in the browser using WebAssembly. And if you can run Node in the browser, you can run Vite in the browser, and then you can run pretty much all the frameworks and meta frameworks using a full, realistic, extensible setup with a terminal and everything. Rich Harris and the team have used this to build a SvelteKit tutorial, but I wanted to think a bit further. What if instead of every project coming up with their own solution to build these interactive tutorials, we could have a tool that lets you write and edit and share interactive tutorials on top of web containers? And that's the proof of concept I have here. So we start from an empty slate with one slide, and we'll get to that, but we can load our starter project from any project on GitHub. And this will bring up all those files and start the web container, and I can go ahead and clear things out because let's say on this slide I only want to show this one file. I can write whatever I want here, like introduction to solid. This is markdown, and then I can add another slide. So on this one, we can choose to copy the state of the previous slide. So I'll do that, and maybe I'll say the first step is to clear code you don't want, which always seems to happen when you start from a template. So I can go ahead and clear this and save the file. And now we have these two slides, each with a corresponding state. So hopefully you can see where I'm going with this. I can also go into preview mode where I can't edit the markdown on the left. And if I do make changes to the code, it will disappear when I come out of preview mode. And I can sort of save this and share this link with someone else. I'll pull up one of these that I made before, and this will also show you a little bit of how this whole thing works. One of the key pieces is CodeMirror. We use CodeMirror on the left for each of these little editors. We use CodeMirror in the center for the actual code you can edit. And also, if you include code this way, like if I say JS console.log hi, this will actually, if we go into preview mode, show us another CodeMirror instance embedded into the markdown. Sorry, just had to hop over to this side so you can actually see the text. But yeah, this little tutorial shows you how to use CodeMirror in Solid. So you import the editor view, you can supply it a doc string. We're still not showing this thing yet. But since Solid works with DOM nodes, you can just include view.dom, which is a literal DOM reference, and it'll just work. You can even return that directly from your function component. And this is why using Solid with old school browser libraries like CodeMirror or something like GreenSock works really easily because Solid deals with real DOM nodes. Here, when we go to installing a theme, you'll see on this slide it switches to the package.json file so we can sort of see what we're installing. And by the way, the full file system is always available here. I've just sort of crossed out the ones that we don't support showing, like images. So yeah, this walks us through step by step, and you sort of get this aspect of kind of a coding walkthrough video where the creator is sort of like guiding you step by step in the process, but you don't have that maintenance cost of when you put out a video and your API changes and you want to change the video. And a lot of people don't like watching videos, and this is a great alternative that is more self-paced. But slides can be as big or small as you want, so it's a pretty flexible tool. Here, I've used it to make one of those traditional show solution tutorials. I literally just grabbed an example from the React beta docs where it asks you to take this example and remove anything that doesn't have to be state. And as usual, I can mess around with it, and then I can press show solution. And what I really like about this is it sort of shows really clearly what the difference between the two solutions are. Like, we've just removed a bunch of code by refactoring, and that was sort of the idea behind the challenge. The way all of this code execution works is with the Web Container API. This is not a normal API, so let's dive in. It's currently invite only, but StackBlitz has been super generous, so just reach out. It's installed like a normal package, but if you try to use it out of the box, you'll run into an error telling you about a shared array buffer problem. Shared array buffer is a web API, which means it's baked into browsers, and let's break it down by going through each of the 3 words inside it. When you're programming and you want to access memory directly, you can do so by using a buffer. In JavaScript, this is called an array buffer, probably because JavaScript developers like arrays. And if you want multiple threads to access the same allocated memory, that's where shared array buffer comes in, where it'll give you that memory and let multiple workers or threads access it. This is really important for web containers because it's trying to re-implement low-level programs like Node, which were written in C, to run in the browser. Unfortunately, though, there turned out to be an exploit which allowed attackers, say from other threads, to access memory from threads they don't own using shared array buffer. So to prevent this, browsers that support shared array buffer will turn it off unless you opt into a kind of protection called cross-origin isolation that makes sure you can only access threads you control. There's actually this panel in the dev tools to tell you whether you have shared array buffers available. So in this live version, I do, but in this errored out version, if we check, we are not cross-origin isolated, so we do not have shared array buffers. We can go ahead and enable the isolation mode by setting these headers, which Vite makes it easy to do for our dev server. Then we can go ahead and use the Web Container API, which is made up of a few functions. First, we want to boot the web container, which effectively grabs the rest of it from StackBlitz's server. Then we can call the load files function to load our file structure into the web container's virtual file system. Importantly, if you reload a directory using load files, it won't overwrite that directory, it will merge them. And so if you want to delete a file, you can't just reload its containing directory. You have to actually go and call the remove command, which takes a path name to remove. Then we can run our code using the container.run function. And that will also take a callback, so we can pipe the output of the command into, say, a terminal. And lastly, we can respond to events. And the most important event, and the only one I use, is server ready. And so what this does is whenever a port opens up, it calls this callback, passes us this URL, which is kind of like the URL that shows up inside of StackBlitz, and then we can do what we want with it. In our case, we use that URL to set our iframe in the top right corner. I did want to show a little bit of the actual code so you can get a sense of how you can use all this web container stuff to get that functionality where as you switch from one slide to the next, it will update the web container according to what changed. And so the idea behind this is we always keep in memory whatever the last state of the web container was, and then we'll re-trigger this sort of diff function whenever the file system itself gets swapped out or whenever a file gets saved. So then in this function, we check if the current files coming in have anything missing from what's saved, and if so, we need to go remove those. We also check, hey, did we change the contents of any of the given files? If so, we need to update those. And so we have an array of files to update, an array of files to remove. So we have these helper functions that wrap those web container functions to go ahead and run that rm command for all the files we need to remove, and go ahead to construct that directory object to load the appropriate files. And then if one of the files that changed happened to be the package.json, then we run npm install and npm run dev. And this is a wrapper function that goes ahead and constructs the right arguments to pass to that container.run command I showed you before. I've been calling this demo tutor with a U. You can check out the full code at tutor.dev/repo. If it works. This is a GitHub glitch. I promise this is not my fault. I have no idea what's going on, but I'm keeping this in the recording. Anyway, I've been experimenting with all sorts of stuff for this, specifically code links that can let you sort of link from the markdown to specific spots in the code, and that could be useful for code tours. And I've also been thinking about audio recordings. But yeah, if you want to get involved, check out this repository. Who knows, it could stay as a demo or it could turn into something more. Regardless, thanks so much for watching, and don't forget to check out ViteConf. So many of the technologies I've been using, they're all going to be represented at ViteConf, so check it out.
Hey there, I'm Eric Simons. I'm the co-founder and CEO of StackBlitz. And for those of you who might not have heard of StackBlitz before, StackBlitz is a web-based IDE that allows you to run full-stack JavaScript toolchains entirely inside of your browser tab. And we've been able to do this because we actually invented a technology called Web Container. We launched it at Google I/O last year. And Web Container is a instant booting WebAssembly-based micro operating system that actually runs inside of your browser tab, which is what makes this experience so fast and really feel like magic. And we built all of this because our mission at StackBlitz is to make web development instant. And specifically, we wanted to solve the problem of having to go to your local environment and context switch when you want to start prototyping a new idea or try out a library that you just found, or even doing bug reproductions on your local machine. It really takes a lot of time and kind of painful to set these environments up and context switch what you were working on. And instead, StackBlitz has turned this into an instant one-click process entirely inside of your browser. So over the past couple of years, StackBlitz has become pretty popular for these different lightweight use cases. In the open source world, it's used by many for bug reproductions and beautiful interactive documentation to try out the libraries. And it's also been adopted by some of the world's largest companies for rapidly prototyping the next great ideas they want to ship. And so we've got a whole bunch of developers using StackBlitz now. And a couple of years ago, we realized that there's still one place where this context switching problem is still rampant. And that's when you're writing production code in your local environments. And that's not to say like when you're building a feature every 1 to 3 weeks or whatever have you in your local environment, tools like Vite have made that process very fast for your development cycle. But the problem comes in when your PM hits you up and says, hey, we've got an urgent bug that needs to get fixed. Can you make a PR right now? Or a coworker hits you up and says, hey, I need you to review this pull request and run it locally to verify it works so we can get this merged in. Because our local dev environments today are like single burner stoves. I have to pop off what I was doing, stash my changes, pull this thing down, install, etc. It's like this whole nightmare of a process. And so we thought, wouldn't it be great if we could take that same instant booting experience in your browser tab and brought that to these production workflow use cases? Because really the problem here is that we ideally would just be able to like take your exact local environment and then instantly clone it. So you can go and create a PR review a PR, and then just throw that out so you can get back to your main feature development on local. But if you're going to do that, that means we got to take the entire power of your local environment and make it something that can boot instantly. It's got to be like actually a lot better than your local machine. It's got to be a lot faster to spin up than you could even do on your own local machine. And this is a huge challenge because we also don't want to lose what is great about local environments. There's no latency, because it's entirely on your computer. It works offline. You don't have to pay by the minute to use it. So if you look at these other cloud IDE things over the past 10, 15 years, they're worse than local in every way for those reasons. You can't work offline. They're incredibly slow. They're even slower than local in most cases, etc. So we're going to need to run this inside of your browser tab. So it's using your CPU, your memory, and ideally it's got to actually be better. It's got to be faster. There needs to be less latency than your own local host. And that is a tall order. Because if we kind of break down, okay, what's in your local environment that we need to run in this browser tab? Well, we've got VS Code, the desktop version of VS Code with all of the extensions you know and love, right? We are going to need Node.js. That's how all of these tool chains are powered. Okay, so we can do that. We also need whatever package manager this project needs, PNPM, Yarn, or NPM. It's got to run. We're going to need Git, like the Git CLI, actually mount that Git repo, and of course an actual operating system as well. And so kind of the first problem is that all of that combined is a couple hundred megabytes at a minimum. So to download that is going to take minutes. But then once you actually execute that, you still need to actually clone whatever repo you're trying to work on, then install all the dependencies, and that takes a long time on local even as well. And so we're going to need to cut down the size of what we're sending down to the browser, from a couple hundred megabytes to, 10 to 15 megabytes if we want this to load in, a second or two. And then for actually cloning and installing dependencies, this needs to be substantially faster than how your local machine can do it. And not just like by, 2x or something. This is going to need to be like 10x faster. And so when we started working on this 3 years ago, we honestly didn't know if this was going to be possible to do. Like we didn't, we thought this might just be an engineering pipe dream or something. But it's turned out to be a bit of an engineering marvel. And the way it completely changes your development workflow is profound. You can seamlessly switch between creating and reviewing pull requests and closing issues, and in a way that just wasn't possible before, and just keeps you in your flow state with your code. And today our team is incredibly excited to announce for the first time ever StackBlitz Codeflow. So what is StackBlitz Codeflow? It is a seamless one-click integration with GitHub that gives you instant environments on every pull request to create pull requests on repos, to close out issues and actually run reproductions without having to context switch in your local environment. And it really works like a dream. I could keep talking about it, but I think that a demo is probably the best way to actually see this thing in action. And so the demo I'm actually going to do is not really a demo at all. I'm actually on the hook here to ship some final things before ViteConf today for our announcement. One of those is a ticket, a Codeflow themed ticket on the viteconf.org website. So I'm going to go ahead and pull up my screen here so we can all take a look at this. So on the ViteConf website, if you remember grabbing your ticket, you could actually customize it with your favorite framework, etc. And so mine is StackBlitz, but we want to add a Codeflow logo down here. So you click on that logo, it'll turn into this beautiful card, maybe like pink with like the Codeflow logo up here. And the way I've been building the site, to start at least, has been in my local environment. And so let me pull up that. And I forgot, I've been working on a big feature. I've got a whole bunch of changes that I made. I'd have to like stash my changes and do that whole dance. Honestly, the fastest way to do this would actually, let me just go to the GitHub repo for this. And what's super handy is on the README for this, there's now this like really slick start a new PR button. So if we actually just go ahead and click that, it's going to basically create this instant copy of my local environment, but inside of this browser tab. Like it's got like the same theme, it's got the same extensions, and it's already cloned to install the dependencies, and the dev server is already running that fast. We're talking about a couple seconds. This is like a full stack application, right? This is, Nux 3, this is, running real backend code in here. So let me, that was a lot to take in. Let me break down exactly what just happened there. When I'm going to hit the refresh button here, what's going to happen? It's going to strip down the operating system. It's going to start a brand new operating system, git clone, run the install process, boot Node.js, boot your dev server, actually run it inside your browser tab, and mount the desktop version of VS Code around it. So you have all of your extensions. And it's hard to believe that this is all running in my browser and not on the server, but it really is. And that means if I disconnect my internet, I can actually go ahead and keep refreshing, and it'll keep on working. I can keep coding and go to my terminal and type commands. So I'll turn this back on, but pretty amazing. So let's get to work. Enough marveling at this thing. I need to add the Codeflow ticket. So let me go. Actually, I'm going to open up this in a new window. Let me pull that over here. So we can do our kind of true web development. That means I can run and debug this in a completely separate window. And I'm going to have this. Make that a little smaller. I need to add the ticket. So a couple things. It's really not too hard, I think, for us to do this. I need to get the Codeflow logo, which I believe I have, just so happen to have pulled up here. And all I need to do is just drag and drop this into that projects folder, and bada bing, bada boom, we got the logo. All right. The other two files I need to edit are the conference file. So I need to actually scroll down here, and I need to add a Codeflow kind of branding theme here. So I'm just going to take pings and add Codeflow. StackBlitz.com/Codeflow. And for the color, I believe there's FF003, I want to say, but we'll find out in a second. I believe, because I don't think that's showing up yet. So I think there's one other file we got to edit here. We just need to add Codeflow as one of these, and voila, you can actually see the Codeflow logo. Oh wow, look at that. That is beautiful. What a beautiful looking ticket. All right. Wow. All right. Yeah. Simple PR. Yeah. Really, really not too bad to add this in. So yeah, I think this thing looks good to go to me. It's looking beautiful. Let's open up a pull request. I'm gonna go over the source control panel, and I'll make a branch called Codeflow ticket. Hit enter. All right. And I can go ahead and make a commit, add Codeflow ticket. It's gonna go ahead and commit and push that. And I just click open new PR. I'm gonna say add Codeflow ticket. And for the description, I think people will dig it. I'm going to go ahead and assign Tomek to this. And just click create pull request. All right, and we are good to go. So I'm going to go ahead and shoot Tomek a message on Slack here to let him know it's time to review this.
Hey, so I've been working on a tricky CSS issue for the ViteConf website, and I've noticed Eric has just pinged me asking for a review of his PR. I really want to see it running in a coding environment, but I don't want to deal with stashing all my current work just for that. Well, that's what CodeFlow is for. So let's use it. The CodeFlow app bot has already prepared a link for me. And would you look at this beautiful inviting button? Let's click it and see what happens. Okay, my environment is launched. I have it set up with the same purple pink theme. I have my local, so that's great. Oh, and the project is already live as well. Let's rearrange the windows a little bit and see what we're looking at. The code looks good, but I want to see that new icon in the actual app. Thankfully, this is a live environment, so I can do it. And here it is. I'll just make sure this brand color makes sense. Again, live environment, so let's just try something. No, the original was way better. I think that deserves a comment. Color is perfect. And looks like we're ready to merge it. Let's ship it. Approve and merge. Okay, I can close the PR tabs and get back to my CSS challenge. See you later.
All right, I just got a notification that this pull request got merged from Tomek. And he even left some nice, I like this. He thinks the color is perfect. All right, and we shipped it. It's merged in. Awesome. You can see how simple and seamless that experience was for everyone involved here. And, this might seem, like a small example of this. And you might be wondering, okay, well, how much can you really do in this workflow? Like, how much can you actually run? Like, what's the delta between CodeFlow and, what I'm running in my local environment? So let me go ahead and pull up my local VS Code here side by side with CodeFlow. We can kind of take a look at it. One of the things that VS Code really pioneered was the IntelliSense and language services, where I can actually hover over things. It'll tell me, I can right click, go to definition, it'll drag into my node modules. We've got that stuff running on the StackBlitz side here too. Again, this is the desktop version of VS Code running over here. And this is actually using PNPM, just like what's going on over here. So if I actually scroll up, I'm in my node modules right now, going and debugging this end of things. Such a key part of the experience. And obviously we have the Git sidebar. We saw an example of that working before. Same deal on the Git side. But one thing in local is that you have a Git CLI. So I can actually type, Git status and actually see a result on my local VS Code. And Git doesn't normally come in a browser. So I'm going to have to, we need to make sure that it would work over here too. Turns out it does. We actually built a version of the Git CLI that runs entirely on top of web containers instantly in your browser. So you can do all the different Git commands that you normally want to do here. And one of the other key things that has made VS Code the most popular code editor in the world is the vibrant extensions ecosystem. You have all of your favorite extensions here. You can also, great different themes. I can flip between them and actually see them live here, right? And so over here, we've actually got the same thing, all of your favorite extensions ready. And we can go ahead and switch the color theme around and actually take a look. And of course, key bindings are such an important part of what you do, in StackBlitz. So over in, native VS Code, you can go and, create a new file, Command N. You can close that file, Command W. Over in StackBlitz over here, Command N. Yeah, I guess it doesn't work. Actually, I'm just joking around. This is actually StackBlitz running as a PWA, because StackBlitz can do everything VS Code can do, because StackBlitz is literally VS Code and VS Code is literally StackBlitz. And you can get access to your full key binding by just popping StackBlitz open into a PWA mode like this. This is not local VS Code. So you can kind of see here the delta is effectively zero between what you can do in StackBlitz versus your own local environment. It is your local environment inside of a browser tab and boots instantly. But being inside of a browser tab actually allows us to take the experience of using this even further beyond what you could ever even dream of doing on your own local. And so to demonstrate that, because we're in a browser, we're all web developers, I like using Chrome DevTools to debug my front end. And since we're running your entire full stack application here, your backend effectively, wouldn't it be great if you could actually use, Chrome DevTools to debug that live too? So let's go ahead and I'm going to run, the command node-mon-server.js, spin up this server. And you'll see I've got a backend server. I'm just spinning up here as the code entirely inside of my browser. And so if I want to debug, hey, what's that request object look like there? I can go ahead and just open up my Chrome DevTools on this page. That's all I have to do. And when I hit refresh, you'll see it actually comes straight in. You can see it there. And if I actually want to, step through this through a debugger, hit save, and this is actually, you can see this browser over here is hanging. I can actually see what all the different variables are set as. And when I'm ready, I can go ahead and just respond. So if I change this to say hello world instead of ViteConf and hit refresh, step through it, you'll notice it says hello world now, right? So this, an absolute dream to be able to use this sort of a debugging experience, because on local, being able to attach to Node, et cetera, requires a ton of setup. So for folks who are doing a lot of debugging in their workflows, this is just an absolute dream. And the people who tend to do the most debugging in their workflows are maintainers, open source maintainers, design system maintainers. And the reason being is they're creating libraries that thousands or millions of developers are using in their own projects. So maintainers tend to have the most bug reports, the most issues compared to any other developer in the world. And it's a huge hassle. A lot of projects actually require you to submit a StackBlitz link now for the instant reproduction, make sure it's a bug and not something else. But even if you verify it is a bug, the next step is you have to download that bug manually to your computer as you're fixing the bug in the actual code base, testing that against the repro. And that's a huge security threat vector because that repro has any bad code in it. So it's a total gnarly hairball. We've actually been working with the Vite core team to solve this entire problem and turn it into one click. So want to show you that now. I'm going to go ahead and pull up the ViteConf design system example repo we got here. And I got a handful of issues on it. And let me go ahead and I'll click on this first issue here. Garrison from our team says that there is a bug. He says that the button should say ViteConf, but it looks like the spelling isn't there. So you can see there's this reproduction. You've probably seen this on a lot of other repos. So I can go ahead and just open in a new tab and it'll boot this up and we'll be able to see if that's actually the case. It should say ViteConf and whatever button is, it says ViteConf. Interesting. Okay, so this actually is a bug. So how do I fix this? Well, the CodeFlow app in your GitHub repo comes in to save the day again. It has instead this time a fix this issue button. And it also gave us all of the links that were in the comment up there. So I can, instead of having to search through the repro links here, I can actually get a one-click link here. But this fix this issue button is very magical when you click it. Because what it does, it's going to go ahead and actually start a new pull request for us. And it's going to mount in our repo on the main branch, the latest. But it's also going to mount the reproduction in a sibling folder right alongside it. It's booted up my design system, so I can actually see the issue over here. And so first of all, let's go ahead and let's fix this issue real quick. And let me find it. So, okay, that's the issue. It needs to say ViteConf. Maybe next year we'll throw a ViteConf, but that looks pretty good to me. And so this looks good now. But I want to make sure, I actually want to run this, in the project over here that was pulling in our component. If I go to the app.jsx, you can see it's actually pulling in from our ViteConf buttons npm package. So CodeFlow actually allows you to specify overrides with the popular package managers, like with PNPM. It'll actually add an override automatically when it got pulled in, that it's going to point at our design system over here. So if I go ahead and I'm going to go up a folder, and I'm going to go to the StackBlitz reproductions folder and then the ViteConf button issue, all PNPMI, which is going to install the dependencies, including the ones that are local. And then I'm going to PNPM run dev. And it should open up another browser port here. And you can see this is the reproduction. You can actually see it says ViteConf. And this is from that user code. And again, this is all executing inside of the browser security sandbox. So this actually can't break out, grab your NPM credentials, etc. So you can actually securely, in one click, fix that issue. We think this is a huge game changer for open source maintainers. You can really imagine yourself flowing through your issues and pull requests, etc., without having to go to your local environment to do it. So we've designed CodeFlow to be an amazing experience for repos that you own or maintain, but we've also designed CodeFlow to be able to open up any repo that you want to contribute to, an open source project, for example, want to just search through a repo, etc. And the way you do it is with this simple little URL called pr.new. You can have pr.new in front of it, any GitHub URL, whether it's a pull request, a branch, it'll turn it magically into a live environment instantly inside of your browser. So to just quickly demonstrate this, let's pull up the Vue core repo. I've never pulled this down to my computer before, but I can just go ahead and put pr.new in front of this URL, and it's going to crack open that repo. It's going to clone it, install it. It knows what package manager to use, pnpm. It's booted up. Again, I don't know. I've never opened this repo before. So it's pretty amazing to the idea of opening up any open source repo, and that's how easy it is to get started now. In the getting started section, we should say, please use StackBlitz CodeFlow because this is so much better. So if I want to like push this back upstream, really simple process. Just hit fork. It knows I don't own the repo, and so it's created a fork of it in GitHub for me, and I can now just create a patch branch. And I'm going to go ahead and just commit my changes, made small change, and I'll commit and push. And I can just open up a new PR into Vue.js core from Eric Simons. You see that there. That's how easy it is to open up a pull request in this. But of course, I can also help the maintainers review their pull requests. So if I want to see what's going on, Evan, you and the team are pretty busy. Again, any GitHub URL, I can put pr.new in front of it. And by the way, you can also skip the slash and it'll still work, which I think is pretty cool. But I can actually go ahead and open up, again, the Vue core repo, boot it up, and actually is running the production tool chain here, down here. And I can actually see the delta of what has happened in this pull request, and I can help Evan, you review it, right? So for any GitHub URL magically turns it into this awesome experience that previously would have just been an unbelievable amount of work and time to get set up on your local machine. So I'm incredibly excited to announce that pr.new and everything you've seen about StackBlitz CodeFlow here today is now available in public beta, and you can sign up for it over at stackblitz.com/codeflow. For open source usage, it's 100% free to use and always will be. If you're looking to level up your team's productivity and completely eliminate context switching, you can head over to stackblitz.com/enterprise or shoot us an email at sales@stackblitz.com. We've actually been giving this to some of our enterprise customers the past couple of weeks, and they've been saying it's going to be a game changer for how they develop software. So we're really excited to get this in the hands of more folks to try it out. And this has been, a monumental effort. And I just want to give a huge shout out to our engineering team. Like, making this sort of thing work in a browser is a monumental challenge, and we've been working on it for 3 years now. And one of the fun and challenging things about working at StackBlitz is that we're often the first people to find bugs in browser engines, simply because we're pushing the absolute limits of what they can do. Like recently, we actually found a bug in Apple Silicon that's causing web apps to run way slower than they should be on Apple devices. And so we're working right now with browser vendors to get that fixed. And for us, it's all in pursuit of this instant, seamless experience that makes development now such a joy to do. And also, it makes development something that you can now do collaboratively in the same way that Figma did for design. And on that note, I'm excited to share that recently Figma became a strategic investor in StackBlitz. My co-founder and I have been friends with Dylan for a little over 10 years now. And so we've been pretty inspired about what he and his team did bringing design to the browser. And we're excited to have them now be a part of our journey in bringing development to the browser in much the same way. So on that note, we are hiring. If you're interested in pushing the absolute limits of what browser engines can do or making development instant and seamless, head over to stackblitz.com/careers because we want to chat with you. We want to hear from you. And I hope to see all of you on stackblitz.com/codeflow. And if you're into documentation and education, we actually do have one more thing for you. So I want to hand it over to Sylwia, who's going to give us the final update for the StackBlitz keynote.
Hi, everyone. My name is Sylwia Vargas, and I'm a developer advocate at StackBlitz. I spend a lot of time helping open source teams and companies make their documentation sites beautiful and interactive. StackBlitz is a popular choice. People use our JavaScript SDK to embed their projects on the documentation sites, blogs, and courses. Recently, Rich Harris talked about using our Web Container API to build the new SvelteKit tutorial. You may actually recognize the name Web Container API from a talk that Jutan gave earlier today at ViteConf. If you haven't seen that talk, go check it out later. Our Web Container API is still in private alpha, but we are working to release it to public soon. Soon you will be able to build these magical experiences yourself. We actually did. We used our Web Container API to build something that I am going to show you today. So I am trying to say that at StackBlitz, we know how to handle documentation. We know how to help you build amazing educational experiences. As a dev community, however, there is one issue that we didn't quite have a solution for until recently, until now. I'm talking about editing docs, about editing your content. It is a little bit frustrating because if you are introducing any changes, you have to run local dev server to see how these changes manifest on your page. That means that you actually have to clone the repo and you have to run the dev server. And if you were doing any work before, now you have to stash those changes, just like Eric said before. It is a little bit frustrating. Let me show you what I mean. This is our docs page that I want to edit. To see any edits that I just introduced, I need to run local dev server. That means that I need to clone the repository, run dependencies, and if I worked on something right before that, I need to stash all those changes. Just like Eric said, it's really frustrating. It's draining. It's a lot. There should be an easier way. So there is a workaround, kind of. Most documentation pages have this button that says edit this page on GitHub. Here it is. I'm going to click on it, and I see a Markdown file. There's a preview. But the preview doesn't look anything like my site. It doesn't look anything like my site. It doesn't help me. Even if I introduce some changes, it still doesn't help me. This is a frustrating experience because I never know what I'm going to get. It is already draining for me as a developer, but what about the non-technical folks? What about your friendly designer colleague or supportive marketing friends? What about them? They also have to update documentation, blog posts, or wiki. Wouldn't it be nice to have a real publishing experience? So we thought about that, and now that we have CodeFlow, and now that we have Web Container API, we actually could build something. Earlier today, Eric talked about pr.new. It is a handy URL that opens any repo. So maybe we could use it here. Let's try. Let's find that button again. All I need to do is to replace github.com with pr.new. And what's going to happen when I click on it? Can I click it? Yes, I can. And bam, Web Publisher, everyone. Web Publisher is a tool designed to make editing experience beautiful. You see there is a file, the Markdown file on the left, but there is also a real dev server running on the right. So let's see what happens if I write hello, hello. Oh, look at this. it updates in real time. Now you can see the changes you are introducing. Okay, so I wrote some changes. What's going to happen next? Well, I'm going to click on Propose Changes. And Web Publisher is going to do all the heavy lifting. It is going to commit, fork, and prepare a PR template. Now I can draft pull request and contribute to the docs. Oh, by the way, Web Publisher works with any framework. DocuSers, Next.js, SvelteKit, VitePress, it just works. But of course, we know that there's nothing like trying it yourself. So we build a page, ilovecodeflow.com, where you can go and experience it on your own. Go to ilovecodeflow.com and make a PR. Tell us what you think. Tell us why you think it's cool. Join others who really love Codeflow. On this page, you will also find all the necessary information to get you started and to integrate Codeflow into your workflow. I'm so excited for you to try it out. I've been using this tool for a few weeks now, and it's been magical. So let me know what you think on Twitter, on Discord, and yeah, enjoy. Thank you for listening.
everybody, how are you doing? I hope you are enjoying ViteConf so far. We've already had such amazing speakers and we got so much more cool content and amazing speakers lined up, so stay tuned. I'm here to introduce the next section, which is about design systems and monorepos. My name is Josefine. I'm a developer relations engineer at Storybook. And I actually thought it was super funny when I was asked to enter this section, because I was like, Storybook, they always get confused, and I thought that was really funny. Anyway, enough about that. But speaking of Storybook, our first talk for this upcoming section is by Ian VanSchooten, and he will introduce us to Storybook, explain how it solves common challenges of working with components, and he also has an exciting announcement of how Storybook will evolve to meet the needs of the growing numbers of Vite users. I learned about Ian that he is a senior front-end engineer at Defined Networking, maintainer of the Vite builder for Storybook, and he organizes the Southeast Michigan JavaScript meetup group. Besides his many accomplishments in the tech world, I found out that he and his wife are raising ducks and bees and actually selling the eggs and the honey, and they also have 2 human kids, but they haven't figured out how to make any money from them. After Ian, we got Hugo Attal, who is a software engineer and entrepreneur. He's also the founder of Luna Park HQ and a bunch of, in his own words, over-engineered projects. He will be telling us all about new ways to write stories with Histoire. Next up, we got Wojtek Mikshu, who will give us an introduction to Ladle. Ladle is a new Vite-based tool for developing and testing React components, and he will give us a demo of its many features and the goals behind it. I got a fun fact about Wojtek as well. He used to play competitive chess since he was a child, or maybe he still is, I don't know, we need to find out. And he also loves skiing, and it's his longtime dream to spend a winter in Japan. After that, we got Juri Strumpflohner. He will talk about high-speed monorepos with high-quality DX, and he will take us on a journey into the world of monorepos and how they can improve developers' lives, optimize speed, and increase developer experience. I actually thought the funniest thing about Juri's fun facts was that he wrote that he's not actually able to come up with any fun facts because it's quite late at night when he filled out our request for fun facts. And our last session for this section is by Zoltan Kochan. He actually loves spicy food. That was his fun fact. I kind of wish we were at an in-person conference so we could find out and test his abilities there. But that's not what he's here to talk about. He will tell us all about what makes PnP performant. He will also talk about the advantages of isolated node modules and some of the algorithmic differences between NPM, Yarn, PNPM, and what makes PNPM faster in some cases. So enjoy the next section and have fun at the rest of the conference.
What's up, ViteConf? I hope you've been enjoying all the great talks so far. My name is Ian, and I'm here to talk to you today about using Storybook with Vite. We'll talk about what Storybook is, why you might want to use it, how it fits together with Vite, and I've got some exciting announcements for the upcoming 7.0 release that I think you're going to love. So, why am I here talking about this today? Well, I've been a longtime Storybook user, and I chose to use Vite as the basis of our front-end tech stack at a young startup that I joined last year. Now, originally, Storybook only worked with Webpack, but I wanted to use it in Vite. Luckily, I found an experimental project from Eirik, which let the two work together, and I started using it and contributing to it, and now I've been helping to maintain it for the last year and a half. So before we jump in and start talking about Storybook, let's back up just a step and talk about components. Components are often the cornerstone of front-end applications and websites. We can think of them a little bit like Lego pieces because they allow us to quickly snap together pieces of UI because they have well-defined shapes and behaviors. But they come with a set of challenges as well, like coming up with the proper abstractions. Serious Lego builders have a term for pieces that can only be used in one way, SPUD, or single-purpose useless decoration. Keeping your components organized is also a challenge. Right? Mixing all of your Lego pieces into one bin makes it a lot harder to find that 2x8 gray plate that you just need to use. And finally, testing. Okay, my Lego metaphor is breaking down now, but testing components is hard. This is where Storybook comes in. They've been one of the big players driving component-driven development for a long time. They're currently number 55 out of the highest starred repos on GitHub. The reason it's so popular is that it helps solve those problems I just mentioned when working with components. It provides an isolated development environment for you to build your components and maybe even full pages inside of. It's a single place where your team can go and find the components that have already been built, and also some guidance on how to use them. And it gives you a lot of different ways to test your components to make sure that you don't accidentally break them going forward. Let's talk a little bit about how Storybook is structured so we can understand how Vite fits in. This is what a typical Storybook might look like. It's a separate app from the rest of your site, and it's made up of a few pieces. In the center here is a component from your app in what we call the preview. Now, this can be either built with Webpack or Vite. And when we talk about using Vite in Storybook, it's this piece here that we're talking about with the code that you're actually writing. And the rest of what you see on the screen here is UI from Storybook itself. So let's see what's there. We have a list of components and variations of those components in a list on the sidebar here. And those variations are what we call stories. And they might be things like empty states or error states, or different kinds of button states like primary or secondary. There are also hundreds of community and official add-ons that can extend the functionality of Storybook. And the ones that you have installed will show up in the add-on bar down at the bottom. And finally, the toolbar at the top has helpful buttons to change the viewport or background, or add outlines to the page, or more. Everything here in orange is part of the Storybook UI that we call the manager. And even if you're using Vite for the preview, this is bundled at runtime using Webpack. For now. Foreshadowing. Let's take a quick look at a non-trivial example of a story. You'll see here that at the top of the file, we're importing our component from its own file. And then we export it in a default export, and this connects it to Storybook and tells it which component we're writing stories for. And then each of the named exports is a story that will show up in the sidebar. So in this case, we're taking a look at what the button looks like when it's disabled. We can make it disabled using args, and then we can also give it a label of what shows up in the button. We can use parameters to control add-ons. So in this case, we're showing the story in a mobile viewport. And we can use decorators to wrap the story in things like maybe context, or in this case, we're just adding a little bit of extra margin around the button. Although it can get more or less complicated, this is all it takes to make a story. Which brings us back to the three main ways that Storybook can help us out, with development, collaboration, and testing. A lot of large companies like Microsoft, Shopify, and Adobe use Storybook as their design systems. So you might think that Storybook is just a documentation tool, but it can be very powerful to use during development as well. Building components in isolation from the rest of your app can improve their interfaces and help you make them more flexible. I know I think a lot harder about a components API when I'm building it out on its own rather than for a specific single use case. It helps keep me from building those Lego spuds. And sometimes we need to create components that the app just isn't ready for yet. I know when I get a design, I like to break it apart into small pieces, and I create the component and the story file at the same time. And I keep Storybook open while I'm building the component. And I add additional states like error states and empty states that the component might need as I go. And to get the component into those various states is pretty simple in Storybook as well. Now, for components that just take props or arguments, I can just write those into the story directly and see what the component's going to look like. And for more complicated components that might be fetching data from an API, I use Mirage.js to mock those responses. And MSW is another popular option that also has a Storybook add-on. So by changing the mocked API responses, I can see exactly how my component is going to behave without having to go through and trigger all of those states in my app manually. And of course, using Vite means you get near instant hot module reloading. Storybook is used by lots of large companies to share information about their components and their design systems. So what makes Storybook useful as a collaboration tool? Having a visual component library helps teams find existing components rather than building new ones each time. If you've ever worked on a large team or a large project, you know how easy it is to end up with 3 of a particular type of component just because nobody knew that one had already been built that would have met their needs. Now, you can get really fancy with documentation in Storybook using things like MDX, and for large distributed teams, that probably makes a lot of sense. But I also really like that Storybook will generate docs from the code itself. It'll find JS doc comments or TypeScript annotations, and it'll use those, which keeps the source of truth for the documentation in the code next to the component, while still surfacing it for those who may not be working in the code all the time. This makes it great for collaborating with others like product managers and designers and even other engineers. When my company hired a second front-end engineer, he found it really useful to poke around in our Storybook and see what components we had and how they functioned. And I also like to tag our designer in my PRs so that he can go in, open up the stories, and see if they're working the way that he designed them. I mentioned add-ons earlier, and there's over 500 of them, by the way. Some of the most popular are those which connect to design tools like Figma or Zeppelin. There's even a way to go the other direction and pull stories into Figma. Lastly, for those who want even more control over their documentation, a new portable docs experiment allows stories to be rendered into other React-based frameworks, like Rakkus, for example. By the way, that top image is from the Storybook component encyclopedia. Dominic from the Storybook team categorized over 6,000 components from over 100 public storybooks, and it's a great way to get inspiration and see what others out there are building. Component testing is notoriously difficult for a number of reasons, but including normally you need to set up some kind of state or data to get the component into the condition that you want to test. You need to have some way to trigger user interactions to verify the component is behaving the way you want it to. And debugging failing or flaky tests is tough when all you've got is a dump of the failing DOM state printed to the terminal. Well, with Storybook, you already have the components shown in different states with mock data in your stories. And we could add a play function in our stories to specify user interactions that happen when the story loads. We'll talk more about this in just a bit. And one of the most powerful parts of testing in Storybook is being able to actually see and inspect your component that you're testing in a real browser. So now, testing components doesn't need to be so hard. Storybook supports several different kinds of tests, but today I'm just going to talk about the two kinds that I use personally and that I'm the most familiar with, and that's visual snapshot tests and interaction tests. With visual snapshot tests, pictures are taken of your stories when a PR is submitted, they're compared against an earlier accepted baseline, and differences are flagged for review. And this can be the easiest way to get some confidence that the changes you're making in a PR aren't accidentally breaking the styles in other parts of your app. Now, I've used page-level visual regression tests in the past, and they were good, but it was always a little bit hard to tell sort of what had changed when halfway down the page, everything started turning red. And with more focused component level, story level tests, it's a lot easier to tell where the change actually happened. On the other hand, if you have good coverage of snapshots, and maybe you even include some pages as stories, you can make sweeping visual changes across your entire app without needing to worry about the crusty little areas like onboarding flows and error states that you always, kind of forget exist. An easy way to get started with snapshots is to sign up for a service like Chromatic. They're also the people who are behind most of the development work on Storybook itself. Or you can spin up your own infrastructure to do this, and there's some open source projects out there that can help you with that. Snapshots are great, but sometimes the only way to get a component into a particular state is to interact with it. If I have a form component, I might want a story showing what a validation error looks like. So I need to tap into an input, maybe type some characters, hit a submit button, and then capture the result. And this is where interaction tests really come in handy. Rather than invent a new syntax to learn, Storybook combines several popular tools into a powerful workflow. It uses testing library to target DOM elements the same way a user might find them, which not only makes them more resilient, but you might find that it also helps improve your accessibility knowledge. I know it did mine. To mock callbacks and make assertions, Storybook uses JestMock and Jest's excellent expect assertion library. Now, these are standalone libraries that Storybook uses without installing all the rest of Jest. When you're writing the tests, you may have Storybook open so you can see exactly what's happening in the browser. But once you're done with your tests, you'll want to be sure it also runs in CI, and that's where Storybook's test runner comes in. It was created by Jan Braga, who has been building a lot of the new testing features in Storybook, and it uses Playwright to spin up one or more headless browsers and run your tests from the terminal. For now, it's using Jest to start up the tests, but they're considering swapping that out for Vitest instead. And by combining together these awesome tools, Storybook makes it easy to start writing high-quality component tests. Next, let's take a look at what one of these tests actually looks like. Here's a real test from my own application that I wrote to ensure my client-side validation logic was working correctly. I wanted to be sure to show an error message if the form is submitted without an email, and that the error is connected to the input correctly for accessibility. Let's step through the code briefly so you can get a feel for what a story with a test is like. At the top is a default export, which gives Storybook some information like what to call this in the sidebar and what component the stories in this file are for. In this case, you'll see that I'm creating stories for an entire page, my login page. Storybook can also create this title automatically based on the file name and path. This named export is a story in the new, simpler CSF3 format, which is just an object typed as a story. Since this page expects to get some authentication information from context, I've added a decorator here that will wrap my story with a context provider using the value I give it. In this case, I'm telling the page that we don't have a logged in user yet. Now we get to the play function. This is where your user interactions and assertions happen. First, I'm pulling a few testing library query functions from the Storybook preview. Then I locate the input and button elements and save them to use later. I use testing library's user event to type a blank space into the input because I want to make sure that I treat that as an empty value too. You can see that on the right, the field is now focused and there's a space typed in. Next, I try to submit the form by clicking the Submit button. We see that an error message has popped up, and we could say, it did what I want, and let Chromatic take a snapshot in this state and move on. But I also want to test a few accessibility concerns, so I'll make some assertions. I want to verify that the error message is treated as an alert, and that it's read off to screen readers. And I want to make sure that the error message is properly associated back to the input. Notice I'm using the to have accessible description here, which is one of the super helpful matchers that are added by Jess Dom and is automatically included in Storybook testing. So now in these few lines, I not only get a thorough test of my form validation logic, but if I'm using Chromatic, I get a visual snapshot in case I ever make CSS changes that break the styles here, and a story that others on the team can check out to see what it looks like when this form has validation errors. So if I've convinced you to give Storybook a try, how do you get it set up and running with Vite? Well, the package that lets you do this is called Storybook Builder Vite, and it's the one that I help to maintain. The easiest way to get up and running in a project that isn't already using Storybook is to run npx sb init with a builder equals Vite flag to make sure that the Vite builder is used. I also recommend going to the README on the GitHub to check more information about how to set things up or to migrate over from a Webpack-based Storybook. And of course, feel free to open issues if you hit any problems along the way. Now for the exciting part. All of the Storybook features I've talked about today work right now with the Vite builder. But the last breaking change of Storybook was 2.5 years ago, and a lot has changed since then. A lot of that due to ESBuild and Vite itself. Storybook has supported Vite experimentally for 1.5 years, and we've learned from the issues people have had and the features that they've asked for. So let me introduce Storybook 7.0, the latest Storybook release and the first that's being built with Vite users in mind. Let's talk about some of the big changes you can expect to see. Storybook has had the concept of frameworks forever, React, Vue, Svelte, etc., but it turned out not to be the right level of abstraction, because those frameworks also included things like Webpack config. So now renderers have been broken out as only those parts dealing with rendering to the DOM, and frameworks encompass the combination of renderer, builder, and configuration. This will allow us and the community to create frameworks much more easily that can be used out of the box without requiring users to override a bunch of config. I've got to give a shout out to Michael Schulman and the rest of the Storybook team for the work that they put into this refactor. I think it's going to be huge. Another big change, thanks to heroic efforts from Norbert, is that Storybook is now pre-bundling its manager UI. In the past, it would install packages like Emotion and React Router that it used internally into the user's node modules, and that could conflict with versions that they already had there. Now instead, a tool called TSUp, which is powered by ESBuild, is being used to pre-bundle our packages. That means that Storybook won't need to build itself each time it starts up, and if you're using one of those Vite-based frameworks that I talked about just a minute ago, Webpack will be nowhere to be found in your node modules. That's right, we heard you asking for this loud and clear. Speaking of node modules, I checked the install size of 6.5 and compared it to a recent 7.0 alpha version, and 7.0 was 44% smaller. And we're still working on paring that down even further. Startup time on a new project was also about a quarter of what it was before. Up to now, Storybook has been a bit tricky to configure because you had to pull in your Vite plugins and your aliases and other config. But in Storybook 7.0, we'll read your vite.config file and use that as a base while still giving you control over the final merged config. This means it'll be a lot easier to get up and running, and it'll help avoid subtle bugs that are caused by your app's Vite config differing from your Storybook config. And we're still working on some other improvements that I think Vite users will really appreciate. We plan to have better PNPM support across the board. Storybook already supports Svelte native story files, but some of the Storybook features like the test runner don't work so well with it. But a Storybook developer named Jeremy is spearheading improvements, and we want to make sure that Svelte developers have a top-notch experience in Storybook. Now that Storybook only supports modern browsers and Node 14 and above, we'll be able to clean up some polyfills and old dependencies. And now that frameworks are easier than ever to add, I expect that Storybook and the community will add many more over the weeks and months to come. Storybook 7 is not yet stable, and some breaking changes may still occur. If you're feeling a little brave, we'd love for you to try it out and give us feedback. If you do, be sure to check out the migration guide if you're coming from an earlier version, and on the official docs site, choose 7.0 for the version and whatever framework you're using. And of course, if you have questions or suggestions, you can find me on GitHub and both the Storybook and Vite Discord at IanVS, or on Twitter at IanVanSchooten. Thank you so much for your time, and I hope you enjoy the rest of ViteConf.
Hey everyone, welcome to the short presentation of Histoire. So yeah, you pronounce it Histoire. It's a French word for story. We quite like French name in the Vue ecosystem, all part of a big plan to make you learn French. Anyway, what is this all about? Histoire is a tool to write stories, but what is a story? So a story is just a small set of UI components displayed in an isolated environment. And this can have a lot of benefits. For example, when you want to build some kind of component for your application, you don't have to mine off the context. You can extract the component to a story, then focus on the features you're building without mining about the integration. And when everything's done, you can import your components back into your application anywhere you want. Another cool benefit is that you have all your components organized in a centralized library so that anyone in your team can see what components are available to them and how they can use it. Because you can document the features of your components so that a developer can see what arguments each component has, any slot they have, and they can tweak those values in real time right into your browser to see how they react. You can also showcase some different use cases of those components using what we call variant. Lastly, you can test your components so that you make sure you don't have visual regression during the development of your application. But why Histoire? There are other frameworks to build stories. What makes Histoire different from them? Well, the first thing is that Histoire is native to Vite projects, so it's super easy to install. You just have to install the package, and by default it will look up for the Vite configuration file of your project, so you can make it work without any configuration whatsoever. It's also blazing fast because it's using Vite, so you have milliseconds to start the servers, and then you have instant automated reloads thanks to Vite. It's also super easy to learn. Stories are basically Vue single file components ending with .story.vue, so there's absolutely no surprise. You can see a lot of examples on the documentation website. It's also feature complete because you have a ton of features to test responsive design, to test your custom events, to save some custom states. So everything is ready to use without any need for any third-party plugin. And lastly, it's 100% customizable. You can customize the look of your Histoire application so that it can match your brand theme, your brand logo, anything. Here's a super simple example of a story file where you just have to put your component there, just like in any single file component. And if you need a reactive state, you can put controls under the control slots here. And there are pre-built controls components like this Histoire text, but you can put anything under that slot. So let me show you some of the cool features from Histoire, starting with the most useful features ever, the dark mode. Then you have the search bar to quickly access your story. Here you have a grid layout with several variants. If you click on one, you can update it, and you see that it's automatically reacting on the browser. You can, of course, copy paste the generated code to be used right into your application. Also, you can notice this little bot. It's meaning that these props are automatically detected from the components, so you don't have to manually create those. Then you have a lot of controls to manipulate your props, some kind of slider, some kind of radio, some kind of selects, etc. You can also save the states, the updated states, so that you can quickly toggle between the initial states and the state you just saved. If you have some kind of tailwind setups, Histoire will generate a bunch of super cool documentation for it. You can also write documentation for stories in Markdown. It will appear here. You can test the responsiveness of your components using these sliders, and there's also a lot of presets to change the resolution you're testing. There's also events that you can display here. You can change the background colors. You can use checkerboard. There's a ton of features. I only have so much time to show them all, so I think I will stop there. I'm Hugo, and I've been building Histoire with Guillaume. And truth is, he built 90% of it, and he's awesome, so go sponsor him on GitHub. Also, anyone up to contribute to Histoire is welcome, so feel free to join our Discord. If you want to dive deeper into Histoire, be sure to check out our post-conference talk with Guillaume, where I'll explain a lot more cool stuff. Thanks for listening.
Let's talk about Ladle. Hello everyone, my name is Wojciech and I work on web infrastructure at Uber. Today I'm going to show you an open source tool we use to develop and test React components called Ladle. Ladle is an application that loads your components through stories so you can work on them in isolation. Let's jump into the demo. Our folder is empty, so first we need to initialize our project. And we need to add some dependencies as React, React's DOM, and Ladle. By default, Ladle looks for your stories inside of the source folder, and it looks for files ending with .stories.tsx, so let's create one. Stories are also just components, React components that need to be exported. Let's create story named first that exports a heading. And now we can start ladle with command serve. It starts immediately thanks to Vite. On the left side, you can find your component, and on the right side, there's navigation that lists all the stories discovered by ladle. By default, it's using file names and export names to create this navigation, but that can be also changed programmatically. Let's add some more stories to demonstrate other features. This story has an accessible button. You can run accessibility check with X if you click on this button. And now it tells us there is one violation. The element doesn't have sufficient color contrast. Another feature is useful when you need to test responsiveness. You can change and switch between different viewports. The default value can be set through the parameter .meta. Sometimes it might be useful to display different variations of your components. There is a feature called controls for that. In this case, we can change the value of size and we can switch between 3 different values. And this is how it looks inside of the code. It's using argument.archetypes where we specify the variable and the options, and then it's being passed back to the story as a prop. There's a feature actions. You can pass a logger into attributes such as onClick. So when you click on your button, ladle gives you a nice log where you can see the details about your event. Action is a function that's being exported from ladle. And there are some additional features at the bottom. You can switch between light and dark mode. You can display your component in full screen. You can switch between left to right and right to left. And you can preview the source code of your story and also its location. And finally, ladle exposes endpoint meta.json that gives you structured information about your stories, including things like IDs, and this can be extremely useful for further automation and testing. So what is ladle? Ladle is built on top of Vite. It's a Vite plugin, React UI, and CLI in one package. And here are some guiding principles and reasons why we built it. We want to have instant server startups and very fast incremental updates. Sounds familiar? Ladle is all in one package, so you will never run into dependency versioning hell. There is no initial configuration, but you can still add global decorators, load additional style sheets or fonts. Ladle implements component story format, pioneered by Storybook, and in fact, it can work in place of Storybook. We also deeply care about Monorepos support and programmatic APIs, because that's how we use it. Ladle was launched earlier this year, and so far it got great feedback from the community. So please join us, give us a star, and thanks for listening.
Vite is really all about speed, and in particular the speed of local development. So Vite's approach to serving your app locally is really innovative and leads to a really fast feedback loop that can help you speed up your development quite drastically. Now, this is just one aspect of the overall development speed, however. In a real-world scenario, we rarely develop in isolation, quite contrary. So we work in an ecosystem of different applications, of different usability and utility libraries that need to work together and that depend on each other. And these come with different versions that need to be coordinated, maintained, and guaranteed in terms of backwards compatibility. Now you can imagine that such a coordination overhead can sometimes really slow down the development process in terms of shipping new features, even though the local app builds are super fast. And this is where often monorepos come to the rescue. So in a monorepo, we really just take our applications, libraries, and packages and group them into a single Git repository. As such, we can already start leveraging and reusing common functionalities such as our CI setup, for instance. But most commonly, what is really useful is that we can easily add new projects and in particular share their features by just linking them locally rather than having to publish them somewhere. And you can imagine how easily you can now see in a single PR how a given change affects the entire set of applications and how those changes propagate throughout the app ecosystems. But what about the speed aspect? Even though our single application is super fast thanks to Vite, as we keep adding new projects to our monorepo, our speed might suffer quite a lot in terms of CI speed. And this is obviously not acceptable. So in order to keep that scalable, this is where you need some proper monorepo management tools. And so getting started is quite easy and should totally be easy. In the case of NX, for instance, you can just npm install the NX package to an existing npm pnpm or yarn workspace, and you can already incrementally adopt it and benefit from the improved speed. But the real challenge lies in keeping things enjoyable in the long run. So once that initial hype is over, questions come up such as how to set up a proper end-to-end system into the monorepo of applications. How do the TypeScript versions among the different monorepo packages work? How do I easily share the code? How do I make sure it works even in like a year? So NX automatically analyzes your workspace, and it even allows you to visually debug and inspect that. Now that information is also being used to understand, for instance, which projects got affected by a given PR, and thus obviously it allows to reduce the amount of projects that need to be computed. On top of that, it also comes with an advanced caching layer, which is local by default. And so, for instance, rerunning the same command will just result in restoring the cache result and obviously be much, much faster. The real benefit from that, you get it when you connect it and distribute that cache by using, for instance, NX Cloud. In that case, you can pull down the cache remotely and thus also improve the speed of your CI system. Additionally, NX Cloud gives you insights into your run, into whether it was local or remote cache hit, and additional logging information. But caching is just one aspect. You can even use the integrated Visual Studio Code extension to generate a fully automated and distributed CI setup, for instance, for GitHub. This also nicely integrates into your PR as a comment, and by clicking it, you can even inspect how the current run is being distributed across multiple different nodes. The parallelization of those tasks is done in the most efficient way possible, also taking the CPU utilization into mind and historical data from previous runs. And so having things like a visual exploration of your dependency graph, having a powerful plugin system in place that allows you to not only quickly set up a new monorepo, but also helps you keep going and make sure those tools are integrated in a nicely and pre-configured fashion. And obviously also things like having a dedicated Visual Studio Code extension that allows you to easily navigate within your monorepo are of immense value. My name is Juri Strumpflohner, and I currently work at a company called Narwhal, where we build and maintain the open source toolkit NX and most recently also Lerna. We have years and years of experience of helping some of the biggest companies in the world set up their monorepos in an efficient way. So our mission is really to make monorepos approachable, fast, but especially maintainable in the long run for everyone. And we do this through open source. Sounds interesting? Then definitely join us, follow us on Twitter, or join our community Slack. Thanks for watching.
Hello, today I'm going to talk about PNPM and the reason it is so performant. My name is Zoltan Kochan. I live in Ukraine. Currently I work for Vite on dependency management. Before that I worked for Just Answer for about 9 years. And since 2016 I'm the lead maintainer of PNPM. Before talking about PNPM, let's briefly talk about other Node.js package managers. So NPM was the first one, and it is the most popular one. In the past, it used nested node modules directory structure, but this structure had many disadvantages. Like, for instance, many packages were duplicated inside node modules, and also because it used nesting, the directory were sometimes very deep, and on Windows there was there were Windows long path errors. In order to solve these issues, the NPM team came up with an alternative node modules structure that they called a flat node modules or a hoisted node modules, and they shipped it in NPM version 3. Around that time, Alexander Google came up with an alternative approach to fix the issues of nested node modules. His idea was to use symlinks. So symlinks allowed to create like virtual nesting without actually nesting directories into each other. This idea was then borrowed by Rico Stackruz, and he created PNPM using the same approach. And recently afterwards, I have joined PNPM, and since then I'm maintaining it. A bit later, Yarn was made public, and Yarn was created by Facebook to solve some other issues of NPM, like non-determinism and speed. NPM is the official package manager shipped by Node.js. In the past, it had many issues, as I said. It was non-deterministic because it did not have a log file. It was extremely slow, and it had no Monorepos support since very recently. In the past, there were many jokes about the unreliability of NPM. Facebook created Yarn. Since then, it is maintained by the community, and they have solved a lot of the issues of NPM. And I think it was the best package manager for some time. In V2, they came up with a radically new approach to solve some of the issues with node modules. They introduced plug and play, which is on by default. This is a very interesting technique to manage dependencies. Some love it, some don't. Since version 16, Node.js ships Yarn with Corpec, as well as PNPM. So if you use Node.js 16, you can run Corpec enable, and both Yarn and PNPM will be available in your CLI. PNPM was created completely by open source contributors. It was developed around the same time as Yarn. So it's not a new package manager. It's as old as Yarn. It was actually public earlier than Yarn. PNPM is supported by a lot of great companies. For instance, I work for Bit now, and a lot of my day-to-day tasks are related to PNPM. And as I said, it is shipped by Node.js through Corpec. So it's kind of official as well as Yarn as well. It has some legitimacy to it. PNPM gained a lot of popularity in the last 2 years. As you can see, the number of downloads steadily increases. And this year we already have 3 times more downloads than last year. And we have a lot of big, well-known companies that use PNPM. So let's talk about this node module structure that is created by PNPM. As you can see on the left, when you have a project that has only one single direct dependency, Express version 4, if you run npm install and you open your node modules directory, you will see all these different packages there, even though they are not in your dependencies. This is because npm hoists all the indirect dependencies. And if you run pnpm install and you open node modules, you will see only those 3 files, .pnpm, .modules.yaml, and express. And 2 of these files are actually hidden files. So you will only get your direct dependency in the root of node modules. As a result, if you will import cookie in a project maintained by npm, your code will work because cookie is hoisted to the root of node modules. With PNPM, this won't work because cookie is in some secret place where I will show later. But this is a very dangerous situation because if you will use cookie but you won't add it to your dependencies, it might happen that Express in some newer version, in a new patch version, will stop using cookie. And as a result, it won't be hoisted to the root of node modules. And your code will break, even though you did not change anything. With PNPM, this won't happen because you won't be able to ever require dependencies that is not in your dependencies. But where is cookie if it's not in the root? So actually it's hidden inside this .pnpm folder. PNPM places all the dependencies, direct and indirect, to a flat directory structure inside .pnpm. And the dependencies are linked into these isolated sub-node modules folders using symlinks. So actually the express that you see in the root of your node modules is just a symlink to this hidden express folder inside .pnpm. And cookie, which is a dependency of express, is symlinked to the dedicated node modules folder of express. This isolated node modules is very, very good for monorepos. With monorepos, if you use a hoisted node modules, your project will be able to use not just the sub-dependencies of your dependencies, but also any dependencies of any other projects. As you can see here, both foo and bar have one dependency, and both of these dependencies are hoisted to the root node modules folder of your monorepo. So as a result, bar will be able to import dep of foo, even though it's neither a direct nor an indirect dependency of bar. So once you release bar and someone will install it, it will break immediately. With an isolated node modules created by PNPM, this is not a problem because you only get your direct dependencies symlinked to node modules, and nothing is actually hoisted to the root node modules folder of your monorepo. All the sub dependencies are hidden inside this .pnpm folder. So foo will not be able to require dependencies of other projects in the monorepo. You might ask why other package managers don't use this approach. Well, actually, npm wants to add the pnpm styled node modules directory as an opt-in because of this issue with monorepos. But this approach has some disadvantages currently because some tools don't like symlinks, like React Native doesn't work with symlinks at all. And many packages in the ecosystem are published with this broken import statements that import indirect dependencies. So this strict node modules breaks many packages. However, PNPM has some workarounds, so you will never have the third issue. And if you have tools that don't work with symlinks, then you can use the node linker hoisted setting, and PNPM will create a traditional hoisted or otherwise known as flat node modules. So PNPM has you covered. You can use it with any kind of project. And, another issue, another reason PNPM is so performant is because it uses disk space very, very efficiently. You might have noticed that your node modules consumes a lot of space when you use npm or yarn. And if you have like 10 or 20 JavaScript projects on your PC, then your dependencies might consume like 10, 20, 30 gigabytes of disk space. This is actually not an issue with PNPM because PNPM uses a central content addressable storage to link the files of your dependencies to node modules. A content addressable storage is basically a directory where files are stored at locations calculated from the contents of these files. This means that, for instance, if you have 3 versions of a single package, and all of these versions of the package have a file with no changes, then PNPM will actually write this file only once to the disk and point. And anytime these packages are installed, it will not create a new copy of these files. PNPM will just create a hard link to a single location in the content addressable storage. So actually, inside your node modules, inside this virtual store, every file is just a pointer to a location in the central content addressable store. As you can see here, like we have project A and project B, and some of the files in these two projects are the same. So they point to the same location on the disk. So we don't have two copies of a file. We have only one copy of the file written to the disk. As a result, when you each time you run pnpm install in a new project, pnpm consumes just a little more space on your disk, unlike npm or yarn, which don't use a content addressable store by default. So you can see on the first install, pnpm uses around the same amount of disk space, but in a subsequent project, when you run pnpm install, it will not consume that huge amount of space again, because the files are already in the store and pnpm just creates new hard links, not copies. Actually, Yarn started to use a content addressable store as well as an opt-in feature for now, and they plan to make it on by default in the next major version. If you have looked at our benchmarks, you might have noticed that in some scenarios pnpm is several times faster than npm and even faster than yarn. The reason pnpm is faster is because it uses a different algorithm to resolve and fetch dependencies. So both npm and yarn have separate stages for installation. At the first stage, all the dependencies are resolved. On the second stage, all the dependencies are fetched from the registry. And at the last, third stage, all the packages are written to node modules. Unlike npm and yarn, pnpm doesn't have these separate stages. It actually tries to do everything concurrently at the same time. So when it resolves a package, it immediately starts to fetch it from the registry. It doesn't wait for all the other packages to be resolved. This is very efficient. So, and when it starts to write files to node modules immediately when the last package is resolved, but it doesn't wait for packages to be fetched. Some packages are still being fetched, and some others are already written to node modules. You might ask why other package managers don't use this technique. Well, this algorithm actually is very complex, and probably some package managers prefer to be a bit slower, but to have code that is easier to maintain and easier to learn for new contributors. And some of the speed improvements are, of course, possible because we use a content addressable store and because we use a different node modules directory structure. Now this is all about pnpm speed, and I just want to mention probably not widely known feature of pnpm. You can actually use pnpm to manage Node.js versions. So you can use pnpm instead of nvs or nvm or volta. There is a command pnpm nviews, which you can run to install Node.js. So for instance, if you want to install Node.js 16, just run pnpm and views -- global 16, and you will have Node.js 16 in your CLI. pnpm has lots of features. You can open up our website, pnpm.io, and open the feature comparison page. You will see this table where you can see that we have implemented almost all the features that Yarn or NPM have. And we have even features that neither Yarn nor NPM have as of now, like side effects cache or managing Node.js versions. Thanks for listening to my presentation. Please visit pnpm.io, give our repository a star, and also follow us on Twitter at pnpm.js, and follow me on Twitter. I'm Zoltan Kochan. Thanks. Bye.
Sup nerds, Theo here. Can't wait for today's stream. We got a lot of exciting stuff to... Oh, sorry, my phone's going off. Yo, Patak, what's good? Wait, I'm not streaming? I'm not even live? This is an intro for a talk for... What? ViteConf? Like the framework? Oh, it's not a framework. It's a meta framework. That's what we're talking about. Really interesting. Who's speaking? Oh, we got Rich Harris, the creator of Svelte, up first, immediately followed by Daniel Rowe talking all about Nuxt and how they're making things like Next.js possible in Vue. Then followed by an Angular talk by Brandon Roberts. What? Angular and Vite? Are you sure? No, next you're going to say you're going to have Nate Moore up for Astro. What? Nate Moore is going to come up and talk about Astro? That's weirdly convenient. Like, what's left? You haven't talked about React. Oh, of course. Right after that, we have Rakus and React stuff by Fatih. That makes a lot of sense. Well, thank you for the heads up. Sorry, I thought I was streaming. The easy mistake to make when you're live all the time. But yeah, thank you for the correction, Patak. I guess we're talking about frameworks. I guess I'm not talking about frameworks though. So get excited for these talks. Really hyped for them. And super pumped I got to be here. If you want to talk more about JavaScript stuff, I'm live every Wednesday at 1 p.m. But it's way less cool than what's going on here. So can't wait to hear these talks. Thank you all again. Should be good.
Hello, Vite friends. My name's Rich. I'm the creator of the Svelte framework, which I work on full-time at the Cell. Now, when I shared on Twitter that I would be speaking at this conference, I did so with a tweet comparing Vite to the United Nations, because it's kind of a place where different projects can come together to advance the common good. But I actually think that misstates the role that Vite has in the ecosystem. I think it's something more fundamental than a deliberative body. I think of it as providing missing infrastructure in the JavaScript ecosystem. Infrastructure usually isn't very exciting or sexy, but it's what allows societies to be built and become prosperous. So Vite is less like the UN and more like, say, the Department of Transportation. Now, the thing about infrastructure is that it needs effective government and professional maintenance, which unfortunately is where a lot of open source projects fall down. And that's one of the reasons that I'm so excited that this conference is happening today. It's a mark of how well supported and established Vite has become, and the diversity of projects that are represented here gives me a lot of hope that that will continue to be the case for a very long time, which is essential for those of us building things on top of Vite. So, about that, like most of the speakers here today, my unstated purpose is to try and convince you that you should be using the thing that we're building on top of Vite. Vite and SvelteKit have been intertwined for a long time. In many ways, they've grown up together and have informed each other's design at critical points. Many people on the Svelte core team are also Vite contributors, so suffice to say that we're invested in Vite's success. I'm sure some of you have heard of Svelte and SvelteKit, but a lot of you probably haven't, so I'm going to begin by explaining what those projects are. Svelte is a UI framework that's been around since 2016. Like other UI frameworks, its job is to let you write your application in a declarative, maintainable fashion using components. The big differentiator is that Svelte is first and foremost a compiler, which means that component authoring doesn't come with the same set of constraints that are associated with most frameworks. And because of that, we're able to write components in a very concise, expressive way while still resulting in incredibly efficient applications for our users. And people really love using Svelte. Among respondents to the most recent State of JavaScript survey, we have the highest satisfaction scores of any front-end framework jointly with Solid, and with a framework that the largest number of developers wants to learn. If you're one of those people, it's very easy to get started. Using the instructions on svelte.dev, just run this command, which will create a Vite project using Svelte, and you're off to the races. But there's a catch. At some point, as you're building your application, you're going to run into a whole bunch of questions like, how do I structure my source code? How do I add client-side routing? How do I add server-side rendering, which is really important for performance, resilience, and search engine optimization? Given that we have server-side rendering, how do we add server-side routing, ideally in a way that doesn't mean duplicated work? How do I load data in order to render it? As well as getting data from the server to the client, how do I get data back from the client to the server? How do I handle environment variables, including secret ones, sensibly and securely? How do I prepare my application for deployment to a wide range of possible environments, static files, node servers, serverless functions, edge functions, and so on? Now, a component framework like Svelte cannot answer these questions. It's not its job. And it turns out neither can a tool like Vite. Because Vite, as we've talked about, is this infrastructural layer, and infrastructure almost by definition has to be relatively unopinionated so that it can support the widest range of possible use cases. And this is where an application framework like SvelteKit comes in. SvelteKit answers all of those questions for you so that you can spend your time on the creative and unique parts of your app. We've been working on it for 2 years with a very energetic community helping us figure out the right answers to those questions, and we're really happy with how it's shaping up. It is pre-release software in a release candidate phase, which means that we're almost feature complete and don't expect any more breaking changes, but it's not yet quite done. In spite of that, we're about to cross 100,000 downloads a week, which is a really cool milestone, not so much as a vanity metric, but because it means that if you choose to use SvelteKit, you'll be in a club of people who are all building apps in a fairly similar way and can share knowledge and support one another. So let's take a look at a SvelteKit project. It's very easy to create one. Just do npm create svelte at latest and follow the prompts. We'll create a new app called ViteConf demo and add TypeScript and Prettier. I'm not going to bother with tests and stuff for now. Install dependencies with pnpm because pnpm is cool, although you can of course use npm if you prefer slow things. Then we can pop the hood and take a look inside. The first thing you'll notice is our Vite config, of course, because this is just a regular Vite project. We're using the SvelteKit plugin, but we can add whatever else we need for our project. All of our Svelte configuration goes in this svelte config.js file. We have a preprocessor for TypeScript and the default adapter, which will let us deploy to various platforms with zero manual configuration. This is also where we configure Vite plugin Svelte, so I'm going to add the experimental inspector option. Now, if we start at the development server, it'll show us the welcome page. We can check that JavaScript is working by fiddling with the counter. And if we want to accept the invitation to edit this page, We can bring up the inspector with Command-Shift, select the element we want to edit, and our editor opens right up to the right place. Obviously, we're using hot module reloading, so we get that nice zippy feedback. Let's take a look at this +page.svelte file. As the name suggests, this adds a page to the app, and because this file is in the root of our source/roots directory, this is our root page. The plus prefix is slightly unconventional, but it works really well to differentiate root files from everything else, which makes it really easy to organize our code, unlike frameworks where every file inside the roots directory is assumed to have some greater significance, so you have to put single-use files in a completely separate directory for no good reason. It also makes it very easy to navigate around the codebase. For example, if I open the Go-To menu and type a few characters, I can immediately see all the pages in my app. So, back to the root page. If you haven't seen Svelte code before, hopefully this is fairly self-explanatory. It's a superset of HTML, so any valid HTML is also valid Svelte code. There are some things in here that you won't find in HTML. These JSX-like curly brace expressions, for example, or this child counter component with a capital C. These are coming from the script element at the top of the page. You'll notice that we're importing .png files. This is a Vite feature that turns static assets like images into a hashed URL that can be cached forever, so our users only need to download them once. We're importing them from the $lib alias, which maps to the source/lib folder. This is a great place to put things like images or components and modules that are used throughout the app. At the bottom of the file, we have styles for our page. You'll notice that we're using Verita selectors because these styles are scoped to this component, meaning we don't need to worry about selectors matching elements elsewhere on the page. There's also this companion +page.ts file for fine-tuning the behavior of the page, which in this case contains a single line, export const prerender equals true. We'll come back to that later on. We have another root file in this directory, +layout.svelte. This contains the stuff that's used on every page, like the navbar and the footer. We're also importing some global styles, which aren't scoped to any individual component. Layouts in SvelteKit can of course be nested, though we don't have any nested layouts in this app. If we navigate to the About page, you'll see that it's really instantaneous, and that's because even though SvelteKit server renders your pages like a traditional multi-page app framework, unlike a multi-page app framework, you don't need to go back to the server and get a whole new page every time you navigate. Instead, SvelteKit will just get the code and the data that it doesn't yet have. You don't need to get the head content and the navbar and the footer because we already have that stuff. In fact, we don't even replace those elements. We only replace the bits that have actually changed. By contrast, if you do a full page reload, then not only do you need to download a bunch of unnecessary data on every navigation and replace elements that haven't changed, you also need to rerun any scripts you have on the page. And we all know that things like third-party analytics scripts, which are largely outside your control, can get a little bit chunky. We have another trick up our sleeves to make navigation feel super snappy. This is our app.html file, which determines the overall shape of the response. You'll notice that on the body element, we have a data SvelteKit prefetch attribute. That means that every link inside that element will be prefetched as soon as your mouse comes to a rest over it, or on mobile, as soon as you touch it, which gives us enough of a head start that navigation usually feels instantaneous, even if you have to load some data from the server. And by the way, we're just using A elements for links instead of framework-specific components, which means that you get client-side navigation and prefetching even for links that come from a CMS or something like that. So far, we've seen that SvelteKit gives you a way to structure your source code that also configures your routing, both server and client-side, and gives you server-side rendering out of the box. What about data? For that, we need to look at the final page in the demo app, which is a Wordle clone called Sverdle. If you haven't played Wordle before, the goal is to guess a 5-letter word. After each guess, the game tells you which letters are in the right place, and which letters are right but in the wrong place. What's interesting about the original Wordle is that it's a purely client-side app, including all the answers, which means that it's really easy to reverse engineer it and cheat. Now, I think that encouraging cheating threatens the very fabric of society. So in our implementation, all of the game logic lives on the server instead. A nice side effect of that is that the browser doesn't need to download all 13,000 or so possible answers. Another really cool feature is that because the logic lives on the server, we don't actually need JavaScript at all. If it's disabled or fails to load for some reason, you can still play the game. We just use a tiny bit of client-side JavaScript to make the game smoother and more instantaneous when it is available. Now let's take a look at the source code. This time, instead of pluspage.ts, we have pluspage.server.ts. Anytime you add .server to a file, you ensure that it will only run on the server. This load function is responsible for getting data from the server to the page. In this case, it reconstructs the game state from the user's cookies or creates a new game, then returns an object with 3 properties: the guesses that have been made so far, the encoded answers that show which letters are correct, and, if we lost the game, the revealed answer. Below that, we have what are called actions: an update action for updating the game state in response to a single key press, an enter action for guessing a word, and a restart action that just deletes the cookie so you can start over with a new game. You'll notice that this data handling stuff lives in a different file to our UI code. That's very deliberate. Some frameworks encourage you to put your server code and your UI code in the same file, but we think this is very misguided. Our experience has shown that when you do that, people get very confused about what code can run where, and it becomes frighteningly easy to do things like accidentally include sensitive code in your client-side bundles. Having this clear separation is really important. So what's on the other side of the fence? Again, we have a pluspage.svelte file, but this time it accepts some data, and if we hover over that, we'll see that it's the return value from our load function. That information comes from this types file, which SvelteKit creates for you behind the scenes. After the data, we have some reactive statements and a couple of event handlers, and then the real fun starts. This form element is what makes everything possible. It posts the data from these input elements to the enter action, which updates the game state. By adding this use in hand snippet here, we can submit the data and update the page without doing a full page reload, so it feels like everything is happening in the page. And we haven't had to write a single line of fetch code anywhere. This is all just HTML. We don't even have a capital F form component, we're just using the native HTML element. Further down, we have the buttons that let us interact with the form. The first button submits the form if we have a word to guess. These next 2 buttons have a form action attribute, which tells the form to post to the update action instead of the enter action, though if JavaScript is available, then we modify the game state client-side using this update event handler rather than making a trip to the server. Now, some of you might be more used to using the fetch API to communicate with your server, but I think you'll find that when you start to do things in a more HTML native fashion, things start to click together really nicely. I just want to show you what happens if we were to accidentally import the word list into public-facing code. We add the import, and the page immediately breaks with an internal error. We can customize this error page, of course. We can create a +error.svelte page, either for specific routes or for the app as a whole, but in this case, what we really want to do is get rid of the offending code. This also applies to environment variables. Suppose we don't want to have this cookie name hard-coded in our pluspage.server.ts. We can create a .env file and add an environment variable called cookie name, and then replace all the occurrences in our code. You'll notice that it auto-completes and automatically imports this env module. This variable isn't public, so just like with our word list, if we try to import it into public-facing code, it will cause an error. If we do want to make environment variables accessible to public code, we just add a public_prefix like this, and now we're able to console.log it inside our page. So we're doing pretty well on our bullet point list. All we need to do now is deploy our app. By default, SvelteKit apps include an adapter that will automatically configure your app for certain popular platforms like Vercel and Netlify, and we plan to add to that list over time. For now, let's deploy our app to Vercel. That was pretty easy, but there is one problem here. By default, at least today, Vercel apps are deployed as single region serverless functions. In our case, that's not ideal because we're not loading data from a central server. It would be better if we could run our game logic at the edge so that you get very fast responses wherever you are in the world. To do that, I'm going to install Svelte.js adapter Vercel, swap out the auto adapter, and add the edge true configuration. Now, when I redeploy to production, my app is going to be served by edge functions instead of a Lambda, making it much faster. Of course, for the home and about pages, we don't actually need to run any code at all because they're always going to be the same. And that's where this export const pre-render comes in. When a page has that configuration, SvelteKit will generate HTML at build time, and it won't bother including code for it in your server functions because no code is faster than running no code. So that last part was a bit of an ad for Vercel, but SvelteKit can run anywhere JavaScript runs, so you can use it with your stack of choice, including to static hosts like GitHub Pages if your app is suitable. Okay, that was a super brief intro to SvelteKit. We've barely scratched the surface of what the framework can do. We haven't talked about how it protects your users from cross-site request forgery attacks, or how it enables you to set up robust content security policies, or how it helps you deal with new versions of your app while your users are still using the old one. But hopefully it's given you a bit of a sense of what it's like to work with. If you're interested in learning more, come see us at github.com/svelte.js/kit or on Discord at svelte.dev/chat. Thank you for watching, and I'll see you around. How do I stop this thing?
Hello, my name is Daniel Rowe. I'm one of the team working on building Nuxt, and I'm here today to talk about how Vite makes Nuxt possible. It is a real pleasure to be looking around and seeing so many interesting speakers representing many different frameworks, and to be here as part of a growing body of people using Vite to build amazing things. So it feels like a family in lots of ways, and I love learning from everyone else, and thought it would be helpful to share maybe a little bit about how we are using Vite in Nuxt. First, just a quick word about myself. My background is that immediately before I was part of the team working on Nuxt itself, I was heading up a small software as a service company, building our product with Nuxt. And really, from my perspective, that's very much where I am. I'm a user of Nuxt, someone who values all the things that it has to offer because I've used them. And so what I'm really excited about, and maybe most excited about thinking about what Vite makes possible, is it makes possible a lot of amazing things from a user point of view, not least its speed, and a few more, of course, that we'll get a chance to talk about today. If you haven't come across Nuxt, then maybe it's worth a brief introduction. Nuxt is a progressive full-stack framework for building web applications. And what I mean by saying that it's a progressive framework is that it comes with a lot of things out of the box. So you really don't need to know a lot about how things work under the hood to get going. Everything should work well. They should have best practice built in. It should be performant. Should enable all kinds of things that you might want to do, from generating static sites to sites without any JavaScript at all, to doing SSR, to having great SEO interaction, to enabling deployment to serverless functions or node servers or GitHub pages. Or the point is, Nuxt is designed to make a lot of things really simple out of the box and as easy as possible. So you don't need to configure anything, no matter how complex it might be to do that normally. But the idea of it being a progressive framework is that things very much are within your control to configure. So you can actually take as much control of Nuxt as you would like. And that's something that's been true from the early days of Nuxt. There's been a hooks mechanism and a way for users not just to configure it within their own project, but actually to publish packages, modules that enable other people to benefit from that as well. If you want to check it out, do go to modules.nuxtjs.org. You'll see some of the many modules that have been built by lots of contributors over the years. The modules ecosystem is a great, wonderful thing that I'm constantly really glad exists. You can see ways of integrating Nuxt with CMSs, deployment targets, languages, component libraries, whatever you might imagine. So Nuxt is a progressive framework. It has lots of great things to start with, and it can be extended hugely. And we're powered by Vite. Webpack's also an option, I should say, in Nuxt 3, but it's Vite by default, and for good reason. One of the key things I want to highlight two particularly. One of the key things is that Vite enables rapid development for us. So with Nuxt 3, we've been working really hard over the last couple of years to roll out a framework that is fit for the future. And there are lots of new features even as we've been building, even just in the last weeks or months, that we want to add to the framework. We want to make it better. And that's never going to change, right? We always want web development to be pushing forward. And Vite is a fantastic thing from a development point of view as a maintainer, because it enables us to build quickly. And that is in no small measure due to Rollup, on which Vite is based, which forms the core of how Vite transforms the code that you write into the code that's actually compiled and runs in the browser or in the server. And I think the way that Vite and Rollup handle that code and the whole transformation process is really one of the reasons it's so easy to write code and make it make new features on a quick and somewhat rapid basis. We have 11 built-in Vite plugins I counted just the other day within the Nuxt code base. Now, that's really very much how we work in terms of building new features. And any Vite plugin can be extracted, of course, into a Nuxt module and bundled up with other features as well, which means that it's really easy for people who want to try something new or add a new feature to Nuxt to create a module to enable that functionality. It has all the same kind of abilities that a built-in Nuxt Vite plugin or module would have, which means that we can actually test things out, test them in one project or many, before actually then wrapping them into Nuxt core itself. That kind of thing is a huge thing. It means that anyone can try, anyone can add features to Nuxt and do so quite quickly. And one of the things that's actually come out of that, and I know it's not used by Nuxt alone, which is wonderful, but the unplugin in the UnJS ecosystem. Unplugin enables you to write code in the format pretty much of a Rollup or Vite plugin, but which is then usable in Webpack or in ES builds. And obviously Rollup and Vite as well. And that's a really, really interesting thing to be able to do, because you no longer have to focus so much on integrating tightly with a particular bundler, but you can actually just adopt the format that Vite uses for plugins and benefit from it. Do check out Unplugin and consider writing your own. I wanted to show you just briefly today what it might look like to create a plugin and extract it into a Nuxt module if you were building a new plugin or library with Nuxt. So starting here just with a really, really basic site, because that's not particularly what I want to show you, but we can actually just add a Vite plugin inline in Nuxt config, just as you could with a normal Vite config. Just a awesome Vite plugin. It's not much of a name, but and all we're going to do really is do a very simple replacement of some code. Where we can just change welcome to Nuxt to Nuxt is awesome. And that's going to pretty much run, and that's going to change the code in our app.view. Obviously, you would want to be doing lots more interesting stuff. But that simple Vite plugin we can now extract using Unplugin into something that could run anywhere. So it could run in your Webpack instance as well, or you could distribute it to run in say some other framework or library using a different build tool. So we can just copy that out, and hey presto, we have an Unplugin. That can just be instantiated by calling the Vite method on it. And there we go. We have something that, just refresh the page, and there we go. It's all working beautifully. But one step further, now we might want to extract that into a Nuxt module. We've got the config to do that. We've got a utility called define next module that takes care of providing typings and things like that. So we can simply create a next module. We give it a setup function. That's where these kind of things normally work. And what we want to do, all we really want to do is add a Vite plugin. So we've got one. And yep, that module would do it. So now we can actually then just drop out the Vite plugin config, stick our module in, and there we go. Now, we can move that into a separate file, preparatory to, say, publishing it. And we can just copy all of that into the plugin file, make it a default export. And what's the... we have a double duplicate export. I'll just get rid of that. And okay, and there we have it. That's the next module built using Vite to inject a plugin to do a code transformation. And that means then that all you or someone else would have to do is just point to that particular plugin, my Vite plugin, and there you go. You could even deploy that to NPM and it would probably work, but you might want to have a build step as well. There you go. That's how simple it is to iterate over a Vite plugin and actually create a Nuxt module off the back of it. Do give it a try. I think it's well worth doing that. It means that it's possible both for us within the Nuxt team and anyone who is actually using Nuxt and wants to share something they've built to do so really quickly. And Vite, of course, enables that. The second thing I really want to draw to your attention just in terms of how Vite makes Nuxt possible is actually what it enables in terms of developer experience. And obviously the thing I've not even mentioned is how fast Vite is. The philosophy of how Vite works, it's obviously pretty incredible. And that will be familiar, I think, probably to all of us using Vite, no matter where we've used it in, whatever framework we've used it in. It's the kind of thing that you never get tired of, right? Making a change in your code and switching over to see it in the browser and not even seeing the flicker because it's already happened in the time it's taken you to actually switch contexts. But here are just a couple of things that we do. So we auto-import utilities. So when in any Nuxt project, there will be lots and lots of code functions that you want to use, things like in a Vue project, things like ref or onMounted, so Vue composables like that. There might also be in a Nuxt project server-side composables. So you might want to access a request object or set a header or set a cookie or something like that. And all of these different kinds of utilities are all available to be used throughout your application, no matter if you import them directly. And you can also create your own just by creating a composables directory in your project. And all of those then are injected into your code. The imports are injected into your code exactly where you use them. So you still get the benefit of bundling them all up and tree shaking out those that aren't used. And all of that is powered by a Vite unplugin, which looks at your usage, makes the transform where required. And again, because it's Vite, we're not having to run that on your entire code base. So obviously, it's only the code that you need to display the page in your browser that ends up getting transformed. And that is a lovely, lovely thing to experience as a developer. I still really struggle when I'm reproducing or trying to reproduce a bug, say, with a pure Vue installation, and having to manually import everything suddenly feels like a huge burden, even though I guess that's probably how I had previously done it for years. And it's not just auto imports of components, but also auto imports of components throughout your app. So you can create Vue components. Libraries you use, modules, might add them as well. And then all you need to do to actually use that in your app is just use it in your Vue template. You'll get type hinting through Volar or whatever IDE plugin you use. And again, in the actual code, it will be automatically imported in that component. either as a lazy import, if you use the lazy syntax, or directly as a straight import in most cases. And again, with all the same benefits of bundle splitting and tree shaking. Well, I thought it might be helpful to do a little case study of 3 in particular things that we do to improve developer experience with Vite. So the first is auto-keyed composables. So one of the things with Nuxt is that it is not just a client-side framework. So there is a server, there is a server bundle, and we can do things on the server. We can make fetch requests, we can get data, we can cache that data. And we ideally want to do that only once. We don't want to run it on the server, a network request, in order to render some initial HTML, and then for some reason have to run that again on the client side. We actually want to track what we've done, what state we've set on the server, and make sure that on the server side it's the same. So in Nuxt, you can, of course, define your own keys, and so we can match up server and client state. But if you had something like this, you just want to have some access to an SSR-safe data value, like we make possible in Nuxt with useState. You probably don't want to have to set a key every single time you use that composable throughout all of your components. And so what we do is we have a Vite plugin that is able to inject a magic key, a key based on the file name and then the position within the file of this composable. And that's going to be the same between client and server, which means we can, if you don't provide a key of your own, we can use that key and ensure it's then matched up. So the rendered HTML has something like this. It has a window Nuxt object, and then there's this magic key that's been inserted and has the value. So on obviously this is a slightly contrived example. No need to use useState for something as simple as this, but it means that you're able to take some data from server, pass it through to client side, and match up the value between those 2 builds with that key. It's something that often people are requesting, some kind of unique identifier that is shared between builds, so you can identify it within a component. And that's what we're able to use Vite to do. You can also do it, maybe more useful example would be to do some kind of data fetching request. And that's probably where it's most used. So if you were running use async data, that's again how your data gets from your server to your client side. The Vite plugin provides a key. That key is then embedded in the HTML and retrieved by the client side Vite bundle. And that's how we're able to get the data from server to client. Here's another example, and one that I'm particularly interested in. It's really under active development at the moment. But one of the things that Nuxt has always had in Nuxt 2 has been the inlining of used CSS. So when you actually write a component and you have your style block with some CSS, that can be embedded in the HTML of the page, meaning that you don't have any kind of layout shift. The browser already knows everything it needs to know in order to render that component. And that's something we really wanted to make sure would be possible with Nuxt 3 as well. So this is an example of a component you might have. A view single file component has some kind of style information associated with it, whether that's through Tailwind or Windy or Uno or just inline in the SFC. And what we're able to do in the Vite build is harness Vite and Rollup to emit a separate chunk containing only the styles, only the actual CSS used by these different components. So in this particular case, it looks a little bit like this. We have a list of components of file names, and then the associated dynamic imports to pull in the CSS, like just as a string. That means that when we render the HTML on the server side, we're able to detect what components are used in the rendering. So we know all of their IDs anyway as part of the Vue SSR integration. And we're able to match those up to the CSS that they emit. So we can actually produce something like this. The global style sheet is still at the moment required for subsequent navigation on client side. We don't add the CSS to the JavaScript bundle. That would seem counterproductive. So we just prefetch it. And then all you need in order to render the actual page that we're pulling down at that moment in time is inlined in the page. And in our preliminary testing, we've seen huge performance improvements in terms particularly of layout shift. But it's, as I said, a feature under active development, one that wouldn't have been possible without the ability of Vite to allow us to take a position inside the build pipeline. And another one as well that's been really helpful for us and is an interesting case study as well. We originally built this within Nuxt itself. So we created the plugins to do this. But subsequently, we worked quite closely with the Vite team, and they've actually adopted this, even a more powerful version of this into Vite itself. The idea was, with Nuxt, we want to be able to build once and deploy anywhere. So you should be able to build a version of your Nuxt server and then change the URL where it's hosted, or change the base URL of it, or change a CDN URL where the assets are located. So you should be able to configure all of this at runtime. You shouldn't need to run a rebuild in order simply to change the location where your assets, your JavaScript, your CSS, your images are located. It should be configurable at runtime, I think. And Vite has enabled this amazing experimental feature, which hopefully soon will be brought into stable, which enables us to render built URLs. So we're able to take something like a JavaScript chunk name or an asset path that might be within CSS, it might be within the JavaScript bundle, and actually we can render that in different kinds of ways. So in particular, this would be how you would use a global function to render the JavaScript chunks for the app. And this is actually something very close to what we use in Nuxt in order to ensure that no matter where you deploy your app, we are able to use a runtime value to determine whether those JavaScript chunks come from. So we can do something like this. We can set an environment variable on the command line, or in a serverless function, you might have a different way of doing that. Run it, and that CDN URL then can be passed through in the rendered HTML to the client-side JavaScript. Obviously, you don't have to recompile it or change it in any way. It doesn't have to be modified, but it's able to pick up on that value, that config app CDN URL, and render and run JavaScript from that base, from that point onward, and do the same for images and fonts and anything else that you might have. Obviously, that's pretty exciting, and I think it's the kind of thing that you would want or expect from a server-side rendered app that you might run in any location. There are, of course, challenges as well, and I thought I'd mention just very, very briefly two of them. Nuxt is an SSR framework, which means we want to run the application within the node environment where we are, in fact, rendering the HTML initially. We also want to be able to run the application in the browser, and we want to be able to hydrate the app in the browser. Now, in production, this is great. It works pretty simply. But in development, we want, as you are making changes to your app, ideally, those are immediately reflected in the HTML that is served up from the server. And we don't want to have to compile the entire application in order to build it, in order to return a single request, because that could be take a huge amount of time. So we have actually two Vite builds within Nuxt. There's the server build, there's the client build. And there are also, therefore, two Vite servers, if you will. There's the one that matches the client side, JavaScript, and the one on the server side. We've been able to harness Vite for that as well, using a really amazing program called Vite Node by Anthony Fu, who also created Unplugin, it's worth saying. And this means we're able to do all the same kinds of things you would want to do with Vite. So only compiling the code that's changed or used on the server side as well. So anyway, watch this space. I think there's going to be a really interesting article coming out from Anthony soon, talking a little bit about how some of these these challenges can be tackled in Vite itself, running in the Node environment. There is so much more to say about how Vite makes Nuxt possible. I would love, if you're interested, to show off some of the Nuxt development process. If you want to help out or contribute in any way, please let me know. You can enjoy something of the development experience within the framework of Nuxt itself. And of course, I hope you are able to enjoy using Nuxt as a user, something of the speed that Vite makes possible in the development experience. I think I hope you enjoy. And of course, please, I would be really glad of any feedback or hearing your experience. If you're interested, check out the docs on v3.nuxtjs.org. There's lots to read there. If you want to see a little bit more about how Nuxt works or how you might get started with using Nuxt. You can follow Nuxt on Twitter or join our Discord server and ask a question or contribute. And please, as I said, feel free to reach out to me at any point. It's always a pleasure to find out about new people using Nuxt and to see some of what they've built. I hope you enjoyed the rest of the conference. I certainly will. All the best.
This is Vite Meta Frameworks in Angular. My name is Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts. I tweet out GIFs, I talk about sports, and I block people sometimes. So that's just what I do. I'm also a maintainer on the NGRX project, which is a set of libraries for building reactive Angular applications. Also a Google Developer Expert, which just means I've been around the community for a while and been able to do some cool things there. Also a software engineer at Open Source, where we help people find their next contribution in open source. So let's get into the agenda for this talk. We're going to talk about Vite, of course. We're going to talk about meta frameworks and talk about how Angular fits into this picture. So first we'll talk about Vite and some of its features and goals that it has provided through the web ecosystem. So first we'll talk about features, and then we'll talk about impact. So Vite was created to solve some specific problems in web development or front-end development. One of those problems was intended to solve slow server starts in development. And one of those ways is instead of using bundle-based development, dynamically loads files using browser APIs. And this is where ES modules has become a lot more important in terms of the ecosystem around Vite and how it works underneath. But overall, it intends to improve the developer experience for building front-end applications. Along with these things it intended to solve, some of the features it has is instant server start to increase the productivity of developers there, HMR support for fast feedback, developer experience out of the box, where it just helps developers be more productive right out of the gate. Faster builds, of course. Everybody wants to get builds faster. Extensibility with plugins to help people build more things around it. And TypeScript support. So naturally, everyone in the Angular ecosystem wants these things in some way or another. So we naturally saw these things and said, we want to have that too. So when there was Vite was being introduced, there was a lot of impact that it had in the web ecosystem overall. If we look at the kind of the landscape of how things are today, there's really been a mass shift to adopt Vite in the web ecosystem, from Astro to React to Solid.js, Nuxt, Vue, Svelte, there's Quick, and even tools like Playwright and Vitest. And there are more tools here that have, like I said, shifted to using Vite just because of these features that it provides for users. Next, let's talk about meta frameworks. Talk about the definition of a meta framework, some of the common features that meta frameworks offer, and get a little deeper into those. So meta framework, as this definition, is a system one level above that stitches multiple frameworks together. And this comes from Ben Holmes, who wrote a post on the Prismic blog that you can check out about meta frameworks more in depth. And Angular itself is a framework at its core, where it already has some of these things built in, such as core components, pipes, directives, and services. It has routing, it's HTTP client, forms module, SSR, and more features that you just get out of the box. When we're looking at meta frameworks, there are already a lot of meta frameworks that exist today that kind of build on top of a particular framework or ecosystem. Ones like Next.js, that's built around React, SvelteKit for Svelte applications, Remix is another meta framework around React. There's also Astro that takes a unique approach where it blends where you can bring your own framework and build that on top of its framework itself. So you can think of it in that terms also. There's also Nuxt and Solid Start and Quick City, just to name a few. So when we talk about meta framework features, there are some common things that these meta frameworks have, such as file-based routing, server-side rendering, where we also have static site generation, and some form of API routes, whether those be embedded in the routes themselves or some other combination of that. So when we have file-based routing, if we look at how routing works in Angular today, we have a configuration of routes that you can define manually as just part of your normal development workflow. With file-based routes, you can use this route to use folder and file-based routing to where this convention is the structure of your folders and files, and you also get those routes generated for you. There's also server-side rendering, where the application is rendered on the server, and then that HTML is shipped to the client. The application is then hydrated on the client, and in the Angular ecosystem, there are applications out there today, such as Angular Universal for this. There's also static site generation, and these are mainly focused on content-focused websites, such as landing pages, marketing sites, blogs, and the tool we normally use today is a tool called Scully in the Angular ecosystem. There's also the islands architecture that has been gaining a lot more popularity these days, and this is the idea of using partial hydration to build entire websites. These are also an alternative to everything loaded in a single JS bundle. And then also these different islands are loaded in isolation and rendered as they are needed on the client, rendered as they needed, rendered on the server, and then hydrated as they needed on the client. So if we look at an example page, we have a header component here and a navigation menu on the side in our content area. And each one of these pieces has its own, it lives on its own independent island. So they are loaded and independently isolated from each other. But there's also API routes, and these are just APIs that you can build without external libraries. Whether you're familiar with just building something out of Nest.js or just Express itself, these are also convention-based And some of them are inline in the route component themselves, which meta frameworks such as Remix that use actions and loaders, or frameworks like Next.js with get static props. So Angular has still been evolving even with the web ecosystem along this way. So like I said, we still want to keep evolving with the web and these frameworks or meta frameworks that these features offer. So going back to the landscape of the web and how everything has shifted in that direction, we definitely want Angular to continue to evolve and take advantage of everything that the web has to offer with tools like Vite and ESBuild and things like that. And that's where tools like projects like Analog have come in. Analog, by definition, is a meta framework for building applications and websites using Angular. And I'm just showing a nice logo there because every meta framework has to have a nice logo there. So I know what you're thinking. I mean, why build this now? Angular already has a framework on its own. It has an ecosystem around it. What do we need to build on top of that for? So this isn't the first time that meta frameworks around Angular have been mentioned. I've even mentioned it myself, and I know other people around the ecosystem have thought about these things. And ideas are great, but those things some things have to be in place for those things to happen. And some of those things have changed over time in helping Angular be in a position to have a meta framework or build a meta framework around it. And some things have changed since then. Angular has definitely made strides in evolving how you build Angular applications. And one of those things is standalone components, which is introduced in Angular v14. This has opened up many possibilities of using Angular in other ecosystems and even environments. There's also the ESBuild based browser builder that's being built into the Angular CLI that's looking at alternative ways from Webpack to build applications with Angular. And although ESM has had its share of pain in the web ecosystem, it definitely has helped with the Vite integration itself. So let's talk about how Angular compilation works today. The Angular compiler wraps TypeScript and to provide Angular specific metadata. This happens globally using knowledge of all the files in the project. It takes those files and then produces an output. Now, Vite definitely works a little bit differently in this way. And a lot of the web ecosystem were already in a position to do this or take advantage of this way, but the Vite transform pipeline works a bit differently. Vite actually works on using single file compilation. So it can process files in parallel and produce these outputs, multiple outputs faster, which in turn speeds up development in that way. So how do we go about supporting Angular within the Vite ecosystem? The first way is with a Vite plugin that we can use to tie these to the build compilation that Angular has, along with the processing that Vite has to kind of work with those two things together. In the future, we could look at a scenario where Vite, the transform pipeline with Vite, works on these multiple files and then produces these output for then. And then looking at a future for Angular team is also looking at the potential of using tools like this, using tools like Vite and ESBuild, which Vite uses underneath, to where the Angular could use this same single file compilation to process multiple source files and produce this output in parallel. So what are some of the features in the analog project? Well, of course, it's powered by Vite, and to enable a lot of these things that we talked about before. We get things such as fast development, take advantage of those, take advantage of the plugin ecosystem, and like I said, continue to tap into that wider web ecosystem that has evolved as Vite has evolved. There's also tools like Vitest, which is also powered by Vite. And if we're looking at the Angular ecosystem today, a lot of the tools use Jest, and Vitest has a Jest compatible API, and also has a smart watch mode to where you can only transform those particular files that are needed, and things such as ESM and TypeScript out of the box, which Angular is built on top of TypeScript already, so it's like a natural progression there. Some other features of analog today, said powered by Vite, supports unit testing with Vitest, and also integrations with other ecosystems such as Astro, where you can use your Angular components within an Astro project, which I wrote up blog posts about that you can check out. Even other tools like Storybook are also moving in the direction of using Vite for their compilation and development pipeline. And even tools like Playwright, which is another tool for testing, has component testing that uses Vite, could integrate with Angular there. And there are also more interesting integrations that could come out of this by supporting Angular in Vite and continue to evolve in that area. So in the future, we're also looking at other features such as file-based routing, server-side rendering, static site generation, and server and API routes. So we have some parity there with other ecosystems, and also provide these integrations that I talked about. We're using Angular and Astro to build websites with, and have those server rendered, and only bring in Angular when you need it for those who are comfortable with using Angular as part of their development. So now we get into contributing to analog. Of course, there are many ways to contribute to this ongoing effort, whether it be GitHub issues, writing documentation to kind of iron out some of the things that people try out with. Pull requests are always welcome, especially in open source projects. And also sponsorships definitely help with some of the things that are involved with maintaining these projects. As you can see here, we already have some people who have been contributing to the project already, and we look forward to more people getting involved with the analog project. You can check out the project itself at github.com/analogjs/analog. And also check out the docs at analogjs.org to find out how you can get set up or even can start contributing to the project. So to recap, I talked about Vite and the things that Vite has brought to the web ecosystem. Talked about meta frameworks and the features that they'll provide, and things that Vite kind of enables in that way, where we can kind of integrate these meta frameworks together and other ecosystems that are built on top of this already. And I talked about how Angular fits into this picture today, and the analog project, and how you can get involved. Thanks.
My name's Nate Moore, and I'm thrilled to be here today to talk about Islands architecture, Astro, and you. It is such an honor to share the virtual stage with such an incredible lineup of people. And I'm really, really excited to introduce you to Astro. It's a new tool for building faster websites. Astro 1.0 launched a few weeks ago, but it's been well over a year of work behind the scenes to get everything ready for this moment. There is an incredible team behind Astro of maintainers and core maintainers, and I really encourage you to check out our community. I'm super excited to show off what we've been working on and chat about Islands architecture. It's a really interesting way to solve performance bottlenecks that come up with the current crop of frameworks. And overall, I think Astro is a really fun, approachable way to build websites that you're going to love. So a typical website looks something like this. And you can see we've kind of broken things down into components. That's really the way that most developers work these days. And a lot of these components are interactive, but most of them are actually static. So there are some pieces that require client-side JavaScript, but in my mind, most of these don't need client-side JavaScript. With a traditional approach, where everything is kind of one JavaScript monolith, you might render this on the server side and then also hydrate it on the client. It's a nice developer experience where the code is isomorphic and you're only writing things once, but it's running in two places. And you end up with hundreds of kilobytes of JavaScript, some of which runs on the server, and then it also runs on the client, even for non-interactive pieces that really don't need any JavaScript on the client. So with Astro, we're using a technique called Islands architecture, and you may have also heard the term partial hydration. So it's a very similar component-based experience, even using the same frameworks that you already know and love, but interactive pieces of the site are broken down into what we call islands. So islands are basically tiny applications inside of your static content. And in Astro, islands are recursive, and the children of islands are actually not part of your JavaScript bundle, but are embedded in the HTML. What this amounts to is up to a 90% reduction in JavaScript overall. So building great websites, that's what we're all here for. And it gets easier every year, but in my mind, choosing the right tool has never been more difficult. You can build a static site with a static site generator like Hugo or 11D, but then you're really hand-rolling your own client-side JavaScript. You can build a traditional single-page application, but that comes with a lot of downsides, like poor SEO and performance. You can mitigate some of that with the Jamstack pattern, where you're rendering on the server and then enhancing it as a single-page application on the client. Or you can fully lean into the server and render your pages at request time. All these come with really interesting trade-offs. So static sites are designed for speed on the client, but like I mentioned, you're hand-rolling your own JavaScript and maybe even setting up a build pipeline. It's pretty difficult to work with sometimes. And spas are designed for interactivity. They are not good for SEO or performance, but for long sessions, they can be really great. Jamstack makes it really easy to work with content, but we're prioritizing our own developer experience over the client-side performance. And with server-side rendered applications, they scale, but with scale comes its own set of problems. So this is why we built Astro. It's the web framework designed for everybody. It strikes a really good balance between all the trade-offs the last generation of tools made. But it's also really approachable for newcomers, and there are still powerful features for advanced users to take advantage of.
in my mind, it's the modern developer experience with the way we should have been building websites this whole time. So Astro has been designed for speed from the ground up. We have a performance obsession. We really use the islands architecture approach to extract your user interface into small isolated components. So instead of rendering everything on the server, sending it to the client, and hydrating again, we are only sending the interactive parts to the client. The end result is that unused JavaScript never ends up in the client, and your site loads faster. You'll have a faster time to interactive and much better lighthouse metrics. We do this using what we call hydration directives. So this is really lazy loading as a core feature of the framework, and it's not something you have to think about or write code in a special way to take advantage of. We have client load, which is a high priority and loads a component immediately. We have client idle, which is a medium priority, and will preload your component as soon as pending work is done. And then we have client visible, which is really fun, and this will load your component only when it comes in and is actually visible on screen. Astro was designed for content, so content is really the foundation of the web. We make building static sites fun and easy. We support pages in HTML, Markdown, MDX. We have really similar file system routing to Next.js, and we make it so easy with built-in fetch support to call any CMS or endpoint using a familiar web API. We also built Astro with interactivity in mind. So you shouldn't have to choose your meta framework based on the framework that you like to use. With Astro, we are framework agnostic. So you can use your favorite, or you can pick a different one and put it on every different page. You can use the tools you already love, and we integrate really well with Tailwind, PostCSS, Sass, all of the things that the Vite ecosystem expects. Astro is not just a static site generator. We really designed it to scale. So you can go from static sites that are rendered at build time and switch into server mode where you're rendering on request. With Astro Add, you're only one command away from deploying to Netlify, Vercel, Cloudflare, Deno, and even more. All right, that was a great intro and some background on Astro, but now I want to build something together. So let's scaffold out our Astro project using our create Astro CLI. All you have to do is run pnpm create Astro. And let's create a folder named ViteConf. And I'm going to start with an empty project, and we can walk through it together. And we will install dependency, but not create a Git repo. And it asks us how we want to set up TypeScript, which is cool because Astro is actually TypeScript by default, so there's never any setup that you have to do. In this case, I'm going to go with strict, and we get some instructions on how to continue. So let's take a look at the files that got generated. We have a public directory, and this is where any static assets that Astro is not going to touch will go. These will just be copied over to the final build. We have a source pages directory, which is where our file-based routing kicks in. And then we have an Astro config file. What's cool about this is you probably don't need to open this file. We have a command line tool that will edit your config for you. But if we look at the index.astro page, it looks a lot like HTML. And that's because Astro has a special syntax that is a superset of HTML. So .astro, anything you can do in HTML, you can do here. But obviously we built our own syntax for a reason. We wanted something that was a really great mix of HTML for beginners and something that had the power of JSX-like expressions for experts. So before we get started, I'm just going to drop a style sheet into our public directory, and then we can just use a regular link tag. main.css. And that's looking a little bit better. One of the most powerful things you can use in Astro is what we refer to as front matter. So this area up here is any server-side JavaScript that is going to set up your template. So we can use things like top-level await and fetch and call any API that we might have. And then we can use a JSX-like expression to map over all our speakers. And I'm just going to put the speaker name on the page. And you can see everybody that is speaking today. But one other thing we can do in an Astro file is use scope styles. So every style in an Astro file is going to be scoped to that file by default. So if I add some CSS here, this will actually just be scoped. So this is not going to bleed out of the file at all. Another thing we can do, I mentioned that component-based workflow. So we can extract this to a components directory, which isn't special, it's just convention. But I'm going to call this title. And I'll just move my H1 over and my styles. So now up here, we can import our title component and then render it like any other component. So I think it would be cool to extract these speakers to their own component. So let's make a speaker card. And we're going to set up some stuff in the front matter. So we're going to grab the name, at least, out of our Astro props. And to type these, all we have to do is write an interface called props. So this will have a name, which is a string, and projects, which is an array of strings. So if we jump back here and import our speaker card, we can replace this with a component that just passes in the speaker as props. Now we have this awesome list of everybody speaking today, and I'm actually realizing I forgot to wrap this in an unordered list. So I'm going to do that, and our styling gets a little better. I also want to clean up our styles a little bit.
A little longer than a few minutes later.
So this looks a lot better and hopefully gives you a good sense of just how easy it is to work with data and pipe it into some markup with styles in Astro. Now, I think this is a secret superpower of Astro that you can get really far without ever touching client-side JavaScript, but I did promise to talk on Islands architecture, so let's do that now. So Astro actually brings the Islands architecture pattern to every framework. And all you have to do is add pnpm run astro add, the framework of your choice. In this case, I'm going to choose Preact because I've really liked Preact signals lately. So I'm going to write astro add Preact. And this will install our dependencies that we need. And it will also ask us if we want to update our config file, which we do. And that's all there is to it. We can get started and add a Preact component. And we're just going to export a button that accepts some children. But that's not very interesting unless it does something when we click it. So we're going to create a store file. And this will use the new Preact signals, which are very cool. And we'll export a signal called menu that starts out closed. And we're also going to export a toggle. So this will switch the value of menu to open or closed. And then it's also going to log that we've toggled something with the current state. And now if we go back to our button component, we can import toggle and set this to be the click handler. And back in this file, we'll import our button. We can use it like any other component, except that you can see we have these hydration directives here. So each of these opts our component into sending JavaScript to the client. This is really nice because you have granular control over what actually ends up in the client. I'm actually gonna just say menu here. And we've got it. So if we check our console, we should be able to see that this log toggle a bunch. So that toggle is working, and now we can hook it up to a menu. So I'm going to create a menu component, imports both the menu and toggle, and also takes some children. And this is interesting. So we're going to render differently based on the state of the menu. So if menu.value is closed, we're going to return nothing. Otherwise, we're going to return an aside. And if we click on this, we're going to toggle. So this will be the backdrop. And this will be the main content. And here we'll stop propagation so that the toggle doesn't get triggered. Hey everybody, my name's Nate Moore. So let's render that menu component here and make sure to hydrate it. And this can take an array of 5 items. And the second argument here is actually a map function that takes a map callback. So we can just return li with page i+1, and we'll wrap it in a list. And now when we click this, a flyout menu should come from the left, which it totally does. So this is an island, and this button is an island, and they are communicating through a shared signal. Everything and that is static is going to stay in your Astro file, and everything that's dynamic or requires a bit of logic is going to be in your JSX files, and you're explicitly opting in to sending that JavaScript to the browser. So you can kind of think of islands like donuts. There's an outer ring that has some interactivity, but everything inside of it is actually revived from the client-side HTML. So this means your JavaScript bundles are really, really small. And there's one other cool thing we can do. We can actually pass in slots from Astro to our components. And the way we do that is just like you would in any other Astro file. We're going to have a fragment here that's called title. And now that we have a slot that is a child of a component, we receive the title as a prop here. And then I'm just going to create a header. We'll call it nav. And we'll use that title, and then just a close button that will toggle. So now when we click on the menu, we should get a title and a close button and all our pages. And clicking here does nothing. Clicking outside or clicking the close button totally works. To wrap up, I thought it'd be really interesting to look at what's going on behind the scenes here. So how is this actually working? And we have to look at our HTML for that. So there's a style and a script that we're injecting. This is the entire Astro runtime. It's really tiny. And we have these Astro Island custom elements. So these are basically loading some chunks of JavaScript with a specific export and a renderer, which basically coordinates how something is rehydrated on the client. And we have some props and the hydration method. And then inside of this, we have nothing. But if I disable JavaScript, so we have some template elements here because our component didn't render anything, but we knew that we have to pass in some slotted content when we do render something. So these correspond to the slotted content. So our title is just going to be the text, and the default slot is our list. And these will be cleaned up when JavaScript starts, but they'll be held in memory. And before hydration can continue, they are essentially passed back to the framework to act as children. And same thing here, but a little different. So we have the Astro slot element. The Astro slot element tells us that everything below this element should be treated as static. And this is what allows us to nest islands within islands and also mix frameworks with each other. Finally, I just wanted to share my favorite Astro feature, which is our awesome community. We have a thriving Discord community with tons of creative people and lots of people willing to help out. So if you liked what you saw today, definitely come check us out at astro.build/chat. Thank you so much for having me. My name's Nate Moore. You can follow me on Twitter, n_more. And I just got to say, we are so happy with our decision to be part of the Vite ecosystem. It is really the best place to be. So thank you again. Please check out astro.build.
Fatih, and today I'm going to talk about Vargas, a full-stack React framework powered by Vite. It's similar in scope to Next.js and Remix, but it was built from the ground up with the latest React features in mind, such as the concurrent mode, streaming SSR, and suspense for data fetching. Aside from all the goodies that you'd expect from a Vite-based framework, like the lightning-fast dev server, hot module reloading, and out-of-the-box support for CSS, TypeScript, etc., Vargas also has many common and not so common features like nested layouts, route guards, and the ability to deploy to serverless and worker environments. I'm going to talk about them in my post-conference talk. This short talk is going to focus on data fetching, and in particular data fetching without an API layer. Vargas's data fetching system is heavily inspired by the excellent React query library, now called 10-stack query. Vargas provides a suspense-only subset of the useQuery API to fetch from your REST, GraphQL, RPC, whatever APIs. But for most applications, there's something simpler. You know, Next.js has get server-side props and Remix has loader functions, and they allow you to create apps without an explicit API layer. You just talk to your database in get server-side props, and your page component magically gets those props. Behind the scenes, both Next and Remix removes those functions from the client bundle, so they only exist on the server side. And Vargas is something similar, but I think much more flexible and easier to use. Enter use server-side query. Use server-side query is a data fetching hook, similar to useQuery, but its data fetching function always runs on the server. It's like get server-side props or loader, but on steroids. Because it's not tied to pages, so you can use it in any component. It even provides type inference, so you can write your app as if almost the client-server boundary didn't exist. You may have noticed that TRPC has been getting a lot of attention lately, and I think it's well-deserved. It offers end-to-end type safety with very little boilerplate. Well, use server-side query offers the same with no boilerplate, but it also offers excellent co-location. Co-locations mean you can find everything related to your component in one place. You can have smart components that not only fetch their own data from the backend, but actually contain their own backend, right in the same source file. Also, one of my pet peeves with standard data fetching systems is having to deal with dates and sets and maps and all those types that don't serialize well into JSON, but which are really useful, so you do want to use them. For those things, Vargas uses Rich Harris's D-value and Ron Brilot's JSON serializer, and it can handle all of those types and provides very great end-to-end type safety. For data mutations, Vargas offers use mutation, again copied from the great 10-stack query API, but there is also use server-side mutation for completely doing away with the API there. There is even now a use form mutation so that it works even without JavaScript because it uses the HTML forms. I kept talking about doing away with the API layer, but why do people have APIs and when is it necessary? In my opinion, it becomes a necessity when you have many clients connected to the same backend. But even then, your server-side query and friends can provide a lot of value because generic backends that cater to many clients have to compromise. So clients end up having to use endpoints that are not tailor-made to their needs. So they either end up fetching too much data that they don't need or too little data and have to make more API calls to get all the data they need to render the view they're rendering. To counter this, there's a growing pattern that is called BFF, or backend for frontend. In this pattern, each client has its own mini backend on the server, and that mini backend talks to the real backend. This way you can pluck out unwanted properties from the API response and send only whatever the specific client needs. Use server-side query and use server-side mutation offer a very convenient way to implement this pattern too. I hope this little presentation tickled your curiosity a little. Vargas has many more interesting and uncommon features, so check my post-conference talk to learn more if you're interested. Thank you.
Everybody, welcome. This is my 5-minute lightning talk on Tauri. My name is Jonas Kruckenberg, and for those of you who don't know, Tauri is a toolkit that allows you to build tiny cross-platform apps using your favorite front-end framework. Why, you may ask? After all, there are a lot of projects that try to do the same thing. Reason number one, the environment. It is not doing so great right now. According to recent studies by the UN, we will almost definitely miss the 1.5 degrees goal to keep global warming below 1.5 degrees Celsius. And we are already seeing the consequences, the most recent example being the devastating floods in Pakistan. Yet, for the longest time, we as an industry have pretended that our actions, our code, has no impact on the environment whatsoever. But that's just not true. An app weighing 200 megabytes being downloaded 1 million times causes approximately 100 tons of CO2 emissions. We want to do better than that. Another area that we think needs improving is security. Cyber attacks have drastically increased since the pandemic started and are estimated to cause over $10.5 trillion in damages by 2025. That is a mind-boggling number. And insecure apps become a gateway for attackers moving through your machine and your network. And of course, security is complicated, but can we build frameworks that are just more secure by default? Tauri is written in Rust. And we specifically chose Rust because it's both secure and fast. So you can complement your JavaScript front end with supercharged native functions. We call them commands for heavy number crunching or sensitive business logic. Tauri also doesn't ship a full browser in every application. Instead, we make use of the web view that is provided by your operating system. And that already decreases bundle sizes by a lot, but we go even further. We give you fine-grained controls to select which APIs will be available in the final binary and which will not, drastically reducing both your app size and your attack surface. Because after all, you cannot exploit code that's just not there. So how well are we doing? Well, a minimal Tauri app is just 426 kilobytes. I'm very proud of that. That is 5 times smaller than the average website for a full desktop app. And that is all well and good. But best practices are useless if they are hard to adopt. Because let's be honest, I'm lazy and you are probably lazy too. So we've been thinking about ways to make developing and deploying apps as easy as websites are today. We built a GitHub action so you can build, sign, and deploy your app right where your code is. We also implemented a self-updater, something that is notoriously difficult with other frameworks, but with Tauri, it's just a few lines of configuration. And additionally to the huge number of supported standard web APIs, you can use Tauri plugins to quickly extend your app's capabilities. Like need logging or crash reporting, we have plugins for that. Storing settings with user data, we have a plugin for simple key value stores and one for full-fledged SQL databases. But there are also plugins for things like storing secret keys or interacting with hardware security devices. And with the huge number of beautiful Vite and Rollup plugins, you can very quickly create amazing apps. To get started, open a new terminal and run our Create Tauri app utility. You can choose from a large number of templates, most of them powered by Vite, of course. Open up the folder and you will notice it looks very much like a standard website, except for the additional source Tauri folder that contains all your Rust core code. Run Tauri dev and your app will open in development mode. Then, once you're happy with it, run Tauri build to bundle your app for production. So, what is next for Tauri? The team is hard at work implementing support for Android and iOS, so you can build desktop and mobile apps very soon. We're also very aware that Rust is not the easiest language to learn. So we plan to support more like C++, Go, Python, and JavaScript to make Tauri more accessible. And lastly, a plugin system that lets users customize their app is just cool. But it's also a security nightmare, so I'm happy to report that we are working on a security-focused plugin system using WebAssembly that will be released soon. And that's it. Visit our website to learn more or stick around for the post-conference talk. And you can join our Discord server or follow us on Twitter at TauriApps to stay up to date or ask questions. Thank you so much for listening and have a great conference.
welcome everyone to ViteConf 2022. I'm your host, Jesse Tomshock. We have an amazing panel here today. I'm going to, let's see here, drop our title card and we can get a view of everybody. We're going to talk about frameworks today. You see some regular characters here and some new faces. So let's go around. Brett, let's start with you. Give us a little, who are you? What framework are you working on? What are you shilling this week? Type and just go around and then dig right in.
Sure, sounds good. My name is Brett Little. I work at Shopify. I'm on the Hydrogen team. Hydrogen is a web framework built by Shopify for building custom storefronts. It's built on top of React, and it's optimized for building really dynamic commerce experiences, specifically with the Shopify API. But excited to be here.
I'm Ben McCann. I'm a Svelte contributor helping to build SvelteKit. And SvelteKit gives you a router, library packaging, form handling, kind of a batteries included approach to building an app with Svelte.
I have to find the unmute button before I can speak. Hi, I'm Mishko. I'm the CTO of Builder.io. We are working on a CMS system, but also on this cool thing called Quick. Previously, in my previous life, I did this thing called Angular that you might have heard about. Quick's big thing is that it's resumable. It's kind of a different way of thinking about how applications are delivered to the user.
Hey, my name's Ryan. I creator of Solid.js, and I've been working on a metaframe for Solid called Solid Start recently, and I work at Netlify in open source.
Hey everybody, my name is Fred Schott, and I work on a project called Astro, which is a way to build websites with a content focus using this really cool technology called islands. So I see Svelte, React, Vue, Solid, everyone represented here. We have a story to tell with all of those frameworks, so it's a pretty interesting spot to be in.
My name's Daniel Rowe. I'm on the Nuxt team. Nuxt is a progressive web framework built on top of Vue with some interesting serverless sugar, some other interesting things to talk about.
All right, excellent. So I think the first question I maybe throw out is, which framework is best? And just let you guys sort of fight it out, sort of like the Thunderdome style. No, we the question I wanted to start with to the group is, so at ViteConf, we're here at Vite, and as a regular user, I tend to use Vite in certain ways and use plugins. I'm curious, we were getting started, and I tried to hold back before we got started. Where does Vite fit into your daily workflow and like your effort at a framework level? Because like for me, it's I work up here, you know, building on top of what you guys do. Like I feel like our day-to-day work is very different. So maybe our interaction with the Vite and the Vite ecosystem and the Vite plugins is probably very different too. So I'm really curious from your guys' perspective, from the group's perspective, like what do you do with it that, you know, how do you interact with it day to day, like plugin style or configuration or considerations or anything like that, that you might find normal day to day, but I'm curious to hear it because it's probably very different than what I do.
So we have an interesting story with Vite, which is we actually started first by building a Vite competitor. If anyone knows Snowpack, that was actually came up around the same time as Vite. Very similar goal, very similar project, and Astro is very much built on top of that. So we ended up using Vite almost like after the fact we migrated to it versus starting from scratch on top of it. So I think a couple other projects in this ecosystem very much are like plugins. They are super kind of like, they were built with that in mind. We very much sit on top of Vite. We ship our own CLI, our own kind of ecosystem, and we very much use Vite as a tool inside of ourselves versus more of the like kind of use Vite and we're like powering it behind the scenes. We sit on top versus underneath, which I don't know if that's shared by everyone here.
So I guess maybe that might be similar for us as well in that we have our own server, for example. So we use Vite's dev server under the hood, for example, for our server rendering with a clever utility built by Anthony Fu called ViteNode. But yes, Nuxt is very much in front of Vite in terms of an experience for users, and that's I think that's really important in terms of how we present it. But it obviously means that there are some interesting things Vite makes available. So being able to step back into what used to be called sort of middleware mode, so it can handle requests and do all of its magic. But when invoked, when summoned, it does that. And that means that there are some things which are maybe a little bit different as well. Vite dev server proxy handling, for example, isn't quite the same with Nuxt as it would be in a pure Vite context.
I mean, I think most of us use Vite in a similar way, right? Like Vite does bundling, hot module reloading, has the dev mode and production mode, coordinates with the rollup. All of those things you need no matter which framework you use, and somebody has to do it. And it's kind of nice that as a community, like the world came together, and now is a standard way of doing these problems. And hopefully, this kind of attitude of like figuring out standard ways of doing things will spread to other areas as well.
It's funny you say that. Yeah, someone had to do it. I was really hoping that someone wasn't going to be me. To be honest, I'm one of those like library over framework kind of people. I prefer just kind of fiddling with stuff rather than telling everyone how the thing should go. But Vite provided something that was really compelling to me. The plugin system, like just having that ability to have these pieces that I could immediately see were reusable, composable. They made me go, okay, maybe I can do this. Like at times I feel like I got kind of bullied into making a meta framework. It's like, oh, everyone needs one of those. But I'm so happy to be here and see what we can do with Vite.
Yeah, Vite 3 introduced this concept of modes, and so it's got SPA mode, multi-page app mode, and then this new custom mode. And so we've been using custom mode in SvelteKit, which has really allowed us to do SSR rendering and a number of pre-rendering and different modes that we have, and then mix and match with all the different plugins in the Vite ecosystem. So if you want to turn off the service worker that SvelteKit provides out of the box, you can use a plugin to do that. You can use Vite plugins to do image optimization and all of these other things that are available throughout the ecosystem.
Yeah, I actually want to correct. I think SvelteKit was actually the first to move from Snowpack to Vite. We actually, I think, saw that you all were doing that. We're like, oh no, we should look at it too. I don't think we were first there. Actually, I take that back.
What were some of the, Fred, I want to dig into this a little bit because you guys had worked on Snowpack, right? And I remember Snowpack as sort of a new way to sort of bundle and stuff. What was the motivation to step away from that sort of low level work and leverage Vite instead?
Oh god, I could write a whole post. I actually did write a bit of a looking back post if anyone wants to go find that, like what I learned building Snowpack. There were a couple things. One thing that Vite did really well was the decision early on to base itself on Rollup. You can even hear a couple of people here talking about that, like Ryan, like the idea that you can pull from that ecosystem immediately. Snowpack was all about like, no, we're going to do it different. We're going to do it better. And, then building an ecosystem from scratch, very difficult.
Honestly, I think it isn't just the ecosystem too. At least building upon the Rollup API has, I think, made it easier for onboarding for us too, because we build a series of Vite plugins for Hydrogen, and those are key to how Hydrogen works. And like as new team members come on board and such, if you have familiarity with Rollup, you're kind of at home now once you're actually editing some of these plugins for Hydrogen as well and working on the project.
Yeah.
There's quite a bit of overlap between the Svelte community and Rollup community. Rich wrote both Svelte and Rollup, and so for us, like we were very, very familiar with that API already, and it definitely helped us hit the ground running and was a big contributor to us running with Vite.
We've been forced in Nuxt to be almost compiler agnostic, because we support both Vite and Webpack out of the box as bundlers for the view part of the application. and obviously Vite is by default what's installed. But we also have we compile that output again another time into our server. And that's Rollup that does it, Rollup and ESBuild. And obviously ESBuild is involved in the Vite process as well. So you think, how many different compilers can you possibly have in one framework? But it means that all of what we want to write, so we auto-import composables, for example, not just in the Vue part of the application, but also in this Nitro, this server-side part of the app too. So if we want code base that can be shared, it has to be generic enough that works in Vite. It works in Webpack. It works in Rollup. And so we've had to very much sort of step back in terms of, rather than the in-depth part of Vite plugins where you can, pull in Vite config and, stick the server in a temporary variable and interact with it or something like that. We've had to be much more generic in our approach and interpretation, which I think it's definitely shaped how we interact with Vite. We can't be quite as much fingers in the pie, but hopefully it means that we come up with something that is maintainable and rigorous and maybe less prone to sort of needing to be refactored as we grow.
Yeah, I think that leads to like the other part of what makes Vite so important for us. I mean, look at all these frameworks represented here. Like, it would be silly to be like, no, come over here to this other ecosystem. Especially for a project like Astro, where we have a great story for every framework. Why would we try and do that somewhere else when all those frameworks are living in this ecosystem pretty remarkably fast? Everyone has moved to this way of thinking, which is just so exciting. So the interop, the ecosystem, that's what gets me really excited about Vite.
Can I jump in and add some to it? So I think it's super cool that Vite is on top of Rollup. So in Quick, we have this thing called the optimizer, which is actually in Rust. But it transpiles to WASM, and because it transpiles to WASM, we now can have it as a plugin to Rollup. And so our custom compilation path is fully supported now in Vite and Rollup because it's just how extensible these things are, right? And so I think that's a key to it, right? Like being able to say like, okay, Vite does 90% of what I need, but I just need to change a little tiny thing, and have hooks so that you can do the thing that you want to do in a way that's both easy, but also extensible so that others can continue doing that as well. And so I think this is the value that Vite brings to the table, right? Is that out of the box with Rollup, it does, 90 or 100% of, depending on your use case. But then if you want to extend, you can do so.
And I think as a group, we're solving a lot of the same problems. SvelteKit had a predecessor framework called Sapper. And, we were trying to implement some of the things that now exist in Vite on our own. And it took a lot of time away from building the framework itself and wasn't as stable and as powerful as those corresponding features in Vite.
I double want to down on that, which is that, when you're building a framework, there's certain value add that you're adding, right? And so the last thing you want to do is spend your time and energy on something that really isn't the value add, right? Like everybody needs to have a build system. Everybody needs to have a hot module reloading. It's just a thing that you need to have in order to be competitive. And so how wonderful it is that you could just like piggyback on top of existing system that just does it rather than reinventing and being different, right? And having yet another way of how you are, because the more different you are, the more difficult it is for people to join, etc. And so the fact that you can just have the basics out of the box is just a huge one.
I think it's a very interesting question for Vite, because in a sense we're all consumers of Vite, and we know a little bit what it's like to interact and talk with consumers of our frameworks and libraries and different demands. I will say Patak is amazing in terms of how he interacts with and juggles, I guess, the not competing, but the different demands, the different uses that we all have for Vite. But and just to say that it's a difficult thing to build something that can be that common platform without just sort of degenerating into some kind of chaotic mess, which Vite isn't at all. Vite has this clear central vision, and yet it is, it's a common ground for us all.
Yeah, I think I saw everybody sort of nodding along with you, Daniel, as you praised the sort of vision and way that Vite goes about handling the different needs, because these open source projects, they get everybody needs are if you go into Git issues, we've all seen that there's only so much time, and it's not like the great Vite corporation is paying for this in spades, right? It's a very sort of different monetary model of sorts, however that might work out. I wanted to, we've talked about commoditizing. Misko brought up a great point that I want to get everyone's opinion here about commoditizing the things like hot reloading and server-side rendering and that sort of stuff. What would be, as all of you are working on your frameworks and things, what would be the next level or next tier or feature that you feel that you would like to do less, that could be sort of commoditized in a Vite-centric kind of way, where you're like, you know what? Everybody requires it. It's table stakes, and I hate doing it. So if we could just put a layer there to sort of take that off my plate, that would be great. I think, Misko, I'm going to start with you because I think you might have an answer off the top of your head while everyone else sort of thinks about it.
Because, I don't have an answer for you directly for the question you're asking. So I'm going to answer something slightly different, but it's the same kind of a point, I think, which is that when I started Quick, I really wanted to not reinvent as much as possible, right? And so Vite was obviously one of them, hot module reloading, etc. And so that was a kind of a no-brainer, and it actually worked. The other thing I wanted to not reinvent is to actually not reinvent rendering. And so I looked really hard into Solid, React, Angular, even Lit, to see if Quick could run on top of an existing rendering system. Turns out in that particular case, the answer was no. Ryan is shaking his hands it's not that simple. The answer is no. But in the case of Vite, it actually worked out beautifully. It's really nice to be able to go to people and just say hey, we just run on top of Vite, which means bring all your plugins along, bring your things like CSS imports, etc. It just all works out of the box. When it comes to higher level things like frameworks or rendering, I think the problem is that there is a bajillion different ways you could be doing it. And as a result, there isn't one best, or rather, it isn't clear what the one best way of doing it is yet in the industry. Whereas I think when it comes to a lower level things like bundling and delivering content, there's a general consensus on what the best way of doing things is. And I think that's the advantage that Vite has. And that's the reason why Vite can be successful across things, because everybody kind of looked at the problem and everybody kind of came to about the same conclusion. And the problem space and the surface area is relatively well constrained, rather than sort of something complicated as a rendering pipeline.
I think that's an interesting point, because I think if you look at the previous generation of build tools, sure, you might build an Angular app or you might build a React app or something like that, but oftentimes your build system would get so complex. With whatever tool you're using, you start to wonder, have I really built a React app, or have I built this crazy complex Webpack app that happens to just compile down into some sort of React sort of thing? I guess my point is if the tooling is solid up front, that it has the features that you need, like a lot of Vite configs I've looked at from different merchants that built on top Shopify, they're not doing anything almost at all in it. They're just taking pretty much everything that's stock out of Vite and rolling with it. And I think there's a something there, if you don't have a crazy bespoke sort of configuration, it's more portable, it's more maintainable, it's less of a framework in and of itself, just your massive conglomeration of plugins and tools and this, that, and the other.
Yeah, the next level up, I think, is a challenging one. Even to think a while ago that we get to Vite's level of abstraction up the tree might have been difficult to imagine. Sorry, Fred, I also tried Snowpack and Vite at the exact same time, and that was the difference for me, that they kind of almost, even if the implementation was, at that point, not where it is today, there was something about being able to generalize at that level of abstraction and being able to latch onto it. And then I think the next level is a lot harder. For me, the next level I think about immediately is routing and, file system routing and all that kind of stuff. And you start going, oh, maybe there's some common stuff there. And I think there might be, but I also think that that's where you start getting into that range because, I mean, I have a whole theory on this thing, but essentially routing backbone of web, every time we have paradigm shifts, every time there's like a generation frameworks, it's all based around the routing. This is a very ingrained thing. And it's something that even though we kind of know there's general points to, there isn't even complete agreement there. So I think we're, I'm saying this right now, I think we're almost at that level where right now where we can't go much higher, but something's going to come up and it's going to surprise us. So who knows? But that's where my feeling is right now. That's like the next thing.
It's interesting that some of those things maybe are also slightly outside of Vite in terms of it's what Vite has to, the scope of Vite, for example. So file-based routing is a very interesting thing and something that obviously I spend some time working with as well. And I mean, my heart would absolutely be to collaborate on anything like that, which is very much why we've extracted things out into separate GitHub organization. So that we can have an after party after this frameworks chat and talk about opportunities to collaborate with some of the Nitro stuff.
The other one is the adapters. Sorry, I just want to throw that out before I jump off again. But the fact that we all deploy to the same cloud platforms and they all have like the same thing, target output that we need to get to. I don't know if we can quite cross, but I just want to throw that one in too.
Surely we can, right? So I mean, I just merged incremental static regeneration for Netlify into Nitro earlier today. And there's a PR for Versal. And there is no reason, I feel like I'm undermining Nuxt in some way here, which I'm totally not, but there is no reason that you have to use Nitro with Nuxt. You can use Nitro with any framework here. And you get that out of the box. I mean, obviously, it's perfectly good to do things separately as well, but I mean, there are insights just looking around the room here. I feel like I'm turning this into something else, but I would love to work and collaborate on some of these things.
Yeah, it's crazy. I've talked to every single person that possible that I can about the meta frameworks, even people outside of Vite, and trying to like pull them in. And it comes down to a lot of us are doing the same work because there's kind of this thing where most of the cloud providers now are working off of the request response model, and that's actually making its way into the meta frameworks and even as this kind of common platform. And it's like, it'd be awesome. I don't know, again, completely do it. And I guess Nitro is an example of where you made an agnostic version of this, that we could all just get our requests and responses and just be like, okay, we're good.
Yeah, there's something so interesting about this group. I think everyone here is using Vite as a JS API, ultimately. They're using the SSR runtime, they're using the build maybe, and it's very different. Someone mentioned the word scope, and I think about that a lot. Like when you go to Vite's doc site and check out their starters, it's seen as this kind of all-in-one builder. Like it is its own, start and end. You use Vite to build a site, but then you get into these projects and they all use it as a thing to build on top of. So I think getting back to the original question, that's something that I would love to see more of an investment in. I think Vite does a great job with some of the SSR stuff. You feel like you're using it, maybe not the wrong way, but in like this other way, versus what the doc site is, very much about Vite, the build tool. We kind of use it one level below, and it's an interesting flow that I think a lot of Vite users don't see, but it's secretly powering all these other projects. And if you multiply all their users, it ends up feeling like a huge use case for Vite that obviously gets us very excited.
I think even without jumping to another level, there's still stuff that Vite's able to add in the future. I think Vite 4 is coming around the corner and starting to get excited and thinking about what's happening there. Like Fred said, Vite has traditionally been a JS builder. So like one of the things that we're really interested in looking at, Bjorn Liu contributes a lot to both Svelte and Vite and built Svelte pre-bundling as a feature. And so, we've historically only pre-bundled JavaScript libraries, but we also want to start doing that with Svelte libraries to make that much faster to load. And I think that that's something that hopefully we can turn on by default with Vite 4.
I sort of even got this impression, and correct me if this is the wrong analogy, working in other language and in other environments, the LLVM has sort of taken that idea of compiler optimization to the next level, where everyone sort of like interacts with the LLVM to get like all that sort of advanced optimizations and stuff for free. Like as long as you target this, you get that output. I think any language now has like an LLVM target compile. That's what popped up as a analogy, Ryan, when you mentioned the adapters, is like this idea that like all the cloud providers seem to be going in a specific model. And is there a place here to sort of align our needs collectively as a larger group and be like, okay, the adapter seems to be close enough to the same. Can we all sort of maybe make a bridge or a link or some sort of compilation target instead of doing this work over and over again?
Yeah, I'll throw a plug out. I really like some of these ideas that we're talking about, the next level of like, could it be easier, for example, to have like some sort of common runtime sort of implementation or abstraction so everyone doesn't have to do it over and over again? I'll just throw a call out to the Web Interoperable Runtimes community group that just recently started up. It's got a number of representatives from Cloudflare, from Vercel, Dino, Node, that are all on there trying to establish sort of some standards that these runtimes can implement, because a lot of them are just running some sort of V8 isolate at the edge or some sort of implementation, but the actual JavaScript APIs that are available and such are not standard. And so I think for Vite to implement a higher abstraction, it would also be super helpful, again, to have a more common standardization of what APIs are available in those runtimes. And sure, I guess Vite can maybe abstract it away, but at the same time, I think having better standards would really help. So if anyone watching this has interest in helping that, there's always help needed in that standardization process.
Is that the group? I want to say I came across something. It's like Dino and Node and the web APIs and Cloudflare and the workers and like everyone sort of working on the web API interface. Am I getting that kind of right?
Yeah.
Like half right?
Yeah. So you just think about like if you're deploying to Cloudflare versus deploying to Dino, what sorts of APIs are you going to have access to? What sort of crypto APIs? What sort of like APIs do they just provide available with the JavaScript runtime that you're interacting with? And if you think about what Ryan said, like honestly, that's just painful for us. Like we're just constantly trying to make Hydrogen work on all of these runtimes, and there's just subtle inconsistencies with it. And then all of us have to deal with it. I feel like with our frameworks, we got to be like, okay, there's some sort of random thing that's slightly different for one of these runtimes, and our users are on GitHub saying, it doesn't work on Cloudflare for this reason. And we're like, oh man, well, yeah, Cloudflare is a little bit different than these other ones. So like if there could be consensus on how these platforms work, it'd be easier for us to actually deploy to them.
Nice. What is I'm having this flash of like getting things to work in IE and Firefox and Safari across the board very, 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 very quickly. What does success for this group sort of look like in interacting with a consortium like the committee? The name isn't really rolling off my tongue. Web interface.
It's the Web Interoperable Runtimes Community Group, or Winter CG.
Okay, that's way better. I was going to say they definitely need like an acronym or something, because I'm not going to be able to remember that at all. Winter is coming. So what is for the group here? What would be success? Like where would success be for it? Where would you consider that committee Winter CG to be successful if they were able to provide you or standardize across X? Like you've seen this group, they're working on these standardizations to try and help you guys out and take away some of the one-off edge cases. What does success look like from your standpoint for that group? Like fast forward maybe a year or two. Brett, what do you think? You brought up the group. Maybe I'm wondering if you've had any like daydreaming thoughts about, wouldn't it be nice if everything just aligned perfectly and I didn't have to deal with this?
Well, we have different essentially adapters for these different platforms that have to be separately maintained. And if there's a new feature or something with one of these platforms, is it available or exposed in our adapter in some form or another? And then who owns and maintains that adapter? Is that something owned and maintained by the Hydrogen or Shopify teams, or is it owned and maintained by like Vercel or somebody separately? So I guess success for us would just be simplifying all that, you know, like, do I really need multiple adapters just to like deploy to like some sort of V8 isolate that hopefully is largely the same? I don't know. Just simplifying all that we have to do to support all these different runtimes would be success in my book.
Yeah, I'll shout out a project called Hat Tip that I'm really excited about. It's a really interesting way to tackle this. Like, we're all doing the same work about adapters. What if we standardized it? It's not trying to build standard adapters. It's trying to build a standard API for what does it mean to create a server, listen to a request. I could totally see a future where that library, in the same way that we're all building on top of Vite as a JS API, we could all build on top of that as a common interface. But then this library basically does the work, and it's I believe looking forward to Winter CG, it's all based on those standards. So I could see a real space here where it's not about sharing common adapters, it's more about sharing common APIs that have been abstracted away to handle this. I'm very excited about that.
And what was that called? Fred, you said Hat Tip?
Hat Tip. Hat Tip JS is the GitHub org. I can post a link.
Yeah, that'd be
Discord
fantastic.
chat.
Thank you. Ryan, you had a lot. You lit up when you said adapters earlier. What is your idea? Is the idea of success for you not ever having to think about adapters again, or is it something else?
I mean, this is a hard one because the layers just keep on pouring on and on and on when I kind of go down that train of thought. Yeah, I mean, I was just highlighting the pain points there. I worked, obviously, immediately went there. Other people had already been, doing work there. I looked at SvelteKit; they were there very early on as influence, and just like realized that. And then I looked at Remix, and then again, like it was like all these like notes in the adapters, like don't do this; it doesn't work on this platform, and like, yeah, I mean, this is one of the most painful things. But standards are also really, really hard because they take a long time to consolidate. And then, you want to be involved in the standards process, but like there's often different goals and different pieces. And and you could end up with, I don't know, web components or something. But essentially, we'll have to see how this goes. I'm optimistic, at least right now.
I mean, of course.
Go ahead, Daniel.
I mean, of course, there's multiple pieces here, right? So there's the runtime, which obviously is really important, and we need that common API and talking about it. But then, of course, there's a lot more to an adapter than just the JavaScript runtime, because you want things like what I was talking about, incremental static generation, which some platforms support, or something like that, or caching APIs, or being able to integrate into a CDN, and that goes far. I mean, that's totally extra. That's not JS runtime territory anymore. But you still also need some common tools for that kind of thing too. But that's maybe what Ben was also about to say.
Yeah, it sounds like a whole ecosystem that you just rattled off, Daniel. Something that we talked earlier about Vite sort of taking the best of breed and some of the ideas that we've learned over, and it takes a while too, right? It's got to bake and sort of, I remember doing gulp concatenate, and then Webpack was like, oh, this is better, and now it's bespoke Webpack, and now like, we iterate, and I feel like, and better stuff, in 10, 20 years, Vite will be superseded, but I feel like this adapter space, we've sort of found something tangible to hold on, like enough common pieces to pull together for adapters, or maybe not. Ben, what do you think?
So we actually have probably about 20 adapters, and they're mostly community maintained because, we just can't be familiar with that many different platforms and all the intricacies of all of them. And so, we definitely see authors having to, kind of reinvent some of the same patterns. And I think, we've seen places where that has started to get better. I think now all the major platforms, all the major hosting platforms now support ESM, which has been a really big win for us. Undici has allowed us to like have native fetch built in directly to Node, which has been really nice. And so hopefully we'll continue to see more traction in that direction. One last thing I was going to add too is that we actually, like, one interesting feature we have in SvelteKit is this idea of SSR route splitting. So we can actually like deploy each one of your routes on a different Lambda, and that keeps the size really small. It makes the startup really fast, and as a request comes in, it'll get handled, I think, much more quickly than if we were to bundle the app as a single bundle and deploy it. That also makes sharing adapters across the ecosystem a little harder, though, because now the adapters have to be a bit familiar with our routing system in order to split based on those routes. It has to have some knowledge of SvelteKit's routing. And so, we actually made some efforts to share adapters with some of the other projects and found out that was going to be pretty hard for that reason. So I really like this idea of continuing to work on the API standards for that reason.
I would love to talk to you at some other point about that, Ben, because we've taken the opposite approach. We have one single entry point, which has dynamic imports to all the different routes, so that the code is split. So actually loading the single handler doesn't load all the code into memory, but only the code that's actually required to render the result. But I'd love to talk to you about that in terms of the performance trade-offs that you've seen with having multiple functions needing separate cold starts, but the benefit of having a smaller bundle.
That is really, Fred brought up in the side chat, Fred brought up an interesting question. I'd like to pose this to the group. So we're talking about adapters, and we've been pushing out to the edge, with different deployment targets where, those functions may be on different servers across different environments, across different regions, or in a sort of centralized single server model where all, Daniel, what you were saying, where all the requests come into a central, and then that central server takes on. Are the frameworks, is that above the framework level? When you guys are considering framework stuff, are we thinking in terms of, are we building the framework to push out to the edge? Are we building the framework to stand up in my mind, I still think about it like I did 30 years ago, where there's a server in a box in a room with the tiles and a hot lane and a cold lane, and that's my mental model. And there's just a bunch of them now in different spots as opposed to just one big building. But that's the way I think about it. When you guys are working on your frameworks, is that your mental picture? Or are you thinking in framework pushing out to the edge? Or does that conversation come up in the adapter and you're like, okay, now I have to make decisions up here because of where those adapter like, are you basically trying to polyfill for edge versus central versus region versus, all this? Ryan, what do you think? I think I made Ryan's head spin a full rotation just a second ago.
Yeah, I mean, it's tricky because it's kind of like a bit of both. Like, you're looking for this common ground, so you can just be like, okay, I can get it there. I can run on the edge. I can run on serverless. Whatever you need, we'll put it there. But on the same time, you're like, okay, if I'm on Cloudflare, I've got like R2 and KV stores and stuff. And then you're like, oh, I can use durable objects to do WebSockets from a serverless edge function. I can't do that other places. I don't think I could be expected to generalize that. So like, that's not a clear line for me, at least yet. But I mean, maybe Daniel's got something.
Well, only that we have tried to generalize storage, so that we have this, which is this concept of unstorage, which also is decoupled from Nuxt, and also in the UnJS organization. I'm not a shill, I promise. So unstorage is basically KV storage that is compatible with lots of different drivers, including things like Cloudflare, Redis, memory cache, file system, stuff like that. And you can sort of merge them onto one. So you can use memory in dev and Redis in one environment and Cloudflare if you happen to deploy to Cloudflare. So we're trying, but I take your point that there are lots of things that platforms offer because they're trying to differentiate, of course, and therefore you can't have something that's 100% equal across all environments. So, a fair point.
Yeah, I think the ideal deployment target really varies by use case. And so like we've tried to make all of these toggles where if you want to deploy to the edge, you can do that. And if that's not what you're looking for, then, it's just an option. And so you can do either quite easily. And I think, also I didn't get a chance to answer Daniel's question earlier, but another one of the reasons why we built SSR route splitting as an option, and again, it's an option that you can turn on or off, like any of the other deployment features, is that like we've seen some of our larger users hit this limits of how big a bundle you can deploy, and so even if you're dynamically loading some of the code, the hosting platform's rejecting the deployment because your app is larger than X megabytes.
Hit that so many times. It's so frustrating. We have a hard stop. This group could go on for days and nights. We already have an after party on routing. Look out for Daniel's invite. Sounds like a wild time. This group really knows how to at a party. We've got maybe 60 seconds, so I want to go around the room and give everyone one last chance to shill their favorite shiny new thing. It could be music, video, comic book, whatever you have seen that is amazing that you must share with the world. And Brett, because you are at the top of the box, I'm going to start with you.
Oh man, I've got to shill something on the spot. I don't know.
Have you heard the good word about hydrogen?
Oh yeah,
e-commerce platform on top of Shop.
Yeah, I could be the corporate shill there and just say that, I guess. But I can't think of anything at the moment. I might come up at the end if I think of something.
All right, we'll go to Ben. Ben, what have you got?
All right, I don't have a pop culture answer, but in the coding world, we're working on building better support for VTest and Vite image tools directly into SvelteKit and our documentations and ecosystem.
Yes, anything for better testing, I will take it. Any effort there has my all-time gratitude. Mishko, what about you?
I have to top my own horn here a little bit. I think the thing to talk about is resumability over hydration. I think people should check it out and educate themselves. Quick is not the only framework who does resumability. There are others. But I think it's the way of the future. Ryan is laughing. Go, Ryan. Make fun of me.
No. I want to talk. Actually, yeah, I'm going to push TanStack and TanStack queries, TanStack location. We've talked a lot about Vite and the agnostic solutions and how we're all here. They've been making adapters or integrations with all the other frameworks, and this is something obviously very felt by Solid, whose ecosystem is a bit smaller than the others. But yeah, Solid Query just came out based on TanStack Query, Solid Table. All these things are basically off these generic things, and they have integrations with Svelte, Vue, React. Really cool stuff being done by Tanner Lindsley.
Yeah, I'll double down on the TanStack. Documentation is top notch. It is always the place where I can find, I don't have to go to the gist or the issues. It's always the place. The documentation is the reason I come back to that stack as well.
Yeah.
Fred?
Oh, Ryan stole mine. That was going to be mine. I've been really, really into that project lately as I play around with some more client-side stuff. TRPC, another fun project that I've been playing around with a lot. You can tell I'm living in TypeScript world where I'm impressed by anyone who does any really cool automatic typing. And HatTip, that other project I shouted out, which I didn't realize had a talk by the author at ViteConf. So there we go, full circle.
Nice. All right, we'll check out was it this morning?
I believe so.
All right, we'll check it out on the flip side on the 12 p.m. showing, or afterwards you can watch the talk on HatTip. Good shout out. Daniel, what have you got for us?
So I was totally going to go in the direction of TRPC, which is amazing. But check out Zod, for example, along the same lines. Wonderful validation of data and even parsing it and shaping it, throwing the right kind of errors, and doing that at the interface where you have unknown data coming into your app, such as when you're fetching data from remote APIs.
really makes a world of difference, because it means that your type safe app is actually as safe as the data that you validated. So that's a super tool. And one more thing, if I can, actually, in this case, toot. It's actually not my own horn. This came from the Google Aurora team, but something called Fontaine or Fontaine. I'll put it in the Discord chat. It's a framework agnostic library. It's built with unplugin, so it works in any Vite framework. Drop it in, and it creates automatic font fallbacks, so your custom web fonts don't flicker around the page when you use them. And it's totally based on algorithms from the Aurora team. Check it out.
Very nice. All right, we've got 10 seconds. Brett, last words.
All right, I'll throw out, check out Preact Signals from the Preact team, just recently announced by Jason Miller. Just kind of an entirely new way of thinking about reactive data in kind of the React world.
Awesome. Thank you so much to everyone on the panel for coming in and giving us your thoughts, your ideas, your time. I think we had a really interesting conversation on adapters, routers, files, Vite, and the ecosystem at large. This group is always a blast to get together. I always have such an amazing time. Thank you, everyone, for coming. We appreciate it. Enjoy the rest of ViteConf.
Hey everyone, I'm Jason Langsdorf. I'm the host of Learn with Jason and the VP of Developer Experience at Netlify, and I am super excited to be talking with you today about the next section. We're going to be talking about hosting and the edge. So what is really exciting to me, and one of the reasons that I'm in the role that I'm in right now, is that it feels to me like we've reached a new era of web development. I think the introduction of edge computing, so the shift to serverless and lambdas, the introduction of true edge functions that are executing at the edge nodes, is giving us an opportunity to build things that were not possible to build before. So we're starting to see innovation in a way that was not possible just a few years ago. And it's going to unlock things that we never thought we were going to be capable of. And so that to me is extremely exciting and one of the areas that I'm most excited about in web development. And the next set of speakers that you're going to hear from are going to be digging into how this works, what you're capable of doing with it, where you can go and do, what is edge computing? What are you actually getting into? So buckle in, because this is going to be a lot of fun. So our first speaker is going to be Matt Kane from Netlify. Matt is absolutely brilliant if you haven't ever seen him speak before, and is going to be digging into Netlify's edge functions offering. Following that, we're going to be talking about how Vite and Vercel work together. We're going to hear from Lee Robinson. Following that, we're going to see how Vite and AWS Amplify work together. So that's Josefine. We're going to see Vite and Firebase. David East is always a pleasure to listen to. Firebase is a lot of fun and has been in this game for a long time. So you're going to see how this has evolved over time. Then we're going to see a new contender. We've seen Bun kind of explode onto the scene with ultra high performance. And, that makes Vite and Bun pretty kindred spirits in terms of just making everything as fast as possible. So can't wait to see what Jared has to say. And finally, Bartek's going to talk about Dino. Dino is really exciting. It's kind of the spiritual successor to Node, to see what we can do to improve a system once you've seen how it works. And Dino is also kind of underpinning Netlify's edge functions and introducing a whole lot of new ideas that are going to be, I think, really exciting for everybody. So It is going to be a great section of talks. Definitely strap in, get comfortable, get yourself a beverage and a snack, because this is going to be a really solid set of talks.
Hi, I'm Matt Kane. I'm Principal Engineer on the Ecosystem team at Netlify. One of my responsibilities is to make sure web frameworks work perfectly on our platform, including contributing to open source projects and writing our own integrations. I'm going to talk about how we were able to help add support for Netlify Edge functions to lots of frameworks using a Vite plugin. We launched Netlify Edge functions in April this year, and had SSR support for loads of frameworks on day one or shortly after. All of the ones you can see here allow you to deploy your whole site to Netlify Edge functions and serve them from the edge for super fast SSR. Of course, most of these frameworks use Vite, and I'm going to talk about how this helped us support so many frameworks so quickly. But first, quick introduction to Netlify Edge functions. These run in lots of locations around the world, so they're closer to the user. They are powered by Dino, which means TypeScript works out of the box, and they need the generated code to use ES modules. The Dino environment is based on web standards, which makes it a lot easier to support different platforms. We also tried to keep the actual Edge function API as standards compliant as possible. The request and response are standard fetch request and response objects, which are supported by most frameworks. As well as supporting middleware-like use cases, we wanted to make it as easy as possible to use by frameworks to do server-side rendering at the edge. So we have extra APIs to make it easier for build tools to generate edge functions. So luckily, Vite is great at doing server-side rendering on the kind of worker-like runtimes that are used on the edge, including Netlify's Dino runtime. With Vite's SSR support, we can generate self-contained ES module output, and it includes a web worker target that generates code compatible with the Dino runtime. If we create a custom server entry point, we can accommodate the different request formats too. So, what do we need to help a Vite-powered framework support edge functions? First, we need an SSR entry point file that can invoke the framework's SSR handler. This is what you pass to the Vite CLI with the SSR flag. Each framework is a bit different here, but the general principle is the same. Take a request, return a response, with a bit of extra magic for error handling and static files. Then we need to make sure we build the SSR output in a Dino-friendly format, and that we put it in the right place for Netlify to find it. Finally, we need to generate a manifest to tell Netlify to invoke this for all requests. Most of these can be done from the Vite config, and apart from the entry point, they are largely the same for each framework. Because of this, we decided to implement them as a Vite plugin. This does everything except create the entry point. It sets the format to ES modules and the target to web worker. This works best with the Dino environment. It also disables external dependencies. Dino doesn't use node modules, and setting this ensures they're all bundled together instead. It generates the edge function manifest and also injects a manifest of static files as a virtual module, which makes it easier to skip SSR for these files. So here's how it's used. In the frameworks that have support, you don't need to do any of this yourself. It's now built in. This is just showing you how it works. Here's an example of what the entry point could look like. Once again, if you're using one of the supported frameworks, then this isn't something you'd need to write yourself. But if you're a framework author, then this should give an idea of what's involved in adding support for Netlify Edge functions. So thanks for watching this quick introduction. If you want to learn more about deploying to Netlify Edge functions, then take a look here. Most people will just need the first link, where you can find out how to deploy your favorite framework to Edge functions. The second link is for framework authors who would like to deploy to Edge functions. You can learn more about the tools and APIs that we provide you, including links to the Vite plugin and more in-depth examples. Also, please do get in touch with me because I'm always happy to help with anyone who's creating one of these sorts of integrations. Best place to find me is on Twitter, where I'm Scorbig. Goodbye, and thanks for watching.
I'm Lee, the VP of Developer Experience at Vercel. I'm excited today to talk about Vite and Vercel. Vercel is the platform for front-end developers, giving you the speed and reliability you need to create when you're inspired. And today, we're going to be taking a look at how you can deploy Vite applications to Vercel. When you have a great idea for a new project, you don't want to be slowed down by your tools. And that's why Vercel makes it easy to develop, preview, and ship your application with support for 35 plus front-end frameworks. Last year, we announced support for zero configuration deployment of Vite projects, including automatic optimization, and I'd like to show you a quick demo of how this works today. To start, we can head over to the Vercel Templates Marketplace, where you can find templates to get started building any type of application with any framework or tool. In this instance, we're going to start with Vite and Vue. So I've just picked this Vite and Vue template. Let's go ahead and click Deploy and get started. First, I'm going to make a new repository on my GitHub account. I'll make a private repository called Vite Vue. I'll click Deploy, and this will kick things off. First, it will clone the Git repository that has this starter template to my personal Git account, download that code, and start the build process for generating my new Vite and Vue application. And it looks like in about 13 seconds, it completed. So that was really fast. We now have our new Vite and Vercel project deployed live on the internet with our own URL. It's really that easy to get started. And now if we go into our dashboard and we go to our project settings, you can see that Vercel automatically detected Vite as our framework preset and sets the correct installation commands, build commands, and everything for us without us having to manually configure anything. Now, Vite is also used behind many popular open source frameworks like SvelteKit, and you can also deploy those with zero configuration on Vercel too, and still be able to eject out of that framework and use the Vite configuration that you know and love. For example, we could go through and deploy a similar SvelteKit boilerplate and still be able to tap into Vite. So to recap, we can go from idea to global application in seconds by using the Vite and Vue template on Vercel or any other template from the 35 plus supported front-end frameworks with zero configuration. Give Vite a try out on Vercel today, and we'd love to hear your feedback. Thanks.
Hello and welcome. My name is Joseph. I'm a developer experience engineer working with our open source developer experience team here at AWS Amplify. And today we're going to be talking about Vite and Amplify, but more specifically, how to build and host your Vite apps with Amplify. And you can do so by getting started at docs.amplify.aws, as well as joining our community Discord server with thousands of other developers using Amplify. All we'll need to get started is an AWS account. And for demo purposes, I've already created an account. I'm logged into the AWS console, and here we can see we have the Amplify hosting console pulled up, and this is where all of our Amplify apps are going to live. So let's get started by building our app. We can scaffold out the Vite project with pnpm create Vite, and we're going to choose the TypeScript React template. Afterwards, we can see Vite has created all of the necessary files for us to get up and running. However, we're going to copy just a few modifications. And let's go ahead and install our dependencies. Afterwards, we can spin up the dev server and take a look at what we've built. And there we have it, our first Vite app. However, this is just running locally, and it would be great if we had it on the internet so we could share it with all of our friends. So let's do so by creating our Amplify app. We're going to want to run Amplify init. And this is going to be our entry point for creating new Amplify apps with the CLI. This is going to prompt us for our project name, as well as a few project configuration settings, some of which we are going to change. So we're going to point our primary environment to main. We use Visual Studio Code, JavaScript, React, source directory, build, and we're going to change these commands to use pnpm. After choosing our target AWS account, we'll see the CLI is going to start creating a few resources behind the scenes, namely the Amplify app, and this would help us extend our app later by adding other resources such as authentication, GraphQL APIs, or serverless functions. Remember, though, we wanted to output our app to build. So we will have to change small Vite setting to output to build. And here we can see the CLI has progressed. We're going to opt in to help improve the CLI. And now that we can see, the CLI has created an Amplify directory, which will hold all of our backend definitions, as well as metadata files for those backend resources. Now that this looks great, let's go ahead and commit this to Git. And we're going to commit this to Git prior to adding hosting, because as soon as we add hosting and connect to our repository, it's going to trigger the first ever build of our site. Now that this is complete, let's go ahead and add hosting. We are going to choose the Manage Hosting solution with Amplify Console and the Git-based deployments. Now we can choose to connect our Git provider, choose our repository, our newly created environment, and the backend role necessary. We see that it's also detected that we have an amplify.yaml build spec file, which contains the specifications to build both the backend and the front end. Next, we can review these settings, and if they look good, we can go ahead and save and deploy. And now, we'll see Amplify Hosting is going to kick off the first ever build of our application. After the deployment has completed, we can now visit our Amplify app. And there we have it. Now we can share this app with all of our friends. And that concludes my talk on Vite and AWS Amplify. Thank you.
Vite is amazing. It allows you to build without needing to be a build tools engineer. TypeScript, CSS modules, framework builds, they all work with no config or just a small amount. Vite focuses you on what matters: building the website. My name is David East and I work on Firebase. And I'm also the self-proclaimed #1 Vite superfan. Vite reminds me a lot of what I like about Firebase. With Firebase, you create a project, and then you can create databases, storage buckets, serverless functions, and set up authentication, all in a few clicks. From day one, our goal has been to simplify backend development so you can focus on your site. And that fits perfectly with Vite. Okay, so I promised the most amazing 5-minute Vite plus Firebase tutorial, and you know what? I have less than 4 minutes to deliver. But that's okay, because it only takes a couple of minutes to show you the basics of building on Firebase. In the Firebase world, development starts with our CLI. After installing via npm, I'm going to unlock an experimental feature. I like to call it Vite mode. From here, you can run our init command for a specific service like hosting. And just in time for ViteConf, the CLI will prompt you to pick from a list of frameworks and tools. Let's get it up and running with Firebase. To access data from your Firebase backend, download the JavaScript library from npm. To set up this library, you have to import an initialize app function. And usually, you have to give it this whole configuration object. But, new feature alert! Say hello to AutoInit. This injects the configuration object behind the scenes, and all you have to do is call initialize app and move on with your life. Firebase is cloud-based, but your Firebase development doesn't have to be. I'm going to spin up the Firebase emulator suite to run Firebase services locally and with a UI tailored for development tasks. The CLI boots up the emulators and detects that we're running Vite, so it spins up the dev server. Now, let's detect login state. The onAuth state change function takes a callback that fires in real time when a user either logs in or out. Right now, the result is null because there's no user. Let's change that. Firebase authentication has so many providers to pick from. My favorite is anonymous authentication. The sign-in function triggers the listener, and this is a core concept in Firebase. We usually don't await the result of an async operation. We use a listener to keep data flowing in real time. Now this user gives us this UID property, and it's essential because we use this to save and secure data in a database like Firestore. Firestore is a NoSQL database that follows a structure of collection, document, collection, document. And you can utilize this hierarchy to create data structures that are read by a key. To write data, you create a reference to a path and use an updating function. And now for the fun part. The onSnapshot function takes in a callback that is triggered anytime an update occurs. And inside, you can assign the result of the snapshot data to some UI, and now it's in sync. And just like that, we have a real-time functioning chat app. Now I want to deploy this. But you know what? There's one more thing to address. You secure Firestore using our own custom language that's designed to match documents at their path, like a router, and specify an expression that determines whether the read or write is allowed. This rule allows anyone to read messages, but writes can only be done by the user who owns the data. Alright, this is secure. Let's ship this. New feature alert! Typing Firebase deploy detects Vite, runs the build, and ships it to Firebase hosting. Plus, you get this cool web.app subdomain. Here's the site, served blazing fast, backed by a CDN. Okay, so I have like 15 seconds left, so I hope you saw that Vite plus Firebase is amazing, and a big thank you to ViteConf, because you know what? This has been my dream.
Today I'm excited to talk about Vite and Bun. Bun is an incredibly fast JavaScript runtime, NPM package manager, JavaScript and CSS bundler, and TypeScript and JSX transpiler. It's designed from the ground up to be really fast. I spent so much time profiling, and the rest of the team spent so much time profiling because being fast matters. And Bun makes Vite faster. Today, you could use Bun as your package manager with Vite. Installing a Create Vite app with Bun happens 39 times faster than NPM, 59 times faster than PNPM, and 82 times faster than Yarn. You can reproduce this benchmark with using the screenshot in the code on the right. You can also use Bun to run package.json scripts. Bun run dev launches Vite 2 times faster than Yarn, 2.5 times faster than NPM, and 3.5 times faster than PNPM. That's the current state, that you can use Bun as your package manager with Vite. The next step, that's coming up next, is that you'll be able to use bun.transpiler to transpile your JSX files. And that's just going to work with Vite. And the reason why that matters is because bun.transpiler is really fast. It's going to make it so your builds run faster, so your hot module reloading happens faster. And it's actually going to be fewer dependencies to install because bun.transpiler is built in directly into the runtime. Bun.transpile transpiles the same JSX file 7 times faster than SWC, 14 times faster than ESBuild, and 40 times faster than Babel. Bun will also natively support Vite's hot module reloading API, import.meta.hot. This will enable Vite's hot module reloading on the server to run much faster than it can in other JavaScript runtimes. Bun will also just run Vite faster than it does in Node. This is what the team is currently focused on, is the remaining dependencies that don't quite work yet at the time of recording. I'm hoping to have something more interesting to show you by the time this video airs. So you should check out my Twitter.
Hi everyone, I'm Bartek, a core engineer working on Dino, and today I'm going to show you how to set up a Vue app with Vite and Dino, and then we will deploy it to the edge using Dino deploy. Before we do all of that, why Dino? Well, Dino is a new JavaScript and TypeScript runtime that is super easy to use, so you don't have to configure anything to get started with either JavaScript or TypeScript. And besides that, we ship with a whole integrated toolchain, so tools like testing framework, linter, or formatter are built into the binary, and you can get started immediately. Besides that, Dino is secure by default, so unless you opt in using these allow flags, Dino won't be able to check your file system, talk to the internet, read environmental variables, or spawn sub-processes. And finally, you can deploy your apps to the edge in seconds using Dino deploy, which is our serverless offering. Okay, let's jump immediately into demonstration. So I'm going to switch to my terminal, and I will do Dino run and -- allow env, allow read, and allow write. So we opt into the sandbox. Then I need this unstable flag, and I'm going to run npm create vite extra package. So let's do that. I use the default project name, and I use Dino view template. Perfect. cd into the project, and I will open up my code editor. Notice that we don't have package.json here. Okay, let's open up the terminal and try to run the project immediately. So Dino task dev. Okay, seems we're up and running. Great, Vite plus Vue, and we got this cute little Dino mascot holding Vite's logo. So since we're at ViteConf, let's quickly try to change something here. Instead of Vue plus Vite, we'll say hello from ViteConf and save it. And sure enough, it's been refreshed. So I think this is good enough to ship it already. So I'm going to initialize a Git repository, and I will actually quickly add git ignore file so we don't have to ship node modules or .vite directory. Okay, I created a fresh GitHub repo, but there's nothing here. So I'm going to git add everything and then specify these things. Okay, the code should be here already. Okay, it is. So let's go to dino.com/deploy and sign in. And I'm going to create a new project. I will select the repository we just created. So ViteConf example using main branch, sure. And we'll use GitHub action mode so we can actually build our app using Vite before it's deployed to the edge. And let's make the name shorter. So linking the project. Okay, the project is linked. Here's a template of what we need to do, but I prepared another template before we started the recording. So let me quickly add a GitHub Actions file here, workflows, and let's just name it deploy.yaml. Paste it here. So we're just cloning the repository, installing Dino binary, running Dino task build, which will actually build our Vite app, and then deploying it to Dino deploy, which will serve it using a simple file server. Perfect. So let's add it. Deploy script, that's fine. Push it. And let's see our actions here. Nice, this is running. Let's wait a few seconds and see what happens here. So we go here. The job is starting, setup job. Okay, let's wait a few seconds. Dino is installed, and notice that Dino is pulling all of these npm packages for us without a need for explicit npm install script. Okay, building for production, perfect. So Vite is doing its job, and it's deployed. We got this ViteConf example dino.dev. So let me actually click this link, and we're live. We just deployed our Vite app using Vue and Dino deployed to the edge, close to our users, in under 5 minutes. I hope you enjoyed this talk, and if you're interested in Dino, make sure to visit our website at dino.land or shoot me a message either on Twitter or via email. Thank you, and I hope to see you soon.
Sup ViteConf goers, hope you've been enjoying the conference so far. In this section, we're going to be talking about something that I think is pretty dang interesting: custom frameworks. I've always said that Vite is kind of a batteries included guide to build your own framework on top, and these two speakers have really taken advantage of that. First up, we have Ram. I just want to get to know this guy personally after learning more about him. He's up in Bavaria right now. He graduated with a computer science degree from Karlsruhe. He loves the Alps. He loves beer. He loves folk festivals. Who wouldn't want to grab a beer with this guy? And he's going to be talking about Vite plugin SSR. I've been following this project for a long time because I was building my own little framework on top of Vite back in the day. And the source code of this one was kind of the holy grail of possibilities that you could do in Vite. So I would definitely stick around for a talk about how you can SSR anything with Vite when you're using this package. Lets you SSR React, Vue, Svelte, and provide some infrastructure for you to build whatever adapters you want for your framework of choice. So super fascinating stuff. Definitely stick around for that talk. Next up, we have Jonas, who spends most of his time in the open source realm. Wish we could all do that. And he is both a snake keeper and an amateur pool player. Interesting dichotomy of skills to go on a resume, I guess. And he's coming out as hot from Fastify DX. This is a way to take your node servers that might already be powered by Fastify and then bolting them onto a powerful Vite front end, of course built with whatever framework that you want to use. So a full stack solution built on top of the generic Vite framework gives you a lot of flexibility, gives you a lot of power, and I'm sure he's going to dive deep into that for his talk. So without further ado, let's jump into our next talks.
Hi, I'm Ram. I'm the author of Vite plugin SSR, which is similar to frameworks like Next.js and Nuxt, but does it do one thing, do it well, Vite plugin. It's slightly lower level, so it means that you need to write a little bit more boilerplate code. But on the other hand, it gives you a lot more flexibility. So for example, you can use Vite plugin SSR with any tool you want, any UI framework, React, Vue, Svelte, Solid, etc. You can deploy it any way you want. And to this day, there's not a single use case that couldn't be achieved with Vite plugin SSR. So in a nutshell, with Vite plugin SSR, you keep architectural control. What some users have been doing with that control is that they've been building their own framework. And one use case that is particularly interesting is building company internal frameworks. So for example, Vite plugin SSR sponsor is using it to deeply integrate Relay with React's 18 new SSR suspense architecture. And that's something, by the way, they couldn't have achieved with Next.js. But anyways, building company internal frameworks is a powerful idea. Because companies, especially large companies, struggle to scale their development teams. One major reason for that is because companies, especially large companies, have a wide range of engineering skills. So on one hand, you have the highly technical developers who care about, they want control, they want to be able to use any tool they want, and they want to be able to integrate tools however they want. On the other hand, you have the more product developers who care less about technicalities, and what they care about is shipping features, and shipping features quickly. So building company internal framework is a powerful way to resolve that tension between a high diversity of engineering skills. An interesting aspect of this is that your company internal framework can include everything. Frameworks like Next.js and Nuxt only include the front end. But your company internal framework can include everything: the backend, the front end, authentication, the API layer, error tracking, logging, etc. So it means that your product developers, the only thing they have left to do is define UI components and business logic. So it's a dream come true for your product developers. And it's also a dream come true for your highly technical developers, because they get to build your company internal framework and they keep architectural control. They can use any tool they want, and they can integrate the tools however they want. So it's a dream come true for both ends of the spectrum. So I highly encourage you to build your own framework. to scale your development teams and to ship features as fast as never before. Thanks for watching.
Hello, my name is Jonas Galvis. I'm a principal engineer working on open source at NodeSource. The title of my talk is Rethinking the Full Stack Framework. And I'll begin by posing a question. What do JavaScript full stack frameworks have in common? Let's start with the basics. You start with a Node.js web server, typically Express, then a modern JavaScript bundler, typically SWC or ESBuild. You connect the two so you can deliver production bundles and also development bundles with hot reload and SSR. So far, so good, but it's not quite there yet. A full stack framework needs to be able to provide client resources, the front end, and server resources, the backend APIs that can power an application. Convention over configuration helps with this. We can make it so every component under the pages folder becomes an HTML route, and every script under the API folder becomes an API endpoint. Sound familiar? And then we need a CLI to expose all functionality. Most frameworks have a dev command, a build command, start command, or something similar. What do JavaScript full stack frameworks have in common? I ask again. They are black boxes. Their architecture ends up being framework first. The framework controls the server and everything else. The result is excellent developer experience, for sure, but the problem arises when you need to extract the best performance possible from your application. Most full-stack frameworks pack so many features that it becomes hard to keep track of everything going under the hood. What do you really need? What could be stripped off? How can you make your setup lighter? That's why I decided to go server first with Fastify. Its architecture and plugin system are the cleanest and most transparent I have ever seen. Fastify is a truly composable framework. You can start small, grow as you need. And that's what I'm trying to accomplish with Fastify DX. Fastify DX is Fastify plus front-end goodness, all powered by Vite, of course. So you just have your server.js file, your Fastify server, the Fastify Vite plugin, and the Fastify DX adapter for your framework of choice. In this snippet, I'm using solid.js. That's all you need. You start your Fastify server, register Fastify Vite, wait for Vite to be ready, in which case it's harmless running in production. This only affects development mode, and you have a single server.js file controlling your application and everything a full stack framework would offer. Fastify DX brings two titans together, Fastify and Vite. You have flexible routing, integrated data fetching, hydration, and a universal store, hot reload, everything you would expect from a full stack framework. Without compromising performance, without compromising developer experience. The public beta is coming on October 20. Follow the project on GitHub to hear all about it, and also you'll find a link to a newsletter there. Thank you so much.
Hey everybody. We've been hearing all day about how great Vite is, especially for building our front-end applications. But did you know it's also good at helping us build our back-end applications? In this upcoming segment, we're going to learn about 2 different ways to integrate Vite into your back-end tools to have a single unified experience when building your web application. First, we're going to hear from Jess Archer. Jess works on the Laravel core team and is going to show us the power of using a Laravel backend to power our front-end applications, and also show us behind the scenes in the Vite integration. The Laravel framework has made Vite its default build tool, and Jess will be discussing that process and demonstrate what it's like to use Laravel with Vite. Next, we're going to hear from Maximo Mussini, who is going to tell us about front-end joy in Ruby and Rails. He's going to teach us how to use Vite to improve our development workflow and how to use it inside of a Ruby web application and how it compares to other tools that are available in the Rails ecosystem. I'm so excited to learn about these back-end integrations, and I hope you are too.
Hey everyone, my name is Jess Archer and I'm a full-stack developer at Laravel. Today, I'm here to talk to you about how we integrated Vite into the Laravel framework. For those that don't know, Laravel is an open-source PHP framework for building web applications. Laravel focuses on creating a great developer experience and providing everything you need to build your app so you can focus on delivering value. While Laravel is technically a back-end framework, it has a lot of affordances for building powerful full-stack applications with whichever front-end framework you prefer. For the past 5 years, Laravel's default front-end build tool has been Laravel Mix. Laravel Mix is a wrapper around Webpack, because while Webpack is a powerful tool, it requires in-depth knowledge to configure it properly. For example, this is a pretty typical Webpack config, and this is what a Mix config looks like. Here you can see our JavaScript entry point and our output directory. We're then running it through the view loader. We're also using PostCSS with a CSS entry point with a few PostCSS plugins. And then we're setting up some aliases and versioning when we're in production. Hopefully this gives you an idea of the APIs we like at Laravel and what we'd need to live up to when replacing it. After joining Laravel earlier this year, my first big task was to investigate Vite, because the speed improvements over Webpack were too good to pass up. Vite's primary use case is for building full JavaScript applications, so there are a few extra things we needed to do to make it work well with a backend framework like Laravel. We considered making another wrapper like Mix, but with Vite already being a joy to configure and already being a wrapper itself, we made the choice to write a plugin instead to allow our users to interact directly with Vite. The Laravel plugin's main job is just to configure Vite in a way that makes sense for a backend framework and to keep the user's ViteConf light. So let me show you what it's like to use Vite with Laravel, and we'll dive into some of the features we added and how they work behind the scenes. So let's jump into our terminal and install a fresh Laravel application. This will also install Laravel Sail, which is a lightweight wrapper around Docker Compose. Once the installation is complete, we can start our containers using Sail up. And now we're ready to jump into our browser to have a look at our application. Laravel doesn't come with a front-end framework out of the box, so at the moment this page is rendered using Laravel's server-side templating language called Blade. Now let's have a look at the Vite config that was created for us. Here we can see the configuration for the Laravel plugin. We're specifying a dedicated CSS entry point in addition to our JavaScript entry point, because when we're using server-rendered HTML, we can't wait for the JavaScript module to load it, otherwise we'd get a flash of unstyled content during dev mode. We also added a refresh option, which tells Vite to reload the page anytime we make a change to our Blade templates. But I prefer to use Vue.js, so I'm going to go and install one of Laravel's starter kits called Jetstream. Once the package is installed, we can scaffold our frontend using the Jetstream install command. I'm going to choose the inertia stack, which will automatically pass data between our frontend and backend. This will install a few npm dependencies and then run our initial Vite build. Once the build is complete, we can run our initial database migrations. And now let's refresh the page in our browser. It might look the same, but this page is now powered by Vue.js and we have a login and register link up the top. If we click on register, I'll go ahead and create an account. And now we can take a look at Jetstream. Out of the box, Jetstream comes with profile management, including password updates, two-factor authentication, the ability to log out of the browser sessions, and the ability to delete your account. We can also enable other features such as profile photos, which I'll quickly show you now. If we jump back into our console and we'll dive into the Jetstream configuration file and we'll come down to profile photos, we'll enable that and refresh. And now you can see we can upload profile photos. Let's jump back into our editor and have a look at the changes that Jetstream made to our ViteConfig. You'll see we now have a single JS entry point, because when we're using Vue, we can import our CSS via JavaScript. We've also automatically installed the Vue plugin with a few options that are required to correctly transform asset URLs when the application is not being served by the Vite dev server. So let's go ahead and start the Vite dev server, which we can do by running npm run dev. You'll notice that we're outputting some extra information, including the Laravel version and the version of our plugin, as well as the URL for our Laravel dev server. You might also notice that Vite's not listening on its default port, and that's because its default port is currently in use by a Docker port forwarding that's been set up by Sail. So let's go ahead and stop this and run this via Sail instead. Now you'll notice it's running on the default port, but also that it's running on a network address. This is something we had to do automatically in the Laravel plugin, because when you're running Vite inside a container, if it only listens on localhost, then it won't be accessible outside of the container. Let's take a quick look at the plugin source to see how that works. Here's where we're returning all of our Vite config options. If we come down to the server option, we have a conditional group of settings here that's only enabled when the Laravel Sail environment variable is present. Here you can see we're configuring Vite to listen on all network addresses, but we always respect the user's config if provided. If we come back to Vite, another issue we ran into is that many of our users were mistakenly clicking on the Vite dev server link instead of the Laravel link. When users click this link, they'd see a blank white page because Laravel doesn't have an index.html template. So let's click on it now and see what we added. Here you can see we have a helpful message guiding our users towards running and accessing the Laravel dev server. We've also included a link to Laravel's dev server URL at the bottom. Let's jump back into our terminal and have a look how that works as well. If we come down to the configure server hook, you'll see that once the Vite dev server is listening, we determine the address for the server, and then we're outputting it to the console below Vite's URLs. If we come down a bit further, you'll see we've also set up a middleware so that any requests to index.html will instead return our dev server index with the application URL injected. So now that the Vite dev server is running, let's refresh the browser in our application to make sure we're using the dev server. Laravel automatically knows when the dev server is running and knows where to load the assets from. Let's jump back into code to see how that works. If we open up our main layout template, we'll see we have this Vite directive where we're specifying our entry point. When the dev server is running, it'll automatically inject the Vite client script and load the assets directly from the Vite dev server. Otherwise, it will resolve the compiled assets from the Vite manifest. So how does Laravel know if the Vite dev server is running and what the URL of the dev server is? Let's jump back into the plugin source. If we come back up to where we're listening for the dev server to start and where we're fetching the dev server URL, you'll notice that we're writing the dev server URL to a file called the hot file. Laravel can look for this file to know that the server's running and what the URL is. If we come down here, you'll notice we've set up a bunch of event listeners for when the process is exited. And when that happens, we go and delete the hot file. Let's go back to our project and have a look at what the hot file looks like. The hot file is located in the public directory right here. If I go and stop the Vite dev server and then come back again, you'll see down the bottom that the file is no longer available. And if I come and start it back up again, then you'll see it's back. This was an idea we took from Laravel Mix, and it's a really elegant solution because it doesn't require any configuration of hosts or ports on the Laravel side. It doesn't even matter if Vite ends up running on a different port. So now let's test it all out, because I never get tired of how fast Vite does hot module replacement. Back in our browser, we'll come over to the dashboard and pop this over to the side. And then in our editor, I'll open up the dashboard.view that comes with Jetstream. If we come down to this welcome component, I'll delete this and then we'll add in a message of our own. Let's make it nice and big and bold, and let's give it a little padding. And we'll say, hi, ViteConf. Let's save that and have a look in our browser, and there we've got our message. Next up, I'd like to talk about a few advanced features. The first one is sub-resource integrity. This is a web browser security feature to ensure that the scripts you're loading have not been manipulated since you compiled them, perhaps by a dodgy content delivery network. This feature was recently added by my good friend and coworker, Tim McDonald. To enable sub-resource integrity, the only thing you need to do is add the Vite Manifest SRI plugin by Maximo Massini, which will automatically add integrity hashes to your Vite Manifest on build. The Laravel framework integration will automatically detect these and add the integrity hash to your script and stylesheet tags. We also support Content Security Policy or CSP nonces, as well as other arbitrary attributes for things like Turbo. While we're on the docs, I would like to point out that we've written some pretty comprehensive docs for working with Vite and the Laravel plugin. We've also integrated with Laravel's serverless deployment platform called Laravel Vapor. When deploying with Vapor, your assets are automatically pushed to CloudFront. And if you're running a Vite build as part of your deployment, the Laravel plugin will automatically pass the CloudFront URL to Vite so that it can be used in any URLs in your compiled code. And it all happens automatically, as you might have guessed by now. I'd also like to mention Laravel's free bootcamp that we recently launched, which is a tutorial I wrote to teach you how to build a Laravel app from scratch, all the way to deployment, using your choice of Vue or React. And as you might have guessed, you'll be using Vite along the way. Well, that's it from me. I'm really pleased with our transition to Vite, and I've had so much positive feedback from the Laravel community. I'd also like to give a huge thanks to the Vite community, especially Matias, Enzo, and Maximo, for all their help along the way. If you'd like to follow me on Twitter, I'm Jess Archer Codes. I hope you enjoy the rest of your conference.
Hi everyone, and welcome to Frontend Joy in Ruby on Rails. Today we're going to explore how to improve our frontend workflow when developing Ruby web applications. My name is Maximo Musini, and I'm located in Colonia de Sacramento, Uruguay. I love open source, and I'm the author of several libraries related to Vite.js, such as BitRuby and EOS. Before diving into what Vite.js can do, let's consider how web development has changed over the past 10 years. Back then, JavaScript was an early language with lots of bad parts to avoid. Organizing your JavaScript code was a difficult task as the language didn't have any primitives to split code into modules. Bundling was about concatenating files, so ensuring a proper load order was the developer's responsibility, with some tools like Sprockets providing aid to avoid duplicates. In terms of development feedback, there was only one option: reload the page to see any changes that you have made. Nowadays, JavaScript has improved a lot, with a more complete standard library and useful syntax sugar like lambdas and safe navigation. Tools like ESLint and TypeScript make it a lot easier to catch mistakes ahead of time. The introduction of a native module system has made it a lot easier to organize code and ensure it always loads correctly. In addition, since CSM can be statically analyzed, tools like Webpack and Rollup have been able to implement sophisticated techniques, such as tree shaking and hot module replacement. Now we can see changes as soon as we save a file, without reloading the page, leading to a faster feedback cycle. And this leads us to Vite.js. Vite is a tool created to improve the development experience when developing web applications. So why Vite? Because it was built around the native module system, it's often faster than similar tools like Webpack, featuring a non-blocking server start and faster hot module replacement. Under the hood, it uses Rollup to bundle your application, applying tree shaking and chunk splitting. Vite also adds optimizations like CSS code splitting and preload directives, ensuring chunks are loaded in parallel. Vite provides most of the features that you'll need to develop your web application, such as integration with PostCSS and CSS preprocessors, support for TypeScript and JSX, and official plugins for Vue and React. Vite also has excellent documentation and is friendly both for beginners and advanced users. Its extensible plugin system, inspired by Rollup, has allowed the community to create hundreds of plugins, covering tons of different use cases. From all the reasons that we discussed previously, the one that stands out to me personally is instant feedback. Let's take a look at a few examples to see what it feels like and get a sense of how hot module replacement and similar techniques can improve our development experience. For example, when editing CSS, changes will be pushed to the browser using WebSockets, replacing the previous style sheet with the new one. As a result, it becomes more enjoyable to iterate on a design and getting it to look exactly like you want. It's so fast that you can tweak from your editor instead of using the browser's dev tools. Unlike in traditional setups, in Vite you can use TypeScript without waiting for the compiler to run. Under the hood, ESBuild is used to discard type annotations. This allows you to prototype quickly, like you would with plain JavaScript, and fix compiler errors later, before pushing your code. If you have used Webpack, this one should ring a bell. When working with frameworks like Vue or React, changes to a component will be applied without re-rendering other parts of the application, which is great for large apps. Vue in particular provides a fantastic experience by skipping re-renders if you only change styles and preserving local state if only the template has changed. This makes iterating in development very fast and enjoyable. As I mentioned before, Vite provides an extensible plugin system and has great documentation. This made it possible for me to implement a plugin to provide hot module replacement for stimulator controllers in only a few hours. Here we have an example with 2 off-by-1 errors. Instead of reloading the page every time that we make a change to the controller, Vite will push changes to the browser immediately, allowing us to verify that everything is working as expected. Once you start using Vite, you quickly get used to seeing changes immediately. In my case, I wanted to see changes to Rails layouts and templates without having to manually reload the page. This prompted me to create another plugin. Although not as fast as HMR, it's still nice to have the page be reloaded for you after modifying a template or translation file. So, how can we leverage all these features in our Ruby applications? Vite Ruby is a project that enables full integration with Vite in Ruby web applications. The design of Vite Ruby shares a common thread with the design of Vite.js. I wanted to achieve a nice experience out of the box by providing strong conventions while at the same time allowing the user to opt out or tweak as needed. It supports frameworks like Rails, Hanami, and Jekyll, providing everything you need to get started with Vite. Typically, adding Vite Ruby to a new app is a one-line install. Let's cover some of the main features. Tag helpers allow you to reference your files, injecting script and style tags. In development, Vite Ruby will proxy requests to the Vite dev server, allowing files to be served on demand. It also provides a helper to inject a client script, which will connect through WebSockets to the dev server, and powers the HMR features that we saw earlier. In production, the build is configured to output a manifest, which will be used to map original file names to the fingerprinted asset URLs. The manifest is also used to inject associated styles, as well as to render preload tags for chunks, in order to optimize load time. Auto build is a feature in Vite Ruby that will automatically trigger a build if any front-end files have changed since the last build. It ensures that build assets are always up to date when using tag helpers, and it's really convenient when running tests locally or focusing on backend work. In this mode, tag helpers will use the manifest to resolve asset URLs, just like in production. Last but not least, deployment. Following a convention present in most Ruby frameworks, Vite Ruby will extend the assets precompile task to build with Vite. It will also configure Vite to output files to the public directory, ensuring they can be served or uploaded to a CDN. Vite Ruby will use the configure asset host and configure Vite to use it as a base URL, ensuring that all assets are served from the CDN, even for dynamic imports. As a result, deploying with Vite Ruby usually requires no manual configuration. So you might be wondering, how does Vite Ruby compare to other tools that are available for Ruby on Rails? You can use Webpacker to achieve a similar integration with Webpack. I used Webpack for many years, and it was a major inspiration for Vite Ruby, so thanks. Now, Webpack is powerful, but it can be difficult to configure it correctly, and it takes time to understand it well. Raise your hand if you have seen a Webpack config that made you cringe. In Webpack, call starts are very slow because it needs to process the entire app, in contrast to the non-blocking Vite server start. HMR is also slower than in Vite, as an incremental rebuild is required on changes. The main problem is that it is proportional to the size of the app and its dependencies. In large projects, cold start can take minutes, and HMR can take several seconds, which becomes painful. There are plans to circumvent some of these performance issues, but that just emphasizes how difficult it is to get a good setup. JS bundling and CSS bundling. These two libraries are new solutions to bundle JS and CSS in Rails, and they work by watching files and rebuilding on changes, requiring two separate processes if you're using both. Compared to Webpacker and Vite Ruby, they are lower level tools, requiring manual configuration to get started. The main downside is that they don't support HMR, so even when using one of the faster options like ESBuild, you will still need to do a full page reload to see changes. And finally, import map Rails, which allows you to define import maps using a custom DSL for pinning URLs. Its main advantage is that it doesn't require Node.js, which can be really convenient for small apps and certain deployment setups. The trade-off is that build optimizations like tree shaking are no longer possible, making it less efficient in production than a bundled counterpart. Also, major browsers like Safari and Firefox don't support import maps yet, and the polyfill requires native ESM support. In contrast, Vite has an official plugin to output code that can support browsers such as IE11. Finally, like with the previous option, it lacks support for HMR, so you need to reload to see your changes. In summary, none of these options can match the fast feedback cycle that Vite enables in development. With the exception of import maps, all other options are roughly equivalent in production, creating an optimized bundle. Vite Ruby requires less configuration than Webpack and JS bundling Rails, making it more friendly for beginners and developers that don't like configuring front-end tools. I'd also like to add that Vite benefits from a larger ecosystem, so there's usually more documentation and plugins available. To wrap up, I'd like to share a brief story about my journey with Vite. It all started back in 2021, before Vite had a major release. I decided to write a prototype in Rails that provided an integration similar to Webpacker, and it worked. Then I extracted a Vite Ruby core and created integrations for Hanami and Padrino. Shortly after, Vite 2 was released. Over the past year, the ecosystem has matured, and Vite now has a CI that can run tests for frameworks and integrations to catch problems before releases. As a result, once Vite 3 was released, projects like Vite Ruby and EOS were able to ship a compatible release on the same day. I'm really grateful to see that this project has been useful to so many people, and for all the contributions to improve it. And that's all, folks. Thank you for watching. I'd like to thank the Vite core team and its contributors. Also, this presentation was made using Slido.
Let's face it, sometimes testing is no fun. and many times testing can be so painful that it gets neglected. In this section, we'll be seeing 3 amazing talks about modern and exciting tools for testing. First is Jessica Sachs, who's going to be talking all about component testing within Cypress, which is actually powered by Vite itself. Next, we'll be hearing from Debbie O'Brien, who will be talking about Playwright and how you can test your components in isolation with Playwright. And lastly, we'll be hearing from Vladimir, who's going to be talking about ViteTest, what it is and how you can use it to improve your workflows. So sit back and watch as these 3 amazing developers share how you can level up your testing skills.
Hello everyone, wherever you are and whatever time it is for you, welcome to my talk on Cypress component testing for Vite. My name is Jessica Sachs. I am a staff engineer at a medtech startup called Path AI. I'm from Boston in America, and I recently left Cypress, but I'm still involved as a Cypress ambassador. I worked at Cypress for 2.5 years, joining in March 2020. I led the team that designed, built, and shipped Cypress component testing in Cypress 10. I'm a Faker.js team member and the occasional contributor to the Vue and Vite ecosystem. I'm loosely involved with the development of ViteTest as an occasional contributor as well. Cool. Now, what is Cypress component testing? Cypress component testing provides a testable component workbench for you to quickly build and test any component, no matter how simple or complex. Cypress is a browser-based test runner, and as of Cypress 10, you now have the ability to fully test drive an individual component's logic, including its CSS. I'll show you what I mean. Practicing a testable component-driven development workflow enables you to break down your work into more manageable chunks, ultimately resulting in components that are developed more mindfully. This is what Cypress component testing looks like in Vuetify, which is the Vue equivalent of Material UI. In this test, Cypress is testing out Vuetify's canvas-based vColor Picker component. On the left, we have the command log, which shows all of the commands that have been executed in this test. They're roughly equivalent to, 1 line of code per command. And then on the right, you have what would be called the application under test if you were end-to-end testing. Instead is called the component under test, which is our beautiful color picker. And I like to show instead of tell, and my goal in this talk is to give you a feel for what it's like to develop using Cypress component testing. So to do this, we will be test driving a simple counter component with a min, max, and initial value. I will also show off how flexible Cypress component testing is when it comes to ingesting your Vite config. We're talking markdown files, we're talking svelte files, JSX. It handles anything that you have configured in your Vite config. So let's open it up. Okay, heading over to the codes. So we're going to be working in Vue today, though it actually doesn't matter because Cypress will handle anything that you have configured in your Vite config. So pnpm cypress open -- component. This template is based off of the ViteTest, not ViteTest, ViteTest component template. I'm going to use Chrome version 105. We're going to start Cypress component testing in that version, and we're going to look at what component tests exist already. So we have this counter component test. We can either look at it, so let's do that, and see what tests already exist. So I've already written a few tests here. I've written a few tests that check out that we have a decrement button, that we have an increment button. It's very small probably for you guys, so let's make it bigger. Let's make my face smaller. Okay, that we have an increment and a decrement button. And you can see that when you click them, nothing happens. So we probably want to write a test for that because we're in a counter. So whenever you hover over the spec name in the test runner itself in Cypress, you can open it in your IDE. If you don't have your IDE configured, it will ask you to configure it. Cypress can be very smart. So the first thing I'm going to do is I'm going to hide the file explorer, and we're going to write a test that says that the counter decrements the value when the minus button is clicked. Let's call it the decrement button because I'm calling it decrement everywhere else. So not only should the decrement selector be visible, but when we click it, and we should, let's call it the, I don't know, I want to make sure that the value is incremented, right? So anything inside of this, data test ID counter. So we're going to get the counter selector. Let's implement that really quick. I'm going to split my screen. I like to have my tests running at the same time as my development. So I'm going to get the counter selector. You can watch the errors pile up, and I want to isolate using only, which is a method on it in many test runners, including Cypress. We're going to say counter selector. You can see the Vite plugin errors, which is pretty cool, kind of pipe up, and how fast that rerun is. So now we have the counter selector, and we can see Cypress telling us, hey, it's the entire node here. And we're going to click it. We're going to should have text. It should be increment +1. So, initial +1. Perfect. So we're expecting that this node should have text, but it was 4. We actually want it to contain text. You see that extra space there? We don't want to have this extra space. And at this point, you should be feeling like this is kind of like a test IDE. So let's command click into the counter and implement an increment function. Did we say we're doing increment or decrement? 1 second. What does the test say? The test says decrement. So let's implement the decrement function. So const decrement. I think I made a mistake actually in my test, but so we're going to say value. .value. Probably should have named it better. Minus. Let's name that counter. And Vite is reloading using a Cypress Vite plugin, the test runner over here. And then we want to make sure that when you click the minus button, and I can see that it's the minus button because I have a nice fancy plugin. When you click the minus button, we're going to call decrement. Nice. Cool. Text was 3, so decrement is working correctly, but my test is actually wrong. The test should be -1. And perfect, it does contain 3. Very nice. Now let's do the same thing for increment. So let's copy and paste the test. It increments the value when the increment button is clicked. Let me move my face over to an unused part of the screen. Very nice. Let's go and say everywhere it says decrement, increment selector should contain initial +1. Oh, did I implement it yet? No, I did not. Copy, increment, counter value ++, at click, increment. And that looks good. And I can play with it. Oh, very nice. Oh, should I be able to go into the negatives? I'm not sure. I think counters generally have the idea of a min, optionally probably. and a max. So let's go ahead and implement those things. So let's say in the test here, not only should it have a decrement button, let's grab these onlys and take them off. Boom, boom. It should not be able to go below the minimum value. Perfect. So let's mount initial, let's mount min to be negative, let's mount min to be 0 and implement that. So we're going to set initial to be 1 and the min, actually set initial to be 0. Let's do the minimum number of clicks. We're going to grab the decrement selector. We're going to click on that. So do we have, that's working fine. Okay, all the tests are passing still. Let's isolate this test. And we've clicked the decrement selector, and we should not be able to do this. So when we get the counter selector, it should have, sorry, we want contain text. It should contain text 0. It should not contain text -1. That's funky. Cool. All right, so now let's add those gates, those logic gates here. So we only want to decorate if props.min is, we only want to decrement if counter.value is greater than or, no, just greater than props.min. Is that correct? Why is it yelling? Unnecessary if after condition. Object is possibly undefined. I think my TypeScript language server is not working correctly. So I'm going to reload this window. Because I think this should work. Yeah. And so now we're going to do, oh. I guess greater than min doesn't feel right to it. So we can add some defaults versus actually fixing the type error. Sorry, min is going to be 0, max is going to be, I don't know, like 10,000, 2,000. Counter value minus minus, unnecessary after condition. I guess the linting rules that come with VitePress do not like this. Perfect. And then the inverse of this is going to be counter value plus plus. Very nice. Increment and decrement. Now let's start to do some weird stuff. Let's add some utility classes. Let's add hidden. So you see there's no more plus button. It's there still. And let's go into the spec file again, and let's like run this one. Oh, no, we do have a decrement. What about the increment button? Well, it's already telling us that the element isn't visible. And all of our increment button tests are failing because the user is trying to click it, but the hidden utility class I was using has display none on it. If we fix the CSS, everything passes. And it took 376 milliseconds to run all of these tests. It's not as fast as VTest. It is not as fast as VTest. However, it does process all of your styles and it does run in a real browser. It makes complete sense to me that it would not be as fast. I don't see a world in which Cypress would ever be as fast as a headless test runner. Except for, actually, let's write the maximum test. Except for when you think of snapshot testing. When I adapted Vuetify's component tests from Jest to Cypress, Vuetify was using to match snapshot, which writes to the disk. And when you write your snapshots to disk, it actually takes a bit of time. And adding Cypress component testing ended up speeding up Vuetify's component tests as a whole, which was shocking to me, but is what happened. So even though you might feel a little weird about, let's see, max is 1,000. Even though you might feel a little weird about having slower tests than could be possible, I think that having all of the development tools, having debuggers available is absolutely worth it. And I do all of my development styles, tests, logic. I do all of my development purely on this canvas in an isolated fashion. It's pretty cool. And especially when you think of all of the loaders that are going on under the hood here. So let's take it back to Vite. Let's finish this test. Increment selector. Whoops. Increment selector should contain text. Let's see, initial and max should contain text 1000. Let's go back to Cypress here. It was 1001. Let's fix it. Go to counter. Perfect. No. Did I break it? If the counter value is less than props.max. Perfect. So simple, yet so easy to break. And it's so nice when you can actually just see it visually there. All right, so from there, let's show off some other cool things like this plus button here. This is called Create New Spec. You can create from component, and you'll notice that these are all nice view files because the project has detected that it's view. But I'm going to show you some weird stuff you can do. So you can grab one of the about pages. So VitePress will grab markdown pages and it will render them for you as components. It will actually create routes and stuff. So this is a markdown component that actually works with view components. Here's our counter. Here is our counter from earlier. To prove that, and to prove that it does or doesn't work, I'm going to comment out the logic inside of our increment and decrement buttons. And you'll see that the about page gets hot reloading. That is super cool. Let's go to About MD. You can see our About counter, and we can start to write tests inside of the About size spec. Because it's a JavaScript file, it's complaining about global types. And we could start to write tests like get data test ID about counter and see that our stuff is correctly hooked up. I have never seen an application or a test runner that can test markdown files like this. VTest probably can, with no problem, but I've never been able to see something that renders it like this. It's so cool to me. All right, so wrapping up, I have a few more things to say in the keynote, and then we should be good. And they are concerning VTest versus Cypress versus Jest. So I'm going to skip over this section because basically Cypress just acts as a Vite plugin. Let me move my little face. There we go. Basically, Cypress just acts as a Vite plugin, and the entry point is a loader that dynamically imports each spec file. So it does a glob search for something that matches the spec pattern. Cypress uses .sci.js so as not to conflict with VTest. Moving my face again. Versus Jest. So we are giving the extension of spec and test to VTest because you probably need a node-based runner and a browser-based runner. You can use VTest for its speed, its lightning fast speed, and you can use Cypress for its ability to test thoroughly, test CSS. So I use VTest for unit tests and business logic and headless composables. I use Cypress for components that render, and I do not use Jest anymore. Some history and thanks. I would go over this in more detail, but I'm out of time. All I would say is that Cypress is highly inspired by the creation of Vite. Its current architecture is strongly influenced by Vite, and without Vite's existence, it is very likely that Cypress component testing would have been very Webpack specific. And for that, I am very thankful for the work that Evan did to create Vite and the Vite ecosystem. So, thank you.
Testing with Playwright. Hi everyone, my name is Debbie O'Brien. I'm a senior program manager at Microsoft working on advocating for Playwright. I'm an international speaker, teacher, YouTuber, open source contributor, and I absolutely love sport. From running to cycling to skiing or playing paddle, and I'm a 4th degree black belt in Taekwondo. So let's talk about Playwright testing. Playwright is reliable end-to-end testing for modern web apps. It can run on any browser, any platform with one API, full isolation. All your tests are run in isolation, fast execution, and it's got some powerful tooling. I'm going to show you a little bit of that now. So to get started, you can actually just use the VS Code extension, which makes it really, really easy. If you're not using the VS Code extension, you can use the CLI, but I'm going to show you the VS Code extension. So basically install it, and then all you got to do is in the command panel, right, install Playwright. And that will install everything that is needed to get your tests up and running. You can choose while you're installing if you want Chromium, Firefox, WebKit, only one of them, 2 of them, 3 of them, all of them, whatever. You can also choose to install GitHub Actions. Now, this is really cool, and I'll show you a little bit of that later, but it will set up the whole GitHub Actions for you so you can run your tests on CI without any extra work. Amazing. So once you've installed, and I've just run this on like a Vite project, you're going to get that GitHub folder with the GitHub Actions. You're going to get a test folder. There's going to be an example test in there and a test example folder with a bigger example test that you can go through in your own time, which is the to-do app. And then the Playwright config in case you need to configure anything else. Now, running your tests, you can run all your tests. You can run a set of tests, single test. All tests run in parallel, and that makes them super, super, super fast. Now, to run your tests, we can do this right in VS Code, which is really, really cool. So basically, there's a testing sidebar. We can click on that and we can go to the test folder. And there's our example test. We can open that file and you'll see a little green triangle and you can click that and it's going to run the test for you. Now, I have show browser selected. So this is going to open the browser and it will run through that test really quickly. Now, it's just a simple example test. So it's very short, but basically that's how you would run your tests. Now, what about debugging when things go wrong? Because things always go wrong with testing, don't they? Yes, well, right in VS Code, you're going to have error messaging. So you can live debug and you can see the error messages really easy. Let me show you. We're going to take this test and we're going to just, break it. This is the example test that comes when you install. We're going to write the text equals star, for example. So we'll rerun that test and it's going to break. Now, why does it break? It breaks because it says error, strict mode violation. So by default, Playwright is in strict mode, which basically means Playwright is looking for the word star and it finds it in star, in started, and therefore there's more than one of these selectors and it doesn't know which one to select. So we can get a breakpoint here. So we can just kind of run in debug mode so we can kind of see visually, what's going on and what do I mean by that. So we look over here in the browser, we've got get started, text equals star. So it found star in get started, it found star in star. And down at the very bottom, it also found the word star in getting started. So Playwright's like, which one do you want me to choose? I'm not really sure. So that's what happens with strict mode. So you should really create your selectors so they're really resilient. So we put started. We still have one of two, right? So it's still like, I don't know which one you want me to click, which one. So be very, very cautious of that and make sure you're choosing the right selectors. So here we want the actual word get started, which is unique. Now we could improve that so much more by making sure it's, in a certain place in the header, for example, in a hero. You can really make sure that those are more resilient. So we rerun that test anyway with that selector and that was going to pass. So again, make sure your tests are written correctly, your selectors are the correct ones, and that will make your tests run much better. But live debugging, very, very cool. Locators. So locators are a way to find elements on the page at any moment with built-in auto-weighting and retriability. So you don't need to do anything extra, it just works out of the box. So that's really cool. And we saw a locator there in the last test we were breaking. So this is basically it. It's created with page.locator and then a selector with the options. It's strict by default, which we saw. So here it's like const get started. I'm creating that locator. I'm calling it get started. And I'm saying page.locator. So I want to find the locator on the page with the selector of text equals get started. Now we can use a CSS selector. We could use an ID selector. There's a load of different selectors. I'm just using the text one here. And we can prove that we could say a H1 has text of get started, etc. So there's a lot of ways. And I advise you to do check out the docs on our selectors to find more information on that. Now you can also pick a selector by hovering over. So right here, I can click the pick selector from the box and I can hover over things and you can see like the P has text, text equals, H1 has text, installation, area label, span has text, span has text again. Here we got an area label. And if I click on it, it's going to select that one. It's going to put it in the pick selector box in VS Code. And I can literally just press enter and it will copy it to the clipboard. Okay, so that makes it kind of easier to kind of understand a little bit about what selectors there are. So yeah, this one is good. Aside, and in the aside, it's got a text of writing tests. So I can basically choose that by pressing enter. Now it's copied to my clipboard and I can just paste it into my test and then I can run my test and keep building my tests. So make sure you're using web first assertions. We have a lot of assertions here. A way to expect locator to be checked, to be disabled, editable, to be empty, to be enabled, to be focused, to be hidden, to be visible, to contain text, to have attributes, to have class, to have count, to have CSS, to have ID, to have JS property, to have text, to have title, to have URL, to have value, to have screenshot, and so much more. So do check the web first assertions on that, and that's going to really help you write better tests. So talking about writing better tests, we have our friend CodeGen. CodeGen is a code generator. It's going to generate your tests by recording your actions. So this is a really good way of getting started with testing, especially if you're new to testing or if you're trying to encourage people to just, get in the door and get started. So let me show you CodeGen in action. Again, in the testing sidebar here, we can click record new and it's going to open up a browser. But if you look over here in VS Code, it has created a test-1.spec.ts file. It's importing the test and it's starting to write my test. So I'm going to put in here, let's test the Vite website, make sure it's good. So here you can see await page go to, and it's going to the right URL. Perfect. And I can click on here, for example, on the word Vite, and it's going to, add that in here. Let's click on guide, for example. And here we've got the guide up and running. And I've got ViteConf. Let's click ViteConf. That's going to open up a new tab. Did you see that? That's great. And I can, click on the ViteConf, make sure that text is there. So we're on the right page. And let's scroll down and the speakers. Woohoo. Oh, there I am. Look at that. Component testing with Playwright. We click on that and it's opened up the scheduling here. And this is the component testing Playwright talk. Amazing. So here I've got like my test run. Now look at this, page 1. So I've got page and page 1. So I've got 2 different pages going on, as we've seen, and I'm able to run tests across 2 different tabs. That's really cool. So here now I'm back in the first test and I'm back on the page instead of page 1. And I can alternate between the 2 of them, which is really good if you're testing a chat application or something like this. And here's my beautiful test generated for me. I can stop that and then I can basically rework that test and make it better. So it's just generated all that code for me without me having to do anything in just a matter of seconds. So that's pretty cool. Now, after this, we need to improve the test, right? So we, again, start using our web first assertions. So we go in here and we can have a look at our test and say, right, this is using span has text Vite. Okay, span is not great. Let's make sure it's in the H1 block, right? So the H1 needs to contain the text Vite, and let's create an actual expect here. We didn't really want to click. It's not a click event. It's just we want it to be visible. We want to make sure that's on the page. So we can use to be, and look at all the autocomplete here. It's giving me all the options, and I want to be visible. So I'll select that one there. I want the page locator H1 as text Vite to be visible on the page once I go to that main homepage. I'll rerun that test to make sure it's working, and yep, still working. That's great. And I'll carry on to improve this test a little bit more. So what happens here? Again, this is I've got a double click here because I was clicking before. So I'll remove that. We don't need that. So we can remove this completely. So the next thing is that we're clicking on the word guide. That's great. And that's giving us, we're clicking on Vite. Yes, we're going to page 1. We're waiting the pop-up and clicking on the text ViteConf. And when we've clicked on that, we want to make sure the text ViteConf is there. So we're going to expect, and we're going to say page 1, our new page, locator H1 has text ViteConf. We wanted to make sure that is visible instead of clicking it, okay? We did click it, but we want it to be visible. That's the test we want to run. So now we can say await page 1 locator text equals component testing Playwright. Yeah, that's good. We are clicking that and we're expecting the URL to bring us down to that schedule part of that page. And here we've got await, and we're going to expect the page 1 to have the text. We want it to be visible rather than clicking on that. So we want text equals component testing with Playwright to be visible. And now we have a much better test. So we can rerun that to make sure it works. And yes, it's working as expected. So we're pretty happy with that. And that's good. Oh, we could continue to improve that test some more. And that's basically how you should use your web first assertions, especially after running the generator. So let's talk about component testing, because we're all here for component testing, aren't we? Now that you know and understand how Playwright works, basically you can run your end-to-end tests, but at the same time you can start creating your component tests. So basically I've got a Vite application here, and I've taken the hello world component and literally just split it up into separate components. A card component that uses slots to contain the count, which is basically just counting, and then the title, which just has the title. So just 3 simple components, and I'm going to write tests for each of those. Now, to install Playwright component testing, we'll do npm init playwright at latest --ct. That will install the config file for my Playwright testing and everything I need for that to work. So once that's done, I need to install global styles, and I'll show you what I mean by this. So here I've written my first test, which is the counter. I'm basically importing the test and expect from experimental, it's still experimental, CT view. I'm importing my count component, and I'm just making, it should just be incrementing when clicked. So I mount the component. So component equals await mount, and I'm mounting that count component that I've imported. And I'm saying, I want the component to contain the text count equals 1. But when I go and click that component, I'm expecting that component to contain the text count equals 1. Sorry, the last one was 0, this one is 1. And now I click it again, and the component should count equals 2, right? So if I run that test, it's going to open up this browser, and I see my component, and it's got count as 2. It kind of clicked it, but it was so fast you didn't see it, right? Now what happens here is there's no style. So if I inspect this a little bit, I can go in here and look at it's a div ID equals root, and the button is just placed inside the root. There's nothing else there. It's title testing page. There's nothing. It's just empty, right? It's test it in isolation. Now, if I wanted styles, because my styles are down here in the style.css file, I've got some button styles here. Now, this came with the Vite app. So these are kind of the styles that are global, and I want every single button to get this style. Now, we could put this in the actual component itself, but because they're global, I just want to actually include this. So all my tests are going to run with this. So this is the title testing page. That's where that comes from. But in the index.ts file, I can import any style sheet I want. So in here, I'll import from the source folder. I'm going to import that style.css file that's just down there in the source folder. And that will then add all the CSS I need for every component that's going to be mounted for testing. Okay, so style.css is imported. Now I'll just show you what that looks like. When I start running that test, you're going to get that button styles from that global CSS style sheet. So here we go, and I'll rerun this. And now my count component is beautifully styled, taking the styles from the global component. So basically, yeah, you can run your styles in your component. You can have styles that are, theming, component, etc. And that's how you'd add them. And you can see now in the head tag, I've basically got the link rel style sheet. That style sheet is now being added in here. And that's how I'm getting my beautiful styles for the button. And it's working as expected. So that's how you do that. So basically, you can rerun the tests right there. And you can see it 0, 1, 2. Did you see that was really, really fast? But you can see that that's loading with the styles as expected. Now you can have various component tests. So I created 3 components. So obviously I created 3 component tests. So when you're working and basically building your components, you can just open that test file, and I can say, like, I'm testing the prop here that has a message of Vite and Playwright, and I'm going to click there, and that's working as expected. I can see it there in the browser. So that looks good. That's exactly what I expect from my title. If I remove that message prop, I've got nothing. It's going to break. It's going to tell me, hey, I'm trying to find this and I can't find it. I expected Vite and Playwright and I got nothing. So you can obviously then start going and fixing that. And as you're fixing it and you put that prop back, rerun that test. Your test is now passing, and that's good. You can move on to the next one. If I go to the card is using the vslot count, and it's basically putting that count component inside the card. And if I run that test, I can see that component working as well. So it's a really nice and comfortable way of running through your tests and building your components, and then, basically just testing them out, working on them, and seeing them in the browser. Just a really nice experience. So how is it working exactly? Well, basically Node.js, right? We have our test runner, powerful test runner, built using Node.js. And then all the components are in the browser. So the button, the counter, accordion, every component is built in the browser. So we've got powerful test runner with file system access, parallelization, but then real browsers. So you got real clicks, no emulation, real clicks, real CSS and layout, and screenshot testing. So let's have a look at how it works under the hood. You compile the component bundle on the facet HTML page. So under the hood, you've got a global setup. So you've got these components, which is, the count, the card, the title. So it looks for those. And then it basically uses Vite, yes, Playwright uses Vite to compile and bundle those components. It creates a cache, Playwright index HTML, and the Playwright bundle.js. And then it uses Vite again to serve that component. So using Vite, we then have that component rendered on localhost 3100. Playwright index.html, Playwright bundle.js. So if you're running using the terminal, you'd have to go to the localhost 3100 to see that component. If you're using VS Code, we didn't have to worry about where it was. We just clicked it, showed the browser, and it opened it up for us. And that's all being served thanks to Vite. So component test features, we've got real browsers, we've got Chromium, Firefox, and WebKit, all Playwright capabilities, a great developer experience. We're importing components, and you can use JSX syntax where possible. Handling component events in tests, VS Code extension we just saw, debugging we just saw, and Playwright tracing, etc. Let me show you a little bit about that. So to get a Playwright trace, first we've got to show you the reports. So we can run the test using the CLI. Once we do that, we can then use npx playwright show report. Now that will give us a report of all the components run on all the browsers, and we could go through all of those. We could see what tests have passed, flaky, failed, skipped tests, etc. We could save a whole report of it. Now, we can also turn on traces. So traces normally are done on CI, and they're done on retry, on the first retry when the test fails. But you could just do it locally. If you want to see what's going on, you can use -- trace on to turn that trace on. So once we do that, we'll see that little trace icon here. And we've got all our component tests. And we can literally click on that little icon or open it if you wanted to and go through it. And now we've got a trace file for our component. So we can literally like scroll along here and see what was happening at each point in time on each event. We can see every single action, and we can see like here, we expect to contain text. We can see in the center there, the action, that red dot is on the actual, that's what we were clicking on. So that's right, that's exactly where we wanted to click. And we can see like the before and after. So in this one, you know, the before and after is the same. If we go on the click one, we got the action is right there, and count is 1, before count is 1, and after count is 2. So we can really understand what's going on with our component. And this is great if you have an error and you wanted to kind of figure out what's going on. Here's the call, expect to contain text. Expression, to have text, we want the expected string, count is 2, and we can see there that the received was count is 2. We can also have a full log. We can see that full log of what's going on. We can look at the console for errors. We can see the network, and we can see the whole source code right there. So we don't even have to open VS Code to see our source code. We can see it right here on the trace. And we can see the metadata. So this is running on Chromium, is mobile, is set to false. And we can like really just understand and work through every single step of that component. So you could also run tests on CI with GitHub Actions. Now, we mentioned that earlier at the start of the talk, that just by clicking that, select, we have GitHub Actions. And that's pretty much all we need to do, except we just want to add a little bit of extra. We want the component tests to run. So we're going to just add like a new name, run playwright component tests, and then run npm run test CT for component testing. And that will then run the component test as well as the end-to-end test on CI. And then literally you're just going to have all this going on every time that you make a change, every time you make a push or a pull request, your tests are going to run on CI. And then you'll be able to open up that actions, open up the summary. You can go through the test and see the log if you like. You can click that playwright report. You can download that, extract it, put it into your playwright project, and then you could open that up using npx playwright show report, the name of that report, which here in this case is playwright report or whatever you download it to be. And then you'll be able to open that up and you'll be able to share it with others, and they can see the trace and see what's going on in that component testing. So playwright testing, we've got the VS Code extension, we've got CodeGen, my friend, which auto-generates your tests, run in debug mode, locators and frame locators, iframes as well, show reports, show trace files. We've just seen that. It's absolutely amazing. It auto-waits built in for all actions, so there's no need for set timeout calls. So make sure you're using web first assertions. Tests run in parallel, so super fast, multiple browsers and devices. Intercepts requests, it follows all redirects, bypasses cores, it manages cookies. Oh my gosh, are you ready to playwright? I really hope you are. And welcome to the Playwright community. Thanks for watching this talk. I really hope you've enjoyed it. And I really like to see more people writing tests. Let's write tests, component tests, end-to-end tests, everything with Playwright. Thank you very much. Bye.
Hello, my name is Vladimir. I'm a front-end developer, and currently I'm working for Zamat. Zamat is an open source help desk ticketing software. We're proud of our open source philosophy, so everyone can run Zamat on their own servers, and to that we have a constantly growing community. I'm also a core team member in Vitest, a test runner that we also use in Zamat, and today I'm going to talk about how Vitest improves your developer experience. Vitest was originally developed as an alternative to Jest for Vite applications because Jest didn't have support for asynchronous transforms and many of Vite's API. It's built on top of Vite Node package, which is a Node.js runtime that uses Vite to transform files before running it. But right now, Vitest is a fully fledged test runner like Jest, Ava, Tap, Mocha, or any other test runner. It tries to be feature-rich without unnecessary configuration. It provides ESM, TypeScript, and JSX support out of the box, thanks to Vite. Here are some of the Vitest features. Vitest uses Vite's configuration file, including transformers, resolvers, and plugins, So you have the same code in development, production, and in testing. ViteTest has smart and instant watch mode. In fact, it's so fast that we had to add an artificial delay before displaying result in a terminal. It uses Vite's module graph to detect imports, which makes experience similar to HMR in your browser. You can run ViteTest to test your components using your favorite framework, like Vue, React, Svelte, and many more. If your framework supports Vite, it supports ViteTest. ViteTest comes with a chai built-in for assertions. It means you can use its assert, should, or expect API with ViteTest. But for easier migration, we also provide Jest's expect compatible API, like to be, to equal, to match, and so on. Tomek DOM API ViteTest provides JSDOM and HappyDOM built-in environments that you can also extend. For coverage, ViteTest provides reporting with C8 and Istanbul out of the box. Also, ViteTest has a unique among front-end test runners feature called in-source testing, which was inspired by Rust's module testing. And we also provide experimental benchmarking feature via a TinyBench package. So now, when you know what ViteTest is, let's see it in action. Here we have a Vue3 component using script setup syntax, as you can see here, with a simple test that renders it and checks some output. This component, as we can see in a snapshot, has a div and a button that increases its multiplier. This snapshot is generated by ViteTest, as you can see here in the first line. The snapshot feature is equal to Jest snapshot, so if you are migrating from Jest, you should be fine. So let's run this. I'm running it with UI flag. So as you can see, ViteTest provides your beautiful UI to view and interact with your tests. And as you can see, it doesn't show you rendered component, which we can see here, because this UI is not meant for this. But we have a package called ViteTest Browser that enables viewing it. But it's in an experimental stage, and I didn't manage to make it work for this demo, unfortunately. But by the time you're watching this, it will probably work. This UI provides you with a way to see a report. So if this had an error, you would see an error here. This UI also allows you to filter your tests to run only filter tests, to filter local tests. You can also, but this test only has one. So, and a feature that I like the most is module graph. You can see here, this is quite a simple test, so module graph is quite small, but for bigger applications, it's very useful to see how all your files are interacting with each other. But one of the best features here is that you can edit your tests right in the browser. I save this and I can see an assertion error happened, and I can see where it happened, and I can also see it in a report. I can click open an editor, and it will open this this tab for me. So as we can see here, it expects when we are multiplying 3 by 2, we expect 6, but here we have a 4 multiplied by 2. So let's revert this to 4 for now. Now our test runs fine. Since ViteTest was made to fix Jest issues, we provide Jest compatible API for easier migration. As you can see here, we are using to contain and to match snapshot matchers, which are fully compatible with Jest. But not only do we support expect API, we also support Jest API, Jest global variable. If you've ever written code like this, this was a little spoiler. You can use the same in ViteTest, but we don't by default we do not expose Jest variable, but we have our own variable with the same API, public API. It's called V or test, You can use which one you prefer the most. We usually recommend using V. So if you have if you want to see how your tests are running under VTest, but you don't want to migrate from just right away, you can use this little trick. You can assign a global this just variable to V, and all your methods should work fine. VTest still has some differences. We provide migration guide in our docs documenting all these differences, but for the most part, it should work. And we also provide you, as you can see here, Josefine is a spy. So VTest also has spies which are fully compatible with just spies, with the same methods and the names and so on and so forth. But probably the best feature of VTest is its watch mode. Let's remove this. It runs only the affected tests. So for example, here, as you can see, it showed me rerun 4. When I edit this test, it will rerun only this test. But this is not where it ends. If we are editing this component here, for example, we can add a new button that adds a multiplier by 2, incremented by 2. Now we can see that our test has failed because snapshot that we had is not equal to the snapshot that it generates now. So for now we can comment it out. Let's now test our new button. Here I will add a new test like this. I don't think this is the best way to do it. I would probably get it by the text inside. But for now, I think it's fine. We're triggering it. We trigger it now, and we expect. I think 4 should be incremented by 2, and we now have 6, which is 24. We save this test, and it runs fine. By the way, as you can see, the actual duration of test is 132 milliseconds, which is quite fast. We think that this experience is preferable, so we enable watch mode by default if you don't override it with the run flag. So I think this is all for front-end part, but you don't have to use VTest with front-end frameworks. In fact, VTest is Node.js test runner by default. So as you can see here, this is a simple Node.js application, just a square root function. We are testing here that the values are correct. This, as you can see in the configuration file, nothing is configured, so this is by default. Now let's run this. And as you can see, everything is passing. VTest has a concept of contexts, which was inspired by fixtures from Playwright. Contexts are an object that is passed as a first argument to your test. So here we can see that this has a type of test context. By default, it has meta and expect, so you can have local expects. This is useful for concurrent testing. If you have, for example, if you are doing too much snapshot inside a concurrent test, but you can put things here. For example, we can use before each function to put something on the context. Expect context. I'm sorry, context full to be 1. Now it says the tests are passing, but the TypeScript shows us an error. To bypass this error, we need to define an interface. Foo is a number. We can pass down this interface as a generic. So we will need to pass it down for each test that we need a context. We can also define it globally. For example, we can do declare module VTest interface text context. Thank you. So now it knows that every test has this context. Every test in your entire suite will have this context. There is a simpler way with using TypeScript. For example, you can do a foo test is test with context. Now we can remove this. Probably should do it here. But now we can do foo test and it will have this context. It will know the context of this test. But beware that this is incompatible with Jest. For Jest had a done callback here. So if you are calling this here, as you can see, it's deprecated. If you are calling it here, you will get an error. Context is not. I'm sorry. Context is not defined. Is here. It's a test now. If you are calling done here, it will call you that it's deprecated, and you should use a promise instead. So to emulate a done callback from Jest, you can return a promise like this, and the test will pass. Each test has its own context. So, for example, you cannot access a context in before all callback. Doesn't have a context, but it does, by the way, have an access to suite, current suite, or a file, whichever it is. You can access its name, for example. I think it has a file path. Yeah, I think this is all I wanted to talk about with contexts. There is also one cool feature that VTest has. It's called VTest Changed. So as you can see here, we edited one file. We changed one file, a test, and we don't want to run the whole suite of tests. So we can do what we can do is run test changed, and this is VTest changed command, and it will see all the files that are changed and run only tests that are imported by it, or the tests itself. For example, here we edited the test and we see the test changed. If we roll back, we should see nothing is changed, so no tests will run. But the cool feature is what if we added here, for example, a console log for an empty string. We can now run test changed and it will run a basic test because this function is imported here, which is pretty cool. Now let's talk about in-source testing. This feature allows you to write your tests inside your source code. Why would you do that, though? Well, this feature could be useful for a number of things. For example, for unit testing small scoped functions or utilities, like here on the slide. For example, if you have a collection of files with a single function each, you can keep your tests inside that file. It's also useful for prototyping. If you are writing tests alongside your program, you might be more focused on the functionality itself. You can also make inline assertions right inside your program. For example, you can test an intermediate value in your function. It's also useful to make an assertion inside of a private method, for example, that you cannot export, or inside a constructor. It's also useful to test functions that you want to keep inside a specific module without exporting it. For example, if add function had some kind of a helper that was defined here, you could have tested this helper in isolation right inside this module without exporting it publicly, which might be the most useful case here. But we do recommend you to use separate test files for more complex tests like components or end-to-end testing, because they usually require a more complex setup, like using libraries to render set components. For example, here, this code will be stripped out from your production code because it's guarded by import meta vtest, which will be undefined or false, whichever you want. But if you are using some kind of an import screen, for example, from the testing library, DOM. I think DOM has this like React. This might be bundled with your production code, so even if you use it only here. Because I think you need a side effect property in your package.json, or in the package.json of the module itself, to specify that it can be safely removed. I think this is all for features that I had time to show you. And let's talk about what is coming next for vtest. Since vtest provides TypeScript support out of the box, we thought it would be a good idea and makes sense to also provide support for type testing also out of the box. So we have an OpenRFC, which you can leave a comment in. Currently, we are thinking about providing 2 APIs for type testing, like we do for regular testing. Sorry, which is expect and assert. So there will be an expect type of function, which exposes similar to expect matchers like to match, to equal type, and so on. And it is inspired by expect type package. And we also think that we will have an assert type function, which is inspired by TSD. But stay tuned for that. It's not implemented yet. It's only in an RFC stage. But what is implemented is benchmarking. It's already implemented, but we are thinking that we can do better. For example, currently we are not happy with the result output. We are thinking that API could be improved and standardized before this feature loses its experimental flag. Vitest also, as I said before, provides a Vitest browser package for previewing your tests in a browser, but currently it doesn't support running tests in CI, but it can be useful to debug your failing tests. This feature is not ready for production use and may even not work for you at this stage, but we always welcome feedback. So feel free to open an issue about this feature right now. We also want to improve documentation. The current state of documentation is that it was written before Vitest left experimental stage, and it focuses more on migration and Jest API, and doesn't help new people get accustomed to Vitest itself. So this is all I wanted to talk to you about. Thank you for listening to my talk.
Frameworks panel, we're bringing together the past and the future of web frameworks. these framework authors have very different and very exciting approaches to how we build our web things, and Vite ties them all together. Kicking us off is Ryan Carniato, the creator of Solid.js, who not only sang in a punk band, but named his JavaScript framework after it. He'll be showing us Solid Start, the new starter for Solid, and how it builds off of Vite to deliver the next generation of server-rendered Solid apps. One of Ryan's longtime collaborators is Dylan Piercy from the Marco team. He'll be taking us into the world of Vite and multi-page applications. He'll guide us through some history of JavaScript and show us some techniques to get rid of it along the way. One of the best use cases for fresh framework approaches is e-commerce, and the Hydrogen team have designed a framework for that use case. Fran Dios from the Hydrogen team will be showcasing how the framework was built with Vite, including how it integrates with React server components. Fran has long been exploring Vite on the edge, and Adam Bradley is also living on the edge with Quick City, the meta framework for Quick reimagined for the edge. Quick blew my mind on stream recently, and if you're used to that divide between single-page and multi-page apps, Quick is sure to surprise. And if you want a peek into how you can build a framework of your own, my teammate Ben Holmes is breaking down Astro's Island's architecture and showing us how you can do it yourself in 5 minutes. I heard he's bringing a whiteboard, and I think he'll need it. Enjoy the show.
I'm Ryan Carniato, creator of the JavaScript framework Solid.js, and I'm excited to be here at ViteConf to tell you about it. This talk is called Getting Started, which plays off the name of our starter template meta framework, Solid Start. And I'm not sure we'd be here if it weren't for Vite. Well, obviously we wouldn't be at this conference, but I don't know if I'd have taken the plunge into trying to create such an ambitious project as Solid Start. All the hours, the late nights, and the maintenance burden that comes with it. I kid, but seriously, I never wanted to make a meta framework. If you look on GitHub, there are issues from a few years ago where I said as much. However, Vite changed everything. Vite has enabled a whole new way to look at developing tools on the web platform, and that's what I'm going to talk about today. But first, perhaps a brief introduction to Solid.js is in order. What is Solid? Well, it's a JavaScript framework for building user interfaces, like so many before it. But let's get right to the elephant in the room. Why would I build another JavaScript framework? Well, a little history here. Development started back in 2016. For context, that was the same year Svelte was created. My goal was to bring back fine-grained reactivity, similar to Knockout.js. I love the patterns of using function components and building UIs from composing small reusable behaviors. I never really made the full move to component lifecycles. They reminded me too much of ASP.NET, web forms, and honestly, that terrified me. The performance claims of the virtual DOM confused me as well, and I knew reactivity to be performant. Maybe we just needed to attack it a different way. So I did, and for all of what became abundantly clear was that for all the good that component architectures had brought, and I mean they are everywhere in modern front-end development, we've conflated code organization with execution lifecycles. Pretty much every framework, components have runtime considerations. They are our primary state management. They're our renderer, our everything. And this wasn't limited to the virtual DOM. It was true for compiled solutions as non-compiled. Tight template literals to VDOMs, single file components to the hottest DSLs. Everything just running top down. I get it. There's a bit of who cares, but it informs every subsequent question. What do I memoize? When do I memoize? What do I use for global state? How do I share reactivity? When to use effect? What's the difference between Redux and context? Why does this log twice? Why does this stupid thing keep re-rendering? These are topics that dominate the conversation, and really, I'd rather be talking about pretty much anything. There are a lot of things that are just unlocked when you change the perspective a little bit. And I can definitely wax poetic about the power of reactivity, how it's declarative and composable, how it helps produce well-structured code with reusable behaviors, and that are independent of any component system. Even how, with a few basic primitives, you can do everything you could ever wish for, including rendering, and with performance we haven't seen since hand-optimized vanilla JavaScript. But that's not why I'm here today. I'm here to talk about a different sort of primitive, and that is the power of plugins in the Vite platform, and how they are instrumental for me doing a complete 180 on my perspective. Which says a lot, because I am naturally an unbundler. I like breaking stuff apart and shifting boundaries. I like proving new concepts, and tend to leave it to others to pass the final judgment on what the right approach is to put it all together. So let's look at why Vite presented me with something I just couldn't easily dismiss. Well, it starts with understanding desired outcomes. I knew server-side rendering was going to be key to where things were heading. A lot of innovation in this space is finding how to better leverage that server-client divide. So SSR needed to be part of the package. But at the same time, I was not willing to throw single-page apps under a bus. It needed to support both, and seamlessly. Moving from client to server shouldn't feel like a chore. And while we are at it, we should have all the niceties, things like file system routing and more ingrained patterns for data fetching and mutation. And of course, it should fully leverage Solid's unique view of reactivity and rendering and be deployable anywhere. At the same time, there were things I did not want to deal with. Having to wrangle a bunch of configuration is no fun. Also, I didn't want to be too opinionated. Well, opinions can be good. First and foremost, this needs to work for everything. And I don't want to be responsible, well, at least that responsible for people's destiny. I've never liked or bothered with meta frameworks myself. So when building a project, why would I try to push that on someone else? Similarly, I didn't want to present a bunch of exclusive ideas. Like, if someone chose not to use this project, they shouldn't feel they aren't fully leveraging Solid. And this really extends to APIs and libraries. Ideally, you just use everything that already existed in the ecosystem. I'd already created a nested router with parallelized data fetching long before I ever thought of making a meta framework. Honestly, I don't want the maintenance burden. You can start to see why I wasn't too interested. How do we possibly get all the upsides without the downsides? Well, as it turns out, Vite 2 couldn't have come out at a better time. The big thing being it offered a single configuration for adding SSR. This was the first problem I needed to solve. Historically, bundlers didn't concern themselves with this, and while you could make a bunch of configs, it wasn't as easy as just running a bundler with a flag. And this is important because it conceptually meant that we have this flexibility now to lay these things on top of each other without additional wiring. We didn't need to be opinionated about client versus server rendering. And this is kind of exemplified on the plugin system that Vite has. It's based roughly on Rollup plugins. And you can author these universal plugins that work across the whole platform. Now, the devil is in the details here, a lot of nuance, but Vite was stacked with a lot of things to make our lives a lot easier. Things like glob imports to handle dynamic file paths. Can we say file system routing? And almost the trivial ability to create virtual modules to allow for custom compilations to break our modules apart. And the best part of this is it's just a common base of just a plugin. There's no need for an actual meta framework, just a collection of Vite plugins. And we realized this almost immediately. Like, we had to do so little to leverage an existing ecosystem. Things like CSS were already part of it. And while maybe there'd be some Solid specific features, anything we built for Solid Start would work in any Solid project. More so, Solid Start could be used for any Solid project. Everything being modular as it is. This addresses half the things on my to avoid list without doing anything. If we wanted file system routing, that worked with Solid's router. There was no point in making Solid Start router. We just build it as a Vite plugin. We ship Solid Start as source instead of being pre-built, and it just slides in everywhere. A huge win for maintainability. But of course, that's just the direct benefit. What we found since it is even better than that. With such a modular approach, we've been able to test ideas rapidly. It's just a matter of writing another Vite plugin. And this sort of experimentation is really important to us. Let me give you an example. We want Solid to work the same client and server and use the same libraries like Solid's router, but there is a definite need for server-specific features. Things like get server-side props in Next or loaders in Remix, but we didn't want to compromise. And we wanted to keep all the benefits we'd come to desire from being modular and composable. The pattern for Solid the past several years has been to define a data function that is attached to each nested route section and runs in parallel to the code splitting. This lets us set up our resources, which are basically a special signal that takes a promise, and handle it in parallel. And this mechanism worked really well because if left alone, it will fetch on the server during initial SSR and then again from the browser on subsequent navigation. But what if I want to always fetch on the server? Well, we had an idea. What if a function could be on the server? I mean, any function. This isn't a new idea. We've seen stuff like this in Blitz.js. But what if we could leverage Vite's plugin system to make this just an opt-in behavior, like file system routing? We could just test an idea and see how it would sit. We immediately saw that meant we could preserve types across the boundary, and this was really quite nice. We could just define a function anywhere, and you didn't need to worry about a URL or API. The URL is also available as a property of that function, so you can use it in APIs designed to handle URLs. We've actually used this to wire up things like WebSockets and server-sent events. But the takeaway is suddenly we had a primitive to do network communication in a type-safe way, and we could use it anywhere. We could put as many server functions we wanted in any file. So it turns out we can just plug this right into our resources as well. Suddenly we have a function now that always runs on the server. It's nice how primitives compose like that. And we can write a wrapper to clean it up a little bit, and well, we're in business. While it's a little bulkier than a simple async function or loader, we get a couple cool things here, like the first argument to our resource acting as a cache invalidation key. So we can granularly invalidate these things the way one would with libraries like TanStack Query. We also can create as many of these server data or resources as we want on the given route and handle them all independently. And on the other side, we wanted actions for mutations. And again, if using the server mechanism, we could define them in any file, as many actions in any file as we wanted. We could basically use these to track the progress of our mutations and manage optimistic updates. By default, they'll just refresh all the data on the current route, but because they're granular, they can also trigger their own invalidation keys. And did I mention they export progressively enhanced forms that work with no JavaScript? This all just piles on top of each other, right? You can define as many of these actions as you want in a file, as they are just server functions, and not feel the restrictions of having to adhere to a file-based API for local mutations or worrying about over refetching on invalidation. It's sort of like a marriage between something like Remix and TanStack Query. And my favorite part of this story is that it started from an experiment with a primitive. That's basically how we develop in Solid. We create a primitive and try to see how it can be used to determine its place in the world. Sometimes there's obvious need that can only be handled in the core and it ends up in the core. But other times we test ideas for months in our Solid primitives repo and, then we learn what the lessons we need to learn. People have been doing incredible things with Babel with Solid, getting Svelte-like compilations and trying new DSL ideas because of how easy it's to build on top of. And for me, the second I saw Vite, I knew we were into more of the same. But if you aren't convinced, one more example. I want to show you an experiment we're working on right now. A huge shout out to Nikhil Saraf here, who put together the pieces to make this demo possible. I'm going to demo an app that I am all too familiar with, the old Hacker News demo. And if you haven't seen Solid Start, it's essentially just a Vite project. You see there's a Vite config right here, and we just plug in our Solid plugin. And we're very easily able to actually just port over one of our existing Vite templates for client side, because all we needed to do really was take the index HTML that exists in our Vite project and kind of convert it to this JSX thing. There's some details here, like our router uses a file routes to suggest that it wants to use file system routing. Once in place, we basically just have our router, and the only other little tweak we had to do really was our data functions, which used to be in separate files, can now be just at the top of the file. And this is very similar to what we were looking at on the previous slides. So let's try our example in action. Start up our server, and this is just your typical Hacker News app. We just navigate around. It's client rendered, client navigated, and there's basically some story listing pages, and then you can go into the specific story and collapse the comments if you wish. And just to show you that it's client rendered, let's look at the network tab. When I load this, what you'll see is initial HTML loading, some JavaScript and CSS, and then you'll see that the stories and the data API call are happening at the same time, and then it client renders. And in fact, you can actually see that the HTML we send has an empty body, and it's a pretty typical single page app. From there, when we navigate to a new page, what we'll see is essentially the new JavaScript and the fetch for the data specific to that page happening in parallel. And this is all thanks to Solid's router. There's nothing new here. But perhaps it would be nice to server render this page. So I'm just going to go into our Vite config for our plugin and just go server SSR true. And now with a quick build, and I'm doing the production build here instead of just doing dev mode because I actually want to show off the resources. Vite has great HMR. We can see when I reload the page that now the majority of the work actually happens on the server while it fetches the data, and then all the rest of the JavaScript loads in parallel. And we can actually see when we look at our rendered page, and now we have a full page that contains all our story listings and serialized JSON that we need to display them. But again, from here, when we navigate around, this is the same client-side routing that we've come to accustomed to. And this is pretty typical that you find in most meta frameworks. But we thought, well, why stop here? I've been seeing really cool things being done in frameworks like Astro and Fresh. So we're like, what happens if we tried to make it a multi-page app with interactive islands instead? So this is an example of us just playing around with a Vite plugin and seeing what we could do. So what we need to do to make those comment collapsing still interactive is just have a way of defining them as an island. And kind of as an experiment, again, using this Vite plugin, we realized, well, what if we could just import our component kind of similar to how we import lazy components. And which one is it? It's a toggle, and kind of define it as an island. And what we're actually doing here is we're looking for this, and actually we're doing a compiler swap that affects the build process, again, thanks to Vite. And if I run this now and start, previously we were looking at about 15 kilobytes of JavaScript on our page in order to basically load all the interactivity and do the rendering. And this is the same on client and server rendering. But in this new islands mode, when we refresh the page, we don't need nearly as much JavaScript. And when we go into our story, it's literally just 5 kilobytes of JavaScript, just enough to trigger the hydration of our islands. And as you can see, this still works. So we have the same interactivity and same experience at about a third of the cost in JavaScript. But again, we have this whole platform available to us. What else can we do? Well, we thought, wouldn't it be cool if we could do islands and still have maybe client-side routing? Because, sorry, I didn't show it off here. with the islands, as you navigate around, you can see this refresh. It's a full page refresh. I can just show this really easily. If we expand out some elements here, we navigate, it's re-rendering the whole page. This is fine, and we still get the benefits of having less JavaScript and great page load performance. But so again, just through Vite plugins, what if we could kind of try to see if we could get the best of both worlds? And yeah, we could load maybe 5 kilobytes of JavaScript initially, but now when we go into our story, we get the extra JavaScript for that toggle, which still works. But as I'm navigating around, we're just fixed at 6 kilobytes of JavaScript. And we're getting client-side routing. What's actually happening here is we're swapping out the portion of the page that changes. The header never re-renders. So when we go here, we're just swapping it out. This is a nested server-rendered client router. Honestly, there's just so much here to play with that I'm pretty excited. I mean, I can't wait till someone realizes that with server functions, it can kind of do a solid start inception. Honestly, the boundaries seem endless here. So that's all I have to say. I was too lazy to make another slide, but mostly because it's really hard to top this one. In the same way Solid Start is going to be the foundation for solid applications in the future, Vite has been instrumental in making Solid Start a reality. I would have told you it would be crazy to take this on before, but now I can't picture not being able to give people such valuable tools to help them making the best web applications. I suppose this talk can't be called Getting Started without showing you all how to get started with Solid Start. npm init solid. That's it. And you'll be on your way to creating the next generation of websites and applications. So thank you, Vite, and thank you all.
Hello everyone. In this presentation, I'm going to be talking about how the web as a platform came from a place where JavaScript didn't even yet exist to our modern day applications where we're sending, in many cases, an order of magnitude more JavaScript than necessary. I'll be looking at how we can reduce that amount of JavaScript. We'll also be comparing the multi-page app and single-page app architectures. And then finally, we'll go into how modern tooling allows us to use either architectural style without compromising the developer experience, including tools like Vite. My name is Dylan Piercy, and I've been working at eBay for the past 5 years on their Web Foundations team, responsible for various parts of the eBay front-end ecosystem. One of the main projects that I work on is a tool called Marco, which is our open source front-end framework. I think by the end of the presentation, you'll find out that it has some unique superpowers that I hope you find interesting. You can find me on Twitter at Dylan_Piercy, and I'm on GitHub as Dylan Piercy. So I've only got 20 minutes, so I'll try and be fast. As you can see here, the amount of JavaScript we've been including on our pages has been steadily increasing ever since we started measuring it. Up until August 2022, where the median web page is sending 500 compressed kilobytes of JavaScript. That's literally megabytes of JavaScript. And so how did we get to this point where we're sending so much JavaScript? And how might we curb our JavaScript usage in the future? 1993 is when we first see the HTML 1.0 specification. We also see one of the first popular browsers, Mosaic. So what did HTML look like at this point in time? Well, for some reason, people were using uppercase tag names, and I don't know why. There's also no divs or spans or a lot of things that you might be accustomed to today. But importantly, there was two critical features that we still use and recommend today. That is links and forms. So in the beginning, HTML was really a document viewer with the ability to navigate between documents and the ability to submit information to a server. And so with that, pretty much immediately people were using server-side rendering to generate HTML, and they would use different technologies for this. One of the earliest technologies that was built for this use case was PHP, which came in 1994. But there was a lot of technologies people were using to generate HTML at the time, including Perl, C++, and so on. In this case, we're seeing a PHP application that is able to request data from a database and interpolate in some dynamic content for our users. And this was really powerful at the time. You could generate and build a lot of types of applications with this. Moving on to 1995, a challenger arises. We see JavaScript for the first time, and it's recommended as a tool to enhance an existing HTML application. For example, one of the recommendations was to use it to enhance forms so that you could show error messages earlier. But people use it for more nefarious things as well, like showing flashing pop-ups and like scrolling banners, things reminiscent of that 90s era. But at the same time, people did want to deliver rich applications and 3D GUIs and you name it. They wanted to deliver all that to the browser just like we do today. And so there was other tools. There was Flash, there was Java applets, there was ActiveX. So many tools popped up at around this 1995 on to 1996 era. But these tools often weren't recommended for building sites. And the reasons might sound familiar to you. They broke the back button, they made the page take longer to load, they caused accessibility issues, they required a specific environment in which to run, you had to be on the latest version of everything, and so they had their issues. But nonetheless, we would see JavaScript continue to develop, and on into 2005 and 6, we see a big change in the JavaScript ecosystem. We see jQuery for the first time with its catchy slogan, New Wave JavaScript. Obviously that wouldn't stick, much like its logo here, but jQuery would go on to make it much easier and lower the barrier of entry for writing JavaScript and cross-compatible browser code. And so with this, people inevitably wrote more and more JavaScript. Another big change at the time is that Ajax was gaining steam. Even though Ajax had been supported since the early 2000s, at this point it was really gaining popularity. And this was just another area where JavaScript was able to do more and more alongside the platform, and people were wanting to, inevitably, write more and more JavaScript. But still, the recommendation and a lot of apps were primarily server-rendered with a sprinkling of jQuery, Ajax, and so on. 2010 to 2012 is another important time period for JavaScript on the web. We see a lot more JavaScript being written and tools to make it easier. One of these tools is _JS, which was like the missing standard library for JavaScript. At the time, browsers didn't even properly support array.map, so this was a needed feature. And this tool also worked with Node.js, which would be released the year previous. Another big thing at this time was Browserify, which piggybacked on Node's CommonJS format for loading modules and allowed you to bundle those up into something that could be distributed to the browser in an efficient way. This meant that we could build larger and larger JavaScript applications and not totally suffer from the performance pitfalls of doing so. Another important tool at the time was AngularJS, which is one of the first popular client-side rendering technologies. I actually wanted to go back and show you the iconic two-way binding input to a div translation that they had in their demos at the time. And so I went to the Wayback Machine to look at their old docs, and what do you know, the JavaScript doesn't work anymore. And so we see this mix of HTML and template code, which if you've worked with Angular at the time, this might look a little bit familiar. But I do think it highlights a point that JavaScript is a little bit more fragile than the HTML that it's built on top of. Finally, 2013 to 14 was another big year for JavaScript. We see one of the most iconic frameworks in the JavaScript world, React. And React brought with it so many great things that I don't want to discredit it at all in this presentation. However, React also brought with it, and in some cases this is good, the mentality that JavaScript is totally capable of delivering a performant user experience that is rendered in the browser. And so pretty much immediately we see tools pop up on top of React, like React Router, that does everything in the browser. We see the routing go to the browser, we see data fetching go to the browser with Ajax, and so much more. All of these utilities, once shared with the server, are now exclusively in the browser. And so now the cat's out of the bag. Our entire applications are sent to the browser. And instead of our applications scaling with the interactivity that is within them, instead they scale with the size of our applications. And partly that's why we have so much JavaScript today. So was React the right fit for all applications? Or is there a different approach that can maintain the same DX that we can also look at? Let's rewind a little and look at a bit of a different trajectory. Specifically, let's look at eBay and its front-end ecosystem through a similar period. eBay is a really interesting company to look at here because it was founded so early. Actually, the first eBay website, called AuctionWeb at the time, was released in 1995. And it amazes me that you could build the core eBay product back then in a time without JavaScript. And so what did the eBay tech stack look like at this time? Well, to generate the HTML, they used Perl. Although quickly they discovered that Perl wasn't going to scale with their growing user base, and so they looked for faster technologies on the server and switched to C++ eventually in 1998 and beyond. C++ was great for performance, but it was hard to maintain, and so developer productivity and velocity suffered. And eventually, eBay made the switch in 2004 to a Java-based stack, which alleviated some of the issues. However, with the growing popularity of JavaScript and the clear demonstrations that client-side rendering could have benefits and had a great DX, eBay was interested if we could build a platform that was better, something that was unified. Because with Java, it wasn't just one application, it was two. It was Java and jQuery. And so that moves us into Node.js. Node.js, although it was released in 2009, eBay was taking a serious look at in 2012. Node.js was great because it allowed us to run performant JavaScript code in our server side. So what if we could, instead of using Java, use a consistent language from front end all the way to our back end? And this is exactly what Node enabled. However, looking at technology at the time left some to be desired. There was a big push, as I said, to client-side rendering. And we knew that client-side rendering was going to require heaps and heaps of JavaScript. And we couldn't make this transition without matching the performance of our existing outgoing Java application. And so we had to look at something else. So we felt Node was just right, but it needed a little bit of investment. And so a framework is born, Marco.js. At the time, Marco was actually bundled in with a set of JavaScript utilities called Raptor templates. However, it quickly became the way that we authored most eBay applications. And so what did Marco offer? Well, obviously one of the main goals before its inception was the ability to have a consistent experience across the server and browser. And so it delivered a way to describe your templates a lot like you would in a modern client-side framework. You could set up state, you could set up event handlers, all in a single format. Beyond that, though, Marco had to meet eBay's needs. It had to be fast on the server. Here I'm showing a benchmark that was recently done by the Builder.io team. They built a really awesome tool called Mitosis that I recommend you check out. It essentially takes a consistent format and compiles it to a bunch of different frameworks. And so they were able to build an application using this framework and compile it to Marco, Svelte, React, and then actually benchmark it. And then they went ahead and benchmarked the throughput of all of these applications. And they found that the Marco application was significantly faster. But this is only one piece of the performance puzzle. We needed to make sure that this raw server-side rendering performance was good. But another big piece is streaming. Streaming has gained a lot of popularity recently, especially since React has come out with suspense on the server. However, Marco has had this feature since 2012, since its inception. The idea being that if you have services that your HTML rendering requires, some data fetching, some database calls, things like that, we don't want the application to be as slow as the lowest common denominator. With a traditional buffered rendering approach where you do all of this processing and then you send all the HTML to the browser, essentially the browser is sitting there waiting while all this processing is happening. Instead, with streaming, we're able to send as much HTML as possible to the browser, and so it can actually begin doing work earlier, like downloading those critical script and style and image assets. And so this not only made it so that the page got delivered to the user more quickly, they could see information sooner, it also meant that the page as a whole completed its download earlier. And so it was just a win-win for us. Another key piece of the Marco story is what we call partial hydration. If you think back to the Java application that we were competing with at the time, it was operating under the sprinkling of JavaScript model, and so sending a lot less JavaScript than we might in a modern SPA. How are we going to compete with that with our new framework? And so Marco, from the beginning, was designed to have server rendering be the default with opt-in JavaScript where the interactivity was needed. And we called this partial hydration. Nowadays, it might be referred to as islands architecture or similar. It's growing in popularity, and we think that's great. And this allowed us to have client-side rendering in the places where it benefited us and keep as much on the server as possible so that we could have minimal JavaScript sent to the browser. And this has a huge impact. On the left, you can see that there is a page that is traditionally hydrated, a SPA, essentially. You can see that the entire application has to re-render in order for it to become interactive. Whereas in a Marco application, only the interactive pieces need to have their code downloaded and executed in order to become interactive. And the savings we get from this technique are significant. A few years ago, we ran an experiment where we turned off partial hydration for some of our popular pages, And we saw as much as 2 times to 6 times more JavaScript when partial hydration was turned off. Hundreds of kilobytes of JavaScript were saved, and obviously that has an impact on our end user performance. Thankfully, Marco is not the only framework that's looking into these types of optimizations. Since 2020, we've actually seen a huge number of frameworks pop up with islands-based architecture as their focus, crazy progressive loading, and so on. And so we're super excited to see where things are going here. Now, one thing that's interesting, and this brings me into part 2 of the presentation, is why is there so many new frameworks in 2020? And I think it actually, in small part, is due to Vite. So obviously in the beginning, Marco didn't recommend using Vite because, well, it didn't exist yet. But Vite is a great bundler and development tool today for building these types of applications. And we have experience building in lots of different bundlers. Actually, the Marco team built its own bundler a while back called Lasso, which in some ways worked similar to Vite, although it's quite dated at this point. We also built integrations with Webpack, Rollup, and so on. But all of these tools we felt were lacking. They did not make it easy for us to build the type of experience that we needed to build. And part of that is because when you're building an optimized, modern, multi-page app, you want to have full control over the JavaScript entry points. It's not a single entry point. You want to have control over the CSS assets. You want to have control over the server to make things consistent. Firstly, Vite is the first bundler I've seen that has first-class built-in support for server-side rendering. This is obviously huge for us because server-side rendering is obviously a key piece of Marco. And Vite makes it easy. You can just load modules directly into a development server that supports hot module reloading and more, and it just works seamlessly with the browser code as well. Vite also offers, and this is critical, a flexible development server. You can take Vite's dev server and embed it into an existing application. This makes Vite a great base for building meta frameworks, even though it's already kind of a meta framework itself. Another great thing about Vite is that it has minimal config compared to the competition. Here, I wanted to show what the same Marco example project looks like configured with Vite versus Webpack. In the Vite config, it's essentially install the Marco plugin, and the defaults are sane enough that you can just have a production application with 10 lines of configuration. Whereas in a Webpack project, well, there's a lot more. It's almost 150 lines of configuration. And that's because Webpack by default doesn't support server rendering. We need a plugin for that. Doesn't come with CSS out of the box. Doesn't come with so many things that you need to actually optimize, build, and develop a modern front-end application. And so a lot of configuration is needed. This configuration burdens the users of the framework, and it also makes building meta frameworks on top of it harder. Vite makes it easy to hook into all of the different underlying tools in a way that makes sense. Part of what makes Vite great is that it brings many tools into one. It's a Node.js hot reloader that automatically transpiles your files. It is a JavaScript bundler that sends only code necessary to the browser and bundles things on the fly. It is also an optimizing bundler so that your development environments start super fast. And then finally, it can bundle your application for production, optimizing images, JavaScript, CSS, the whole thing. Everything you need for your application is included. And this makes things so much easier and cohesive for developers. Another awesome thing about Vite, and I can't give this enough credit, is that they have an awesome community and set of maintainers. Vite actively works with different framework authors to ensure that their integrations work seamlessly. Vite actually has an ecosystem CI where they will run changes they make against ecosystem projects. For example, our Marco plugin. Whenever they release a change to Vite, they will automatically run our test suite. And the same is true of bigger projects like SvelteKit and so on. This is huge, and it allows us to continue to move faster and build these awesome developer experiences. Now, obviously, Vite isn't the sole reason for this rebirth of multi-page app and islands-based architecture frameworks. However, I believe it has helped greatly here. It has dramatically lowered the bar for building these types of experiences where you have to consider the server and the browser. You have to look at how you optimize between the two, and you have to deliver an excellent developer experience as well. And Vite delivers on that. And so I want to say thank you to the Vite team who have been so helpful in helping us integrate with Vite and many others, and for delivering such a great product. And I want to leave you with this. If the next project you're building is a document that you can navigate around and submit some data to a server, well, maybe you don't need that single page application and all the JavaScript that comes with it. Thank you.
welcome to this talk about headless commerce with Shopify Hydrogen and Vite. My name is Fran Dios. I'm one of the members of the Hydrogen team at Shopify, and today we are going to see why we created Hydrogen, a brief introduction to React Server Components, and also how we use Vite to power everything behind the scenes. To begin with, there are many frameworks already out there, so why did we create our own? The answer to that is that Hydrogen is a web framework tailored for online commerce. As you probably know, online commerce is quite challenging. It's right in the middle of two sides of web development that we have here. On one side, we have static pages that need to prioritize and maximize for SEO ranking and performance, such as blogs or marketing pages. While on the other side, we have dynamic web pages that requires engagement and interactivity. Think of, for example, a social network dashboard or a calendar web application. Commerce is right in the middle. It needs to be performant and rank high in SEO, but we cannot give up on interactivity and engagement either. At the end of the day, it's hard to create a framework that excels at everything. You need to prioritize and maximize for the right metrics and features for the problem you are trying to solve. That's why we thought that instead of using a general purpose framework, we could create our own that is tailored for online commerce specifically. Hydrogen is a framework based on React, and it has streaming and server-side rendering capabilities. For the local development, we use Vite because it allows us to focus on important features for online commerce rather than implementing everything that Vite already brings, such as TypeScript or multiple flavors of CSS. Also, Vite gives us a lot of flexibility for implementing certain features that we will see later. In this diagram here, we have an overview of the architecture of a Hydrogen app once it's deployed. In principle, we can deploy Hydrogen to any JavaScript runtime, such as Node.js, Cloudflare Workers, or Dino Deploy. Here we are going to use Oxygen as an example, which is a hosting platform provided by Shopify for Hydrogen apps. In the Oxygen worker, which is located at the edge near the users, it gets a request from the browser, process the request running our Hydrogen app, and streams back to the browser a response so that the browser can start painting things on the screen quickly. In the worker, we can make sub-requests to the Storefront API so that we can get information about our Shopify store. Or we can make sub-requests to any third-party API, such as a custom CMS, in case we have a journal or anything like that. An important feature in Hydrogen is the cache. It allows us to customize the sub-request cache, but also the full page cache. It provides sensible defaults, but in case we need it, we can manually change them. For example, let's say we have a marketing page where the content doesn't change often. We can use a longer full page cache for this case. But if we have a dynamic page, such as a product page, where some data is very dynamic, then maybe we can use a shorter cache duration for that specific data and a longer one for other data as the sub-request level. Earlier I mentioned that Hydrogen is a framework based on React, but to be more precise, we are currently working with an experimental technology called React Server Components that was implemented originally by Meta and more recently got contributions from other companies like Vercel or Shopify itself. The original implementation was required Webpack, but at Hydrogen we made an integration to bring React Server Components to Vite applications. The implementation details can be found on the pull request on the screen. Aside from that, I'm going to explain here briefly about React Server Components, but if you want to know more details, there is a great article in the Plasmic blog, so I encourage you to check it out. The URL is on the screen. All right, so what's React Server Components? It basically allows you to group your components in different types. First, we have server components, not to be confused with server-side rendering. That's a step that we will see later. Server components look pretty much like regular components, except for the fact that they need to be stateless. So we cannot use hooks like useState. However, we have access to server APIs, such as fetch, so we can make fetch requests to external resources. And this allows us to do, by combining it with suspense, we can do fetch as you render. On the other hand, we have client components, which are truly like regular React components with state and everything. These components run on the server, but also on the browser. So unlike server components, which only exist on the server. Therefore, in client components, we should not place private information such as private API tokens or anything like that. Since they can have state, they can do interaction like on click and so on. All right, here on the left, you can see there's a React app tree where we are mixing server components and client components. The key is that when we pass this app tree to the React server components renderer, the renderer is going to go inside the server components, run whatever it finds there, like fetch request, and then render the output, which is HTML from the server component. But when it finds a client component, it's not going to render it. Instead, it's going to put a placeholder that looks basically like a JSON object with an ID identifying the client component and the props that it should be getting. Once this process is done, we get an output, which is, we can call it the React Server Components payload, which is a mix of HTML representing server components and JSON representing placeholders or client components, as you can see here in this image. Once we have this payload, we can pass it to the more traditional React renderer that is going to keep the HTML that it finds, but when it finds the placeholder, it's going to grab the actual client component, thanks to the ID, pass the props, and then render its output, so that finally we get a full HTML page out of this renderer. If we do this process, passing the server component payload to the renderer in the server, we are going to be doing server-side rendering, which is useful for the first time the user lands in the website. However, if we do this in the browser side, we are going to be doing client-side hydration, which is useful for like subsequent navigation within the same page. Also, this process is compatible with streaming, meaning that when a node is rendered, it can go to the next step so that we start getting information in the browser as soon as possible and do render as you fetch. Another benefit is that if we can use server components for most of our application, it means that we are delivering a lot of HTML to the browser that doesn't need to be hydrated, so that we are shipping less JavaScript to the browser. All our interactivity will be in client components, of course. All right, so now let's have a quick look at a code example of a Hydrogen page. In Hydrogen, routing is based on the file system, meaning that when we get a request, the URL needs to match the path name of the file. In this case, we can see that we are exporting a server component in the default export. And this component is only going to run when the request has a get method. We can see that we are returning regular HTML and also some components. But if we look closely, we can see we are using a special hook, which is making a fetch request. When React finds this code, it's going to suspend the rendering of this component, do something else in the meantime, and wait until the data is back. Once it's back, it resumes the rendering, and we can use the data from the response normally. Next, we have another server component nested in this one, and that server component can also make its own fetch request to get data, right? We are wrapping it in a suspense boundary and passing a skeleton component as the fallback. This all means that while that component is fetching data, we are going to send the skeleton component to the browser and render it until the data is ready, and then we can replace the skeleton with the real component. If the request that we get is not get, but it's other method like post, instead of rendering this component, we are going to be looking at the API function that we can also export from the same file. In this case, it's just a regular JavaScript function where you can run any business logic. For example, reading the request body, making a fetch request to a third-party API, redirecting, or generating any type of response. All right, so Now that we kind of know how the core works in Hydrogen, there's still one big problem that we need to solve. And that is that building headless storefronts is hard, even with a framework, because you need to build all the UI and all your components needs to be performant, reliable, and accessible. Think, for example, of a shopping cart, which is quite complex. It needs to handle items, but also network errors, maybe even optimistic UI. So that's a lot of work. Fortunately, Hydrogen is not just a framework at the core, but also a set of UI components that are unstyled. So you can import them, put the CSS that you want, and use them in any kind of storefront. For example, it provides shopping cart, checkout buttons, and even 3D models for the products. We used to include these components in the Hydrogen core, but recently we are transitioning to extracting these components into a separate package that we call Hydrogen UI. Right now, it's in alpha version, and the main reason we wanted to do this is to make it compatible also with other frameworks. And it's actually already compatible with some of them, such as Remix or Next.js. Aside from that, we also provide some templates where you can find Hello World to start from scratch, but also a full feature demo store where you can find really every possible feature that you will think of in a storefront, such as user accounts, search page, journal, and so on. All of that is powered by Vite, so you're probably familiar with the developer experience. All right, next let's have a look at some examples of how we use Vite in Hydrogen to make all of this possible. First of all, in Hydrogen right now we are defaulting to Vite 2. That's because Vite 3 wasn't stable when we released Hydrogen 1.0. But Hydrogen is already compatible with Vite 3, so we will probably default to that version once we release the next major version of Hydrogen. So let's start with an example of how we find the routes in a Hydrogen project. Originally, we asked the user to import all the routes and pass them to Hydrogen, but we wanted to do that automatically. And by using Vite, this was possible. One of the features I like the most in Vite is the virtual files. So for example, here, in order to import all the routes, we import from a virtual file and assume it's going to return all the routes from the user application. And then we can continue and create the router and so on. The next step will be creating that virtual file, right, at the Vite level. So we create a plugin with a load hook. If we match the ID for the virtual file, then we're going to provide some code. And the code is basically using import metaglob that is also provided by Vite with the path to all the routes. The path can be modified in Hydrogen config, so we read it from there and append a glob to find all the server components in that directory. And Vite is going to resolve this import metaglob at a later stage in another plugin. And with that, it's going to import all the routes in the file system from the user and re-export that so we can get it in Hydrogen core. Next, let's talk a bit about Hydrogen extensibility. So right now we are actively working on a plugin system for Hydrogen so that third-party developers can integrate their own services with Hydrogen. Think, for example, of a plugin that when you install it, you get user accounts automatically. For another plugin that when you install it, you get error reporting to a third-party service, such as Sentry, for instance. For this, we don't need to rely on Vite to make Hydrogen extendable in many different areas. We can look at the right side, and this is what we think a Hydrogen plugin could look like, even though it's not the final version yet. For instance, a plugin could provide a middleware file that exports a function that runs before Hydrogen can handle a request. A plugin could also export route files, just like the in-app routes, which can contain, again, server components or API functions. And a plugin could also export public files, such as a service worker, for instance. If we take a look at how we can implement the routing from a plugin, we can see that we can go to the same virtual file that we had in the previous example, where we were exporting all the user routes, and basically just add a bit more of code here, where it's basically a new line per plugin. And again, we rely on import metaglove from Vite that is resolved at a later stage. And what this is going to be is that suddenly from the same virtual file, we have all the user routes re-exported, but also all the routes provided by different plugins also re-exported, right? Then we can merge them later in our router and continue. We found that in general, Vite makes this very manageable. And in fact, all the other extensibility points are fairly similar to this. Finally, we have here one more example, this time related to the React Server Components integration that we made for Vite. First, we need some context here. So in React Server Components, we have basically two different builds. One for the server, where the entry file is your main application with the React tree. That means it bundles server components and also client components and, well, some other routing logic and wiring logic. And on the other side, we have a build for the browser, which is kind of different from a typical single-page application client build. In this case, we don't bundle any component. We only bundle generic hydration logic and some minimal error handling. But apart from that, we also need some kind of utility that allows us to fetch client components on demand. So when the server says, we need to hydrate a counter component for in the browser, we need to know how to fetch that counter component and then hydrate it, right? So if you look here at the bottom, you can see this kind of a utility that we need. It's basically an object that when the server says use counter.client, then we can know how to download it from the server. However, how can we create this kind of utility in the build for the browser if we are not importing any client component at this point, but all the client components are importing the server instead? There are probably a number of solutions for this, but the one that we are using is kind of peculiar. So let's see. Imagine we are running on a build for the browser here. So this is a Vite plugin running browser build. And of course, we are going to use again a virtual file like in every other feature. And inside that, we're going to create a secondary Vite instance. Since Vite is so fast to create and to load everything, we don't really perceive any penalty while doing this in the client build, right? So once we have our secondary Vite instance, we are going to load the server entry point. Just load it. Once we have that, that's going to discover all the client components in the application because Vite traverses all the import statements and adds them to the module graph. Therefore, we can use that module graph to find all the client components and use that in the main Vite instance that we had before, the one that is running the build, right? So once we find the path for every client component, we can now create our utility for fetching client components, which basically is like this. We again rely on import metaglob. We merge all those import metaglobs and end up with an object that has a key from that the server also understands, and we can import the generated chunks for each client component. All right, so that's all for now. If you want to know more about Hydrogen, you can have a look at our GitHub repo or join our Discord channel. And if you have any question, feel free to reach out on Twitter. Thank you.
So today I'd love to talk about Quick City, which is a new meta framework built on top of Quick. My name is Adam Bradley. I'm the Director of Technology at Builder.io. And previously I worked on projects such as Ionic, Stencil, and Parttown is another project of ours that we're working on. So today I'd like to talk a little bit more about Quick and how it's working with Quick City. So what is a meta framework? So for example, Gatsby and Next.js are both meta frameworks built on top of React.js. And SvelteKit is built on top of, you guessed it, Svelte. And Nux is built on top of Vue.js. So some of the common features that a meta framework would provide would be something like file or directory-based routing, data fetching, server-side rendering or SSR, static site generation or SSG. But the biggest thing that I think it provides would be the developer experience and tooling that it adds. So for example, you absolutely could build a high-quality React.js app without one of these meta frameworks. However, it provides all of the developer experience and the tooling to make it much easier for developers to bust out and create a high-quality application as quickly as possible. Now, Quick City is, you guessed it, the meta framework for Quick. Now, it has many of the traditional features that you expect in a meta framework, such as routing, data fetching, SSR, SSG. But what I really like to talk about is what makes Quick City different and also why we're able to score so well in Lighthouse scores and page speed scores. A limitation commonly seen in many of today's meta frameworks would have to be their poor time to interactivity, or TTI. The amount of time it takes for the page to become interactive can often be attributed to the underlying framework's use of hydration. But it also comes down to the framework's heavy reliance on JavaScript to get the app up and running. Basically, the low-level frameworks have a lot of baggage which the meta frameworks have to deal with. There's just too much reliance on JavaScript. But is site performance really a problem? Well, the answer is yes. Actually, a better way to put it is a faster performing site will increase your conversion rates, whatever those may be. Now, I'm not going to read each of these individually, but the web is packed full of case studies like these, showing that the faster your site is, the more your conversion rates improve, such as increased sales, more signups, less users leaving your site, and many, many more case studies. So yes, a faster site can make a large impact for your organization. When you see the core web vital scores of many of today's top websites, you'll notice many struggle to create a fast website for low-end mobile devices. But what's deceiving is that these same sites work just fine on a high-speed desktop device throughout development. However, when we're out in the real world, trying to load a website on our mobile devices, we're all quick to give up and hit the back button after a short period of time. Basically, we're not willing to wait on a slow website. We're instead going to find one that's fast. So we ran Core Web Vitals on the top 50 e-commerce sites, only to find out that most of them are in the red and actually quite slow on mobile devices. But hold on here, remember all those case studies? Many of these case studies prove time and time again that site performance can benefit site conversion rates. So to help research why sites are struggling with performance, at Builder.io we created a performance insight tool where it's able to try out different test experiments. Basically, the tool tries different experiments to see which optimization makes the biggest performance impact. For example, it tests out how fast your site could be if you optimized only images or only CSS or only JavaScript, or how fast your site could be if all of the optimizations were applied. In this test, we're able to see that the site's current score is a 36 out of 100. If we were to optimize all of the images, it still gets a 36. If we were to optimize all of the CSS, it's still a 36. However, if we were to optimize the site's JavaScript, you'll see that the drastic difference is now a score of 96. And if we did every single optimization, the score is now 97. By breaking apart the test like this, you can see that JavaScript is by far where the time and effort should go to optimize page performance. So we ran the same test on many of the top websites out there. And just like our previous test, it actually shows that if you were to optimize the images and the CSS, there's only a small impact to performance. However, there is a massive difference for all of these websites if only the JavaScript was optimized. This shows that if you're going to invest resources into improving performance, basically it's best to first focus on JavaScript. And it only seems to be getting worse with time. According to HTTP Archive, the amount of JavaScript on a mobile site has increased over 700% in the last 10 years, and the trend is only going up. You can see that there's a correlation between the sites becoming more interactive, which requires adding more JavaScript. But sadly, however, JavaScript is the biggest culprit to slow sites. So who is responsible for slow sites? Could it be the developers that create and maintain the sites? Or is it the tooling which developers use? Or are the underlying frameworks themselves the ones that are dragging down performance? It's pretty common that developers are often given the blame here. As the old saying goes, a developer can make a slow site no matter what the framework. But I'd like to review this a bit and wonder if it's not the developer, but rather the mental model which today's traditional frameworks are based on top of. The current trend is linear. Added functionality means added JavaScript, and it doesn't seem to be slowing down. But what if we could break apart this correlation? What if no matter how much functionality you add to a site, the startup cost would stay the same, and the time to interactivity would stay the same? We've created 2 projects that help take the site performance problem head on. One of them is dedicated to improving third-party scripts called PartyTown. A third-party script is code from another domain, which you do not have control over, but still is running alongside your application. Some examples include Google Analytics, Facebook Pixel, A/B testing services, and many, many more. They notoriously destroy site performance, but there's little developers can do about it because the data from these services are extremely valuable to organizations. But rather than letting third-party scripts compete for resources with your application, it instead runs these scripts from another thread using a web worker. And by doing so, the main thread is dedicated to your application, and the third-party scripts are offloaded to a background task. This is a simple diagram showing that instead of all of the scripts sharing one thread and continuously blocking each other, PartyTown can instead offload many third-party scripts to their own web worker thread. Now, PartyTown is still experimental, but so far has been proving to make some large performance gains. Now, this talk is about Quick and Quick City, but there's plenty more to learn about with PartyTown, so I encourage you to take a look at this open source project. But let's get back to Quick. So while PartyTown addresses the third-party script problem, Quick addresses the first-party script problem. These are our 2 open source projects we're working on to help speed up sites. Now, first-party code means your code, the code which you have control over. This also includes the framework code being imported, the components being written, and the main scripts being executed from your site. But immediately the question is, why is Quick any different? There are hundreds of frameworks out there that say that they're the fastest. How is Quick actually different from one of today's popular frameworks? This leads us back to one of our earlier topics regarding the mental model of today's frameworks. Basically, many of the popular frameworks today use hydration to start up a server-side rendered application. The big difference is that most of today's frameworks are replayable, whereas Quick is resumable. Okay, so now you're like, what the heck? Why are we just making up words here? Well, let me try out an analogy. Think of a virtual machine, where in the first machine you can run an application to a certain point, then freeze-dry the application state and hand it off to another machine. The second machine is able to pick up exactly where the first one left off. This is very similar to what resumability is for Quick. The server is able to generate the HTML and within it include the application's current state, which means how the page is currently rendered, depending on the URL or any other parameters. At this point, the HTML is like a VM, where we freeze this app, send it to the browser, and the browser can pick right back up to where the server left off. It's not that Quick had to reload the app to a certain point, it simply continued from where the server left off. Now, hydration is entirely different in that the application needs to run twice, once on the server and then once on the browser. After the server renders the HTML, it ships the content to the browser like you'd expect. However, the client or the browser has to replay everything the server already did. It needs to again execute the application so it can get back to the point where the server left it off. So before the application can start to handle any user interactivity, the browser first needs to download the app's JavaScript, replay the app logic, rebuild the VDOM, and then diff the VDOM. And this is all before the user interaction can start to kick in. This is why we call it replayable and not resumable. It needs to replay the app a second time to get it up and running again and back to the same state the server left it off at. You can see the hydration cost yourself with some performance profiling. This long-running task here, and all the work the application is having to do at startup, is the hydration process. And remember, to even get to this point, we first have to download the framework and parse the scripts. And during hydration, it's having to re-render an already rendered application. This is one of Quick's biggest differences here. The app has already rendered, so Quick has no work to do at this point. It doesn't even have to download the app or framework at this point, and it doesn't have to re-render the application. This is where Quick uses resumability and not hydration. There's no initialization code, rendering, diffing, or setting up listeners just for it to run on the client. It picks up right where it left off. If you step back at this point, you might say that this is no different than what PHP or Rails were doing. They server-side rendered the HTML, and browsers immediately rendered the content. But what's different is that for any interactivity to be integrated, you'd use something like jQuery. But what we learned from that is that it came at a cost of keeping the server and client-side code wired up correctly. Even though it was the same application, there was a server model and a client model to keep in sync. The current form of development has drastically improved the developer experience of, say, 15 years ago. Frameworks have unified the model, improved the development practices, and improved how we scale complexity. However, these framework origins come from creating single-page applications. The server-side rendered aspect of today's frameworks were more or less an afterthought and only became popular in the last few years. The underlying frameworks, which meta frameworks are built on top of, were not built from the ground up considering SSR first. This is where we're hoping to see the next generation of frameworks go next. Wiz is one of Google's internal frameworks doing this, and this is what powers products like Gmail. Marco 6 has been doing this for a while now too, and is an open source project from eBay. Quick is what we've been working on as a way to combine React-like development experience with resumability. It's as if React was built from the ground up considering SSR first. Alright, what about Quick City? Where does it come in? So again, Quick City is the meta framework built on top of Quick. So all of Quick's benefits of resumability and extremely fast time to interactive is also true for Quick City applications. But what's unique here with this meta framework is that because it's leveraging Quick's core feature, that means there's actually very little runtime involved at all with Quick City. Now Quick City comes with many of the expected features of a meta framework, routing probably being one of the most important. It uses directory-based routing, which is similar to Next.js's recent proposal and SvelteKit's latest updates. Below is an example of a typical directory structure within the source routes directory. To make a route, the directory should have an index file, and the file's hierarchy of directory names is what creates the URL path. Directory names can also be used to read params within segments of the URL path. Another common feature would be nested layouts, which is basically the ability to wrap page content with the layouts found in parent directories. Now Quick City's nested and named layouts are absolutely inspired by SvelteKit, and its grouped layouts are inspired by Next.js's latest proposal. But another feature it provides is a top layout, which is a way to not inherit parent layouts, but instead stop at a certain level. One feature where Quick City really shines is request handling and its integration with existing servers. Request and response handling is a core feature, and what I really like about it is it kind of brings us back to the basics of an HTTP server. Each page can create its own on-GET or on-POST request handlers and provide their own logic on what to do. This would include being able to provide authentication, HTTP status, redirecting, or handling form submissions. This also includes being able to use a resource component, which is found in Quick Core. By combining request handlers to load data and the resource component to render the data, it provides a great utility to seamlessly communicate between the backend and frontend. The same resource component also makes it easy to asynchronously load client-side. This resource component also makes it easy to asynchronously load data at client-side while also showing a loading spinner until it's resolved. And the same request handler API is available for any route, not just routes that return HTML. So for example, the same request handler API can be used for just an endpoint API, returning JSON data, or whatever the developer chooses. In this example, the source file exports an onGet function and a default component. While the onGet only runs on the server, the component runs on both the server and the client. To connect the two worlds, the component calls the useEndpoint utility from Quick. What's great is that the types also naturally flow between the two different worlds. The product data interface returned by the onGet is also correctly typed within the component renderer. Up until this point, we've talked about fairly common features of a meta framework. When numerous meta frameworks are built on top of the same framework, and each offers the same features, it's getting kind of difficult for one to be drastically improved over the other. And again, this falls back to using the traditional framework mental model. What's unique about Quick City is not any slight differences in the meta framework features, but rather how it's able to take advantage of the Quick framework itself. One that's been fun to build out is its ability to actively prefetch any potential execution paths. Now, developers will often point out that lazy loading on demand causes latency issues, which is usually true. However, Quick avoids this by actively prefetching what's possible. But that absolutely does not mean that we're prefetching most of the application, only what's needed. So for example, if the only thing a user can do is click a button, then that's the only module prefetched. In this example, the browser wouldn't download any render code or even the Quick framework itself. It only prefetched the possible listener. And instead of using the link tag for prefetching, Quick City instead uses the cache API, which actually offers better support compared to the link rel module preload. And all of this happens within a background task using a service worker. And because we're able to intercept requests and understand the app's module graph, we can also reduce the network waterfalls by starting off all the imports we know an interaction will need at the same time. Actively prefetching an application as a user navigates an app is kind of like the concept of video streaming. For example, if Netflix had you downloading movies, you'd have to first wait for the entire movie to finish downloading before you could start watching the opening credits. However, Netflix, YouTube, Hulu, and all the other video services instead have you stream the video as you watch it. This means customers are only prefetching the content just before they need it. I'd like to think that Qwik's active prefetching is quite similar, and that it's only actively prefetching the next possible interactions as the user is interacting with their application. Now, static site generation is something that many great projects can already do. Where Qwik is different here is its ability to add a heavy amount of interactivity, but without a large JavaScript overhead. One of the reasons some frameworks prefer client-side routing is because it's expensive to do a full page reload. But because there is no hydration cost for Qwik, then each page load is extremely cheap, no matter if it's one component or 50 components on the page. So with Qwik, it's still easy to create a multiple page application, an MPA, while also adding in a heavy amount of interactivity. Next is server-side rendering, or SSR. By default, QuickCity is able to stream content back to the user just as HTTP intended for it to work. This is in contrast to many frameworks that will block until an entire single HTML string is completed. Because Qwik's renderer is async, it's able to stream back large chunks of completed HTML as it's finished. This means that the document head and a page shell can immediately respond with its HTML, while the product data can still be loading from a database. And when the product finishes loading, the HTTP stream will continue with the completed HTML. But a traditional SSR setup often has its own performance issues from the very beginning. Because the framework is always rendering the entire tree, for every request, this becomes very expensive for the server. As you can see here, Amazon stated that they simply could not use React SSR because, in their words, it wasn't fast enough. So this is heavy on our minds as we don't want to fall into the same performance issues React SSR has. This is where I'm excited about a hybrid approach of mixing static generated content and dynamically rendered content. It's really difficult to get anything faster than SSG. It's basically already rendered and no work needs to be done. With SSR, however, usually the entire tree needs to render because the application isn't sure what's static or dynamic. However, with Qwik's optimizer, it does contain this information and it does know what's static and what's dynamic. This means that while generating SSR renderer code, we can create modules that are largely pre-rendered strings of the content. It's not having to render the entire tree, but rather concatenate all of the static parts, which could be most of the page, and dynamically render the small sections. This would be ideal for personalization, where 100% of the users could see the same product content, but small sections of the page will be personalized to the user. Another realization we've had with Qwik is that the lines have blurred a little bit between a multiple page app and a single page app. With a multiple page app, an MPA is great for content-heavy websites, like an e-commerce site with product pages. MPAs are great for SEO and fast loading times. Alternatively, a single page app or an SPA is great for complex applications and immediate user feedback, like a dashboard. But with Qwik, the downsides of each approach is less of a problem. And rather than having to make an MPA versus SPA decision at the very beginning of the project, every single user interaction can make the decision if it should be an MPA or SPA. So all of this can ask the question of why? Why is Builder working on open source software directed at improving web page performance? And all of it circles back to our project, Builder.io, with the goal of easily scoring 100 out of 100 no matter what you throw at it. So Builder.io is our visual CMS you can integrate into any existing stack, such as React, Vue, or Angular. But with Qwik and Partown, we feel we can push Builder's performance even further by rethinking how you can integrate into CMS into your stack. That's all I have for now, so this was a fairly short talk, so I apologize for running through some concepts and completely skipping over others. But it'd be great if you could test it out for yourself. You can start a QuickCity app by using npm create Qwik at latest, and it'll only take a minute and you can inspect the performance for yourself. At the very least, I encourage you to take a look at our docs and run through some of the examples and tutorials. Thank you for your time, and please feel free to ping me on Twitter and Discord. Thank you.
ViteConf goers, Ben Holmes here, B Holmes Dev everywhere else, and I'm here to talk about Islands architecture. Now, hang on, is that Whiteboard the Web calling me? Hang on, I'm gonna take this. Hey, how's it going? Nice sunscreen. Oh, yeah, I just got back from an island retreat and I'm getting back into the swing of things. Yeah, I'm recording a conference myself. You wanna record the intro? I was getting ready to record a Whiteboard the Web for that, but sure, I could give it to you now. I just need to clean up real fast. 1 second. Crazy guy. Guy's back. Yeah, I'm fast. Let me reset this guy real quick. Do you want me to start with an example? Sure. Okay, cool. Basic HTML page here. And I capitalized all the components I might be pulling from Preact or Vue or Svelte, like a nav bar that slides in and out on mobile, a hero banner is just some text, maybe an image carousel that you can slide through, and the ones that actually need, like JavaScript and clicking, are in red. Does that make sense? Sure. Okay, cool. So if I build this whole thing top to bottom with JSX, I'd ship JavaScript for the whole thing. Of course, these aren't real numbers, but we're getting a sliver of JavaScript to represent every element on our page, interactive or not. It's not very efficient. Yeah, exactly. So what if there was a way to only ship JavaScript for these ones and erase it for the other ones? That's where I would bring in something like Islands architecture to turn these two guys into hydrated islands. So I added some client directives here to decide when to load JavaScript for these. So we're not going to load JavaScript for any elements on the page. Save on that. And then for the nav bar, I'm going to load JavaScript when it's 600 pixels or less. So only load the mobile slide out, make it static on desktop. Smart. Yeah, it's cool. And then for the carousel, I'm going to use client visible to say delay loading that JavaScript until it scrolls into view, because maybe we have a big carousel library or something. It's like Astro. Yeah, it's like Astro, but I could see the way to do this with just web components too. I have an example repo if you want to try it out. Sure, send it. Okay, awesome. I can send you the link if you want to, and you can demo that for your talk. Saves some work. Perfect. Okay, I'll send it to you. But I'll hang up. Definitely get back to what you're doing. I'll see you around. Yeah, great talking to you, man. Visit whiteboardtheweb.dev. Oh my god. Okay, let's grab that example repo, see what's going on. All right, I have it pulled up. Okay, let's go ahead and just run this guy. I'm sure it's just the dev command. Sure is. We can see a dev server here, and it's just Vite plus Preact. It almost looks like the starter. I assume we're using Preact Islands for this, but it's not always what it seems. Let's check out the code. Yeah, some spiciness going on here. So we have a Vite land, which I assume is a Vite-powered island, and that's loading up our app. And we have one script on the page for client.ts. Let's see what that is. Okay, so ViteLand is a web component as promised, and whenever that component loads, we're going to reach into this islands object. Okay, so this is a manifest of all of the islands inside of this fancy islands folder over here, with functions to delay loading that component until we actually need it. Very cool. So we grab the component, and if it exists, we're going to render it with Preact. Pretty simple. So we have some other components in here. Let's try them. Linking out to one of my blog posts here on building an image carousel adapted to Preact. Definitely worth a read if you want to learn how to build an accessible carousel. But to add that to the page, I'm sure I can just make another island, this time with image carousel. According to that manifest, that should load. Yeah, with some nice album art too, interactivity. Awesome. But we probably want to delay loading that JavaScript until it scrolls into view, like that cool demo. So I'm going to make this work, client:visible, a lot like Astro. So in order to check that in a web component, I'm sure you can just say, does it have the attribute client visible? If so, we're gonna wait until it's on the screen. And we have some helpers up here. So this is going to wait for this intersection observer to resolve. So when it's intersecting the page, we're going to resolve true so that we can fall down and load the component. So here I'm just gonna wait for it to be visible on the screen, and I'm gonna pass in this as the element, this web component. So now it should only load the component it's on the screen. And if I head over here, I can add a little divider maybe, so that's off the screen. We can check that it's actually doing it in our network activity. We can add margin top to this guy. All right, and now it's off the screen. Let's see our network activity, scroll down, and there it is, even lazy loading the images. Oh, that's so cool. And I'm sure we can do that with our mobile nav here. We can only load it when it's like, on mobile, and on desktop, we can avoid loading JavaScript entirely. I'll add another island for that. Mobile nav is what I saw. And client media is what we want this to be. And this is going to be max width 600 pixels, or 500, sure. And Inside of clients, we have a media utility, sure. This is checking window match media, which is a cool native browser API for this sort of thing. So similar game as this, check if it has the attribute, this time client media, and instead of visible, we're gonna wait for this media query to be satisfied, and the query is just this.get attribute client media. So whatever you pass in, I'm gonna pass to match media. Okay, so now we don't see it on the screen, makes sense, but when I squoosh this down to mobile view, all right, it pops in, and we see our client being loaded down here. Awesome, with interactivity. Okay, so yeah, pretty simple demo of islands. If you want to use base web components, you can wire up attributes on your own, but if you want to handle like server-side rendering, prop passing, other frameworks other than Preact, of course I'm going to point you to astro.build, an amazing project to let you use any framework that you want with some of those client directives that I showed you, with a whole bunch more for like Markdown, adding Tailwind with no config, etc. So definitely go check out that project if you want to buy into islands. Otherwise, enjoy the rest of the talk. Thanks for your time.
My blog did not build with Vite. I tried to isolate the issue, and as it turns out, it was because of a piece of HTML that was pulling in from a library that Vite's HTML parser just did not accept. As the good citizen that I am, I opened an issue and had a quick, verbal but respectful fistfight with Evan, in which he beat me handily. We compared our approaches to parsing HTML, and while he acknowledged that my complaint was very much valid, his current approach to parsing is as well, and he actually ended up teaching me something about parsing HTML along the way. I went back to my chambers, and after Matias made me aware of Vite's plugin hooks, I came up with a functional but pretty hacky workaround for my problem, which I shared somewhat self-deprecatingly on Twitter for some reason. A couple weeks later, I found out that the Vite team had decided to canonicalize my hacky workaround, that they had been working on a proper implementation of it and has now merged it upstream. And that's the story of how Vite switched to Parse 5, a spec-compliant HTML5 parser, which means that Vite now parses HTML the exact same way as all the browsers out there. Now, there are a couple moments in the story where you think, this is not how you're supposed to contribute to open source. And I would agree. So if you want to know more of how you contribute to open source properly, this section is for you. First up is Bjorn, who's an experienced tooling author working on both Svelte and Vite, and he'll talk to you about the techniques and the etiquettes of contributing to open source. Afterwards, Brian will tell you about the lessons learned from people contributing to Vite, but also how you can leverage the community to help with your own open source project. Next up is Hao Chin, who is a core team member of Vue and Vite, and he'll talk to you about the process of migrating Vue to use Vite and what the future of Vue plus Vite has in stock for you. The last talk in this section is by Dominic, who is a member of the Svelte team and the maintainer of the Svelte plugin for Vite. He'll talk to you about Vite Ecosystem CI, which runs other projects' CI so that the Vite team can know ahead of time whether they're breaking a downstream dependency without having to cut a release. And lastly, we'll bring this conference to a close with a panel with some of the core members of the Vite team and Tracy, who will be moderating and hosting. So I hope this sounds as interesting to you as it does to me. I'm gonna sit down and enjoy, and I hope you can do the same.
Hi, I'd like to start with a story of how I got into contributing in open source.
So back in 2020, I got my first full-time job as a front-end web developer. But at the time, I have an issue where I'm trying to find technologies to learn, but I always don't have the time to put it in side projects. So I was thinking, what could be less effort but have the same gain in return? So that's when I got into open source projects, and the first one I contributed to is Vite plugin Svelte, which is a Svelte plugin for Vite. And I quite like it. I use it at work, and I found a bug, but then I made a fix. And then what I find is that the fix I made contributed to everyone who's using the package, and I kind of feel great knowing about that. And from there on, I've been working on open source since. So the topic for today will be contributing 101, which I'll cover tips and tricks and everything you need to know about contributing in the world of open source. So a little bit about me. I am Lu. I'm from Malaysia. I am currently a core team member of Vite and Svelte. I am also a core resident in Astro, and I've been dabbling with open source for about 2 years right now. And I also love nature. I could spend like hours watching the sky or something. But without further ado, jump next to the main point, which is open source. So you may know this in the open source community, we have this acronym called OSS. So what is OSS? OSS stands for open source software, which is software that you can read the source code directly to understand how it works. And oftentimes, open source software is also related to something called FOSS, which is F that stands for free, so free and open source software. This is usually the case because open source software is easily distributed free, but sometimes you can see paid software as well. For example, paid licenses or commercial licenses. But you quickly notice a problem. If it's free, how does it sustain itself? So this is a big deal. And sometimes you notice like an issue like this on GitHub where someone's asking if a project is to maintain. Sometimes it's true because the project is working fine as is and there isn't anything that needs to be maintained, so that it's perfectly fine. But sometimes it actually is abandoned because the project maintainers doesn't have the resources to continue on the project and it is left as is. And this is also an issue that comes up often in the world of open source. So how do we help? So from my experience thus far is that there is basically 3 things that we could help. So the way to summarize it is that with code, community, and funding. So in this talk, I'd like to deep dive into these 3 points and provide information of how you could work in these areas and contribute to them. So contributing code. The first thing we would do in a project would be making bug reports. So if you find an issue, you create a bug report. But something important to notice is that making sure that it is actually a bug. Sometimes you may only have a question or you're uncertain if you're doing it the right way. Sometimes it is actually a configuration issue where in your project you're not using the project correctly. So knowing if it's a bug or not saves a lot of time. And in that point, you would also want to follow the template. So each repositories may or may not have a template when filing an issue. If they do, it's important to follow the issue list and read through them and follow the instructions to, for example, create a minimum reproduction. Because sometimes it's important for maintainers to easily reproduce issues so that they can easily hit it and make a fix quickly instead of having everyone manually implementing your own setup. So this is contributing code. But the main takeaway from this is that it saves times for contributors. So not only the maintainers, but anyone who is interested in helping in the project would also benefit from if you follow these guides. But besides creating bug reports, there's something else you can do, which is directly making the fix yourself. So when you start making a fix, it could be on a small project or could be in a big project. For a small project, it may take 30 minutes or an hour plus to digest everything and make the fix. But sometimes in a big project, it could be hard, which is understandable. To this day, I don't really understand everything in the Vite code base, but that is fine. And an easy way to start off is to read the contributing guide. It should have all the information you need to set up the project locally, to test it, and to make changes that you need, and where to find it. And I've also found it easiest to start with fixing a bug, since a bug usually touches a very specific domain. So you only have to fix maybe a specific file or maybe just a directory. So you don't have to read the entire code base to make your own fix, but only a certain small piece of code. And usually this is enough for you to gain context on the fix itself and send a PR or a pull request. But sometimes if you get blocked, in Vite, we have a contributing channel in Discord where all the contributors, including the core maintainers, are there to help. But it's also important to understand that sometimes people are busy and they may not get in touch with you soon. So you may have to figure things out yourself, but I think ultimately this leads to the final point where this is a self-learning experience, where you're more independent on your own in the world of open source, but you also, at the end of the day, save time for maintainers since you're doing them a favor in the long run. Another thing you could do is by triaging bug reports. So on the image on the right, you could see that there's a bunch of issues which is not being viewed yet. And this is a common problem in big open source projects, is that there are so many problems, but there's so little time to understand, is that actually a problem or is it already fixed, etc. Which kind of brings back to point number one, where you should understand whether it's a bug or not. But if you're interested in triaging issues, which is a very helpful thing to do because it acts as a first line of defense before the issue reaches to the hands of the maintainers, because sometimes an issue is invalid or it lacks a reproduction, and these could be easily skimmed off before we dive deeper into it. And going through all these issues also helps us understand edge cases. Sometimes you find a very specific issue or 5 or more issues that are kind of related to each other. So you would have like context on specific issues where you could fix in a holistic way instead of fixing just one very specific thing. And also triaging issues helps you understand the context behind decisions. For example, if maintainers decide to reject a proposal or reject a bug, maybe because it's intentional, or maybe there's like a very good reason it is out of scope of the project. So knowing how to act in certain cases like this is very helpful because you could think the way maintainers think, and that helps to release some of the responsibilities that they have. And of course, this often leads to experience in the project direction and their philosophy in a whole. And another thing you could do in contributing to code is reviewing code changes. So basically, when in a project you might have pull requests with a bunch of changes, reviewing PRs takes time too because you need to make sure that what change is correct and it doesn't break anything else. So if you're new to reviewing PRs, starting small is a good place to start. For example, typo changes, documentation, or small fixes to a very specific logic in the code, which is easily digestible. But also making comments also brings you to a long way. Because making comments on specific issues you may find, for example, you try to test your PRs locally and you find problems or maybe not. But this shows that you put effort into reviewing PRs. So making comments kind of makes it more credible to the maintainers, knowing that you actually put effort into it. And lastly, this also comes up to the previous point, which is learn the context behind the decisions that the maintainers make. Sometimes you have changes that maintainers reject, or maybe they request specific code changes to it, because this helps you understand the specific patterns that the project uses. And further along, you start understanding specific patterns that you should follow, and you could bring this along too when you start reviewing PRs as well. And ultimately, from the previous points, you're actually applying your experience when you review your PRs. So from triaging issues, making issues, or just making a fix, these are all helpful in ultimately reviewing the PRs. That is code that's going into the main project. So to kind of summarize the code contribution point of view, you can kind of see that further along, the responsibilities start to rise. So this is more or less like a spectrum when you become from a contributor to a maintainer. So the more responsibility you get, the more important you are. But on the next point, we have the community. So community is also another very important aspect in a project. Like without a community, the project is basically no one uses it. So the first important thing is asking the right questions. So when you go in the community, you don't really just go on GitHub or just go anywhere. It is important to know where exactly you are supposed to ask the questions and also the information that you should give. Sometimes you give it too long or if it's too verbose, people don't really feel like checking it because it's like an essay and they have put a lot of effort to understand the question. So try to be short and concise. Try to give all the information needed so that someone can read it once and they can answer it once. So it saves time in both parties. And also keeping it short helps them to reduce the cognitive load when they try to understand what your problem is. And also, a side note, try not to spam in the channels, because sometimes not everyone has the time to check out your problem or your question. And if it's important, feel free to always ping again, like in a couple of hours, so that everyone has a chance to revisit that again when the time comes. And while you're asking out questions, a helpful tip that I had in the past is try to answer them at the same time. So before you ask questions, you can look around, see if anyone else has problems. You can try to answer them the best you can and give ideas, even if you're not sure how to fix it. And that is a great way to invite others to answer your question as well, because it's like a two-way street where everyone is helping each other. And at the end of the day, sometimes questions actually bloom to a problem where documentation is a problem. It needs to be clarified. And all these leads to understanding the pain points of the project. So this is a very important thing where the users of the project know more than the maintainers. So for Vite, here are like a few links that Vite uses for support. You can go chat.vitejs.dev, which is a link to Discord where you can seek for help. Or we can also ask in GitHub discussion in the ViteJS GitHub repo. You can also check out the documentation at vitejs.dev, and the documentation changes could also be made on the ViteJS repo. So the next point will be funding. So funding is also another important aspect. Even if you're only contributing money to it, it is vital for any project to sustain itself because maintainers are always spending their own free time working on it. So one way is to use sponsorship to sponsor them on a monthly basis or one-time basis. This includes GitHub sponsors or Patreon. And besides that, some companies also offer a percentage of the work working on open source so that, for example, you can work 70% on the main company work and 30% on open source work. And at the end of the day, it benefits both sides where the company may need the expertise of the open source project to work on their main company as well. So this is also another two-way street where it helps everyone. And also some developers offer consulting services, which is kind of like sponsorship, but you get something in return. Say you need support from the maintainers, you can get direct help from them, which is also another way to support these project maintainers. And ultimately, the project that you use or depend is also maintained, which also helps with the product that you use to build on top of it. So it will help you in return as well. To kind of summarize the talk, here's a handy list that I've made, compiling every points that we have talked thus far, which you can use to reference in the future again. And most importantly, have fun. Work on projects that you're interested in, make it as a hobby. Don't try to push yourself too much and take breaks where needed. Don't burn out, and also be respectful to others who are also trying to contribute to open source as well. And that is all for my talk. Thank you for listening. I'd like to give special thanks to Dominic and Fatih who helped me in the journey in open source, where I've never been where I am today without their help. And you can look for me on my socials on GitHub, which is Bluey, or on Twitter, Bluey. Thank you.
What's up, y'all? My name is Brian Douglas, founder and maintainer of Open Sauce, and going to be talking about insights and open source contributions. So let me go ahead and share my screen and jump right in. So last year we had the opportunity to actually talk to Evan Yu about Vite right before the 2.0 launch. And after that conversation, we ended up switching all of open source into Vite. So super happy to be a part of this community, to be contributing, not too much contributing upstream, but hopefully soon, because that's what our goal is, to actually find open source contributions. But I want to mention, I'm going to quickly just give it a quick demo of what my fuller talk will be. This will be sort of like a sneak or a snack of OpenSauce.pizza. And yeah, I'll jump right in. Yeah, so open source is open source intelligence dashboard. We've been indexing Git repos and providing insights on top of that. So we've been messing around this for pretty much all year. I've been working on this full time for the past 3 months, and really happy to share. Finally, we have a URL, which is insights.opensauce.pizza. This will be the home for all of our insights and dashboards. For the time being, we'll be supporting Hacktoberfest to provide insights on all those repositories and identify things like spam and contribution. So definitely check it out. But I wanted to really just start the stage here real quick and talk about like what GitHub offers. And not that we're trying to compete directly with GitHub. We want more people to contribute open source and leverage GitHub. But I do want to point out that GitHub actually has some missing pieces, or at least a part of this feature. So when you go to the Insights tab on GitHub, this is what it looks like. This is for Vite. And this is all the contribution in the last actually 4 months. Actually, 5 months at this point. My math is off. And the biggest top 2 contributors is Safi and Patak. And just wanted to point that out because a lot of people don't know you could actually grab just like one section of the calendar to then find contributions for that time. A lot of times when you look at contributions, it tells you indefinitely since inception. And sometimes you just want to know who's contributing recently. We want to answer that question in open source pretty easily. The other thing is like you don't really get insights on what actually is happening. You get blobs and you look like distribution and activity. So you see Anthony had a big push earlier in May. Bluevy contribution across the board for a while. And it's good to see this because then you can see who's active and who to reach out to if you want to get unstuck or unblocked on certain things. But open source, like we believe that you shouldn't have it to know the secret sauce in order to contribute. Like we want to share that secret sauce, and that's what we've been doing with our platform. And so this is the same calendar. It's just flipped. So today is on the left. We're going to switch it back to the right. But anyway, this is distribution of all contribution in the last 35 days. Because a lot of times when you want to see if a project is active or see who's around in the community, you want to look at like who's been contributing recently. And that's what this is. And these are representations of pull requests. But right off the bat, you can see in the first quadrant, you have 7 days is the last 7 days. And already you can see there's one person, Safi, who's sticking out from the rest. And if it was any higher, we'd probably be concerned about bus factor or knowledge transfer, but it's still okay below the 50% mark. But what I want to point out is that actually seeing this distribution, now you have an idea of like across a team or across the community, what's happening. But we're still in the same position as GitHub, where you can't actually see all this context unless you open a bunch of tabs or a bunch of PRs to see what kind of contributed to what release. So with open source, we want to make this easier. Here's all contributions that are happening in the last 35 days, or particularly Safi. So it's not just one PR, it's multiple PR, multiple commits. And we see like the top one, 736, that's how many lines have changed up in the top right. So it looks like there was some dependency change. So like maybe the package lock file. I didn't look into this actually prior, but there's a lot of changes in dependencies, which is why he's standing out from the rest. But the good news is most people have the same sort of size contributions. Things are easily tracked and reviewed. So it's hard to always review a large PR. The other thing that we were able to do is actually index based on line. So we can do some heuristics in identifying whether it is a maintenance change, so if it is a package lock file, or if it's actually new code, new features added to the project, or if it's just refactoring. So files are still the same, but things are moved around, functions are moved around. So identify things like this, and I meant to circle that, but identify that type of stuff makes it easier to know what types of contributors are they casual contributors, are they active contributors, are they maintainers. Those are things that we're hoping to start surfacing through this insight. So we're just getting started, looking forward to ship way more. We want to go past just green squares and identify opportunity for contribution. So if you're interested in chatting more about your project, or if you have any projects in the Vite ecosystem, we would love to chat and see if we can provide insights for you. So check out the full talk and enjoy the rest of the show.
everyone. I'm Haoqun Jiang from the Vue.js team. Today, my talk title is Vue's Road to Vite, and I'm going to talk about the new Vue.js developing experience centered around Vite. Let me quickly introduce myself first. I'm a member of both the Vue and Vite core teams as a full-time open source developer. My main focus is on the toolings for Vue.js, so I maintain and contribute to several projects related to Vue.js project scaffolding and bundling, most notably Vue CLI, Vite, and Create Vue. My GitHub username is @soderT, and my Twitter handle is my full name @haoqunjiang. Earlier this year, we put the good old Vue CLI project into maintenance mode, meaning that we will no longer actively add new features to it, but only ship bug fixes. Now the official recommendation is to use the following command to create new Vue projects, npm create Vue @3. It is much more lightweight than Vue CLI, requires no additional global installation of tools except for npm and node, and it is always up to date. Recently, we also managed to incorporate it into the official Vite templates. So now when you run the npm create Vite at latest command, you can also see the customize with create Vue option in the drop-down alongside the two minimalistic templates provided by Create Vite. It will create the exact same project as the Create Vue command, and they are both based on Vite. So in today's talk, I will try to answer these questions for you. First, why do we, the Vue team, decide to switch from Vue CLI and Webpack to Create Vue and Vite? Secondly, what are the different approaches the Vue tooling ecosystem is taking in the era of Vite? Third, what more interesting new features can we expect in the near future in the Vite Vue ecosystem? The first and most notable change is to turn our ecosystem away from Webpack. I have to say that it takes some courage and struggle for us to make this decision, because by doing so, we are essentially dropping lots of our previous efforts devoted to the Webpack ecosystem. But the Vite ecosystem is now getting more and more mature, and we believe it's worth it. The benefits are very obvious and impressive. We all know that Vite's dev server is way faster than Webpack's. To be precise and completely fair, well, it is actually possible to get nearly the same performance as Vite with Webpack, as long as you have configured the native compilation tools such as SWC or ESBuild, and you have a very good cache configurations, and it is a warm startup. However, it is extremely hard to get all these configurations right, and it requires tons of dependencies. Meanwhile, in Vite, the good performance is out of the box. You don't have to configure anything additionally. Besides, when it comes to the hot module replacement feature, the time complexity of the Vite implementation is constant, while Webpack is proportional to the module count. So when the project grows, the hot module replacement in Webpack gets slower. And this is by design, meaning that Webpack can never catch up with Vite. Another benefit of Vite is its simplicity. The configuration format of Vite is easy and intuitive, so that we don't need another layer of abstraction like Webpack chain to let the users easily get their desired configurations in Vite. And even for ecosystem package authors, it is easier to extend from the Vite core than from the Webpack core. For example, it is a universally acknowledged design PT in Webpack that it shouldn't have both the loader and plugin API, because this brings two problems. First, users might not know which API to use. Sometimes they might even have chosen the wrong one at first. Like the ESLint loader was later turned into ESLint Webpack plugin because the authors found that the plugin APIs are more suitable for the use case of ESLint. And sometimes we may need both the loader and the plugin APIs to achieve one single functionality. That's the case for Vue Loader, even though it has the word loader in its name. Users still have to use the Vue Loader plugin export from the same package together with the Vue Loader to make Webpack support Vue single file components. These are no longer problems in Vite and the Rollup because they only have one way to extend from the core. That's the plugin system. Lastly, as of Vite 3, the third major iteration of Vite, we believe that Vite is mature enough and more than ready for serious use cases. Because with all its simplicity, Vite still has a power enough core. It is ready for use with many built-in integrations. It uses Rollup, the battle-tested bundler for production bundling. And of course, the super performant dev server is one of its most iconic feature. And it has static asset handling enabled by default. No extra user configuration is required. So this makes Vite more like Webpack, more like Vue CLI than Webpack. That's another reason for us to switch to Vite directly instead of creating another layer called Vite CLI or something else. And for more sophisticated use cases, such as browser compatibility issues and unit testing solutions, Vite already has a rich ecosystem. It has first-party plugins for Babel transpilation, and it has third-party tools like ViteTest for unit testings. So Vite is now in feature parity with Vue CLI mostly, and that makes us more confident in the switching. It is a mixed blessing that Vite is a completely new generation of web tools. So we can take the opportunity to take a different approach on some of the issues that wasn't possible previously in Vue CLI and Webpack. So we drop support for many anti-patterns. For example, ESM and CGS code are no longer allowed to be mixed in user codes in user projects. You cannot use module.export and import statements in the same module. Of course, CGS only code are allowed in dependencies, but your project code will be cleaner with this limitation. As of the Vue plugin of Vite, we now force explicit .vue extensions when you import from a Vue single file component, because that makes the integration with other tools easier. ESLint and TypeScript can recognize the Vue single file components earlier, and that would be less problematic in the future. Vite does not only take a different approach on technical issues, it also improves the project management on many levels. It now has a predictable release cadence. That is, it would ship at least one major version every year to be in line with Node.js versions. So every year, Vite would drop support for end-of-life Node.js versions. This year, Vite 3 dropped support for Node.js 12, and next year, 2023, Vite would drop support for Node.js 14. This more frequent and predictable release cadence also makes the migration path of each major version smoother. It will have fewer breaking changes in each major releases, so you will no longer see the long list of breaking changes in the migration guide. And this ease of migration is also guaranteed by the Vite ecosystem CI repository. With every release, Vite is tested with all the major players in the ecosystem. And if you are using Vite with a wrapper or a meta framework or something else, they will be guaranteed to be usable before the release. So the migration path is smoother. In the transition from Vue CLI to Vite, we've also taken this opportunity to decouple some complex features from the main tool. In Vue CLI, we used to have the concept called generators, which are special plugins used to create or modify files in a user project. These generators are often tightly coupled with each other. For example, the TypeScript plugin is used to modify JavaScript files created from the CLI service package, but has special handling for files created from the router plugin. So that makes these generators hard to maintain in the long run. Now that we are creating new tools, so we decided to create a dedicated scaffolding tools for each of these use cases. We have created Vue, which have all the basic necessities for a Vue project. And for those who are using their own templates or using older Webpack-based projects, we have the Vue /create ESLint config package that are used for only creating the ESLint configurations for you. And if you want to have your own project templates, I think it is a good choice to create GitHub repositories as templates and use the Git to download these templates for you. Another type of plugin in Vue CLI is service plugins. These are plugins used to extend the Webpack config from the core CLI service and CLI plugins. Now that Vite is easier to configure and extend from, we no longer need another layer of abstractions. So no more service plugin. You can just use plain Vite plugins in a project. Okay, now let's take a closer look at each of the core Vue CLI plugins and see what we've got in the Vite ecosystem. First, let's start with the ESLint plugin. The ESLint plugin was used to help users configure ESLint in their projects and lint the files during project compilation. For the configuration part, we've created a new tool, and you can call the command npm create @vue/ESLint config to help you configure ESLint in any Vue projects. That includes Vite, that's not only in Vite projects, but also in Webpack projects or in Vue CLI projects. As for the linting during project compilation part, we now find that it is not the ideal way to do linting because it hurts the compilation performance. And most IDEs and editors have ESLint plugin. So we now recommend you to just use your IDE or editor feature to use ESLint instead of use a bundler plugin. And as for the TypeScript plugin, transpilation of .ts files are supported by default in Vite with help of ESBuild. If you want type checking, we also recommend you to use the integrations of your editors or IDEs. And if you want to do the type checking in command line, then you can install the Vue TSC package separately. Of course, if you do want to see the linting and type checking results in your browser page in real time, there is a third-party plugin called Vite Plugin Checker that runs these tools in a worker thread, which is non-blocking, and the results will be shown in the browser error overlay, just like what we've got in the Vue CLI in the past. As for the unit testing solutions, actually, we are not satisfied with any of our previous solutions. Jest is a great tool, but the biggest problem of it is that it doesn't share configurations with the bundler. It has its own ecosystem of transformers and resolvers, and users have to maintain standalone configurations files just for Jest itself. And the testing environments might not end up not the same as the project execution context. So that's not ideal. Mocha is another great tool, but it is tedious to configure Mocha to make it work with other bundlers. The Mocha pack, they mostly use the Mocha integration with Webpack, takes much time to upgrade to Webpack 5, and it still hasn't upgraded to Mocha 10 yet. Luckily, we now have Vitest, which is a Vite-based unit testing tool, so it's faster by default, and the configurations of Vitest is derived from the Vite configuration. So the users run all the code in a similar environment. And most importantly, it is well maintained by people who are familiar with Vite. So it's easier to upgrade to new Vite versions. And it is also part of the Vite ecosystem CI. So much for the ecosystem. Looking into the future of Vite Vue integration, we still have many exciting new things planned. For example, it is a common source of bug that there may be more than one Vue copies in the same node modules. So we want to dedupe the Vue package by default and keep only one copy of it. We'd like to ship this feature after thorough testing. And here's another potential improvement, that though Vite encourages ES modules whenever possible, there may be some legacy packages that were shipped in the CommonJS format, and they might even require the CommonJS version of Vue. So we want to improve that kind of packages interoperability with newer packages. And we want to do something in the Vue plugin to help improve the situation. Though Vite is already very fast, there is always room for improvement, and we won't stop looking for ways to speed up Vite even further. So that's it for my talk. Thank you for listening. Hope you enjoy coding with Vue and Vite. Thanks.
Hey, I'm Dominic G, and this is Vite Ecosystem CI. The Vite ecosystem is a lot of projects, many packages that depend on Vite. Frameworks use it to build awesome things. We've seen so many cool presentations today, and all of that is made possible by Vite. It's growing fast, and to continue to thrive, we need a stable base to work with. This is ensured by continuous integration. Every change in Vite is tested with a CI built on Vitest and Playwright, but fails still happen downstream. It's only possible to run downstream tests after Vite was released. Or is it? With Vite Ecosystem CI, we are able to run downstream tests before we release Vite. And that means we get immediate feedback and less fails happen downstream. To do that, we automate a typical maintainer setup that links projects and installs tests and then reports back to the upstream project. We also support a lot of tools the Vite ecosystem projects use, like PNPM, Yarn, Deno, JIT-LFS. And through custom scripts, you can basically build everything. Also, nesting is supported, which is important for complex setups like Vite plugin Svelte and SvelteKit. It's almost impossible to run this manually all the time. So we use a GitHub action matrix to run all the tests in parallel and get scheduled feedback. We can trigger it manually, and thanks to an awesome contribution by Safi Red, a comment on a Vite PR is all it takes to test the code in that PR with most of the Vite ecosystem CI. This is unbelievably great. It's a great way to ensure that changes do what they intend to and don't have unpleasant side effects. We can run it on every Vite commit, branch, tag, or releases on the npm registry. Also, reports come back to a Discord channel, so we have a place to ping maintainers and talk about fails and see what needs to be done to fix them. And when push comes to shove, we can still check out the ecosystem CI project locally and use a nice bisect mode to analyze the fail and find the exact commit that introduced it. Currently, there are already many great projects using ecosystem CI, but it's not hard to add your own. It's just a little bit of config telling us about your repo and the scripts needed for building and testing, and the rest is done automatically by ecosystem CI. This benefits not only Vite, which gains less effort and faster feedback, and also a lot more coverage than would be possible by maintaining just a single test suite. But it also benefits the projects that use it, because you get notified of bugs early before they enter a Vite release and might hit your users that use a peer dependency. Or you gain confidence for updating Vite because Ecosystem CI already ran and passed your test suite. One of the main benefits is that it also allows you to upgrade to a new Vite major release in a faster way. Because when Ecosystem CI runs on a Vite beta and you participated in that, upgrading after Vite has released its final version is effortless and seamless. So for sustaining growth in the Vite ecosystem, please collaborate on Vite Ecosystem CI with us and continue to be awesome and build things we don't even dream about today. Thank you so much for being awesome, and also thanks a lot Patak and Safiret for working on Vite Ecosystem CI with me, and the lovely people on Unsplash for providing awesome photos. This was Vite Ecosystem CI. I'm Dominic. Thanks for watching. Goodbye.
And we are live. Welcome everybody to this amazing panel. I think most of y'all see some familiar faces here. I'm your co-host today. My name is Tracy. You can follow me on Twitter at Lady Elite. I'm the CEO of a consultancy called This.Labs. And today I have Jen, who is a software developer here at This. And we are so excited to close out the day with this amazing panel. So thanks all for hanging in there all day. And, maybe we can just go around really quickly and do quick name introductions. For those of you who don't know, this is the Vite team. And I'll start with Evan.
Hello, I'm Evan, and I'm the author and team lead for Vite. Yeah. Currently
hello,
in Singapore.
Okay. I'm Hao Qinjiang from the Vite and the Vue.js team. So I work for the Vue.js organization full time. And you may know me on GitHub as at Soda team. I'm based in China.
Okay, and it's Anthony Fu here, and I'm a Vite coding member, and also I create a few Vite plugins and tools like Vitess and SlideDiff. And yeah, thanks, Patak.
Yeah, I'm Matias, also known as Patak, and I'm also part of the Vite team, and I work at StackBlitz, where I get to spend like full time in Vite lately.
Oh,
John?
Hello, I'm Bjorn. I'm a team member of Vite and Sylwia and co-resident Astro. I'm working on open source as well. And next up, Shini.
Yeah, hello, I'm Christopher, aka as known as Shinigami, and I'm also a member of the Vite team and always working when I have time in my free time at Vite and yeah, managing stuff.
Cool. Thank you so much for the introductions. And we can get right into the panel.
Okay, so the first question is, how was the conference for you? Let's go ahead and start with Evan.
Emotional? Was it emotional? Surprising?
Yeah, it's quite surprising, to be honest. I kind of remember when we had the first ViewConf, right? That was in person. This one's virtual, but still, when Matias first came and floated the idea with me saying, okay, we want to do a ViteConf, I was quite skeptical. I was like, are you sure? Like, maybe we don't have enough people that's interested. But then when they started working on it, I see more and more of these framework authors getting on board with talks. And actually, in the whole process leading up to it, Matias was kind of giving me spoilers of the talks. I get more and more excited about it because it's actually interesting because, when you are, we are not actively keeping track of what everyone's doing in the ecosystem. But now at the same time, everyone's showing you all the things they've been working on. At the same time, it gives you a much more impact. You feel the impact of the thing you created, and it's truly amazing to see all these people building stuff on top of Vite. Yes.
Any other comments? Any other emotional thoughts from today?
Yeah, Patrick first. Okay.
Like Evan said, it has been really interesting that a lot of these maintainers choose ViteConf to be the place where they do this announcement. Like we saw today, Ian from Storybook saying that in Storybook 7.0, there is going to be like the Webpack was not going to be needed anymore. So it's going to be Vite only if you are in a Vite app. So like that's a huge announcement. We saw like Deno working with Vite, or Lukas from Rollup choose this date in particular to release Rollup 3. That is like enormous for us, like that we need to start working on Rollup 4 now. But as Evan said, like there's like a lot of things happening today. It will take us like weeks to unpack everything that happened just like in the past 12 hours.
A lot more work, it sounds like. Which is a blessing, of course. A blessing and a curse for open source. Matias, you kind of talked about a few of the big kind of showcases, but anyone else have comments on kind of like things you're excited about when it comes to the showcase, or any other announcements that you found interesting?
Yeah, so I'm thinking currently about 1.5 years ago, Ivan, you made that team shout out for looking for a team for Vite, and raised my hand for that, and I'm really, really happy to be in this ecosystem now and so on. And now seeing that there's a conference bringing all this framework maintainers and from every side of the world together. We talked in the in some channels about in the past there were framework wars, but now it's more like all frameworks coming together, bundled in Vite, and it's so nice to see that everyone is coming together. And, yeah, that makes me really happy.
Ho-Chin, any comments? Bjorn, any comments?
Yeah, I think I have to give a huge shout out to Matias, because I think he's the only person in this in this whole front end world to get the whole picture of the Vite ecosystem. It's the first time that I've seen so many packages or teams around Vite to show up together, and I'm very excited to see the announcements in my time zone. It's last night that the Rollup maintainer Lukas actually technically he's not part of the Vite ecosystem because he's a universal front end tool, but he chose to use this stage to announce that Rollup is open for Rust rewriting, and I think that's very exciting for me.
Yeah, I'm quite excited in Rollup 3. It's quite a big news. And I think StackBlitz as well, throwing so many features out in just one small talk. I can't wait to use it. And I think I missed quite a bit of the conference because I have to sleep, but I'm definitely catching up in the second half. Yeah, it's really good.
Yeah, I have to confess that I haven't finished all the talks since like 12 hours of content is crazy. And yeah, due to the time zone, I was sleeping and I just wake up and trying to catch up the talks. So I didn't finish before we go into this panel. But yeah, I would like to say that I'm really impressed about the whole ecosystem, the innovations created or inspired by Vite, or like the collaboration inside of the community that's come up with so many ideas, and to involve our like daily workflows or our developer experience to push that much forward. So yeah, I'm really impressed about the community we had for the Vite and around Vite. Yeah. And I will just try to finish all the talks later today.
Yeah, same for me. I actually missed quite a few of them, so I'm trying to catch up as well.
But that was the idea. It needs to work like that, because now you like all of Asia and Europe also like has the opportunity to see them all. So it's good. And one thing I like the chat, as Shini was saying, like it has been like this, like it has been like 11 hours of like content, constant content from like a lot of communities. When it was interesting because like, I don't know, like in the Solid Start talk with Ryan, the whole Solid community came to ViteLAN and they were talking there. And then like the in the quick talk, the same was there. Or in the next stack, like the Vue community was there. And like in one particular channel, it was like crazy how fast the text was going of how many people were interacting there.
Yeah, branching off of that, there's a lot going on during a conference. How does the team work together? I mean, with the time zones and everything, how does the team get to work together?
Yeah. So originally, when I started the team, we intentionally made the whole similar to how the Vue team works. We make it quite loose in terms of structure. Team members just decide what's important enough for them to work on, to invest their time in. So there's no really hard responsibilities per se. Essentially, I don't go around and say, hey, like, this is your job, you need to do this, or anything like that. And one of the reasons people become team members, similar to how I try to do things around open source, is motivated contributors typically will step up by themselves because they are genuinely passionate about the project. So they have the natural drive to notice what's important because they are thinking about how to improve the project. So they notice the problems that needs to be solved and they work on it. And I think that's critical in building a team that can be self-driven in a way. So outside of that, we try to do bi-weekly triage meetings where so we try to organize and triage the issues when we're not meeting, put them into different priority categories. When an issue comes in, we see, okay, is this a feature request or a bug report? So these are kind of codified. We have a workflow for that. So anyone on the team can help to put the issues in the right buckets. So we have a board where all these issues are kind of sorted into different categories. So during our team meetings is where most of us would get together and go through these by priority. And usually if an issue is non-controversial, team members can whoever happens to work on it can just propose a solution. And if another team member approves it, we can just merge and go, right? So typically the things we discuss at meetings are the ones that have relatively bigger impact. We need to get a consensus or get input from me directly to call a shot, say, okay, this is what we're gonna do, this is not what we're gonna do. So I think so far that's been working pretty well for us. And obviously, all of this kind of works because there's Matias who's just tirelessly sort of reaching out to people outside the team and bringing feedback so he can provide the insight for us to make more informed decisions. So yeah, that's pretty much how it works.
I would also like to add, so yeah, I'm really happy like how Ivan is structuring this team and Patak is leading the meetings and so on. And in one of the meetings, like I think half a year ago or so, I need to make a shout out to Anthony Fu because we had a discussion about Jest, and that's the test system we are using in Vite itself is really slow. And then we made, I think it came of a joke that we said something like we test, and then Anfu on the next day created VTest, and around that is a complete ecosystem was built and so on. And Anthony is also pushing out repositories and projects like no one else. And I'm depending on him in my open source projects. I'm depending then in my company projects. So not also even you with the Vue ecosystem, but also Anthony with all his repositories. It's such a huge ecosystem, and in the last half year I didn't do any so much in Vite anymore as before, because I became the maintainer of Faker.js, and but even this is helping because when I'm using stuff like Vite and Vue and VTest and so on, I can report back stuff to Patak, how we use that, and also we discussed an example about labels in GitHub, how to manage a repository and so on, and all these projects improve by each other. Yeah, and that's also really, really cool.
Yeah, thank you. And I feel I'm quite being over credit. So I guess similar to Vite, I think Vite is not a one-man work, and that's like I think that's credited to the community and the team we had, or the foundation we had for the Vite. So the first idea or the first demand that comes from our team to say what the testing framework we would recommend, and the core mechanism to like that Vite running on Node is based on the feature Vite provide, and also the initial idea. We worked on Nux to solve the SSR issues that Puya provide to all these things to make Vite possible as an idea. And then we have we have a kind of Vite team with the help of from Patak and from many our team members to make these things happen. And the community, they kind of push the tools forward to be the current state that we kind of being like very satisfied with, to being able to fit our needs with the like more collaborations with the Vite ecosystem. And I think that's being one of the examples that how Vite unite this community and to make things I think universals for each others.
I would also like to shout out, like since we are giving shout outs to everybody, to Bjorn and to Safi. That is like Safi should be here also. That like he normally is in the meetings, in the team meetings, and like they have been doing such an amazing work with triaging and fixing bugs, like in the past 6 months or a year. Like if you take just into account what happened in Vite 3, like we had 800 issues open, and like they started a sprint to close it. Bjorn sent a tweet saying, "I will take the open issues down to, I don't know, like what, 100? I don't know, whenever you are going to reach someday." But it went from 800 to 400 just in like 2 months, and that was like just impressive. Like also Soda got involved there, like with like the lead of Evan to go through all of the issues. And that's just like amazing, like going like every single issue and created like a mental, and it's not like that, how would you call it, but like a map of categories of what are the things that we should focus on Vite moving forward. That is also really helpful.
This is so inspiring because I just gave this talk about how to contribute to open source, and was talking about all this today. And I think, you know, like some of the stuff you just mentioned, Matias, are great ways that other people could potentially get involved. You know, you don't have to think about, oh, I'm never as good as Anthony in creating all these things. But, you know, there's so many other ways you can become so critical to the success of open source projects such as Vite. So I think somebody else was going to talk, though. Did I hear somebody unmute and want to make other comments?
I'll just try and say thank you for the shout.
There's so much love in this room. No, it's really great. And also, I have to say, you know, kudos and shout out to kind of hearing the way, Evan, you kind of decided to structure the team with both of you and Vite. You know, it's amazing what passionate people who come together, who want to solve hard problems, can do with lack of politics. So it's great to see the innovation that has been able to happen, you know, kind of like outside corporate doors. outside of corporate open source, if I could say that. So I guess, kind of going to that, y'all have provided a lot of really amazing examples on how team members here have, been able to help Vite be successful. But how can others get involved, for that developer sitting there listening right now, wanting to do the next thing? Like, what can they do to help Vite?
Well, I think there are different ways of being part of the community and contributing. So I always say, even just going on Discord and help each other out, answering other people's questions is a form of contribution, right? So share your knowledge, share your experience, answering questions maybe on Stack Overflow also. So these are like the lowest kind of hanging fruits anyone can do. If you want to go a bit further and directly contribute to Vite itself, you can take a look at our issue list. We always have tons of new issues coming in, so help us triage them. So typically we spend a lot of time figuring out how to reproduce a problem. So you can help us with verifying, okay, this is happening on my system as well. This is happening, maybe reducing the scope of the reproduction to make it easier for us to identify the problem, or even if you identify the fix yourself, submit a PR to fix it. So these are kind of natural progression, right? So you can start with just helping other people out and then helping triaging issues. And once you do that for a while, you kind of get a hand of it. You can also, follow along the issue to see how it got fixed, to follow through the process, see how other people have submitted a PR. So you learn from it, and then you can do it yourself. I think this kind of applies not just to Vite, but to any kind of open source project, right? So if you don't know how to get in, you kind of have to lurk around a little bit, just see how other people are doing it. That's how I got into open source. That's how I learned to write code, actually. I learned by just reading other people's code on GitHub, because everything is open, right? So all the things that core team members are doing are also open, right? You can take a look at, the PRs people have submitted to Vite, see how they're working with it. That helps you familiarize with the code base as well. So yeah, that's in fact how a lot of people got, most of our core team members started by submitting small PRs. The first PR Matias submitted was just fixing a typo. And then he got more and more involved and eventually become a team member, right? So you start with small things, do it consistently, and we will, the team members who interact with the project daily will notice that you've been there, you've been contributing. So we have a nomination process where current team members can say, hey, this person has been doing great work lately, and we think he or she should be on the team, and we'll do that. So that's the typical process. And outside of it, if you're not directly interested in working on Vite itself, you can create plugins, right? So because, in fact, a lot of the problems that people are trying to solve may not be suitable to be solved inside Vite core, because we do have a scope problem where because Vite has so much exposure to the whole web tooling scene now, right? Sometimes we have a tendency of saying, okay, we wish Vite could do this, but maybe it's not the best idea to do it because it's possible by just building a plugin for it. And in that case, you can solve your own problem with a plugin, publish it so that other people can reuse your work. I think that's also a great way of contributing to the ecosystem.
Yeah. Well, one thing that, like adding up what Evan said, in Vite in particular, like the quality of contributions, like issues, like how the issues are reported and the PRs, like most of them are coming from the maintainers of the other projects, because like Vite also grows a lot with all the other projects that are involved. So this thing that Evan say about like go to Vite and check how others are like doing the PRs or how they are even structuring their thoughts, no, like how they are presenting the problem. Vite is a great place to learn that, because you are going to see a PR from Rich Harris, from Ryan, from like the people from Quick, from like Daniel Roy from Nux. Like they are all great open source folks. So you're going to learn a lot by following them, like Evan is saying.
Exactly, yeah. So I think what I see a lot from beginners or newcomers to open source is, first of all, you don't know where to start. And the second is sometimes maybe you try for the first time, you submit a PR, but there are little things that's kind of common etiquette in open source where like when you submit a PR, there are certain things you should avoid, like don't use a formatter to format the whole file with unrelated changes. You know, these small things. And then also how to best explain the problem you're trying to solve. Like how to make it easier for the maintainer to make the decision to whether merge it or not. In fact, as a maintainer myself, my biggest struggle a lot of times is I get a PR with good intentions, but sometimes maybe it just didn't really explain the problem well enough. So I was having a hard time just understanding why this is needed. So usually it's better to have a good explainer of what problem is trying to solve, how we ran into it, why this can only be solved inside the project core, and this is how we're trying to solve it. Maybe other solutions you've explained, right? If you look at the PRs from some of our framework collaborators who are building stuff on top of you, usually the PR they send are very high quality because they usually very well explain the problem they're running into and explain why they think this is the right solution. And that makes it a lot easier for us to consider, like, okay, this makes sense. And so it also reduces the amount of back and forth needed to get feature merged. So overall, it just makes the whole process faster. So there's definitely a lot to learn just by watching other people work. And I think that's the great thing about open source on GitHub is, the whole process is open for you to learn.
Well, that's really amazing. I think there's, I laugh at Matias' little fix because, I always say, and I think every single maintainer asks, I'm sure all of you all on the team are like, where can we start? Maybe you could help with the docs, right? It's a very common thing that we hear that, all open source projects need. And if we look at Matias as an example now, right? Like that small little PR turned into something so much more amazing. And it's the small things and don't discount the small things and your ability to be able to be involved that way. So I'm excited now. I need to go into the Vite ecosystem and figure out what I can do. I'm so inspired by this panel. But moving on to the next question, Jen's about to ask like the big question that everyone's waiting for.
Yeah, so what is next for Vite?
Dun, dun, dun.
Yeah, that's a quite a loaded question. And to be honest, we don't have this like big bang kind of thing that we're planning to do because at this moment we think Vite has essentially reached a critical mass where there are a lot more things that's being built on top of it. So I think it's a period where we're trying to stabilize and let people iterate on top. And because Vite has gone through its own moving fast and break things phase now, and now other people are iterating on top of it. So we kind of have to start thinking about how we make sure that things we do don't affect things that's being built on top of it. Which is why we also invested in things like the ecosystem CI, which make sure that everything we land doesn't break things accidentally on top. So I think right now, like for this very moment, this focus is in fact just making sure Vite can serve well as the common tooling layer, making sure that it's because there are still a lot of little things that we need to fix, and we're trying to take this moment to also gather feedback from people building on top of it to see what is the next thing that we can significantly improve for all of them, right? Because to be honest, like from my personal perspective, I've solved most of the problems I started out to solve with Vite. Like I'm super happy with it as a user myself. But now we have more users than just people building directly using Vite to build apps. Now we have these framework authors, and we are facing a lot of different needs, pulling us in different directions. And we need a time to sort of think about what is the overlapping things that we could benefit all of these frameworks together. Yeah, and I think Matias may have something that he already has in mind that he wants to push in Vite for.
Now, I think that is like you said, like a lot of what we did since Vite 2 has been like looking inside and trying to like make it, I don't know, reduce the bugs, like trying to move like from some regex to like other methods, or I don't know. I think that moving forward, there will be a lot of moving to Rollup, for example. That will not be like felt that much outside, but internally it will make things more maintainable. We could replace some parts, maybe like instead of post CSS, we could use lighting CSS from the Parcel team. There was a POC going around there from Devon. So yeah, I don't know. Like I think for a while it will still be kind of like more introspective changes and giving the base that you say is needed for others to innovate on.
Yeah, one potential thing we've been thinking about, but this is a bit more further down the road, right? One of the bottleneck that we want to solve eventually in the long term is the amount of requests during development. When you have like thousands of requests, there's just congestion at the network level, which Vite itself is not able to solve, just due to the eager nature of native ESM imports. But there could be potential ways to work around it, for example, with web bundles. But these are kind of specs that are really early and in flux. But we've recently started, got in contact with the browser folks who's directly working on the browsers, and we're trying to exchange notes and see what future features in the browser could potentially benefit Vite that we could leverage, to improve. And the other thing is, So we've been recently doing quite a bit of communication with people working on browsers to see what are the potential ways to address this bottleneck. I think that is probably one of the things I want to solve the most, but in the short term, it's quite difficult. So we're kind of setting our hopes on future specs in the browser directly that maybe can help us with that.
What about the rest of y'all? Any hopes and futures that y'all are hoping for?
I think. Sorry, you can go ahead. Slow down.
Okay, so I think the main characteristics of Vite is fast and lean. So I think Vite 3 will go more extreme on these two sides. For example, in Vite 3, we cut the publish size in a third. And actually, with the Rollup 3 release and in Vite 4, we can further cut the install size because Rollup removed their browser bundle from the NPM package. And on the other hand, Vite is very simple. So now, as we're looking more inside our internal complexity, so many of the new options will go into the experimental flag, and that will keep the new features easier to start with, and we might find a way to integrate it into the existing options without confusing new users. And that's what I was looking forward.
Yeah, I think mostly for me, it's polishing up. So everything will stay the same, but better. So like Rollup 3, for example, we change internally, but you wouldn't feel it. It'll be a transparent change. And there's some improvements from pre-bundling that I guess we want to bring back from the early V3 alpha days. But yeah, all these changes shouldn't affect you. It should just work magically, so you'll get the performance out of the box. You don't have to mess around with configs or anything. So I guess, yeah, that's kind of the future of V so far.
Yeah, I kind of agree. And from my kind of personal perspective, I feel that as the community we already have, the ecosystem we already have, that kind of being approved that Vite itself is being very flexible. And since we have so many tools on top of Vite, and I think for Vite itself, we should kind of limit our scope to not introducing that really like new features, but we could now like leave the innovations to the framework, and we kind of already see that we got a lot of new we got the frameworks with tons of new features and new ideas and already going on in this talk. And so kind of feel that for Vite itself, we should keep doing our jobs to like optimize and to make things even faster, or like improve the things itself. So I kind of feel that we won't have like have a like keynote to showcase that we kind of have tons of new features coming in that get people excited. But I think the works inside of Vite to keep things stable and to keep things like very maintainable and fast is still a crucial job to make it for the whole community to use, I think.
That makes sense. Although I know everybody, whenever you talk, Anthony, is waiting on bated breath to figure out what library or tool you're going to create next. So we're excited. I feel like anybody who wants to see that, we got to just keep watching your GitHub. But, you know, I love that. I mean, the things that I hear about Vite and kind of how y'all are stabilizing and trying to make it maintainable and no breaking changes or very little breaking changes are really amazing goals. And I, feel like that's also what Vue has done. So surprise, surprise, very similar team working on the same thing. But Evan, I know, over the years, whenever I talk to you about Vue, it's always like just improving performance and improving things and, constantly like improving things under the hood. So it's great to hear kind of like the same methodology here.
I have firsthand experience on just a project going through different phases, because when you're just starting out, you can do whatever you want. Then when you have only early adopters, you can ship big changes, big improvements while caring less about disrupting things built on top of it, because early adopters are typically more open to that kind of thing. But when you reach a critical mass, you have a lot of you have a wider audience. You have people who are just using your thing to build stuff in production, and there are a big group of users who, for them, first priority is stability. They don't want things to suddenly break, and there will be a point where you are solving the problem well enough that stability, in a way, becomes a really important value for the thing to uphold. So I think Vite is in a transition period where we want to essentially bring back our focus a little bit. Instead of thinking about, okay, what's the next big thing? What's the next new thing? We're going to say, okay, how to make the current things better? How to keep it working the same way, but faster, leaner, and more robust and more stable under the hood. I think that would be the focus for, at least for now. Yeah.
Thank you so much. And we are just about out of time, but one last question. Will there be another ViteConf?
I don't know. Do you enjoy this one?
I hear the next one is ViteConf.
Oh, okay.
We do one year ViteConf, 1 year ViteConf. I think
actually,
yeah.
Yep.
Go.
Yeah, actually, I think in Gaza, like in 10 minutes, we will starting over again, and that will be another. Yeah.
That's true. That's very
you
true.
have 12 hours to enjoy.
Yeah.
Well, stay tuned, everyone. Thank you all for joining this panel. Thank you, everyone, for joining ViteConf today. It was absolutely amazing. If you haven't gone back or if you missed some of the talks, I mean, there's just been some really amazing announcements lately. Storybook, Dino both made some really big announcements, as well as many others. So we will see you next time. Thank you all for joining. And thank you so much, Vite team, for being here today and being up so early on your time zones. Thank you so much.
Thank you.
Bye.
Thank you.
Thank you.
Bye.
Bye.
Hello again, everyone. We made it to the end of the first 12 hours. Weren't those panels so good? But wasn't really just the whole conference so amazing? This was so well done. Everybody give a round of applause to Matias and all of the amazing folks that were behind the scenes and that put this together. They've just done such an incredible job. And whether you are just getting up or maybe heading to bed like me, it is very late here. Keep posting on Twitter. Let us know your favorite talks. You can use @ViteConf or #ViteConf on Twitter and let us just know what you liked, what you enjoyed. And we had so much fun being with you. And this is all going to start again. Matias should be in here in just a second. He obviously just got off the panel, but is going to be coming in and joining me. But just keep posting and letting everybody know that you want to be back here with us again next year and showing all of this support. I was so excited to see all of these amazing tools and the people that Vite really brings together and makes this community feel like a family. I love how we can you don't have any framework wars. It's just all of us enjoying and being a part of everything together. And I loved what this conference did to us. The community and seeing everybody in the chat was just so amazing. I know Patrick or Matias spent a lot of time like doing the Discord, having all of the forums set up. That was like a schedule. Everything was just so well thought out and done so well. And we hope everyone enjoyed it and didn't see a lot of issues, but thank you to all the moderators that were out there helping keep chat clean. And thank you everyone for being kind too. I mean, did everybody get a chance to check out all the panels? I know we had a framework panel. We had the Vite panel that just happened. And then there was a panel earlier today. That was very exciting. 12 more hours. I know people are chanting 12 more hours. So we have 12 more hours to go. It's kind of crazy and exciting that all of this is going to start over again in play. So if you're just getting up, you haven't missed out. Join in the chat. And actually, I think there's going to be a Discord stage event after that. Unfortunately, I have to go to bed, so I won't be joining that. But if you're interested, get in the ViteLand Discord. I think we have a thing that we can put below for the link to join. I don't remember what it is. I'm failing on everything. And I thought Matias would be in here by now, but here we are. I'm just spitballing now. So I hope everyone had an amazing time. There we go. I think we have him now. You're muted though. There he is.
I'm here.
Okay. Hey, how's it going?
I'm fine. Well, are we live? I don't know if
we are live, I think, right?
Wow.
Wow. Yeah, right?
How was that for you? How did you feel it?
It was amazing. I just spent like the last couple of minutes just telling everybody how well done this conference was. And kudos to you. Kudos to all the team behind the scenes, the moderators, the people that just made this an amazing day.
Yeah, it has been crazy.
I'm sure you were like going.
It's now we are reaching like 12 hours. This is half of it. Like for like everybody that is watching, stay now because like we have a talk from Evan, a talk like I will be again, and then Anthony, and then Rollup will be there.
It's
and
all gonna replay for you again. You get the whole day again. So if you're just getting up, you're not missing a thing.
Yeah. And yes, thanks to you too, and to all the moderators that were there around the day. It was not that hard actually to moderate because everybody was like sending flowers to each other. So
That's
it was
exactly what I was saying right as you were coming in. I was like, everyone was so kind. I feel like we didn't really need a lot of moderation, which was amazing. But I thank you to all the moderators. That was incredible.
Yeah. It was really nice to see like ViteLAN converted like in one day as a space where all the communities get together. Like I was saying there in the Vite panel now that, I don't know, like when was the solid talk, like all the solid folk room came to the room.
I said that too. It's like how Vite really brings all of these communities together, and it felt like a family. Like we were all being nice. There were no framework wars. It was just all of us being kind and being together, which felt really good.
Yeah. And as some of the speakers said, like I think this is a good thing for the future of the ecosystem.
100%.
Like what happened, like also like Evan said, now that like it's really interesting to see like not like once announcement every 2 weeks, but like a lot of people use it this particular day as a hard day for them to do an announcement, like from StackBlitz that have been working so much to actually launch CodeFlow in this. Like if you are listening for the second part, like CodeFlow doesn't exist, you're going to get to know it. Like
no spoilers.
No spoiler now. But also like Storybook actually announcing what is going to happen with 7.0, or like the Rollup 3, Lukas there, like choosing that date is kind of like significant, no? Like it's making it Rollup and Vite a lot closer, I think.
I know. I saw people like asking for SvelteKit 1.0. I'm like, we just hit release candidate. You guys slow your roll a little bit. We can't have everything released today, right?
Yeah. But it was Rich talk was incredible also, like the first part when he was talking about like this analogy of Vite as the infrastructure like for the ecosystem. I think like that's quite on point. It was really interesting to hear.
I agree too. Yeah, I thought all of the talks were just so well thought out. It was really an amazing day, and you are in for a treat if you're just joining in.
Yeah, totally. So yeah, I don't know how much time we have, like, but you should like stay around now. Like one thing that is important, I think, like to share also now like we did a lot of noise when we started, so a lot of communities joined, but now like a big part of the community is joining. So it would be nice if you invite them to came here. So like if you share like the link that is like ViteConf, ViteConf.org/live, that is kind of like the link that you have to share. There you're going to we are going to be together, like explaining all this.
I know, it's just going to replay over again.
Yes, so maybe we shouldn't explain that much now. But yeah, like we didn't said there that I think it's important now. Like a big part of these 12 hours was not only the talks, but was also watching it together in Discord and in all these like channels. So I think like go out, invite others, and like so you get that same experience now.
Yeah, I completely agree. And I was mentioning to everyone that if you have a favorite talk or something that you really liked about today, make sure you're tagging at ViteConf, using hashtag ViteConf, and sharing that on Twitter, like getting more people in. I can't believe 20,000 registrations. It's just incredible.
Yeah, and actually the people continue to register now.
Yeah.
So like we were seeing the number.
It's
and
just
like,
ticking up and up and up.
Yeah. I think it's like a 23.5K now registrations, and if I check correctly, there were like 1,000 new members to ViteLAN, to the Discord, like 1,000 new people that joined ViteLAN. That's quite important, because like one of the ideas of not making the conference in a separate space, let's say like a separate chat, was the idea of like, let's use ViteLAN. So all this movement actually stays with us. Like hopefully some of the people that were here today like actually like the community and are going to stay around and then get involved and
it brings
help us.
more people into your community. Yeah, I completely agree with that. And meeting your community where they're at. So now that you have like all these community members in there, they can find help and they know where to go and look for those things. I know you mentioned at one point that there might be a Discord stage. I didn't want to put you on the spot, but I mentioned something about that. Is that going to happen, or?
Let's check how we are in
everybody's
12
probably
hours.
A little delirious.
Yeah, in 12 hours more, like if we don't do it now, we can do it in 1 week. But yeah, like stay after like the conference is over, like after this second half. And if we are together and we decide that is a good moment to like talk with the community, let's do it.
Okay, sounds good. And maybe the ones in the future, like, do you have events that you post in the Discord that people can go and see? Like, I know ViteConf has the event in there right now, but would you post like, are there future events or reoccurring events that the ViteLAN Discord has?
Like, this is the first kind of like official, let's say, like event that we did in Discord. But maybe like given like the reaction that this is having, maybe we should do more often. Like I know, for example, like in the Astro Discord and maybe in the Svelte also, you have like once every 2 weeks or something that you get like together and just talk with the community. So maybe we should do that.
Yeah.
Like
Astro does that and Redwood does that. The Svelte team doesn't do it, but we've talked about doing that because I think that's really good for like building community involvement, especially with these open source things. So I think that is really beneficial for these communities to have that. So that would be really cool.
That's actually a good idea. I think like we can discuss now, like in this next 12 hours, we have some time to discuss about these other meta things.
I'm gonna sleep for about 8 hours.
I think I will do too. Like, but the like Blue, Anthony, Soda, like there is a lot of like Evan, like there is a lot of people that just working up. So like there will be some like exchange of teams and moderators, and then we are back. And I wanted to just like take some time to thanks again. Like you're going to see thanks us, like, but it's good. Like all these happen also because first, like the speakers, like you said that like the talks were amazing because they really were. Like there were some that like were like Hollywood kind of production. Like it's just amazing. So thanks a lot everybody that put so much effort. There were a lot of first time speakers that actually did so good. I hope they go and have like other conferences later. And yeah, like thanks for like StackBlitz for like sponsoring the event and like the community partners also for the help. And yeah, like thanks everybody that was involved, the communities, thanks everybody that invited others and took it here. And this is also kind of like going to be repeated as the end of the conference. Yeah. So if you're staying, like if this is the half and you're staying, like just like take it as this is staying. If this is the end of the conference for you and you're watching it like tomorrow. So yeah, I don't know.
And thank you for sticking through the whole thing and being here at the end with us.
Yeah. This has been an amazing experience, and yeah, I think we should repeat it. What do you think? Should we do it again next year?
I absolutely think we should do it at least next year, if not in 6 months.
Next year.
I just put all the
next year.
Next year, please save my heart.
No, it was good. It was good.
It was so good, and it's so nice to see all these people come together. I love that part of it.
Yeah. So yeah, I think I don't know. Let's close it and let's give the word to the two of us.
Yes.
Again.
hand it off to Brittney and Matias. See you guys.
See you. Thanks a lot.